Hello everyone, I'm Siddharthan. This is the fourth part of our complete machine learning course, and this machine learning course will be 60 hours in total. So in this section of our ML course, we will discuss about some of the important topics such as cross-validation, model selection, hyperparameter tuning, and model evaluation. So we will also discuss about some of the machine learning use cases such as movie recommendation system, customer segmentation, etc. So before getting started with this fourth part of this machine learning course, so I'll just give you a quick recap of what are all the topics that we have discussed so far and what are all the topics that you can expect in this fourth section. Okay, so let's get started. So in the first part of this machine learning course, we have discussed about the basics of machine learning. So that was the first module where we have discussed about what is the difference between AI, ML and deep learning. And we have also discussed like what are all the different types of machine learning such as supervised learning, unsupervised learning and reinforcement learning. So the second module was completely about Python basics for machine learning, where we have discussed about topics such as data types and loops, if condition, and functions in Python. So the third module was completely on, a detailed explanation of Python libraries such as NumPy, Pandas, Matplotlib, and Seaborn. So these libraries are something that we often use in machine learning. So the fourth module was all about data. So we have seen where to collect this data and how to process this data for training a machine learning model and so on. And we have also discussed three machine learning use cases such as rock versus mine prediction, diabetes classification, and spam mail prediction. So these are all the topics that was covered in this first part. And in the second part, we have discussed about the mathematics behind machine learning, where we have discussed about this linear algebra, statistics, and probability. So the sixth module was a deep module about this machine learning models. So it had topics like how a machine learning model works, what is this model selection, what is overfitting and underfitting, and so on. So we have discussed these topics, and there were also machine learning use cases such as art disease prediction, Boston house place prediction, and loan approval prediction. So these are all the topics in the second part, and the last part was the part three of this machine learning course, which is completely about building machine learning models from scratch. So we have discussed about four models such as linear regression, logistic regression, support vector machine, and lasso regression. And in each of this model, I have explained you about the intuition behind that particular model, what is the math behind it, and how to build this model from scratch in Python. So these are all the three parts that we have discussed so far. And in this fourth section or this fourth part of this machine learning course, we will discuss about the topics such as cross validation, hyperparameter tuning, model selection, and model evaluation. So this will be our eighth module, and there will be multiple videos in each of this topic. So the first video will be a theoretical video where I'll explain you what is meant by this cross validation and how it works. And then in the next part of the video, I'll explain you like what is or how you can do this cross validation in Python. So similarly in hyperparameter tuning, there will be a theoretical video and also an hands-on part where I will explain you how to implement this hyperparameter tuning in Python. So that will be our eighth module. And in this model evaluation, we will also discuss about topics such as accuracy score, precision, recall, F1 score, and confusion metric. So all these videos are very important. So please watch all these videos and try to practice the codes that are given here. And the last part will be machine learning use cases where we will discuss about big Mart sales prediction, regression problem, and breast cancer classification, calorie burn prediction. And the last two is movie recommendation system. So this one is pretty different from the other use cases that we have seen. And the fifth use case will be customer segmentation using clustering, where we will use k-means clustering in order to group customers. So these are all the five machine learning use cases that we will discuss. So these topics will be covered in this fourth part of machine learning course, and in the fifth part, we will discuss about some of the deep learning use cases and also how to deploy your machine learning models using various techniques like Streamlit or Heroku, or how to deploy your models as API. So that will be the last part of this course. Okay, so I hope you are excited to learn this. So let's get started. Eighth module, we will be discussing about the topics such as cross-validation, hyperparameter tuning, and evaluation metrics. This is probably one of the most important modules in our entire machine learning course. These topics are important in both ML project implementation point of view and ML interviews point of view, and there will be a lot of questions asked based on these topics in an ML interview. Okay, so please follow all the videos that are posted in this module. And once we complete this particular module, the next module will be on how to implement different ML models through sklearn. Okay, so this is an introductory video on what are all the topics that we will be discussing in this module, so that you will get an idea of what to expect. Okay, so let's get started. So in this module, the first topic that we will be discussing is cross validation. So cross validation is a very important technique that we use in machine learning in order to get a more reliable evaluation metric such as an accuracy score. So in this module, the first video will be on this topic. So once we understand about cross validation, we will also be discussing something called a scaffold cross validation and how to implement the scaffold cross validation in Python. So this is the first topic, and the next topic will be on hyperparameter tuning. So again, this is one of the most important things that we have to do while implementing a machine learning model. So in machine learning, we usually have two kinds of parameters. So first kind of parameter is the model parameters, and these model parameters are derived from the data set that we have. So if we think about a linear regression model, we have the parameters such as m and c, where m is our slope and c is our intercept. So m and c values are derived from the data set that we have, and the other set of parameters is called as the hyperparameter, and this hyperparameter determines how your model is being trained. So we change these hyperparameter values in order to get the best fit of the model, in order to get an efficient model. So we will be discussing about what is this hyperparameter tuning and how we can implement this. Okay, and when we talk about hyperparameter tuning, there are two main important techniques that we can work on, which is grid search CV and randomized search CV. So this will be the next set of videos that we will be discussing. So first I'll explain you what is meant by this grid search CV and randomized search CV, and we will be taking an example and working on Python in order to implement this grid search CV and randomized search CV. Okay, and one more thing that I wanted to mention, that is, like, in all the videos there will be both theoretical aspects and hands-on part. So if we think about cross validation or hyperparameter tuning, in the first part of the video I will be giving you a theoretical aspect of all the concepts that is present there, and based on that understanding we will be implementing the same thing in Python. So this would be the structure of the upcoming videos in this particular module. So once we complete this cross validation, hyperparameter tuning, grid search CV and randomized search CV, so using all these things we will be discussing how to select models. So the next topic will be on model selection. Again, this will be both conceptual and hands-on part will be covered here. So using all these techniques, we will try to select the best model which is suitable for our particular problem. So once we complete this model selection, the next part will be on model evaluation. So under model evaluation, the first thing that we'll be discussing is accuracy and confusion metrics. So we'll be discussing in detail about what is this accuracy scores, and especially confusion metrics. So these are all very important metrics when it comes to classification problems in machine learning. Okay, so the next topic will be on precision, recall, and F1 score. So there has been a lot of ambiguity on this particular topic, and this is also used in classification problems, where these are again evaluation metrics which are more reliable when compared to the accuracy score. So we'll be discussing about what is meant by this precision, recall, and F1 score, and how to calculate this while we are working on a ML project. So we'll be discussing this in Python as well. And the last part of this module 8 will be metrics for regression. So we know that we have different error metrics such as mean absolute error, which is called as MAE, and also we have mean squared error and etc. Right? So we will be discussing what is meant by each of these error metrics and what is the significance of each of these error metrics. So these are all the topics that will be covered in this particular module, and I hope that most of you know the importance of all these modules. Okay, so all these topics. So first, as I've told you, the first part will be cross validation and hyperparameter tuning and model selection, and the next part will be on model evaluation for both classification and regression problem. Okay, so I hope you are interested to learn about all of these concepts, and I'll see you in the next upload where we will be discussing about cross validation and k-fold cross validation. Okay, so we'll be discussing about topics such as cross validation, hyperparameter tuning, and model evaluation. These are some of the most important topics in machine learning. And the first video in this topic will be k-fold cross validation. This is a conceptual video, and once we understand the concepts clearly, we will move on to the hands-on part in the next video where we will implement this k-fold cross validation in Python. So let's get started. So first of all, I'll just give you a formal definition on what is meant by k-fold cross validation. So in k-fold cross validation, we basically split the dataset into k number of folds, or you can think about these folds as subsets. one chunk of data is used as test data for evaluation, and the remaining part of the data is used for training the model. And each time a different chunk will be used as the test data. So this is the formal explanation for this k-fold cross validation. And if you don't understand what this definition means, it's all fine. So I'll explain you clearly what this means, and we will also be taking some example and understanding what this basically means, right? So I hope that by this point you would know what is meant by train test split and what is meant by evaluating our model. So you can think about this k-fold cross validation, in which we will be doing a kind of train test split and model evaluation in a single step, but in a more better and efficient manner. Okay, so you can think about this like this. So let's try to understand this with an example. So let's say that we have a data set. So this can be any data set. So it can be the diabetes prediction data set, where you have data about people with diabetes and people without diabetes, and there can be many factors such as their age, BMI, blood sugar level, etc. Okay, and let's say that there are about 1,000 data points that are present in this data set. And when we do train test split, so within this 1,000 data points, we will take 80% of the data as training data and 20% of the data as test data, where this 80% of the training data will be used to train our model, and the 20% remaining data will be used to test our model, right? So everyone knows up to this point. So instead of doing this train test split, what we will do is, so while using this k-fold cross validation, we give some value for this k. Okay, so generally we give the value as 5 or 10. So it's the general thumb rule. So let's say that we are giving the k value as 5. So now what happens is, this data set will be splitted into 5 chunks, or you can call this as folds. So this is the technical term that is used. So hence this is called as k-fold cross validation. Again, when we talk about cross validation, there are different types, and one of the mainly used type is k-fold cross validation. And in the end of this video, I'll tell you what are all the different types. So we have k number of folds, and now when the k value is 5, we will be splitting the data set into k number of folds. Okay, and you can see here, so we have 5 folds here, right? So we have 5 iterations on the first iteration. So let's say that the fifth chunk of data, or the fifth fold of data, will be used as a test data set. Okay, so as I've told you, let's assume that there are 1,000 data points. So if we split it into 5 folds, and each fold will in that case contain 200 data points, right? Because 5 into 200 will be 1,000, the entire data points number. So each fold will have 200 data points, and this fifth chunk will be used as the test data for the first iteration. Let's say that we are using the logistic regression model for all the iterations. So for the first iteration, our logistic regression model will be trained with all these 4 chunks of training data, and once the training is completed, it will be tested on the test data. This is the first iteration. And for the second iteration, the fourth fold of the data, or you can think about this as the fourth chunk of data. So this fourth subset of the data will be used as the test data, and the remaining data will be used as the training data. So this is the procedure. For the third iteration, this third chunk will be used as test data, and for the fourth iteration, the second fold is used as the test data, and the remaining data is training data, and so on. So similarly, we have 5 iterations. So the number of folds of your data is probably equal to the number of iterations that you have. Okay, and what we will do is, in each step we will try to find the accuracy of the model on test data. Okay, so as we know that once we train our model, we will evaluate our model using the test data, right? And we, if it is a classification problem, we may get accuracy like 80% or 90% or 95%. So 90% accuracy means out of 100 data points, your model can predict correctly for 90 data points out of 100. So that is called as 90% accuracy, right? So for each iteration, we will try to get this accuracy score, and once we have all this 5 accuracy score, we will take the average of that accuracy score, and this will be the final accuracy score. Whereas if we think about train test split, what we will do is, we will just take the entire data as I've told you before. So 80% of the data will be training data, and 20% of the data will be your test data, right? So if we think about this number, the training data will be 800 and the test data will be 200, right? So the advantage of k-fold cross validation is like, you are testing your model with different chunks of data, or different data points. So I'll explain you what is the advantage with an analogy or an example. Let's say that a student, an higher secondary student, is preparing for his JEE exam or something, and we know that there is physics subject is there, chemistry is there, and so on. Let's say that there is a chapter called as semiconductors, which we all would have studied, right? And that particular student has studied all the concepts and formulas, and now we are going to test him based on the previous year questions. Okay, and let's say that in the question bank there are about 200, or let's say that there are about 100 total previous year questions that are based on the chapter semiconductors. Now let's say that we are taking the entire 100 questions. So out of those 100 questions, we are going to test that particular student on 20 percentage of data. So out of the 100 questions, we will be asking only 20 questions to him, and we will check how he is performing on those 20 questions, right? And let's say that he has answered correctly for 15 questions out of that particular 20 questions, and now we will try to evaluate him and what is his percentage and so on. Now the problem with this approach is that particular student has seen only that 20 percentage of data. This is probably not a good evaluation metric. Whereas let's say that we are subjecting that particular student to different set of questions, so it would give a more reliable idea on how much he has understood that particular subject, right? So that is the same idea here. So when you have a small data set, when you just use train test split function, your model will be evaluated on a very small portion of your data, and we cannot use that as the proper accuracy score. Whereas if we use k-fold cross validation, we kind of use different test data for each training session. Okay, and when you add that 5 accuracy score, so we will get a more reliable score. So that is the idea behind it. And another thing that you need to note here is, so once you are, let's say that you are training your model for this first iteration, where this fifth chunk of your data is the test data. So after that iteration, so that is like and once we find this accuracy score, that is all that we are doing. So we will create a new instance of the logistic regression model, and we will train that with the test data. So here you need to understand that we are not training the same model which has been already trained for the second iteration. So we have to use a new instance of that particular model. So this is very, very important, because like let's say that you are using the same model, same trained model. So in that case, there is a possibility that that model has already seen the data that is present in this test, right? So the model already know what is present in this test data, because this is the training data in the previous step. So I hope you understand this. I'll just quickly repeat this particular thing, because it is very, very important. Let's say that we are training our logistic regression model with this first iteration, and in this case, the first 4 chunks of data are your training data, and the final fifth chunk is your test data. If you use the same model for training on top of it, now the model knows what this test data is, because it has already trained on that particular chunk. So in each iteration, we will create a new instance of that logistic regression model, or whatever model we are using, and test it for different accuracy score with different test data. So this is very important. Okay, now you will get a reliable score. So the basic idea is, you need to check whether your model is performing on the overall data set. So that's the idea behind this. And one of the main applications and where we use this k-fold cross validation is when it comes to model selections. Let's say that we have this support vector machine and logistic regression, and for a particular case or a particular data set, we want to determine which model is the most efficient and which model is the accurate one. Okay, so in that case, instead of going with a single train test split and a single evaluation metric, which is accuracy score, we can use k-fold cross validation, and it will give a more reliable accuracy score or evaluation metric. So that's the idea. And let's consider an example. So similarly, let's say that we have a data set, and let's say that this is our the same diabetes data set that we have been working on lately. So it is a famous data set, so we all know that, right? So we have the diabetes data set, and and let's say that the k fold or the k value is 5, and we are going to implement this k fold cross validation. And first we are using a support vector machine. So first we will load an instance of this support vector machine, and training with the first 4 folds or 4 chunks. Here I mean fold and chunks, which basically mean the same meaning here. Okay, so we are taking the first 4 folds or the chunks of data as training data, and the fifth chunk of data as the test data, and then we will calculate the accuracy for this particular case. So the accuracy on test data, which is very important, and not on training data. And the second iteration, we will load a new instance of the support vector machine model, and now the fourth chunk of data will be your test data, and the remaining data will be used as the training data. Now let's say that the accuracy score is 83%. So your accuracy will definitely change, because here the test data is different, okay, and the training data is again different. So there will be a slight change in your accuracy. In most cases, the accuracy change won't be that much, but in some cases where the data set is very complex, and when some of the data are missed in this split and all that, so there will be a significant change in this accuracy. So let's say the accuracy in the second iteration iteration is 83 percentage, and in the third iteration where this third chunk is used as the test data, let's say the accuracy is 86, and for the fourth iteration, let's say it's 81, and the final iterations it's 84. So as you can see here, there is a slight change in accuracy. So instead of taking one accuracy which we will do while we are using train test bed, so in k-fold cross validation we will take all this accuracy score into consideration, and we will divide it by 5. So because there are totally 5 accuracies, so we are just taking the mean accuracy of all the accuracy values, and the average of this particular accuracy will be 84.4 percentage. So you can say that the reliable accuracy score value for this support vector machine for this particular data set is 84.4 percentage. So once we do this with the support vector machine, we will do the same procedure with a logistic regression model. Okay, so every procedure is the same. So in this case, now we have 90 percentage accuracy for the first iteration, and the second iteration it's 88, third is 86 percentage, 91, and 85. So these are all the 5 accuracy score we are getting for logistic regression, and in this case, let's say that the mean accuracy is 88 percentage. Now we can compare this accuracy with the mean accuracy of a support vector machine model, and we can say, and we can basically compare them and say in this case the logistic regression model works well. So this is one of the things that we do while we are selecting the model. So when it comes to model selection, there are apart from this cross validation, there are also other things that we need to consider, so which we will discuss in the upcoming videos. For now, understand that this can be used as one of the steps in the model selection procedure, where we need to select which is the more optimum model for your particular data set. So here we can say that the average accuracy for the support vector machine model for a particular data set is 84.4 percentage, whereas the mean accuracy or the average accuracy for logistic regression model is 88 percentage. So we can say that this is the best model for this particular case. Okay, so this is how we use cross validation in order to select our model. Now let's try to understand what are all the advantages of, or what are all the pros of using this k-fold cross validation. The first step is, it's a better alternative for train test split when the data set is small. So this is very, very important. So if you, let's say that you have a very large data set, so let's say that that particular data set has about 10,000 data points or 1 lakh data points or something like that. So in that case, you can actually go with the train test split, because the test data set will contain a huge proportion of the data, even for 20 percentage of the data. Okay, so if you think about 20 percentage of data for the 10,000 data points, or 20 percentage data for 1 lakh data points, that is pretty large. Okay, so in large scale data sets, you can actually go with train test split, whereas if your data set is a small, then k-fold cross validation is a better idea, because in that case you can check how your model is performing for the overall data set and so on. And the other reason k-fold cross validation is not advisable for large data set is because, so when your data set is large, the training is going to take a long time, right? So in that case, k-fold cross validation is not a proper step, because like each iteration may take several hours for training that particular model, and we cannot train the model for 5 iterations if we don't have that much training time and so on. So it is a trade-off between the amount of time that you can spend and the data set and other things and so on. So it is a trade-off between time and the accuracy of the model. So that is what I would say. So if it is a small data set, then k-fold cross validation is actually a better idea. It's up to you. So if you have good amount of time, you can actually use k-fold cross validation in large data set itself. But it is, as I've told you, it's completely up to you, whichever you can use. But k-fold cross validation is always a better idea when we compare it to train test split. So this is one advantage when we use small data set. You can just think about the JEE example that I've told you, where the student will be tested on different questions from that particular chapter. So that is one example, and it is better for multi-class classification problem. Again, so let's say that there is some mathematics exam has been going on, and the subjects are, let's say, statistics and algebra. So if we just split it like train test split, there is a chance that all the data points in the test data set will contain algebra questions, and there will be a very small amount of statistics questions. So that is not as advisable, right? So in that case, again, k-fold cross validation is advisable. And as I've told you, there are different types of cross validation. So one is k-fold cross validation, and another widely used cross validation technique is stratified k-fold cross validation, in which the split of the data will be in the similar proportion. So let's say that we have two classes. One is person with diabetes, and the next class is person without diabetes. So the proportion of the classes in training data and the test data will be similar to the proportion of your classes in the original data set. Okay, so let's say that you have 750 data points for person with diabetes and 250 people without diabetes in a particular data set. So in this case, the proportion is 3:1 for the two classes, right? So when you use stratified k4, the proportion will be the same for training and the test data set itself, which is like more advisable. So your training data will contain 3:1 ratio of people with diabetes and people without diabetes data points, and again it will be the same for test data. So we can actually do that for train test split as well. So we know that we have this train test split function in skl1.model selection. So in that we can use an attribute called as a stratify, and in stratify we give that value as y. So I'll explain you in the next video about this stratify example in train test split, and if time permits I'll also explain you how a stratified k-fold function works in Python. So we'll look into it, but again it is better suited for multi-class classification when the data set is small. So it is more advisable compared to the train test split, and again it is more reliable. So instead of just giving one accuracy score, we can find the accuracy for different iterations and different splits of the data, and we can give the mean accuracy, which will be a more reliable value on this accuracy. And it is useful for model selection. As I've told you, instead of taking train test split and one accuracy score, we can use this k-fold cross validation to get a more reliable accuracy score, and we can select the model based on this particular mean accuracy score. So these are all some of the main advantages of k-fold cross validation, and in the next video we will try to understand how we can implement this in Python. We are discussing about the topics such as cross validation, hyperparameter tuning, and model evaluation. And in the previous video I explained you what is the theory and concept behind cross validation and k-fold cross validation, and in this video we are going to understand how we can implement this cross validation in Python. Okay, so this will be the agenda for today's video, and let's get started. So for this implementation of cross validation purpose, we are going to use the art disease dataset. So in my channel I have already made a video on this art disease prediction use case. So I'll give the link of that particular video in this video description. You can check that out if you haven't already watched that. Okay, so in this particular video I won't be going in detail about the data processing steps and other details. So if you want to learn that, you can watch that particular video. So the purpose of this video will be mainly on cross validation. Okay, so the first step is importing the necessary dependencies that we need. Okay, libraries. So first we are importing numpy, pandas, and so on, and then we are importing the train test split. So the two important functions that we need in this particular video are train test split and cross validation. So you can see this cross val score. So this stands for cross validation score. So we will understand what will be the output of this particular function, how to use it. But these are all the two important functions that we need: train test split and cross validation score. And then we have this accuracy. So and other thing is that if you haven't watched this k-fold cross validation video, please watch this video as well. I'll give the link for this video in this video description as well, so that you can understand the concepts clearly before going into the hands-on part. So these are all the dependencies that we are importing, and then we are importing four models. First is logistic regression, support vector machine classifier, k nearest neighbor classifier, and random forest classifier. So this is a classification data set where we want to predict whether a person will have heart disease or not. So this is a typical classification problem, and these are all the famous classification models that we are going to use. So you can also add another models, other classifications model if you want. So these are the two first steps. So first is importing the dependencies and importing the models that we need, and then we are just loading the data set into a pandas data frame, and we are naming this as art data. So you can see the first 5 rows of this data set and all the columns. So I'm not going to explain what these columns represent. As I've told you, you can watch that art disease prediction video if you want. Okay, and we are checking the shape of this data set, and we can see that this data set is pretty small, which has 303 rows and 14 columns. Okay, and we are checking whether there are any missing values, and we can see that there are no missing values, and we are seeing how many values are there for the label 1 and label 0. Here label 1 means people having defective art, and 0 means people having healthy art, so they don't face any art disease issue or something like that. So here the split is almost equal. So you can see here, so the split is almost equal, like it's almost 1:1. So there is more data points for the label 1, but it is not that much imbalance. So this is kind of a balanced data set. Okay, and the next important step is to split this features and targets. So features will be from this age column to this last before column will be the feature. So if you give all these values, the model can predict the target. So the target value will be either 1 or 0. As I've told you, 1 represents defective art and 0 represents people with healthy art. So we have to split this features and the final column, which is target, which we have done here. Okay, so we have done all these things in the previous video itself, and you can find a deeper explanation on that particular video. So in X, we are storing all the features, all the columns except the target column, and we are storing this target column in Y. So we have to feed this X and Y to our model. So you can see what this X contains. So this X doesn't contains the target column, whereas Y contains only the target column. So the next step is the most important and the basic things that we do in any machine learning or data science use cases, which is to split the data set into training data and test data. So I'm sure that most of you know the reason for this. If you don't know what this means, we usually train the machine learning model with the training data, and we will evaluate. So evaluate means we are checking the accuracy, the performance of the model by testing it on the test data, and this is the reason for splitting this data into training data and test data. Okay, so this is why we have imported the function called as train test split. Okay, and this is imported from sklearn.model selections. So first, let's try to understand this train test split. After that, we can move on to the cross validation score, because both of these are related. So you will understand that better if you understand this train test split. So we need to create 4 arrays when we are using the train test split function. So these arrays will be x train, x test, and y train, y test. So these are all the 4 arrays that we need, and I'm going to use the train test split function. So train test split, and within this we need to mention certain parameters. So we are going to mention x, y, and test size. So I'm going to give the test size as 0.2. Okay, so I'll explain you what all these things means, and the next thing will be stratify. So stratify is equal to y, and finally random state is equal to 3. Okay, so let's run this. So now let's try to understand what we are doing here. As I've told you, so this x and y is our entire data set, and we are going to split this x and y into training data and test data. So you can say this x train. So what happens is, like, you can see this test size is equal to 0.2. So what this means is we are going to split the data into 80% of the data and 20% of the data. So this larger data, like larger proportion, which is 80% of the data, will be taken as the training data, and the 20% of the data will be taken as the test data. So I'll just change this. So there is a error here. Okay, so we usually take 10% or 20% of the data as test data, and the remaining data will be a training data. So you can see this x train. So x train will be the training data. So 80% of the training data, which contain only the features. So this x will be split into an array which contains 80% of this entire things, and the corresponding label. So you can see the y here. So the corresponding y values will be stored in this y train. Okay, so you can just link this x train and y train. So x train contains all the features for the training data, and y train contains all the corresponding target, which is either 1 or 0. And the remaining 20% of the features will go to the x test. So features is nothing but this particular array. So we'll go to this x test, and the corresponding label will go to y test. Okay, so these are all the 4 arrays we are creating, and we are using this train test split function. So the attributes or parameters that we use in this functions are x and y. So x is my entire feature data frame, and y is my target column. So you need to give this x and y, and the test size. So as I've told you, test size is what is the size of the test data that you want. And then we have this stratify. So stratify is a very important thing that you need to mention in this train test split. So you can see this split. So we can see that 165 data points are there for the label 1, and 130 data points are there for the label 0, right? So when you don't mention this stratify, so what happens is the split won't be proper. So the reason for using the stratify is to have the same proportion of the two labels in your training data and test data. So I'll try to explain this in a better way. So we can see that let's consider that the split of the labels is almost similar. So it's 165, 138. So let's say that the proportion is 1:1. So almost it's 1:1 for the label 1 and 0. So when you don't use stratify, so there is a chance that most of the data points with label 1 will go to the training data, and all the data points with label 0 may go to the test data. So in order to avoid that, in order to have correct proportion which is similar to the entire data set, so we need to mention stratify. So it will stratify the entire data based on its classes, and it will create a similar proportion in both test data and testing data as well. So let's say that let's say that there are about 500 data points for the label 1, and there are only 100 data points for the label 0. So in this case, the split of this labels is 5 is to 1, right? So for 5 data points with label 1, we have only one data point with label 0. So in that case, if you use stratify, what happens is that the training data will also contain the same the proportion. So in the training data there will be 5 is to 1 split of this label 1 and 0, and it will be the same in the test data as well. So stratify is like very important. And then random state. So I hope everyone knows what is the purpose of using this random state. So like let's say that I'm splitting my data in some specific way. So if you don't mention this random state, let's say that you are also splitting the same data set using the train test split. If you don't mention the random state, your data will be splitted in a different manner and my data will be splitted in a different manner. So we will have different data points within our training data and test data. Whereas let's say that I'm mentioning this random state is equal to 3 and you are also mentioning random state is equal to 3. So in that case, your data and my data will be splitted in the same way. So this is just to reproduce the code, and that is the reason why I mentioned random state is equal to 3. I'll explain in the other step why I mentioned this. So there is a reason for this. So wait for it. Okay. So let's run this. So we have successfully run this particular cell, and then we can try to print xtrain shape. So xtrain dot shape. So we will know how many data points are there. So first let's print x shape. So x shape, xtrain shape, and finally let's check what is the size of x test dot shape. Okay. So you can see that there are the original x is nothing but our original data set without the target column. So it contains 303 rows and 13 columns. Okay, so you can see the 303 rows here. So this contains 303 rows and 13 columns. So xtrain contains 80% of this data points. So 80% of 303 will be 242. So xtrain contains 242 data points and xtest will contain 61 data points. So we will use this xtrain in order to train our model, and this xtest to evaluate our model. So this is the reason for splitting this. And as you can see here, we have 4 models. Okay, so what you can do is, so the one thing is you can train all these models separately and you can evaluate these models separately. So that's one way of doing that, but let's not do that because it is it is a long process. So instead of that, we are going to automate this process where we will create a function that will train all these models individually. So the work will be pretty simple. Okay, so we use the same method in our machine learning challenge. So I have mentioned that in the machine learning challenge solution video. So we are going to use the same method. So this part will be comparing the performance of the models. Okay, so this is completely based on this train test split. So after completing this train test split method, we will be using the cross validation method, which is very important. Okay, so but before going to that, we need to be very clear with this train test split. So here I'm going to create a list of models. So all the models that we are importing. Okay, so you can see the models that we have are logistic regression, support vector, k nearest, and random forest classifier. Okay, so I'm going to create a list, and let's name this list as models. So models is equal to logistic regression as my first model, and so you need to mention this parenthesis. So this is nothing but one instance of this logistic regression model, and I'm going to call svc, which is support vector classifier, and for kernel I'm going to use linear kernel. Okay, so linear, and the next model, sorry, so it should be svc. Okay, yeah, support vector classifier, and the next model will be my k nearest neighbor. So k nearest neighbor. So the reason we are taking all this model is that we are going to see which model okay, so it shouldn't be k nearest, it's k neighbors classified. So the reason we are using this is we are going to compare the accuracy score for all this model. So k neighbors classifier, and then the last model will be random forest classifier. Okay, so these are all the four models that we are taking. So I'll run this particular cell. So there is a list called as model, and it contains a list of models that we are going to compare. And now we are going to create a function, and let's call this function as compare models. And this will be based on the train test split function. So train test. So let's name this function like this: compare models train test split. Okay, so I'm going to create a for loop here in order to train all these models individually. For model in models, okay, so for model in models, we are going to fit the models first. So model dot fit x train and y train. Okay, so I'll explain you what this means just a second, and then this data prediction. So text data prediction will be model dot predict. So and in this we need to give x test, and then the next step. So let me just give a space here. Accuracy is equal to accuracy score of y test and test data prediction. And finally, let's print the accuracy of the models. Print accuracy score of the model. So this will be equal to. So I'll explain you all these things just a minute. So the accuracy will be. Okay, so this is our function. So let's try to understand what we are doing here. So as I told you, we need to train all these models individually. So we are going to train it using the training data that we have, which is X train and Y train. So once we train this, we need to evaluate it with this X test, and for evaluation, we will use this Y test. So we are creating this function called as compare models train test split, and we are using a for loop. So when the for loop runs for the first time, so you can see here. So for model in models, so models is nothing but the list that we have created, which contain all the classifiers that we have. Okay, so when this for loop runs for the first time, this variable model will take the value as logistic regression when it runs for the first time. And when you consider that this model is substituted by logistic regression. So here we are fitting the logistic regression model with our training data, which is X train and Y train. So once we fit this data, we are going to calculate the accuracy score. So for that, we need to predict the values. So here you can see that we are giving both X train and Y train. In this case, we are predicting the labels for this X test. So this will be our test data, and this part of the code will be evaluating the model. So this model.fit will be so this model.fit, the purpose of this will be training the model, and the purpose for this test data prediction will be for evaluating the model. So I'll make this comment so that you understand this clearly. Evaluating the model. So this particular line model.fit is for training the model, and then we are going to evaluate this model using the accuracy score. So if you remember, we have imported this accuracy score from this sklearn.metrics. So you can see here. So accuracy score, Y test and test data prediction. So the test data prediction is nothing but the values predicted by your model. So you can see here, so test data prediction is given by this particular line, which is nothing but model.predict. So once this model is trained on this data, so this is training, and once it is trained on the data, the model can predict the labels for this test data. So we are giving this X test. So models predictions will be stored in this variable called as test data prediction, and now we need to compare that with Y test. Y test is nothing but our original labels, our true labels, whereas Y test is the predicted label. So we are comparing the true labels and the predicted labels, and finally we are printing the accuracy score of each model. So when this particular for loop runs for the first time, this model takes logistic regression and all the steps will be completed. And when the for loop runs for the second time, this model takes the value as SVC, so subprotector machine classifier will be trained, and so on. So this model will for loop will run 4 times, and each time a particular model will be trained. So let's run this particular cell, and let's call this function, which is compare models train test split. Okay, so I'll call this function, and we will get the output as You can see here. So accuracy score of logistic regression, supported conversion classifier, and all the models are there. So there is some error. So you can see here. So convergence warning. So logistic regression failed to converge status. So number of iteration reached limit. So the reason we are getting this error is if you see the data set, our data set is not standardized. So as you can see here, few columns have the values as 1 and 0, few columns as are labels, and few columns have the values in the range of 150s, few have 250s, and so on. So we haven't standardized our data set. So the reason I didn't standardize this data set is that it also contains categorical columns. So you can see the column called as sex. So it will contain the values as either 1 or 0, which basically means male or female. So we cannot apply the standard scalars on categorical columns, so that will be a mistake. So we should not standardize this columns as well. So what you can do is you can take the column such as age, this particular column, cholesterol column, and so on. So all this column, and you can standardize them separately, and after that you can add this with the categorical columns. Here the categorical columns will be sex. So this particular column, this and this. So 0 and 1 will be the categorical column. So you can take all those columns. So you shouldn't standardize those columns. So this age can be standardized, this column should be standardized, this one and this one. So these columns can be standardized. After that you can just combine those columns. So you can do that by yourselves. As I've told you, the reason for this particular video is to understand cross validation. So we are not going into detail about that particular issue, and you can in order to remove this particular warning, you can increase the number of iterations for this logistic regression. So you can just see the suggestions here. So you can either increase the number of iteration or scale the data. So in this case, let's increase the maximum iter, which is given by max iter in this logistic regression. So the default value for this max iter is 100 iterations, and in this case, let's use 1000. If you use anything less than this, this warning will come. Okay, so it doesn't mean that this model will go through the data 1000 times. So it will go through the data until it reaches this convergence point. So convergence point is nothing but you have optimum parameters for your model. Okay, so it will probably reach before this maximum iteration. Okay, so let's run this again, and now let's train this models and compare the accuracy. Now you won't get this model. So this is our final accuracy score. So you can see all the accuracies. So logistic regression has about 77% accuracy, and support vector machine also has the same accuracy. So k nearest neighbor has a bit, it has the minimum of accuracy compared to the 4 models, and random forest classifier seems to have the highest accuracy among these 4 models, right? Okay, so this is the reason we are comparing these models is that, so this process is called as model selection, where we compare which model performs best for this particular data set. Okay, so there are also other things we use in this model selection, say for example hyperparameter tuning and all that. So we will discuss those things later, but for now we are just comparing the models with the default parameters and so on. So you can see that in this case random forest classifier has the highest accuracy, so you can just mention it as an inference. Now we need to understand what is the problem, or what is the disadvantage while using a train test bed. Okay, so just a second. Okay, so as I've told you, right, there is a reason why I used random state value as 3. So if you change this random state value, let's say that we are changing this random state value is equal to 0. So in that case, the split of the data will be different. So it won't be splitted in the same way as this particular data is splitted. So it will contain different data points for training data and test data. So in that case, you may get higher accuracies. So if what I'm saying is, like, for different values of random state, the accuracy may change. So you cannot choose a random state that has higher accuracy. So we cannot do that. Okay, so the reason is the problem with this is, like, this particular data set is very small. So you can see for training we have 240 data points, and for testing we just have only 61 data points, right? So this data point doesn't contains the entire pattern that the original data set contains. So we are just testing it with only 61 data points, and this is why this is not a good method in order to split the data set. So this is why what I have mentioned in this particular theory video. So you can see here. So in this case, our model is not being evaluated on a large proportion of the data set. So this accuracy score is not that much reliable. So this is where cross validation is very helpful, where in cross validation we will split our data set into different folds, or you can call this as chunks. So each time you will have different test data, and your model will be tested on different test data. So this is how cross validation works, and for this purpose we are going to use the cross val score. So you can see this function here. Okay, so And another thing is that so this is the function that we are going to use, which is cross-val score, which is present in this sklearn library model selection module. And there are also other functions like k-fold and stratified k-fold. So again, so all these things works in the same way. The only difference is that when you use this k-fold, this is used only to split your data set into training data and test data like this, different chunks. So this is what the k-fold function does. So once you split this data, you need to again write some code in order to find the accuracy for all this iteration, and you need to write code in order to find the mean accuracy score and so on. So instead of doing this, if we use cross-val score, it will split the data set into training data and test data. It will do the evaluation things as well. So if you see this train test split, so what we have done is we have splitted our data into training data and test data, and then we have written some code in order to test our data, train our data and test our data, right? So instead of doing all these things, we can do all this in a single function called as cross-val score, which will create all this cross validation folds, and it will also calculate the accuracy for each folds of data. Okay, so that is the advantage of using this cross-val score. So if you want to use this k-fold, you can again use it. It is the same procedure, but you need to write code for training your model, testing your model separately. And stratified k-fold is like similar to the stratify parameter that I've explained you. So when you use this stratified k-fold, the proportion of the classes will be similar in your training data and test data, which will be the similar to the original data that you have. So stratified k-fold is always a good thing to use when we compare it to the k-fold. So in this case, we are going to use the cross-val score because it is more easier and effective compared to k-fold, because we don't need to train our data separately and so on. Okay, so I'm going to use this cross-val score. You can also try this k-fold and stratified k-fold if you want. Okay, so this part will be cross validation. So I'll make a text here as cross validation. So this will be the important part of this particular video. So I'll just block all these letters. Okay, and now I'm going to create a section. So if you include an hash before this, it will create a section. I'll just create a section here as well for this train test split. So just include a hash, and you can just enclose all the cells within this. Okay, so this particular section will contain all the codes that we have done before, and all the cross validation codes will be stored in this particular section. Okay, so now we are going to use the cross val score function. So this is very important that we have imported from this model selection. Again, we are going to train all this model and compare the accuracies. Okay, so as I've told you, this is more reliable than train test split because we are evaluating the model with different folds of the data set. So I'll create a variable called as CV score. So CV stands for cross validation, LR. Okay, so LR is nothing but logistic regression. So first let's try to use the models or train the models separately, and after that we will use create a function like this. So first we will train the model separately and evaluate it. After that, we can create a function like this in order to automate this particular process. Okay, so cross validation. So first is using the logistic regression model. So LR stands for logistic regression. So here we are going to use the function cross val score, and there are certain parameters that you need to mention. So the first parameter that you should mention is your the model that you are going to use. So in this case, we are going to use the logistic regression model. Again, mention this maximum iter is equal to 1000. So you can also try to standardize the data as I've told you. So that is a more efficient, or it is the correct way to do this particular project. So you can also try that. So logistic regression, I'm going to give max iter is equal to 1000. Okay, and the second parameter. So the first parameter that we are using within this cross val score is the logistic regression. You can also check out this documentation of cross validation. So just go to Google and search sklearn cross val score. So you will find this documentation. So you can see all the parameters that you need to include. So logistic regression, maximum iteration. So first thing is representing your model, and then we need to mention x and y. Okay, so x and y, and next parameter is equal to CV is equal to 5. So x and y will be your entire training data, x and y. So you are not going to use this x train x test, because like you can use either train test split or cross validation. It's not like we are going to use both. So we are going to use cross validation as an alternative to this train test split. Okay, so we are not going to use this extra and extras and so on. We are going to use the entire data set. So this cross val score function will do all the work. So it will split the data into different training data and test data, and all the things will be carried out. So the first parameter is your model, the second parameter is your x, third parameter is your y. So x is nothing but our features, y is our target, and cv is equal to 5. So what this basically means is, as you can see here in this case, so we have an entire data set. So you can see here, so we have an entire data set, and this entire data set is split into 5 folds. So fold is nothing but different chunks of data. So 5 folds of data is split. When the model is trained for the first time, we are taking this fifth fold or fifth subset of data as our test data, and the remaining 4 will be our training data. And the second time, the fourth set of data will be our test data, and so on. So this process will be continued, right? So we are having some value for this k, right? So this is nothing but how many folds of data or how many subset of data do you want. So when I mention k is equal to 5, my entire data will be split into 5 subsets. So if you mention k is equal to 10, in that case it will be split into 10 folds. So in this case, let us say that I want to split my data into 5 folds, and this is why I'm mentioning cv is equal to 5. So if you go there, so you can see that int so determines the cross validation, and that is a thing. Okay, so for int or none inputs, if the estimator is a classifier and y is either binary or multiplied, stratified k fold is used. So what this basically means is, if you mention the cv value is equal to 5, it automatically uses the stratified k-fold method. So as I've told you, when you use stratified k-fold, your class distribution will be even, which is similar to your entire data set and training data and test data, which is very important. Okay, so in order to use this stratified k-fold, you can just mention some integer values for this cv. So you can also again use this k-fold. When you use only this k-fold, your data won't be stratified, and again, that is not a good way of doing your code. So you should always use stratified method. So when we mention cv is equal to 5, this cross val score assumes that we want to use a stratified k-fold. So this is like everything that you need to do. So just mention the model that we are going to use, mention x and y, and mention cv. So what is your cv value? So whether you want to have 5 folds. When you have 5 folds, your model will be trained for 5 iterations. When you have 10 fold, your model will be trained for 10 iterations. Okay, so this is all you need to mention. So the model will actually do stratified k-fold instead of a normal k-fold. So that is what is represented here. Okay, so this will calculate our cross validation score, and let's try to run this and print this cv score. Okay, so print cv score lr. So cv score lr is nothing but the cross validation score for our logistic regression model. Okay, so I'll print this. So you can see, so we have 5 accuracy values. So this is the first accuracy value, this is the second one, third, fourth, and fifth. So your data will be split into 5 splits, and each split will contain different test data. Okay, so for first iteration, so this is our first iteration. So in this case, the first iteration value is an accuracy of 88, right? So this is some random value that I've used. So first iteration accuracy, second iteration accuracy, and so on. So you got accuracy for 5 iterations. Okay, so 80, like 0.80 is nothing but 80%, 0.86 is nothing but 86%, and so on. So we can just understand that. And this is our cross validation score. And what we have to do now is, we should take all these values and take the average of it or mean of it. So just if you have 5 accuracies, add all the values and divide it by 5. If you have 10 iterations, if you have 10 accuracies, again add it and divide it by 10. So we are going to just take the mean accuracies, and that will be the next step. So what I'll do is, so I'll just add this here itself. So cv score, so I'll just remove this and paste it here. So print cv score lr, and I want to find the mean accuracy. What is my mean accuracy lr? And this is equal to sum of cv score lr, and this should be divided by length of lr. So I'll tell you what I'm doing here. Okay, and then mean accuracy lr is equal to this into 100, and again this is equal to round off Mart 2, and Now we want to print our final mean accuracy. So let's try to understand what we are doing here. So we know that when we run this cross-val score, we will get a list that will contain 5 accuracies because we are taking 5 folds, right? So this will print that particular list which contain those 5 accuracies. Now we need to take the average of all these accuracies, right? So that is why that is what we are doing here. So I'm creating a variable called as mean accuracy, and I'm going to add all the values and divide it by the total length. So you can see here sum of CV score LR and divided by length. So this is just this particular step. So when you use this sum of CV score LR, so all the accuracy values will be added, and when you use length of a CV score LR, so this will just tell you how many values are there. So if you can see here, so yeah, so the length of this particular CV score will be 5 because it gives us 5 accuracy score. So this is just nothing but finding the mean accuracy value. I hope you understand this particular thing. And as we have seen, the value will be in the range of like 0.80, 0.86 and so on, right? So let's say that I wanted to convert it into percentage, so that's why I'm multiplying it with 100. So I'm taking this particular value and I'm multiplying it with 100 in order to convert this into percentage value. So instead of having 0.80 or something, we are going to take 80 percentage, 81 percentage and so on. And finally we are rounding off. So because like this will contain a lot of decimal places, so 6 or 7 decimal places will be there. Let's say that we want only 2 decimal places, and for this you can use this inbuilt function in Python called as round. So it will round your particular number into, you can see here, so round a number to a given precision in decimal digits. So if you mention this instead of 2, if you mention 3, you will get 3 decimal places. 4 means 4 decimal places and so on. Okay, so let me run this and see what is the result I'm getting. Okay, so this is the final result. So I'll remove this cell. So you can see here. So I'm printing my CVs for LR first. So this is the list. And once I get this list, I'm finding the average value for all these 5 values. So for that purpose, I'm adding all the values and dividing it with the number of values that you have, which is nothing but 5 in this case. After that, I'm multiplying it with 100 so that all the values in this range are converted into percentage, and I'm rounding up. So you can see the number of decimal places we have here. So let's say that I want only 2 decimal places, and that is what we are doing here. So now you can see the final value, which is 82.83, which is, instead of being in this range, it is in the percentage range, and it has 2 decimal places. If you want 1 decimal place, you can just use 1. So this is the cross validation for logistic regression. So when we use train test split, as I've told you before, we just got only one accuracy, right? So in this case the accuracy is 77%, but we cannot use this as a reliable metric because the model is not tested on different chunks of data. The model has been tested on only a small proportion of the data. So cross validation is a better aspect because we are testing on 5 different folds, and we are taking the accuracy for 5 different folds. So in this case, you can see here, for the first iteration the accuracy score is 80, for second it is 86. So there is a huge difference between them. So about 6% of difference is there, right? So in this case, also like there is a change in all these values. So the last one has the minimum accuracy, which is 75. So all these 5 accuracy values will be taken into account, and all this will be averaged, or we will be taking a mean in order to get a more reliable. So this will be a more reliable accuracy score for this logistic regression model. Okay, so I'll just copy all these things, and now I'll just use the support vector machine classifier. Okay, so support vector classifier, and I'll just paste this, and I'll just change this to SVC. Okay, so this is for cross validation of logistic regression, and this one is for support vector machine. And let me copy this and paste all these things. So this will be mean accuracy of support vector machine classifier, SVC. Okay, so I'm just replacing. So the procedure is same. We are just changing the model. So SVC. Okay. So here we need to change this logistic regression to support vector classifier. So I just remove that. So all the other things will be the same. So SVC, and for kernel we are going to use linear kernel. So kernel is equal to linear. Okay, so let's run this. Well, let me check once whether everything is correct. Okay, mean accuracy. So let's run this and see what is the accuracy for this particular case. So you can see here, so you can see the accuracy score for, in this case, you can just compare it with logistic regression. But when you take average, both logistic regression model and support vector, it kind of have similar accuracies. Okay, so you can, what you can do is, so by this same method, you can do this cross validation for all the other models, so k nearest neighbors and random forest classifier. So if you want, you can also include other classifier models as well. That is completely up to you. So I'm just showing this for 4 models. So what I would suggest is, so I'm just shown you how you can do this for logistic regression and support vector. So you just copy all this code and find the cross validation metrics for k nearest neighbor and random forest classifier. Okay, so that is what I'm giving you as an assignment or something now. So instead of doing this separately, so you can see here, so we are like we are doing this in individual steps, right? So instead of that, we are going to create a function that will automate this step. So like this particular thing where we have used a function in order to compare the models in a single line of code, single function, and so on. So we are going to create a function like that. Okay, so this function is for train test split. Okay, and this will be for cross validation. So this will be very useful for you. This particular code template will be very useful for you. You can just save it and you can use that for some other use cases you are working on. So okay, so this will be creating a function to compare the models. So here also we need to create the list of models. So it will be actually the same. So it will be the same. So I just copy this and paste it here. So actually you don't have to do this because we have already created a list. But if you just see this collab file, you may not understand why I'm doing this. So that's why I'm just creating the list of models. So it is nothing but the same step that we are doing here. So you don't actually need to do that, but I'm just doing this for to understand the continuity of what we are doing. Okay, so this will create a list called as models, and this models list will contain the 4 models: logistic regression, support vector classifier, k neighbors, and random forest classifier. And now let's create a function and let's name this function as compare models cross validation. So this will be compared based on the cross validation score, whereas the first function that we created compares the model based on the train test split. Okay, so let's do that. So first, so we are not going to do anything different. So we are just going to include all these things, but just in a slightly different manner. Okay, so again we need to create a for loop. So for model in models, so when the for loop runs for the first time, it will take this logistic regression as its first model and so on. So CV score. So CV score is equal to cross validation score. And this cross validation, so we don't need to mention logistic regression or support vector machine. You can just use this model. So this model is nothing but the variable that we are initiating in this for loop. Okay, so model and other things will be the same, x and y and CV. So you can also change the CV value to 3 or 6, anything you want. So you can just do that for different CV values and you can check that. Okay, and we are going to find the mean accuracy. So it is just the same thing. It's similar to what we have done here. Okay, so I'll just copy this and paste it here. So I'll just name this as mean accuracy. Let me just give a space here. So mean accuracy is equal to CV score. Okay, and then it will be, the next step will be to convert the values in percentage. So CV score, and let's change this. The next step will be to round off the values to 2 decimal values. So you can round off this to 1 decimal values or any number you want. So that is completely up to you. So I'll mention 2 decimal values here. So mean accuracy, and finally we are going to print this mean accuracy. So yeah, let's print 2 things: cross validation accuracies for the model. Okay, cross validation accuracies for the model will be equal to CV score. So this particular value, CV score, will be my first thing. And next I'm printing The accuracy is as accuracy percentage of the model. So why I'm using this model is that, so I want this to be replaced by the model we are using. So when you run this for the first time, this will take the value as logistic regression. So how the final print statement will be like cross validation accuracies for the logistic regression model and so on. Okay, so let me remove this. So that is the reason we are using this model and so on. So this is pretty simple, and here we will mention the mean accuracy value. Okay, so mean accuracy, and I'm just going to use some dotted lines so you will understand why we are using them. Just give it a minute. Okay, so let me check whether everything is correct. So for model in models, CV score is equal to cross val score model x5, CV score length, mean accuracies. Okay, I think everything is proper. So let me run this. So once we complete this, let's call this function. So this may take some time because each model has been trained for 5 times. So this may take some time. So I'm not sure about it. Let's see. Okay. So what happens is, so you can see the values here. So for the first time, the logistic regression model is trained. So this is the cross validation accuracies. So you can see the 5 values here. So cross validation accuracies for logistic regression is this, and the average accuracy percentage for logistic regression is 82.83. And the second time the for loop runs, it will train the support vector machine classifier. So you can see the support vector machine classifier values and cross validation accuracies for k nearest neighbors, and finally random forest. So this will be a more reliable way of testing the model, because we are not testing the model for only one time. So in this case, we are testing the model 5 times, and we are taking the mean values as the final accuracy. So if you just compare this with the train test bed, there may not be that much change in the values, but like what I would suggest is like this won't happen in all the cases when you are working with a large data set, or if your data set is complex or something, if your data set contains different patterns and so on. In that case, cross validation is actually a very good method. So I would suggest you in order to use cross validation method, which is like very effective and so on. Okay, so you can see that logistic regression model has been printed because that's what we have done here. So this is just simple print statement. So let's try to understand what this particular function does. So when this for loop runs for the first time, this model will take the value as logistic regression. Okay, and the cross validation score will be carried out, and this model will take the logistic regression value, and this particular thing. So this will takes place. Okay, so what we have done here, but this will take in a for loop. So we are just finding the cross validation accuracies, which is this particular list which contains 5 values. And once we do that, we are finding the mean of all these values. And once we find that, we are multiplying it with 100 in order to convert it to percentage, and we are rounding it so that we have only 2 decimal values. And finally, we are printing both this list and the final mean accuracy value. So it is just like printing all the 5 accuracy value and then printing the average accuracy value. So that is what doing it. In order to have just like if you don't include this dotted line, so it may just look very concise. So that's why I've mentioned this dotted line, so that you can see the output separately. Okay, so the first part of the output is for logistic regression, support part of like second part of the output is for support vector machine, and then k nearest neighbor and random forest. So instead of writing the codes individually like this for logistic regression and support vector machine and so on, you can just create a simple function like this, which will give you output like that, and you can compare the accuracies here. Okay, so this is a very good implementation for model selection. So what I would suggest is like please understand this code thoroughly, and you can use this particular function for the different use cases that you are working on. So instead of training all the models separately, you can use this function as a very consolidated and as an effective method. Okay, so I hope everyone understood this videos completely. So this is a very important concepts in machine learning and data science. So please try all the codes. So what I would suggest you is that please try different data sets. So don't try the RDSS data set. Please try different data sets so that you can understand this in a better way. So this is one useful method for model selection. So you can just see how to select the models with higher accuracies and so on. So after that, after this, the next video will be on hyperparameter tuning, where so in this case we are just considered model. So here in the next video what we will do is we will consider different parameter values for different models, and we will see which hyperparameters are the best one. So we will discuss that in detail about the next video, and I hope everyone understood this video completely. Here we are discussing about the topics such as cross validation, hyperparameter tuning, model selection, and model evaluation. And in today's video, we will be discussing about one of the important concepts in machine learning, which is hyperparameter tuning. In hyperparameter tuning, we have two types, which are grid search CV and randomized search CV. So in this video, first of all, let's try to understand what are all the different types of parameters that we have in machine learning and what is meant by this hyperparameter tuning. Finally, we will discuss what is meant by this grid search CV and randomized search CV. So this is a conceptual video, and once we understand the basis and the concepts behind these terms, in the next video, we will move on to the hands-on part, where we will try to implement grid search CV and randomized search CV in Python. Okay, so this will be the agenda for today's video, and let's get started. So we have discussed this before in my channel about the different types of parameters that we have in machine learning, and I would like to recap about this particular topic. So in machine learning, we often deal with two types of parameters. Okay, so one type of parameter is called as the model parameters, and the other type is the hyperparameters. So let's try to understand each of these types of parameters with their definitions. So model parameters are those parameters of the model that can be determined by training with the training data, and these can be considered as internal parameters. Okay, so we know that in machine learning, we often deal with data and we have some models. So you can think about the models like logistic regression, supported machines, or k nearest neighbor, and we feed the data to the model. Okay. And what does this model try to do is it will try to find the most optimum parameters. So these parameters that are determined by the model using the data are called as the model parameters. So once we carry out this training process, the model will try to find the best parameters. So examples of these model parameters are weights and bias. Okay, so if you consider a linear regression model, so we have the equations as y is equal to wx plus b, where y is my dependent variable. Okay, or you can call this as the target, and x is my independent variable. So if we consider an example, let's say that we want to determine what is the salary a person can make depending on his years of work experience. Okay, so in that case, y will be the salary that we are going to predict, and x will be the number of years of experience. Okay, and we know that the equation of the line is given by y is equal to mx plus b, and here w is similar to the slope. So we know that we represent slope as m, right, and intercept as c. So instead of that, we can write as w and b. So w represents your weight, which is similar to your slope of a line, and b represents your bias, which is again similar to the intercept of a line. So this w and b will be your model parameters. Okay, so we initiate with random weight value and bias value, and once the model is fed with the data, it will try to find which is the best parameter value for this w and b. So these set of parameters are called as the model parameters, and there are other set of parameters called as hyperparameters. So hyperparameters are the parameters whose values control the learning process. These are adjustable parameters used to obtain an optimal model. So, and these parameters are also called as external parameters. So let's try to understand this hyperparameters. As I've told you, these set of parameters, weights and bias, which we call as model parameters, are determined, or these values are derived based on the data set that we have. But the hyperparameters is something that we give to the model. So this hyperparameter determines how your model is going to perform. Okay, so this set of values are determined by working on the data set, whereas this is given to the model, and these parameters dictates how a model is going to train from that particular data set. So hence we call these as external parameters, because we can control these parameters. Okay, so you can change the values of hyperparameters, but you cannot do it directly when it comes to the weights and bias, which we call as model parameters, because the model tries to find the best parameters on its own, whereas we control the hyperparameters. Okay, and the examples of hyperparameters are learning rate, number of epochs, and n estimator. So these are few examples. Again, there are a lot more examples of hyperparameters. So learning rate is nothing but how much do you want to change your weight and bias. So if you have seen my gradient descent videos before, so in that we have seen that when a model is training on a data set, what it will try to do is initially it will randomly assign some values to this weight and bias. So we usually initiate with value as 0. So after that, it will try to improve the performance of the model. So in other words, it will try to minimize the loss function or the cost function, and in each step it will try to change the value of weight and bias and again calculate the loss function and loss function for that particular weight and bias. So in this case, the learning rate determines how much change do you want to give to your weight value and bias value. So this is your learning rate. So if you don't understand this, I'll give the link for my gradient descent video. So please watch that. It will give you a better understanding. Okay. So that is an example of learning rate. And then we have number of epochs. So you can also call this as number of iterations. So this determines how many times your model is going to go through your data. So if you represent this number of iterations as 100, it means your model will go through the data 100 different times. So you can give it as 1000 or whatever you want. So it all depends on how efficient you want your model to be. And when it comes to a random forest model, there is an hyperparameter called as n estimator. So n estimator is nothing but the number of decision trees that you want in your random forest. So I hope you know that random forest is nothing but it is an ensemble models where we have several number of decision trees. Okay, so it is a group of decision trees, and this n estimator is nothing but the number of decision trees we want in our random forest model. Okay, so these are the two set of parameters. One is the model parameters, and the other set of parameters is your hyperparameters. And the most important thing that you need to remember is that model parameters are derived by the machine learning model by going through the data, by understanding the data, whereas this hyperparameters is going to determine how your model is going to train. Okay, so these set of parameters we can change depending on our requirement. Okay, so when we talk about machine learning, these are the two main steps. One is the hyperparameter tuning, and the next one is the model training. So when we talk about hyperparameter tuning, we try to find or we try to set the optimum value for the hyperparameters. As we have discussed before, the hyperparameters such as number of iterations and we have the number of epochs in estimators, etc., right? So we will try to set optimum values is nothing but for that particular set of hyperparameters you will get the highest accuracy or highest efficiency for that particular machine learning model. And model training, so model training is in this case we may implement algorithms like gradient descent, which is an optimization algorithm that will try to give you the optimum weight value, bias value, and other model parameters value. So the main important task in machine learning is to carry out these two steps so that we can get the best hyperparameters and the best model parameters. And the reason for doing both these things is to get the highest accuracy or to get the highest efficiency when we work on machine learning. Okay, so as I've told before, in hyperparameter tuning we have two main important techniques. So we will try to understand about these two main important techniques, which are grid search CV and randomized search CV. Okay, so before moving on to that part, I'll just give you a quick definition on what is meant by this hyperparameter tuning. So hyperparameter tuning refers to the process of choosing the optimum set of hyperparameters for a machine learning model. This process is also called as hyperparameter optimization. I hope now you understand the definition of this hyperparameter tuning, as we have discussed this before in the previous slides. Okay, so what we are doing is we are just tuning the hyperparameter values so that we can get the optimum set of values. Optimum set in the sense we are going to get highest accuracy for our machine learning model. So it's not like we are going to do this for only specific models. So it's not like that. We will do this for all the machine learning models that we will work on. Okay, and this you can also call this as hyperparameter optimization, because we are just optimizing the process of training the machine learning model by these set of parameters. And again, there are two types of hyperparameter tuning. One is grid search CV and the another one is randomized search CV. Okay, so when we say grid search CV, what we will do is, so when we have a machine learning model, when we take a machine learning model, there are different hyperparameters that we need to work on. Okay, and there can be different possibilities, different values that a hyperparameter can take. So when we use a grid search, use a grid search CV technique, we will try to use all those values. So we will, in each time we will try to check that particular hyperparameter value and see which value is giving us the highest accuracy. And in the randomized search CV, instead of calculating the performance of the model for different combinations of hyperparameters, we will randomly select only few parameters and then we will try to find which is the best value. Okay, so here blue color dots represents the best value and the green color dots represents the different hyperparameters values which we can choose from. So if you don't understand this, it's completely fine. I'll just give you an example. Now you will be able to understand this clearly. Let's take an example of a support vector machine classifier. Okay, so we know that this is a very important classification model that we will work on in machine learning. So examples of hyperparameters for support vector machine classifier includes C value and kernels. Okay, so C is nothing but what is the penalty that you're setting for your model. So if your C value is very high, that means your model doesn't allow any misclassifications. Okay, whereas if your C value is very low, that means like your model allows some misclassification to occur. So this is the importance of C value. So I value of C means no misclassifications are allowed for the 2 classes or 3 classes that you're working on, whereas low value means you can have misclassifications. Okay, and kernel is we have discussed about this in our support vector machine classifier. So we have built the support vector machine classifier from scratch. So in that thing I have explained you how this linear polynomial kernels everything works. So I'll also link that video as well in this video description. You can check that out. Okay, so these are all different possible values that you can have for your C and kernel. Okay, so now let's try to understand this grid search CV and randomized search CV based on this support vector machine classifier. Okay, so in this case we have 3 set of values, right? So what we will do is we will create a list, or we will mention. So these are all the possible values that I want to check, and we just want to check for which values of C we are getting high accuracy when we are using a support vector machine classifier. Similarly, we have different kernel values. So we have linear kernels, polynomial kernels, RBF basically means radial basis function kernels, and sigmoid kernels. So these are all the different set of kernels we have. So we need to check for which combination of C and kernel values we are getting the highest accuracy for that particular data set. Okay, so here green color dots represents the different possible values that we are going to take, and blue is the value with highest accuracy. Let's say that for C value of 10 and the kernel value of polynomial, let's say that we are getting highest accuracy. So that is represented in this blue color dot. Okay, so this is just a graphical representation of understanding grid search CV and randomized search CV. Okay, so in this case, so green colors dots represent all the values that we are going to test, and in this case we are just taking 3 values. Okay, and for kernel we are taking 4 values. So out of all these values, which is your best value? So we will consider each value for the C and kernel, and then we will try to find this accuracy, and finally we will choose the hyperparameter value for which we are getting highest accuracy, which is represented in this green color. And so this is not doable, and this is not we can't do it every time we are working on a machine learning project. The reason is that you can have a several number of possibilities. You can have several combinations of the C kernel, and apart from this there are also other hyperparameters as well. So we cannot test for each of this hyperparameter values, because if you have a very large data set, in that case your training is going to take a very long time, and you cannot sometimes we don't have the resources as well as the time to check for all the possible values for this hyperparameters. Okay, so it is not like computationally, it may be computationally expensive. Okay, so you may need a lot of resources. So in that case what we will do is we will opt for randomized search CV, where instead of checking for all the possible values, it will randomly choose some hyperparameters values, and among that set of values it will try to give which parameters as the highest value. So this is the difference between grid search CV and randomized search CV, where in the case of grid search CV we will try to find the accuracy for all the different combination of hyperparameter values, whereas in randomized search CV we will try to find we will just take some random hyperparameters values, and we will see for which combination of values we are getting high accuracy. So this is how grid search CV and randomized search CV works, and this is a very important concept which we will use in machine learning in order to determine our most optimum hyperparameter values. So I hope you have understood the concepts covered in this video, and in the next video we will discuss about the next video will be an hands-on video where we will try to implement this grid search CV as well as randomized search CV in Python. In this 8th module, we are discussing about the topics such as cross-validation, hyperparameter tuning, and model evaluation. In the previous video, I explained you what is meant by hyperparameter tuning, and we have also discussed the concept of grid search CV and randomized search CV. If you haven't watched that video, I'll give the link of that video in this video's description, so you can watch that video before this one, so that you get a clear understanding of the conceptual aspects. Okay, so hyperparameter tuning is that, so we are just basically tuning the hyperparameters. If you consider machine learning models, there are different hyperparameters. So if you take a support vector machine classifier, there are hyperparameters such as C value, kernels, etc. So for a random forest classifier, there are hyperparameters like n estimators. Similarly, there are different hyperparameters for different model, and each of this hyperparameter can take any values. So our goal is to determine which parameter values is the best for our use case. So best in the sense, so like if you use that parameters for your model will have the highest accuracy. So that's the idea behind this. And in this hyperparameter tuning, we will try to find that particular parameter which is the most optimum one. Optimum in the sense, as I told before, it will give us the highest accuracy. And the two techniques to do this hyperparameter tuning are grid search CV and randomized search CV. Where in grid search CV we will try different combinations of parameters, whereas in randomized search CV we will randomly choose some parameter values and do the validation and so on. So you will understand this in more detail as we implement this. And for this hands-on part, we will be using the breast cancer dataset that we have worked before, so that we get a better understanding of the data. Okay, so I hope you have watched that video. If you haven't watched, you can also watch that one if you want to understand what are all the different processing we are doing in this dataset and how to build a predictive system for this breast cancer use case. Okay, so I'll give the link for breast cancer classification video in this video's description. You can check that out. So I'll just quickly explain what are all the basic processing things that we do on this dataset. So the first part is importing the dependencies, where we import the required libraries and functions. And I am sure that at this point most of you would know this. And the two main important things that we are importing are grid search CV and randomized search CV, which we are going to use in this video. Okay, so we are importing this grid search CV from sklearn library, and sklearn library has a module called as model selection. And this is in this module, there are various functions like train, test, split, and so on. Okay, and grid search CV also comes under this model selection, and again randomized search CV is also present in this model selection. You can also search the documentation of grid search CV and randomized search CV and just give a read on it to get some understanding of it. Okay, so next the basic things are just loading the data set and loading it to the pandas data frame. And this data set is present in this sklearn.datasets. So from that we are loading our breast cancer data. So you can see the data here. So this is in the form of a dictionary, where the this data array contain all the feature values, and the target array will contain all the targets 0 or 1, where 0 represents malignant and 1 represents benign. So you can see here, so 1 means benign and 0 means malignant. So these are all the labels that we have, and these are all the features names. So the target names is malignant or benign, and the feature names are given here. So we have about 30 features in this one. And now we are loading this data into a pandas data frame to do easier analysis and processing. So we are naming this data frame as data frame, and pd.data frame is the function that we are going to use in order to create this data frame. And the data for this particular data frame will be this breast cancer data. So you can see, so this is what we are loading. So data is nothing but all the values of the features that we have, and then we are giving the feature names. So this is basically mentioning the column names. And when you print the first 5 rows of the data frame using the set function, you will see this. So the first 5 rows, and we have about 30 columns, and you can also see the column names which we have given using this feature names. Okay, so columns is equal to feature names will load all these names of the features and put it in the column names of the data frame. So that is what is happening here. And now we are adding the target column to our data frame. As I've told you before, this target array contains either 0 or 1, where 0 being malignant and 1 being benign. So the primary use of this dataset is to build a machine learning model, to train a machine learning model, so that it can classify the data points into either benign or malignant. So we are adding this target column to our data frame, and we are creating a new column called as label, and that is where we are going to load this data. Now if you print the first 5 rows, you can see the last column, which is label. It will contain either 0 or 1, but it won't be present there in the first one. Okay, so you can see that here. And we are just checking the shape. So how many rows and columns are there? So totally there are 569 rows, which means there are 569 data points are there. That means like this data is for 569 different patients, and 31 columns, where first 30 columns are our features and the last column is our label, which is basically a target column. And we are just checking whether there are any missing values are there. So these are just basic processing things that we usually do in all the data sets. So we are just checking whether there are any missing values. So we have 0 in all the values, and we are just checking the distribution of the target variable. So how many data points are there for class 1 and how many data points are there for class 0. So you can see here class 1 has 357 data points and class 0 has 212 data points. So there is some imbalance in this data set, but this imbalance is not like very large. So like there can be data set where there is no balance in the distribution of the class. Say for example, there can be like two classes 1 and 0, and the number of data points for 1 will be 500 and the number of data points for 0 will be just 100. So there is a 5:1 ratio, so there is a clear imbalance and a large imbalance. So in that case we have to do some more processing, but in this case the imbalance is not that much high, so we can use this data directly itself. So as I've told you before, 1 means benign and 0 means malignant, and you can go to sklearn.datasets. So you can go to this sklearn.datasets documentation and check this load breast cancer data. So in that case, in that documentation you will you can see the details about the features and the target and all the things, and you will also see there, 1 represents benign and 0 represents malignant, so it will be represented there. And now what we are doing here is like we are splitting the features and target. So all the features will go to the variable x, and the target, the label, will go to the variable y. So data frame dot drop, so we are just basically dropping the label column and storing the other columns in x, and we are storing the last label column in y. So this is what we are doing. So like we are not going to do much analysis and processing and all of those things, because the idea of this particular video is just to show grid search CV and randomized search CV. So we won't be going into detailed analysis. So if you want to learn detailed analysis of this data set, you can watch my exploratory data analysis video. I link that video in this video description. You can check that out if you want. But here we will be working on only grid search CV and randomized search CV. So here you can see that we are printing x and seeing that it doesn't contain the label, and y will contain all the labels. So the next step is converting. So this is basically in the form of pandas data frame, and now we are going to convert it into numpy array so that it is easier for our processing. So for that we are going to use the numpy library, which we have imported as np, and we are going to use the function as array, and this will create this data frame x into array, and that array will again be stored in the variable called as x. So this is where we are going to use our grid search CV. So after this point, so I'll just create a text here and name this as grid search CV. So basically what we are doing in grid search CV is that, so I'll also put create another text, and I'll mention what we are doing here. So grid search CV is used for determining the best parameters for our model. Okay, so in this case we will be using a support vector classifier. So you can see here, so we have imported the support vector classifier from sklearn.svm. So in this we will be giving different values for the hyperparameters of svm. So you can see the different hyperparameters that we have. So we will be taking C and kernel, and we will be doing this hyperparameter tuning. So once you watch this video, you can try this SVM classifier, or you can also try other models like random forest classifier, and you can do hyperparameter tuning in those models as well. So in this case, we will consider only the support vector classifier. Okay. So now I'm going to load my grid search CV function. So okay, so before that, let's just load our support vector classifier. So loading the SVC model, where SVC stands for support vector classifier, and let's create a variable called as model, and let's load the instance of this SVC. Okay, so which we have imported. Now we have to create a dictionary with hyperparameter values. So I'll just create a comment here as hyperparameters, and I'll name this dictionary as parameters. Okay, so this parameters is equal to, we know that in Python the dictionary is enclosed in curly brackets. So I'll just create the key value pair, which is kernel, and for this kernel we can try different values, such as so let's try the values. Linear. So support vector classifier as linear kernel, RBF kernels, and so on. So I have explained this in the support vector classifier from scratch videos. So you can watch that one if you want to understand about this linear kernel, RBF kernel, and so on. And sigmoid. So these are all the different kernel values that we are going to check: linear, poly, RBF, and sigmoid. And the next hyperparameter that we are going to choose is C. Okay. So C is equal to, so in the previous video again I have explained you what is meant by this C as well. So I'm going to take different values such as 1, 5, 10 and 20. So these are all the different C values I'm taking. So the significance of the C is that, like, if you have a very small C value, then like the model doesn't allow any misclassifications to occur. So if you just split the data using hyperplane, so we know that in subprotected classifier we classify or we segregate the data using hyperplane. So if you have a very small C value, then there won't be any mix of classes, so there will be a clear cut hyperplane. Whereas if you have a larger C value, then there will be some mixing of these classes, because the margin will basically be larger. So that's the idea of the C parameter in subprotected classifier. And I'll run this one. So we have just basically created a dictionary called as parameters, and this parameters, so we know that dictionary is basically a key value pair where we have key and specific values for that key. So in this case, kernel is one key, and this particular list is the value for this key called as kernel, and again C is another key, and the value for this key is 1, 5, 10 and 20. Now what we are doing here is, so we are going to use this grid search CV, and we are going to determine for which combination of these parameters we are getting the high accuracy. So basically what we will do is, first we will take subprotected classifier with linear kernel, and for linear kernel we will take C value as 1, and then we will try to train our model and print the accuracy, and then we will take this again linear kernel with C value as 5, after that linear kernel with 10 and 20 and so on. So this will be done for linear, poly, RBF and sigmoid. So all the combinations of this kernels and C value will be executed, and we will train our model with these different combinations of kernel values and C values, and we will determine which values are the most optimum one. Optimum in the sense that will give us the highest accuracy, and this is what we call as grid search, because we will be checking all the parameters, all the combination of these parameter values. So hence it is called as a grid search, where we are checking for all the values in the grid. Whereas if you consider, or if you think about this randomized search CV, instead of trying all the combinations of all the parameters, we will randomly choose some parameters and train our model. So the reason is, in some cases the data set will be very large, and training your model will take a huge amount of time. So in that case we cannot try all the parameters possible. So in that case we will randomly choose some parameters. So that's the difference between grid search CV and randomized search CV, where in grid search CV we will try all the combination of values, and in randomized search CV we will randomly choose only certain parameters, and try to find which parameter combination has highest accuracy. So that's the idea. So I'll just create a text here as grid search. Okay, so grid search, and I'm going to create a variable called as classifier, and this is where we are going to load our grid search CV and our model, which is subprotected classifier. So I'll call the grid search CV function grid search CV. So if you remember, we have imported this grid search CV from sklearn.model selection, which we have discussed before. So we are going to use that, and the parameter values of the grid search CV, or the attributes value that we have to give to this grid search CV, you can see here. So estimator and parameter grid and so on. So we are going to give those things. So the first thing will be the model that we are going to test. So model parameters, and then we are going to give CV is equal to 5. Okay, so the first attribute that we have to mention is model. So because so model is nothing but our subprotected classifier. So for this model, for this subprotected classifier, I'm going to apply this grid search CV to determine the optimum parameters, and the parameters that I'm going to check are this. So parameters is nothing but our dictionary that we have created here, right? So where we have different kernel values and different C values, and CV is equal to 5. So CV is nothing but cross validation. So like you can give the CV value as 3 or 10 or whatever you want. So this is basically the number of folds that we have in our data set. So as I've explained in the previous video, in this particular module, we have discussed what is meant by this cross validation. So in cross validation, we will split our data into different folds, and each time a particular fold will be used as your test data. So CV is equal to 5 means 5 folds of the data will be splitted. So that's the idea. So you will get 5 accuracies, and we will take the average or mean of those 5 accuracies as our final accuracy value. So this is called as grid search CV. So first we have to specify the model that we are going to use, and what are all the different combinations that we are going to try, and what is the number of folds for your cross validation. So I'll run this. Now we need to fit our data to this. Okay, so X and Y. So we know that X is our features and Y is our target, which is our labels. So this is like fitting the data to our model. So if you note, we have not splitted our data into training data and test data. So the reason is the grid search CV automatically do those things. So it will again. So in this case, we are actually not doing train test split, but we are doing cross validation. So instead of that, we are doing this cross validation. So we don't need to split this train and test data. So once we do all these steps, once we find the optimum parameters, after that only we will split our data into training data and test data. I'll show you how that works. So first, now let's train our data. Okay. So classifier. So classifier is nothing but our grid search CV function. So you can see here classifier dot fit. So fit x and y. So when you mention this, classifier dot fit, so it will load the model. So in this grid search CV, we have used this model, and this model is nothing but SVC. So this data x and y will be fitted to the subprotector classifier model, and each time the different combinations of this kernel and C values will be tried, and we will be given the different accuracy values. So I'll run this particular cell classifier dot fit x and y. So let's see. So this probably is taking some time because like we are trying different combinations, so the training is going to take some time. So it may take some time, less than a minute or something like that. So once this training is complete, we need to print the result of this grid search CV. So for that, you need to mention the name of the so we have loaded this instance of grid search CV to this variable called as classifier. So mention classifier dot CV results. Okay. So CV results will print us the result of this grid search CV, which is basically the accuracy and other search values. So as you can see here, the code is still running. So let's wait for it. And so the process will be the same for the randomizer search CV as well. So all the things are same. So the only difference is that instead of trying all the parameter values, we'll be just randomly choosing certain values. So the reason is that, as I've told you before, there can be large data set, and you won't have resources for that much amount of magnitude. Like you won't have the time to train your models for that many different combinations, or you may not have the RAM or the computation power to do it. So in those cases, instead of trying all the different values, we will randomly choose some values so that the training doesn't take that much amount of time. Okay, so that's the idea. So I think this is like taking a long time than usual. So let's wait for it. Okay, so grid search CV, estimator CV, param grid. So param grid is nothing but grid is nothing but all the possible values that we have. So in C we have the values like 1, 5, 10, and 20. For kernel we have linear, poly, RBF, and sigmoid. Okay, so now so basically what happens is, as I have told you before, first the grid search CV will take the C value as 1 and the kernel value as linear, and then it will train our x and y with this, and it will give us the cross validation result. So after that, it will take this C value as 1 and kernel value as poly. So for C value as 1, we will be trying linear, poly, RBF, sigmoid, so individually. So after this is done, we will take C value as 5, and again, so all this linear, poly, RBF, sigmoid will be trained separately, and all those results will be stored. So for printing that result, we need to mention the function name. So basically the classifier, or the variable into which we are loading this grid search CV, and mention this dot CV results. So let's print this. This will give us the result. So this is the result that we are getting. So you can see the different combination that I have told you. So the first combination is C is equal to 1 kernel linear, and then we have C is equal to 1 kernel poly, and 1 RBF, 1 sigmoid, and then we have C is equal to 5 linear, 5 poly, 5 RBF, and so on. So all the different combinations are tried for it, and we have some rank test score, split 0, split 1, split 2. So these 5 splits, so split 0, split 1, split 2, split 3, split 4. So we have 5 splits here, right? So these are nothing but our cross validation folds, cross validation splits. And as I've told you, you will have 5 accuracies, and for this we will try to find that mean accuracy values. And so as you can see here, this is like the value for the different parameter combination. So that's why you have these many accuracy values. And now, so this is like not like it is hard to interpret these values. So for this, what we can do is we can load all this data, we can load all this information to a pandas data frame, so that we get a clear picture of what all these things means. So I'll create a text here as, okay, as loading the results to pandas data frame. pandas data frame, and result is equal to pd dot data frame. So in this pd dot data frame, we need to mention classifier dot results. So we know that this all the results of this grid search CV are stored in the CV results, right? So I'm copying this and pasting. So classifier is our grid search CV. CV results is where or all the values are stored. So before that, what I'll do is I'll just try to print what is the best parameters that we have. So out of this different combinations, we are going to print which is the best parameter, and for that best parameter, what is the accuracy that we are getting. So this step will be uh, best parameters. So we are going to print the best parameters for our support vector classifier, and I'll create a variable called as best parameters, which is equal to classifier dot best params. Okay. Now you can see, so when we run this classify.cv result, this result of this grid search CV will be printed, and when we run this classify.best params, so out of all these combinations, the classifier will return us for which parameters we are getting the highest accuracy. So that's the idea. And now those parameter values will be stored in this variable, and now I'm going to print this variable, which is my best underscore parameters. Let's see what is our best C value and best kernel value. Okay, so as you can see here, the best parameters are C is equal to 10 and kernel is equal to linear. So basically what this means is, for this data set, if you use the C value as 10 and kernel value as linear, you will get the highest accuracy. And for other combination like C as 1 or 5 or kernel values like RBF and poly, you won't get that much of high accuracy. But when you use C is equal to 10 and kernel is equal to linear, you will get the highest accuracy. And that's the idea here. And now let's try to determine what is that highest accuracy that we are getting for C is equal to 10 and kernel is equal to linear. So this will be for highest accuracy. So I'll create a comment here as determining the highest accuracy for this particular thing, and let's create a variable called as highest accuracy. So this highest accuracy is equal to classifier dot best score. Okay, so you can save this code, you can save this template for your other use cases. So you will probably be working on different use case, so you can just understand what are all the steps we are doing here, and you can implement those steps in order to do this grid search CV for your particular use case and so on. So best score, and now I'm going to print my highest accuracy. Let's see. So the highest accuracy that we are getting is 95.2 percentage. So 0.952 represents 95.2 percentage. So what this basically tells is, for this different combination of C and kernel values 1, 5, 10, 20 and linear, poly, RBF and sigmoid, the best parameter combinations are C is equal to 10 and kernel is equal to linear, and the highest accuracy that we are getting for this parameter combination is 95.2. And now we are going to load this information into a data frame to get a better understanding of this. So let's run this one. So we are just creating a data frame. We are naming this as a result, and we are using this pandas library, and that we have a function called as data frame to create a data frame, and the data for this will be classifier.cv result. So let's run this. And now let's print the first 5 rows of this data frame. So result.date. Okay, so you can see mean fit time. So how much time you are like the model is taking to fit to the data. So standard fit time, so this probably is the standard deviation and so on. So mean score time, again the standard score time, param C. So this is the different combination of values. C is equal to 1, param kernel is equal to kernel is equal to linear and so on. So we have split 0 test accuracy. Okay, so like what this value means is, like, what is your cross validation accuracy for parameter value of C is equal to 1 and kernel is equal to linear, and this is the split like second split. So split 0 is our first split, split 1 is our second split and so on. So totally we have 5 splits because we have mentioned this CV is equal to 5 here in this grid search CV function. So we have mentioned C is equal to 5 and so on. So we have various features or various metrics, right? So here the things that are important for us are the parameter values. So this C parameter values is important for us, kernel parameter value is important for us, and what is the test score. So if you see this, mean test score, so what is the average test data accuracy for each of this different combination of parameter values. So I'm going to choose those values alone. So grid search, so I'm just shrinking this data frame with only certain columns. So grid search result, so we are creating grid search result, and this grid search result is equal to result of. So when you mention this two square brackets and mention the columns, so the columns from this original data frame will be loaded to this grid search result. So the columns that I'm going to need are this param C. Okay, so this is one column, and the second column that I'm going to take from this larger data frame is param kernel, which is the different values for our kernel. And finally, I'm going to take my test data, mean test accuracy. Okay, so mean test accuracy. So these are all the different columns that we are taking. And let's run this. So now we are just creating a different data frame called as grid search result, and this is nothing but in this result data frame. So this result is our original data frame which contain all the results of grid search CV, and in that we are from this original data frame we are choosing the column param C, param kernel, and mean test score. And now I'm going to print this entire data frame. So let's put this here and run this. So you will see that, so what this basically tells is, like for parameter, like when you give C value as 1 and the kernel value as linear, the test data accuracy is 0.94, and for parameter value, like C parameter value is equal to 1 and kernel value is poly, so this is the accuracy. So this is basically the test data mean test accuracy for the different combinations of parameter values, so which I hope you can understand this. So in the code, the different C values that we have tested are 1, 5, 10, and 20, and these are the 4 kernel values, so linear, poly, RBF, and sigmoid. So those are all the different combinations that we have. So for first, like for firstly what happens is, like for this C value of 1, all the combinations of kernels will be tried, and for C value of 5, again all the combinations of kernels will be tried. So this will be done for all the different C values, and out of this we are just going to find which combination has the highest accuracy. So here C value of 10 and linear has the highest accuracy of 95.2%. So that's what we have printed here. Okay, so this is how you can interpret the grid search CV results, and you can interpret this in data frame, or you can print that in this highest accuracy. So I'll just create a text here, and I just put that for this support vector classifier, the highest accuracy that we are getting is 95.2 percentage, and the best parameters for this support vector machine are best parameters is equal to. So I'll just create something like a dictionary here. So for C, the best value is 10, and for kernel, the best value is, we know that it's linear, right? Linear. Okay, so I'll just include this in quotes and put this like this. Okay, so the highest accuracy that we are getting is 95.2, and the best parameters are C is equal to 10 and kernel is equal to linear. So this is grid search CV. Now we are going to do all the same procedure for randomized search CV, as I've told you. So instead of trying all these 16 combination from 0 to 15, so we have 16 combinations. So because like we have 4 C values, 1, 5, 10, 20, 4 different C values and 4 different kernel values. So instead of trying all these things, we will randomly select few parameters value and do this same procedure. Okay, so this is called as randomized search CV. So I'll name this as randomized search CV. Let's just make these letters bold. Okay, so I'll just go here and create a section for this grid search CV. Okay, so grid search CV. So if you just create some text and you put hash symbol here, so this will create a section like this, and it will enclose all the cells below that particular section. So this will make your code more concise. I'll just create this randomized search CV as another section. So you just need to include a hash here. So I'll just go to the top. I can just compress all the cells to this particular section. So this is the second section. So grid search CV cells will contain the code for all the procedure that we have done using grid search, and for this randomized search CV that we are going to work now. So I'll just expand these cells. I'm just going to copy all the things. So the only difference that we are going to do is, instead of grid search CV, I'm going to use randomized search CV. So we are not going to do anything other than that. So we can just copy all the cells and we can just uh, you know just change it to randomized search CV. So let me put it here. So first we are loading, again we are loading the subprotector classifier, because we cannot use the same model because it is already trained on the data. So we are creating a new thing called as a model, new variable called as model, and we are loading the instead of subprotector classifier. And now we need to mention the hyperparameters. So this can be like, you don't need to do this parameters because it's kind of the same, but I'm just doing this so that you don't get any confusions. So these are all the different parameters that we are going to work on. And now I'm going to create a randomized search. So instead of this, so this is where the code changes. So instead of grid search CV, we have to change this to randomized search CV. So apart from that, all the things will remain the same. So classifier, I'm going to use randomized search CV. So we have imported this randomized search CV from sklearn.model selection. I'll just copy this and paste it here. So randomized search CV. So we are having the model, and the parameters that we are going to consider are present in this dictionary. So it should be in this format. So other formats probably won't work. So you have to give this in the form of a dictionary, and then CV is equal to 5. So let's run this. And the next thing that we have done is, to fit our data, right? So we are going to fit the data to our model. So here we are not doing grid search CV, we are just doing randomized search CV. Okay, so classify dot fit x and y. So let's run this. As we have seen, this might take some time, so we can see. Okay, so the next step that we have to do is print the classifier results. Okay, so classifier dot fit. So this is like classifier dot cv results, which will give the cross validation results. And we are going to print the best parameters that are determined using the randomized search CV. Classifier results, best parameters, and highest accuracy is the next one. So CV results, highest accuracy. So just copy all these cells and put it together. So this cell, this one. So we are just loading the data to a data frame. So result dot copy. Grid search results. So let's rename that later. Okay. So I'll just paste all the cells here. Okay. So now let's just, so let the code run. So I'll just change the value. So classify dot paste best parameters, highest accuracy. So we are just creating I'll just name this as, okay, so let this be result. So let's change this grid search result to randomize the search result. Randomize search result. We are going to print that randomize the search result. Okay, so now let's see. I think the yeah, so the classifier has fitted to our model. So we can see, so instead of grid search CV, now we have this randomized search CV. So cross validation is equal to 5. Estimator, so the model we are choosing is subprotected classifier. So this is the distribution, so the different combination of C value and kernel value that we are taking. So apart from this, there are also other hyperparameters, so you can also try those parameter as well. So here we have just used two hyperparameters, so you can combine more parameters as well. So that's not a problem. So the model has fitted to our data. I'll just run this classify.cv results, which will print my result. Okay, so now you can see here, in the previous case we have several combinations, right? So we have different combination, about like 16 combinations are there for the different parameter values. But in the case of randomized search CV, you don't have that many combinations. So the randomized search CV will randomly choose only certain set of parameters. So it will just randomly choose, so hence the name, so that the training doesn't take that much time and it doesn't take that much resource of your computational power. So that's the idea of using randomized search CV instead of this grid search CV. So let's find which is the best parameters. So in this case also, the model has rightly found that the best parameters are linear kernel and C value of 5, and the highest accuracy will probably be the same, because like we are not changing the parameter values here, right? So that's the reason. So we are loading the result into a data frame, we are printing it. So finally, we are just choosing only the C parameter, kernel parameter, and mean test score. So let's run that, and let's run this data frame. So as you can see, so this data frame contains only like 10 combination, right? So it doesn't contain all the 16 combinations. So we just have 10 combinations. So like this may seem like it is not a big difference, but in some cases you may have to deal with like even more number of combinations. So in that time, your hyperparameter tuning will take a huge amount of time. So that's why we can choose between grid search CV or randomized search CV. So here also the best parameters that we got are kernel is equal to linear and C is equal to 10. Okay, so just copy the text from here. So this is the result that we get from a grid search CV, and now we are going to put that here as well, because like we are arriving at the same conclusion, right? So highest accuracy of 95.2, best parameter of C is equal to 10, kernel is equal to linear. The only difference is that accuracy are determined by grid search CV, and this one is determined by randomized search CV. And here the main thing that you need to remember is all the time like the result won't be the same. So like the idea here is like grid search CV doesn't exclude any combination of parameters, right? So what happens is like, so we know that 10 and linear are the best parameters. So when randomized search CV is running, it may skip that part. So it can you can see here, so 10 and linear, so it can like skip that particular parameter combination, and it will give us a different accuracy as the highest accuracy. So that's the drawback of this randomized search CV, whereas grid search CV will try all the different combinations. So the idea is like, in this case we got the result as same for both grid search and randomized search, but it won't be the same in all the cases. I want you to remember this is like very very important. So the reason that we have this two kind of techniques is, as I've told you before, in some cases you may not have the computational power, you may not have the resources to try a different set of parameters, different combination of parameters, because the main thing that you need to remember is, in this case we have tested for only one model, which is support vector classifier. Often what we will do is we will take 5 or 6 models, and for each of this model we will do hyperparameter tuning, and we will determine which model with which parameters we are getting the highest accuracy. So that is like computationally larger and a more complex problem, and it will take so many computational resource and time as well. So it will take a huge time to run. And in that case, so instead of going with grid search CV, we will go with randomized search CV, because we are not checking for all the combinations. We are just randomly choosing some with a hope that we will arrive at the highest accuracy. So that's the idea. So if you have a small data set, if you don't have that many hyperparameter combination, you can go with grid search CV. But if you have different models that you have to check and different hyperparameters that you have to check, in that case you can go with a randomized search CV. So this is the important thing that you need to remember. Now what we have to do after this is, so like we are getting C value as 10 and kernel value as linear, right? So this is not the end. We are just searching for the best hyperparameters, but we haven't trained our model yet. So we haven't like completely trained our model yet. So these are all kind of the evaluation. So the prerequisites that we often do. So now what we have to do is, so you can just go to this X and Y that we have splitted before, right? So you can see, yeah, so the X and Y. Now you can split this X and Y into training data and test data. After that you can create a variable called as model, and while loading the supported classifier, in this we will mention C value as 10 and kernel value as linear. So this is where you will use those hyperparameters which have the best accuracies. So what we are basically doing here is we are trying different combination of hyperparameters values. Once we determine that optimum parameters for which we are getting highest accuracy, we will split our data into training data and test data, and then we will train our supported classifier with those specific hyperparameters. So you can see, so we have C and kernel values, right? So we will train with C value as 10 and kernel value is linear, and after that we will do the basic evaluation and other things and so on. So this is how you have to work on this. And yeah, I hope everyone understand until this part. So that's it from my side. We have discussed about the topics such as cross validation, hyperparameter tuning, grid search CV, randomized search CV, and so on. And the next topic that we will be discussing is model selection. So model selection is all about choosing the right machine learning model for our problem, and there are a lot of different factors that has to be considered while performing this model selection. So in this video, let's try to understand what are all the different factors that influence this model selection. Okay, so once we understand this, The next video will be an hands-on part where we will try to implement this model selection technique in Python, where we basically try to compare the performance of different machine learning models. Okay, so let's get started with today's video. And first of all, let's start with what is meant by this model selection. So as I've told you, model selection is machine learning is the process of choosing the best suited model for a particular problem. Selecting a model depends on various factors such as data set that you have, the task that you wanted to do, and the nature of the model itself. So these are all the different things that we have to consider. So like when we say best suited model, it is the model that gives you highest accuracy, or in the case of regression problems, it is the regression model that gives you the least error. Okay, so we can call that particular model as the best suited model for that particular data set and that particular use case. And again, so this model selection depends on what kind of data that you have and what is the task you are going to perform. So if you are performing classification, we know that there are classification models are there. If you wanted to perform clustering, again we have different clustering models and so on. So these are like few factors. So we will go in detail about these factors. And again, as I've told you, there are like two factors should be considered while we are performing this model selection. The first thing is, what is the logical reason in order to select a model. So why we have to choose a particular model in a particular case. So we will discuss about this first one in today's video, and the second one is about comparing the performance of the models. So this is what we will try to do in Python in the next video. Okay, so it is just comparing how different models are performing for that same data set. So how we can do this comparison in Python. So we will focus on the first part in this video, and we can move on to the second part in the next video. Okay, so when we talk about this model selections, models can be selected based on like two important factors. One is the type of data available, and the next one is the type of the task that we need to carry out. Okay, so if you talk about the first one, which is like selecting the model based on the data that we have. So usually when we have image data and video data, we use CNN. So CNN stands for convolutional neural networks, and convolutional neural networks are known for image recognition and this computer vision tasks. And again, so video is nothing but they are like several images that are present in frames. So like videos are nothing but they are basically images. So for image data and video data, so we like CNN are the best suited models. And when you have this text data or speech data, in that case we use RNN, where RNN stands for recurrent neural network. So all these things comes under deep learning part, and we will discuss about the CNN and RNN in the deep learning course, and we will also be working on several deep learning projects along with this machine learning course. So in that you will understand so how the CNN works, so how we can use them, and how the RNN works and so on. And generally, like when it is numerical data, we go with the machine learning models like logistic regression, support-acted machine decision trees, and so on. So it is not that we can apply only machine learning models with numerical data. We can also use neural networks as well for numerical data. But so generally we will go with machine learning model itself when the data is like simple, like like numerical data. Whereas if you consider image data and text data, the data is kind of complex, and it is there is like a huge amount of data has to be processed and has to be learned from. So that is why we move with deep learning for this image and text and speech type of data with deep learning, and work on this SPM, logistic regression, and these kinds of simple machine learning models when it is numerical data. And the second like based on the task, how we can select the model. So if we talk about this, so classification task, we use the models like support vector machine classifier, logistic regression, decision trees, etc. So we know that classification task, we will try to classify the data point into different classes or categories. Okay, so logistic regression is a pure classification model, so you cannot use it for regression. So it has this name called as logistic regression because it is developed from linear regression. So that's why this has the it has the name logistic regression, but actually it is used only for classification. Whereas if you consider a support vector machine, so support vector machine, it has both classifier as well as regressor. Again, so we also have models like random forest classifier, which can also be we also have a regressor based on random forest. So like most of the models can be used for classification as well as regression, but logistic regression is mainly used for classification. And another important thing is logical regression is widely used for binary classification problem. Binary classification in the sense when you have only two classes or two categories. It's not like every time you will get best result, but if you have a linear data and if you have a binary classification problem, in that case logistic regression kinds of works best. Okay, and if we consider support vector machine, it kinds of works well when the dimensionality of the data is high. When you have several number of columns in your data set. So in that case, support vector machine is the best suited model for your work. And regression task. So if we talk about regression task, we have models like linear regression. So we also have random forest regressor and so on. So we also have like support vector machine regressor. But so in general, random forest regressor kinds of gives you better results because it is an ensemble model, and it is like widely used. So we have linear regression, random forest regressor, polynomial regressor, and so on. So apart from this, you have KNN classifier, KN regressor as well. So these models are also there. And if the task that you are performing is a clustering task, so obviously we have to go with k-means clustering and hierarchical clustering. And these are unsupervised learning models where we don't need labels at all. So these models will try to group the data based on their similarities and so on. So these are like two important things that you can consider. So if so the thing is, you can choose your model based on the data that you have and based on what is the task that you wanted to follow. So these are like few factors upon which you can select your model. So apart from this, you have to understand about the advantages and disadvantages of all the models in machine learning. So once you understand this, it will give you a clear picture of which model to use when. So I'll just take 3 models and explain you how we can do this, and you can do the research on other models. So we cannot go through all the models that we have. I'll just show this for the 3 models that we have. Okay, so we know that linear regression is a very simple model, and it is used for linear regression tasks. Okay, in other words, the regression problems. So the advantage of linear regression is like it is very simple to implement, and the main advantage is it performs well on data with linear relationship. Linear relationship is in the sense like if the x value increases, the y value also increases. If x value decreases, the y value also decreases. So there is only a linear relationship between them. So you can consider this t as x and y as it can be y. So if you see this curve, there is no a linear relationship between them. So it is kind of a sine relationship, right? So like this is the curve you get for a sine function. So when the data is this kind of a function, so in that case we cannot use linear regression, so it cannot capture that trend in the data. Whereas if you have linear relationship in the data, in that case linear relationship, linear regression works well. So that is the main advantage of linear regression. So you can understand this the linear relationship using the correlation matrix. So once you build this correlation matrix, you can put that in an heat map to understand whether there is some linear relationship within the data, within the different features and so on. Again, so if you think about the disadvantages, it is not suitable for the data having non-linear relationship. So when there is when there is no linear relationship in the data, when you use linear regression, you will get the results won't be good. So there will be like high error values. So we kind of try to avoid this linear regressor. Linear regressor is a very simple model. Okay, so we don't use it that much, but it's better to understand about this. Again, so it has this underfitting issue and sensitive to outliers. So this is another important factors. If your data has several outliers, then it is best to not use a linear regression, because like linear regression models are sensitive to outliers. So the function that we create using this linear regression is affected a lot by the outliers value. So we have to consider these things. So so if you think about different models, so this is how you can evaluate on which model to choose. So you have to take into consideration both the advantages and disadvantages of a particular model and what is the data that you have. So if you have a linear data, it is not like that much complex and you don't have any outliers, you can go with linear regression. So you have to consider all these factors and you have to come to a decision. And if we talk about logistic regression, so we use it widely, and again, so it is a very easy to implement model. It is like a very basic model in machine learning, and it is actually like built from linear regression. Okay, so we take the linear regression function and we apply the sigmoid equation. Okay, so that's how we get this logistic regression model. And yes, this logistic regression also performs well only on the linear relationship data, and again it is used only for binary classification problem. It can't be used that efficiently for multi-class classification or regression problems. You cannot use it. But for binary classification problem where the data has a linear relationship between them, in that case we can use logistic regression. It is a very good model. And so if we consider about disadvantages, like if the dimension within the data is very high, in that case logistic regression won't perform well. So there will be this overfitting issue. Dimension in the sense when you have when the number of columns is very high in a data set, so in that case logistic regression won't work well. So you have to look at the data and see whether okay, whether we can use the logistic regression in this case, or I have to go with subprotected machine or random forest classifier and so on. So if the dimension is more often subprotected classifier used, because like it kind of works well on high dimensional data. So that is one thing. And again, so if like this logistic regression, it is difficult to capture complex relationship. Again, it is based on linear regression, so it works well only on the data set which has linear relationship between them. Again, this is sensitive to outliers, and it needs a larger data set. So small data sets, it cannot capture the trend properly and so on. And this is the last model that I will discuss. So remaining models, you can do your research on what are all the different advantages that you have and the disadvantages that you have and so on. I just wanted to give you an idea of how you can look at this advantage and how you can select the model. Okay, so if we talk about decision tree, it can be used for again both classification as well as regression, and it is like easy to interpret. So we have this decision nodes, or what we call as so we have the branches, and we have like two nodes, and each node like will have two outcomes. So it can be like yes or no, and if the answer is yes, it will go to one branch. If the answer is no, it will go to the other branch. So we have seen this in decision tree intuition video and so on. I hope that you have seen that video. So like it is like easy to interpret and understand how this decision tree works, and like no need for normalization or scaling. So normalization is when we try to convert all the columns so that all the values are in the same range. So that is what we call as normalization. And we have this scaling, right? So what the standard scaler does is it will try to bring the data to a normal distribution. So that's what the standard scaler does. So when we are working with the regression model, we have to do this normalization and scaling, whereas for the decision trees and random forest model, so if we want, we can skip these steps, because these tree based models can understand the data without normalizing or scaling. And again, so these are like not sensitive to outliers compared to the regression model. So if you like, this is like a very important thing. Like this particular question can also be asked in interviews as well. So they would ask like which model is not sensitive to outliers. So the correct answer would probably be tree based models, whereas regressors are greatly affected by the outliers. So the linear regression, lasso regression, and so on. So these decision trees are not affected by outliers. So if you have a data set and there are like several, like a few outliers are there, so if you don't want to process the outliers, you can directly use the models like decision trees or random forest. But if you want to use a regression model, you have to process this outliers before using them. So this is like the other thing that you can consider while selecting the model. So if we consider about the disadvantages of this decision tree, so it has this overfitting issue where you will get high accuracy for training data, but the accuracy on test data will be low. And again, small changes in the data may alter the tree structure, causing instability. Instability means like you may get different results, because like if the values are like changed by a small factor, then the result will change by a huge factor. So that's what I have mentioned by this second disadvantage. And the third main disadvantage is the training time is relatively higher. So the amount of time the model takes to train, and when you take a new data point, and if you want to predict the label for the new data point, it is going to take a somewhat longer time compared to the other models. So this is something that is like very crucial, because if you have a data set that has 500 data points or 1000 data points, that's not an issue. But if you have a data set that has like, let's say, a million rows, in that case, if you're going with the tree based models, it will probably take a very long time. So these are like different factors that we have to consider, and this will help us to choose the best model for our particular use case. So I have just discussed about these three models. I'm not going to go deep into the other models. So I suggest you to please do some research on the advantage and disadvantage of all the models that we have in machine learning. So this will give you a clear idea, and it will help you in a long run on how to choose the models, and which model is suitable for which case and so on. So this is about the different factors that contribute to selecting the model that we have in machine learning. But this is not all. So in the next video, as I've told you, we will be working in Python, where we will try to build something where we will try to automate this process of selecting the model. So we will basically process the data set, and we will feed this same data set to different models, and we will check like what is the performance of the different models. So performance in the sense, we will compare their accuracy scores or their error values, and we will choose which is the best model. So these are like two things. So first, you have to consider or you have to choose the model based on your logical understanding of the machine learning models that you have. And the next step is, so scrutinizing few models. Let's say that based on all this advantage and disadvantages, you have a particular data set and you are coming up with three machine learning models. So out of this three machine learning model, you have to choose only one ML model. So in that case, we can go to Python. So we have to train all these models with the same data set and we have to compare the results. So this is how we usually do the model selection. And I hope that you have understood all the things covered in this video. In the eighth module of our hands-on machine learning course. And in this eighth module, we are discussing about the topics such as cross-validation, hyperparameter tuning, model selection, etc. And in my previous video, I explained you what are all the different factors that we have to consider while choosing the right model for a machine learning problem. And we have also seen for which kind of data set we have to use which kind of model and so on. And in today's video, let's try to understand how we can perform this model selection in machine learning with Python. So this will be the agenda for today's video, and let's get started. So here we will be taking a sample data set and we will be performing this model selection in order to understand this process. And for this, we are taking this art disease data set. In my channel, I already made a video called art disease prediction using machine learning. So we are going to use the same data set that we had. So this data set basically gives us the data on whether a person is having any art diseases or not. So this is a typical classification problem. And in this case, we are going to take five models and compare their, compare their accuracies and see how we can perform this model selection. So that is what we are going to do in this particular video. So these are the steps that I've already done in that video as well, but I'll quickly explain you what are all the steps that we are doing here. Okay. So the first step is importing the dependencies. Dependencies are nothing but the libraries and the functions that we need. So first of all, I'm importing my NumPy library and pandas library. And from sklearn.model selection, we are importing cross-val score. So in sklearn library, we know that in sklearns we have various functions for training our models, several models like logistic regression, protected machine, etc. So there is also a module called as model selection. So in that we have a function called as cross-val score, which is basically gives us the cross-validation score of a particular model. And we have already seen this while we have discussed about the scaffold cross-validation and all of those things. I hope that you have seen those videos. If not, I'll give the link for that video as well in this video description. For this art disease prediction also, I'll give the video in this description. Okay, so I'll give the link for that. And then we are importing this grid search CV. So grid search CV is what we call hyperparameter tuning technique, where we pass like several hyperparameter values, and this grid search CV will try to tell us which hyperparameter is the best that we can consider. Best in the sense, when you use those hyperparameters, you will get the highest accuracy for that machine learning model. So we are importing these four dependencies first of all, and later we are importing the models that we are going to use. So in this case, as I've told you, this is a classification problem because this contains the target variable as either 1 or 0. 1 being a person has heart disease and 0 being a person doesn't have any heart disease. So this is a classification problem. So we are importing 5 classification models that we have. The first classification model that we are importing is logistic regression, which we are importing from sklearn.linear model. Then we are importing the subprotected classifier, then k nearest neighbor classifier, and random forest classifier. So these are all the 5 models that we are going to take, and we will be comparing their accuracies. Okay, so I think like there are like four models, not 5 models. There are like 4 models which you are going to use. And as I've told you, this is the art disease prediction data set. I'll give the link for this data set in the description of this video as well. You can download that file and upload it here. So I have already uploaded this file, so you can upload it here and do all this processing. So once I upload this file, I'm reading the CSV file to a pandas data frame using this read CSV function. So we know that this is a very common and basic function that we use, and I'm storing this data in a data frame called as art data. Okay, so in this I have to give the path of the CSV file. After that, I'm printing the first 5 rows of the data frame that I've created using the set function. So these are all the first 5 rows that we have. So if you want a clear detailed explanation on what are all these different columns that we have and the other things, you can watch that art disease prediction project. So here I'm just quickly going through all the steps that we have done. And then we are checking the shape. So how many rows and columns are there in this particular data frame? So as we can see, there are 303 rows and 14 columns. Okay, 303 means 303 data points or 303 different people are there in this data frame. And we are checking whether there are any missing values. Fortunately, there are no missing values in this data set. So we can move on to the next step. Then we are checking the distribution of the target variable. Here, as you can see, I'm mentioning the data frame name and the target column name and value form. So this is the function that tells me how many values are there in each class. So there are like 165 data points in one class and 138 data points in the class 0. So the distribution is almost equal, so we don't have to do anything. So in case the distribution is not even, in that case we have to do upsampling, downsampling, and so on. So here 1 means defective art. That means like a person is suffering from art disease. 0 means a person doesn't have any art disease, and so on. So now we are separating these features and target. Features are nothing but these columns. So we have this age, sex, CP, BPS, and so on. So we have various columns here, and one column is this cholesterol, and so on. So based on these factors, we have to tell whether a person will be having, heart disease or not, whether the value is 1 or 0. So these columns from age to this last before column is my features, because with using these values, I'm going to predict whether the target value is 1 or 0. Okay, so I'm going to separate all these values separately and target column separately. So that's what I'm doing here. So I'm storing all the features in my X, and I'm storing my target column in this Y. Okay, so I'm separating it, and you can see I'm printing my X. So these are all the columns. Now it doesn't have this target column and Y as the target column. So these are all the things that we have done so far, and after this we can perform our model selection steps that we have. Okay, so you don't have to separate the data as training data and test data. So we will do that in the later part of the code, but you don't have to do that. So I'm separating my features and target as X and Y, and after that I'm converting it to a NumPy array. So instead of having it in the form of data frame or a series, I'm converting it to a NumPy array, and you can do that by using NP. So NP means NumPy library using as array function X. So I'm converting this X into a NumPy array and Y into a NumPy array. Okay, and now we will do this model selection. So in this model selection, we will perform like two ways, like two things we will do here. One is like comparing the models with the default hyperparameter values, and then we will also compare the model, or we will select the models with different hyperparameters. Okay, so first thing that we will do is I'll just make a text here as comparing the models with default hyperparameter values. Okay, so default hyperparameter values using cross validation. So this is why I've imported this cross val score function, cross validation. Okay, so this will be the first step, and later we will compare the models with different hyperparameters as well. So there are like two parts for this particular video. And first of all, let's try to create a list that contain all these models. So we have imported these models, right? Logistic regression, SVC, k nearest neighbor, and random forest classifier. So here I'm going to create a list. So this will be a list of models. You can also try other classification models as well if you want. So models is equal to, so this is the list that I'm creating. The first model is logistic regression. Okay, so logistic regression. So this is my first model, and the second model is support vector classifier, which is SVC, and k nearest neighbors. So k neighbors classifier is my third model, and finally I have my random forest classifier. Random forest classifier. So these are all the four models that I'm taking, and I'm going to like give a few values to it. So in this logistic regression, I'm going to give this max iter. So max iter basically represents the maximum number of iteration, and I'm going to give this maximum iterations is equal to 1000. And support vector classifier doesn't work if you just mention this SVC. You have to mention at least one kernel value. Okay, otherwise it won't work. So I'm going to say kernel is equal to linear. So it is the most default one and the basic kernels that we have. So apart from this, we also have this polynomial kernels and other type of kernels as well. So kernel is equal to linear kernel for support vector classifier, and then we have k nearest neighbor, so we don't have to give any parameters here. And random for us, we will set a random state. So if you don't include this random state, you will get slightly different accuracy score each time you run this. So I'm setting my random state. So if you give some random state, your accuracy value will be the same if you train this random forest classifier multiple times. So that is the reason. And the reason I'm giving this max iter is that we are not standardizing the data in this case. As we can see, we are using the data in this same format. So it will give us an error if we don't standardize the data before using it in logistic regression. So we are increasing this max iter, but the correct way would be will be in order to will be to standardize the data, but we can't use it using this cross validation directly. So we have to use something called as pipeline. So we have to build this pipelines and pass this standard scalar and grid search CV and so on. So it is a bit complex. We will discuss about that later, but for now understand that we are using this maximum iter so that it doesn't give us any warning. So that's the reason, but we will discuss about this pipelines later on. So here I created a list called as model, and I have like four models here. First is the logistic regression model and supported classifier model, k nearest neighbor, and random forest classifier. So these are all the four models that I'm considering. And now I'm going to create a function that will compare the accuracy score of these models. So if you remember, we have already done this in our machine learning challenge. So I'll take the same process and implement here. So I'm going to create a function called as compare models using the cross validation score. Okay, compare models using cross validation. So this is the function that I'm creating. So you have to mention this parenthesis here, and here I'm going to train models individually. So for this, I'll create a for loop. Okay, for model in models. So I'm creating a for loop here. So when we call this function, this for loop runs, and when this for loop runs for the first time, this model will take the value as logistic regression, and it will train with the given data set, and it will print us the cross validation score. The second time the for loop runs, this model takes the value as supported classifier and so on. So this process kind of happens every time we run this. So for model in model, so I'm iterating this for loop through this list called as models, and each time it will take one model at a time. So this is how it works. So for model in models, I'm going to say CV score. So I'm creating a variable called a CV score, and now I'm going to use the cross val score function. Okay, so I'll copy this. So this cross val score, which I imported from model selection. Cross validation score is nothing but your data will be split into 5 folds, and each time different data fold will be used as your training data and test data. And if you don't know about this, I'll give the link for this cross validation video. You can check that out, and this is like very important. Cross validation is one of the important topics that we have in machine learning. So I'll paste this cross val score function that I imported, and here the parameters that we have to give are estimator, as you can see. So estimator is nothing but the model that you are creating, and x is my features and y is my target. So I'm going to say model. Okay, so model x y and a CV is equal to 5. Okay, so the for loop runs for the first time. So this model will take the value as logistic regression of max iter 1000, and it will go here. So we are using this cross validation score function. So it will basically give you the cross validation score for logistic regression for this data x and y. And x and y is nothing but my RDSys data set that I have split into features and a target. Okay, target is what you are going to predict, and feature is the values through which you are going to predict this target. Okay, so here I'm going to predict whether a person is having art disease using the factors like age, sex, and so on. Okay, so we have this cross val score model xy CV is equal to 5. CV is equal to 5 is nothing but your data will be split into 5 folds. So you will be having like 5 chunks of data, and each time different chunk of data will be used as your test data set. So that is how this cross validation works. And you can also like change this CV into 3 or 5 or some other values as well, depending upon your data set. So this CV score will basically give you 5 accuracy score, and from that 5 accuracy score we have to find the mean accuracy score. Okay, so I'll also print this accuracy score if you want. Hmm. Okay, so let's print that, but let's print that at a later point of time. So I'm going to say mean accuracy. Mean accuracy is equal to sum of CV score divided by length of CV score. So this is how you can kind of find the average value of this cross validation score. I'll explain you later on how this particular code block works. And this mean accuracy is equal to accuracy into 100. And the next thing I wanted to do is I'll copy this mean accuracy, paste it here, is equal to round mean accuracy by 2 factor. And now let's print this. Print. So just give me a minute. I'll explain you what we are doing here. Cross validation accuracies, um, accuracies for the model is equal to CV score. Okay, so this is the first print statement. And next, let's print our final accuracy score of the model. Model is equal to my mean accuracy percentage. Okay, let's run this one. So what we are basically doing here is, let's say that the for loop is running for the first time, and when I say for model in models, so it will take the logistic regression as I've told you before. Now I'm passing this logistic regression model to this cross value score function, and I'm passing my data, which is my features and target, and I'm saying like I want five folds of data, so I'm mentioning CV is equal to 5. So what happens in this particular step is your data will be split into 5 folds, and your data will be trained using this logistic regression model. So this logistic regression model will be trained with the data that we have passed, and this will happen for 5 times. With each time there will be like different test data because of this 5 folds that we are creating. So the result of this particular CV score line is that you will get like 5 accuracy values. So it will be in the form of a list. So from this 5 accuracy values, we are going to find what is the average of these 5 values. So that will be the final accuracy that we will consider. So for that only we are using this mean accuracy. So mean accuracy is equal to sum of CV score divided by length of CV score. So this is nothing but we take, like, let's say that there are like 5 accuracies. One is like 80%, another one is like 85%, 83%, and so on. And we are adding all those values and dividing it by the total number of values that we have. So in case like there are like 5 values like 80, 85, 83, 84, and 83, so we will add all those values and divide it by 5 because there are like 5 accuracy values. If you increase the cross validation fold, you have to this will change as well, the length of CV score changes as well. And now we are calculating the mean accuracy. So here I'm multiplying the mean accuracy by 100 because the value will be in the range of 0.9. So if a model has 90% accuracy, it will be represented as 0.90. If a model has 85% accuracy, it won't be given as 85, it will be printing as 0.85. So we are multiplying it with 100 in order to convert it to a percentage. So this is just simple percentage conversion. And this step, mean accuracy sum by length, is for calculating the average. This is for converting it to percentage. And I'm going to say mean accuracy is equal to round of mean accuracy comma 2. And the reason we are using this particular step is there will be like several decimal point values. So I'm going to say I want only like two values after the decimal point. So I'm saying like round, I'm going to round this mean accuracy value, and I want only like two decimal places. You can also give like 3, 4 depending on how many values that you want. And finally I'm printing my cross validation score. So I'm going to say cross validation accuracies for the model. So this is my variable that I've created here. So this for loop runs for the first time, it will print cross validation accuracy for the logistic regression is equal to some cross validation values. And again, so this is not in the string, so we have not enclosed this in quotes. So this is actually a variable that we have created. So here it will say accuracy score of the logistic regression model is equal to the mean accuracy, and so on. So let's run this step and see whether this works. Okay, so we have created this function. Now we have to call this function. So I'll copy this and I'll run this one. So this will print me these results. Okay, let's see. So all the splitting of data will happen inside this. Okay, so let me just add one more line to it so that the results are kind of splitted. I'm going to say print. I'll just print some dotted lines here. Okay, so I'll run this again now. So the result will be the same. So we just have this dotted line in between. Okay. So as you can see, this is the result when the for loop runs for the first time. So it will take the value for this model as logistic regression. So that is what is replaced here as well. So cross validation accuracy is for logistic regression, as you can see. So cross validation accuracy for the logistic regression is equal to these 5 values. Okay. So for the first fold of data, we are getting the accuracy as 0.80, which is 80.3%. This is 88.5%, 85%, and so on. as you can see, there is a clear difference between them. So we have like accuracy score in the range of 80. We also have accuracy score as 75 percentage and so on. So this is why cross validation score is always preferable instead of train test spread, because train test spread will give you like only one accuracy score, but this is like more reliable as we have like multiple accuracy score and we are taking an average of it. And the average of all these five values are this 83.5. So that's what we are doing in this particular step. So when I say CV score is equal to cross val score of model X with CV is equal to 5, this is the result that I get from this particular line. So this is the value of this CV score. So these five values are the value of this CV score, and I am adding all these values using the sum of CV score, dividing it by total number of values, which is equal to 5. And then I'm multiplying this value by 100, and I'm reducing the decimal places. As you can see, there are several decimal places, and I'm reducing the decimal places is equal to 2. So this is how we are converting this value from 0.80 or whatever we have to this particular percentage value, which is 83.15 percentage. So we have two decimal places here because we have two here. So if you replace this 2 with 3, you will get 3 decimal places. So it is completely up to you. It will round the values. So this is the final value for this logistic regression cross validation. And once this for loop runs for the second time, this model will take the value of this SVC, which is my second element of my list called as models. So this is the cross validation score of support vector machine classifier with linear kernel. So these are like some of the basic hyperparameters we choose for these models, and this is the value. And then we have the average of these values is like 82.83 percentage. So this is the cross validation average value for logistic regression. This is for supported classifier. And finally, as we can see, k nearest neighbor has 64.39, which is very less. And then we have the like accuracy score for random forest classifier as 83.81. So this is how you can compare the accuracy score of different models using this particular simple function. So you don't need to train your model separately in order to do this. You can just create a list with all the models that you want to compare, and you can just build a simple for loop like this, and you will get a result like this. So you can save this code as a template, and you can use this for any other use cases that you're working on. So this kind of saves a lot of time, and this is a pretty good way of doing this model selection. And the thing is, here we are doing this with the default hyperparameter values which we are having. So we are not doing any hyperparameter tuning on all those things. We will do that in the next part of this video. Okay, so we have the list of models and we are comparing this model. So within this we have to see which model has the highest accuracy. So it is obvious that logistic regression and logistic regression and random forest classifier has the highest accuracies, and among this random forest classifier has the highest accuracies, as we can see, which is 83.81 percentage. So this is like very close to logistic regression as well, and k nearest neighbor has the minimum accuracy, which is like 64 percentage. So here I'll create an inference. Okay, let me put this as inference as for this particular art disease dataset. For the art disease dataset, random forest classifier as the highest accuracy value. Okay, so as the highest accuracy value with default hyperparameter. So we are not changing any of the hyperparameter values yet, except for this maximum meter in logistic regression alone. So kernel is linear is like we have to give at least one kernel value, so that's why we are giving it. So with default hyperparameter values. Okay, so let me put this random forest classifier in bold letters. Okay, so this is the influence that we are getting, and the important thing that we have to note here is we are not doing any hyperparameter tuning. So this is what I have mentioned here as comparing the models with default hyperparameter values using cross validation, because we have used this cross val score. And now what we are going to do here is we will take all these four models and we will check these models for different accuracy score for different hyperparameter values. Okay, so it's like doing hyperparameter tuning as well as model selection together. Okay, so this is the next part of the code, and this is again an interesting thing that we have. So let's see how we can do this. So in this case, instead of this cross validation score, we will be using this grid search CV, as we have to do this hyperparameter tuning as well. Okay, so in case this is like enough for you, so in case like you don't have to do any hyperparameter tuning, you just wanted to compare the models with default hyperparameter values alone, in this case you can use this particular code snippet. And after this, what you have to do here is like you have this x and y, right? So you have to split this x and y into training data and test data. So we have already discussed about this. So you can also refer my art disease prediction project video in order to understand how we can perform this train test split, train the model and so on. So after splitting the data into training data and test data, you can, instead of like using logistic regression or SPC, you can use this random forest classifier. So this step is just to understand which model has the highest accuracy, and we cannot like use this any. I mean, we cannot use this further. So this is just for comparing the model. So once you do this, you can train your random forest classifier after splitting the data into training data and test data. So that will be the next thing that you have to do. So I'm not covering that train test split as we have done that several times before. So once you perform this cross validation, you have to split your data to training data and test data and train the model, do the model evaluation and all those things. And the second part of the code that we are going to do here is comparing the models with different hyperparameter values using grid search CV. So okay, now let's create another list. So it is again the same list, but I'll just copy this and create a new name for this. You can have the same name, but I'm just creating a new one. So let's call this as models list. So models list and logistic regression, I'll just change the maximum meter to 10,000. So if I just use this 1,000, it is giving me some warnings. So that's why I'm using this maximum meter. But the correct way of doing this will be to standardize the data and do all these things. Again, for that we need pipelines. So let's not go in detail about that. Let's change this maximum meter value alone. Okay. And then I'll just remove this kernel is equal to linear. Okay, because that's what we are going to check here. So we'll be checking the support vector classifier for different hyperparameter values, like different kernel values. So we have different kernels like linear, poly, RBF, sigmoid, etc. So we will be comparing all those things as well. Okay, so so we have created a list of models. First is logistic regression with the maximum iteration, support vector classifier, k nearest neighbors, and random forest classifier. So you can also change this random state value if you want, but please include this so that we don't get different results each time we run this code. So now the next thing that we have to do here is, so here we have created a list that contain the name of all the models that we are going to use, the logistic regression classifier, SPC, etc. Now we have to create a dictionary that has all the hyperparameter values. So that is the next important thing. So here we are creating, so creating a dictionary that contains hyperparameter values for the above mentioned models. Okay, so let's name this dictionary as model hyperparameters. Okay, so this model hyperparameters is equal to, as we know, we have to enclose the values of a dictionary in curly brackets. So I'll create this curly brackets. And so we know that a dictionary is a key value pair. So it contains a key and some set of values, right? So the first key that I'm going to create is logistic regression. So logistic regression, I'll just mention this in short form. So logistic regression hyperparameters. Okay, so this is the first key that we have, and here we are creating another dictionary. Okay, so I'm going to say logistic regression hyperparameters is C colon. I'll explain you what we are doing here. So this may seem a bit complex, but this is actually very simple. Let me just complete this and explain you. So here you have to mention what are all the different hyperparameters that we want to consider. So here for logistic regression model, I'm going to change the different hyperparameter for the C value. Okay, so that is what I'm mentioning here. So C can take values like 1, 5, 10 or 20, and so this is my first thing, and there should be a comma here. So this is my first set of values, and the next model that I'm considering is support vector classifier, right? So it will be SVC, support vector classifier hyperparameters Okay, so SVC hyperparameters. So again, we have to create another dictionary within this, and those values are two things. One is kernel, and for kernel, I'm going to consider different kernels like linear kernel, polynomial kernel, which is represented as poly, and RBF. So we have discussed about this different types of kernels in our supported classifier video, so we can check that out. So it will be in the 7th module of our course. And then sigmoid kernel. So these are all the four kernels that we have: linear, poly, RBF, and sigmoid. And finally, let's also change the C values. So for C values, I'm going to say 1, 5, 10 and 20. So these are the different C values that I'm considering. So I'll another comma here, and the third model that we have is k nearest neighbor, right? So for k nearest neighbor, I'll mention this as knm hyperparameters. So we have also discussed about this k nearest neighbors as well. So it kind of checks how many nearest neighbors are there to a particular data point in order to determine its labels. So knn hyperparameters, and in this case, the hyperparameter that we are going to consider is n neighbors. So n neighbors. Okay, so if you are not sure how I am doing this C kernel and n neighbors is, if you can just search it. So I'll say k nearest neighbor sklearn. So let me just search this in Google. So this will take us to the documentation of this k nearest neighbor classifier, as you can see. So these are all the different hyperparameters that we have, and n neighbors is basically the number of neighbors that we consider for determining a particular data point. So if you don't understand this, you have to watch my k nearest neighbor intuition video. So basically, k nearest neighbor works is, let's say that there are like two groups of values. So here we have like data with labels as 1 and 0, right? Similarly, when we are training this model and predicting a new value, this KNN model will check this particular new value that you are predicting is closer to which group of data, whether it is close to 1 or it is closer to 0. So when you say 5, it will like consider the 5 nearest data points to it, and it will say like which data points are maximum. Okay. So if you want a detailed explanation on this, please watch the k nearest neighbor video that I have created. So in this case, the default value is 5, and now I'm going to consider like different values for it. So I'm going to check for different values such as uh, 3 neighbors, 5 neighbors, and 10 neighbors. Okay, and this will be the hyperparameters from a third model. And finally, we have the random forest classifier, and I'll create the key as, let me just include another space here. Okay, so this will be random forest classifier. Okay, so this is my, okay, let me just put this as random forest hyperparameters. Okay, hyperparameters, and here the hyperparameter that we have to consider is my n estimators. N estimator, this n estimators is equal to 10, 20, 30, and 100. Okay, so this n estimator is nothing but the number of decision trees that you need. So we know that we have a machine learning model called as decision tree, where it kind of builds this tree and so on. What is meant by this random forest classifier is that this model contains multiple decision trees. So that is how this random forest classifier has been built, and this n estimator kind of tells it like how many decision trees should be there in this random forest model and so on. So this is how this works, and yeah. Okay, so there should be a comma in this place. Just a second. Okay, so let's try to understand what we are exactly trying to do here. So here I'm creating a dictionary called as model hyperparameters. So what is this dictionary is? It contains the different hyperparameter values for all the models that we have listed here. Okay, so that is the idea of this. And so this is a dictionary, and we are creating another dictionary within this. So we know that a dictionary is a key value pair. So there will be a key and a set of values to it. So for this model hyperparameter, there are four keys. The first key is logistic regression hyperparameters, and the second key is SVC hyperparameters. Third one is k nearest neighbor hyperparameters, and finally random forest hyperparameters. So all these four things represents a particular key, and the second one represents the corresponding values for this key. So this one is the value for this first key, and these two things are the value for second key. Third one is like n neighbors is the value for this one, and so on. The only difference is that instead of having values or list, we are creating a dictionary itself as a value. Okay, so if I build a simple dictionary in this case, just a second. Okay, so let's say that I'm creating a my dictionary. Let me just put this as a. So a is my dictionary that I'm creating. So here I can say name. So like let's say that name of a person is John. Okay, and there is like another key here called as age, and I'm going to say age of this person John is, let's say, 30, and let's say the country he belongs to. Okay, so country he belongs to is, let's say, US. So this is the dictionary that I'm creating, and I can also like print this A and C. So this is my dictionary. Here we have three keys. One is a name, and then we have this age and country, right? So this is how we create a dictionary. So this keys are similar to what we have created here. So this logistic regression hyperparameters is similar to the key name, and then we have this SVC hyperparameters, right? So in this case we have three keys: name, age, and country. So similarly we have four keys: logistic regression hyperparameters, SVC hyperparameters, and so on. The only difference is that the value for this key name is in the form of a string, right? So this is the key, and the value is John. The value for this key name is John, and it is in the form of a string. And the value that is associated with this age is 30, which is an integer value, and country is again a string. So the only difference is that instead of having string or age as my value, I'm having another dictionary within this. Okay, so this is the dictionary that I'm considering it for values. So this is just like saying uh, instead of like John, so what I'm going to say here is like there can be a list with there can be John, and let's say there is like this Sam. So this is the name of different people that we have. So you can also like create this list like this. So I'll run this one. So instead of having string, I have created a list here. So similarly, in this case, instead of having an integer or a string or a list, I have created another dictionary as my value. So this will be the correct way of specifying your hyperparameter values. So this is actually a dictionary, but we are just using it in a different form. So we have the dictionary called as a model hyperparameters, and within that model hyperparameter, we have multiple dictionaries. Okay, so this is the dictionary associated with the first key value, and this is the second dictionary value associated to this SVC hyperparameters, and so on. So I hope you understand this. This is like very important, but this is like very simple thing that we are doing. So in case you wanted to try multiple hyperparameters, so in this case for logistic regression, we have considered like only one hyperparameter, which is like C value, but logistic regression also has other hyperparameter values as well. In that case, how you can do that is like how we have done this for support vector classifier. For support vector classifier, I'm considering like two hyperparameters. First one is kernel, second one is like C. So that's why I have to include this comma here. So I'm just saying like there are like two set of hyperparameters for which I have to check. So this is my first key value pair. So I have separated with this comma. This is my second key value pair. So this is my first set of values. This is my second set of values. This is like third set of values. So all these things should be separated by this comma, and this is like very important. If you remove this, it will be it will basically show you an error. Okay. So I hope you understand this part. So we are just creating a list of models, and we are creating hyperparameter for the listed models. The only important thing here is we are creating it in the form of a dictionary so that we can use it efficiently. Okay. So model hyperparameters is the dictionary that we have created. So I'll copy this and paste it here. So you can also check the type of this model hyperparameter. So it will tell us that it is in the form of a dictionary. Name is not defined. Okay. Okay. So I have to run this cell first. So it seems like I didn't run this. Okay. So I'll run this one. Okay. So DACT, which stands for dictionary. And I can paste it here, and I can say keys. Okay. So let's print this keys of this dictionary. So let's see what is the output we are getting. So when I say model hyperparameter dot keys, so these are all my keys: logistic regression hyperparameters, SVC hyperparameter, K and then hyperparameters, and so on. And I can also check the values of this or items of this. So let me just put this as model hyperparameters dot values. So these are the values. So the value for logistic regression hyperparameters is the C, and the value for SPC hyperparameter is this one, kernel and C, kernel and C. As you can see, all these are given in a dictionary format. So this is how you can analyze the dictionary that you have created. So when I say, uh, you know, let me put this as keys as okay. I'll just remove this one. So I just want this keys alone. I'm going to convert this keys into a list. So let's create a variable for this model keys is equal to list of model hyperparameters dot keys, and I'm going to print this model keys. Okay. Yeah, so I have created a list which contain all these keys. So we need this in order to access the data that we have. Okay, so how you can do this is like if you copy this name model hyperparameters, and if you say the name of a particular key. So this is my first key. I'll copy this. If I paste it here, so if I paste this within the square bracket, I will get the corresponding value for this particular key. As you can see, if I just replace this with this SPC hyperparameters, I will get the corresponding value for subprotector machine classifier. So this is how we are going to access the individual hyperparameters for the models that we have created in this list. Okay, so that's why I've created this list called as model keys. And instead of using this SVC or hyperparameters and something like that, we are going to use the index of this particular list. Okay, so I'll say, mm, so this is the list we have created. So let me just move this cell above. So this is my keys, and this is the list that I've created. And we know that we can print the first value of the key using the index, right? So when I say model keys of 0, and model keys is the list that I've created, when I say 0, this first element will be printed. The first element is logistic regression hyperparameters, right? When I say 1, the value with index 1 is SVC hyperparameters, and 2 is for k nearest neighbor hyperparameters, and so on. So this is how we can print this, and this is what I'm going to use. So I'm going to all these keys, instead of like mentioning their name, I'm going to call them from this list called as model keys. So the important things that we have to do here are creating this list that contains the name of all the models, creating this dictionary, and converting the keys into a list. So these three are like very important steps that we have to consider. So first is like creating the list, second is creating the dictionary, and converting the keys in the form of a list. So when I say model hyperparameters, model hyperparameters, and within this, instead of like instead of mentioning this SVC hyperparameters or logistic regression hyperparameters, I can say model keys of 0. So when I say model keys of 0, so the value that I will get is, so this is how I'm going to access my hyperparameters. Okay, so if I say keys of 1, I will get support vector machine classifier hyperparameter. So what I'm basically doing here is, instead of saying model hyperparameters of SVC hyperparameters, I'm going to say model hyperparameter model keys is equal to 1. So we are just doing this in a in a different way. The reason is we will be creating another for loop. So we'll be creating a function, and we'll be creating another for loop like we have done for this one. And in that case, instead of using the keys as such, it is always better to kind of load it to a dictionary and call the values using this index. So you will understand why we are doing this, but these are all the steps that we have to do before creating that particular function. First is creating the list, and then creating the dictionary, and converting the keys in the form of a list. Okay, so as we have done here, so I'm taking this list, and I'm converting all these values into a list using this list keyword. Okay, and now let's try to create this function that kind of do this model selection, but with different hyperparameters. Previously, we have trained our model with only the default values, right? Now I'm going to consider different hyperparameter values. So, and yeah, so here I'll just make a text here as applying grid search CV. So grid search CV is the hyperparameter tuning function that we have, and this is how we are going to select our models as well. So I'll create a function as DEF. So DEF stands for define, which is used for creating a particular function. And I'll name this function as model selection. Okay, so model selection. or let me put this as like this, model selection. So let me just change the case of m and n, sorry, m and s, and the parameters that I give to this particular functions are the list of the model that I have created, and the hyperparameter dictionary that I have created. Okay, so here I'm going to say uh, list of models, or let me just put this as, so let's not use the same name that we have created here. So let's put this as models. So first models, and the next thing is hyperparameter. So let me just put this as hyperparameter hyperparameter dictionary. Okay, so I just don't want to use the same variable name that we have here. So model hyperparameters model list. So let me just put this as list of models. Okay, so list of models and hyperparameters dictionary. Okay, so I don't want to use the same thing because like it will be directly passed to it. So I'm creating a function, and I'm mentioning like that we have to give two parameters to this. So the first parameter is the list of models, second parameter is the hyperparameters dictionary, the two attributes that we have. And the reason I'm creating this function is, if you want, you can add another model to it. So you can add, another classification model to it, and you can add the corresponding hyperparameters to that particular model as well. So that is this reason I'm creating this. So the name of this function is model selection, and here I'm creating an empty list. So result is equal to, I'm creating an empty list. So this is where, so in this list only we will store all the best hyper parameters. So we will like check which parameters has the best value. So we will be storing all those things in this empty list, which is result is equal to this square bracket. So this is how we can create an empty list. I'm going to say I is equal to 0. So we need this I. So this I is just for this index. So we have seen that we will call the hyperparameter using this index, right? So for that we are creating this I, and I'm initiating this I as 0. And this is where I'm going to create my for loop. For model in this list of models. Okay. For models in list of models, key is equal to model keys of I. So this model keys is nothing but the list that we have created here. Yeah, so this is the list that we have created, and I is the index. So the for loop, when the for loop runs for this first time, the value of I is 0. So model keys of 0 is nothing but, so when I say model keys of 0, or when I say model keys of 0 here, the value that it will print is logistic regression hyperparameters, right? So that is what I will get here. So when I say key is equal to model keys of 0, the value of key will be logistic regression hyperparameters. And now the parameters. So we have to check what is the parameter. So I'll create a variable as params. So this is where we are going to pass the parameters of this logistic regression model. So I will say model hyperparameter model of keys that particular index, right? So I can say this as um, the hyperparameters dictionary. So if you don't understand what we are doing here, is like, please hang on. So once I complete this, I'll also explain you clearly on all the steps that we are doing here. So it is, I'm going to say key. Okay, and then I'm going to increment this equal to 1, and I'll also print the name of the model, and I'll print the hyperparameters that we are using this params. Okay, so what we are basically doing here is like we are just specifying the model that we are going to use using this for loop, and I'm just creating this index so that we can call that specific model's hyperparameters. So I'll also explain this again, but this is for combining that model and the hyperparameter of that particular model. The reason is that I cannot use this set of hyperparameters, right? I cannot use this C and kernel while I am training the model with this logistic regression, right? So whenever I'm training with this logistic regression, I should use this set of parameters, and while I'm training it with this SPC, I have to use this SPC hyperparameter. So that's the reason, and yeah. Mm. So that is why we are creating something like this. And once we have done this, we can build our grid search CV function. So we'll create a variable as classifier. So classifier is equal to, we have to use the grid search CV function, grid set CV, and we have to give the model. So the first attribute that we have to give is like the model which using which we are going to train our data. Then we have to give the params, the parameter that we are considering, and CV. So what is the cross validation, number of folds for your this cross validation, and so on. So this is like creating the instance of this grid search CV using this classifier variable, and now we have to fit the data to this model, fitting the data to classifier, and I'm going to say classifier dot fit, classifier.fit x comma y. So this classifier is nothing but the grid search CV. So when this for loop runs for the first time, so grid search CV will be applied for logistic regression, and the logistic regression will be trained with the training data and test data. The result is that we will get the accuracy score for all the different hyperparameters that we have used. So we will get the hyper like accuracy score when we use hyperparameter 1 and hyperparameter 5, 10, 20, and so on. So this is what it kind of happens. And finally I'm going to store this best result in the list called as result. Okay, so this is why we have created this empty list. I'm going to say result dot append. So append is the function that we use in order to add new values to our list, and I'm going to do this again in the form of a dictionary. So I'm going to say model used, model used. So we have to mention model. So if you haven't watched my grid search CV video, the hyperparameter tuning with Python video, please watch that video first, and then only you can kind of understand how this grid search CV works and so on. So that is like very important. Otherwise, this may not make sense to you. And the next thing I wanted to add is the highest score for a particular parameter. So highest score is equal to, I can say, classifier dot best score underscore. So you have to mention this underscore after score. And the third thing that I'm going to consider is best hyperparameters. Okay, so best hyperparameters is classifier dot best params. So best, okay, so best params, this will be stored. And finally, let's create a simple data frame using this dictionary. So result data frame. I'm creating a data frame here, which is equal to pd dot data frame, and result columns is equal to, first column that we will put is the model used. So these are the column names for my model. And the second thing that we have to consider is the highest score. And finally, the best hyperparameters. Okay. So we are just finding the hyperparameters for which we are getting the highest result, and then we are storing it in a dictionary. And finally, we can return this return this data frame. So return result data frame. Okay. So this is the function that we are creating. Okay. So I think everything is correct in this case. Yes to score. Okay. So we have to put a comma here. These are different set of values. Let's run this. Now I'll call this model selection, and now I'll pass my models that I'm comparing, which is my models list, and then this model hyperparameters. Okay, because these are the two parameters that we have to pass. One is we have to pass a list that contains the name of the models that we are using, and then we have to pass a dictionary that contains the hyperparameter values. So first is the models list, and the second one is model hyperparameters. Okay, we run this one. The models list is not defined. Okay, I think I didn't run this cell maybe. Yeah, so I didn't run this cell, so that is the reason. I'll just run all these things again. Accepted. Okay, so there is some issue that's happening in this code. Let me just check this one. Okay, so this should this result thing should come out of the for loop. As you can see, there is a for loop that we have here. So come out of this. Okay, let me run this again. So training the support vector classifier will take a bit more time because we are considering like two set of hyperparameters in this case. So what happens is like in the first set of cases, logistic regression will be trained for these different hyperparameters. C is equal to 1, C is equal to 5, 10, 20, and so on. And after that, for support vector classifier, we will train with kernel is equal to linear and C is equal to 1. Then kernel is equal to linear and C is equal to 5. Then linear 10, linear 20. And then after that, kernel poly and C value of 1, 5, 10, 20. All this will be trained individually and so on. So what happens here is, so we have already created a list which contain the four models: logistic regression, SBC, k nearest neighbor, random forest classifier, right? And we have created the set of hyperparameter for the corresponding models as well. And then we have created this list called as model keys. So these three things are important, as I've told you before. Now we have created this function called as model selection, and the two attributes or parameters that this particular function takes are list of models and hyperparameters dictionary. So you have to pass these two values to it. And within this function, what I'm doing here is I'm first creating an empty list called as result, and I'm creating this I is equal to 0. And after that, I'm performing this for model in list of models. So when the for loop runs for the first time, it will check like what is the first value in this list of models. So the first value in the list of models is this logistic regression of maximum meter 10,000, right? So this model value will be logistic regression maximum meter 10,000, and key is equal to model keys of I. So when I say model keys of I, the first time the for loop runs, the I value is 0 because I have initiated the value here, right? So model keys of 0 is nothing but it's same of saying model keys of 0, which is equal to logistic regression hyperparameters. And so here the value of this key will be this logistic regression hyperparameters. After that, params. So here we are passing the parameters of this logistic regression. So I'm calling that by parameters dictionary, which we are passing key. So it is similar to saying model hyperparameters. Within this, we are saying like logistic regression hyperparameters. Okay, so let me just copy this and paste it here. So it is like similar, like same way of saying this. So instead of saying model hyperparameters of logistic regression hyperparameters, I'm going to say params hyperparameter dictionary key. So it is like both are the same things. So as we are doing this in for loop, this is more efficient way of doing this. And after that, I'm incrementing this I value. So the reason is that the second time the for loop runs, it will take the model as SVC and it will automatically choose this SVC hyperparameters. If you don't increment this I plus, so I is equal to I plus 1. So in that case, what happens is that the model that is trained will be SVC and the hyperparameter will be considered as these hyperparameters. So we don't want that, right? So we want logistic regression and the corresponding logistic regression hyperparameter, SVC and this hyperparameters. So that's why we are incrementing this I. So first we have initiated this and we are incrementing this. And every time we are just printing the models and the parameters that we are using. So we are printing it, and after that we are training a grid search CV, and we are printing the best results and so on. So this is the first set of value for which the grid search CV is trained. First with, it will train the logistic regression model with C value 1, 5, 10, and 2 on. So this is what we are printing here. Print model and print params is what is happening here. So this is when the for loop runs the first time, and after that we are training us. So the for loop, so totally the for loop runs for 4 times. So second time it runs, it will train our support vector classifier, and it will check for these different hyperparameters: linear, poly, RBF, and sigmoid, these values. So third time it runs, it will train with this k nearest neighbors classifier and so on. I'll also put another dotted lines here so that you kind of understand the count of this for loop. Let me run this again. Okay, so this will take some time. Okay, so this is when the for loop runs for the first time. This is when it runs for the second time. So here we are passing this grid search CV. So again, if you want to understand this performance or how this grid search CV works, please watch my videos on hyperparameter tuning, like a theoretical video as well as the hands-on video that we did. I'll also give the link of that video in this video description. So you just have to watch all the videos in my module 8. There are like 5 or 6 videos, so please watch all those videos. This is like 8.6, so watch all the 5 previous videos, so then only you can understand this clearly. So grid search CV, what it basically does is, so it will take a model like logistic regression, and it will try to find the accuracy score when we are using like this different hyperparameters. So when you are using c is equal to 1, you will have a accuracy score like, let's say, 80. And let's say when we are using the hyperparameter value as c is equal to 5, we will get a different accuracy score and so on. So it will calculate all those accuracy scores. So each time the for loop runs, we will check this for each model that we are considering. After that, once we are like, completing this training and so on, we are finding the best result. So I'm saying like model used is equal to model. So this model is nothing but the values that I'm taking from the list of models. So this one. So this logistic regression. So first time the value for this model is model, and then we have this classified dot best score. So what happens is like it will tell you what is the highest accuracy that particular model has reached. So what is the for all these four considerations of this hyperparameter for 1, 5, 10, and 20. What is the highest accuracy that you are getting, and what is the best parameter? So best parameter means for which hyperparameter you are getting highest accuracy, whether you are getting the highest accuracy when using 5, or you are getting highest accuracy when using 20, and so on. And similarly we get for all these things. So for which set of for which combination of this kernel and c you are getting highest value, and what is the highest accuracy and so on. And we are just loading it in a pandas data frame, right? And we are creating this column names as model used, highest score, and best parameter, and this is our final result. Okay, so as we can see, so we have used like 4 models. So this is the first column, name of the model used, what is the highest accuracy for that particular model, and what is the best hyperparameters for that model. So how we have to infer this is, when using logistic regression, the highest accuracy score that we are getting is 0.8315, which is equal to 83.15 percentage. So this is in this zero, like in the range of 0 to 1. So this is actually the percentage value. You can just calculate this one. And you are getting this highest accuracy of 83 percentage when you are giving the c value as 5. And if we come to the next one, when using the supported classifier, the highest accuracy that you are getting is 82.8, almost 83 percentage, and you are getting this highest value while you are giving the hyperparameter values as c is equal to 1 and kernel is equal to linear. So while using this hyperparameter, you are getting the highest value. So this is for k nearest neighbor. So instead, like if you use different k nearest neighbor values, like as we have mentioned here, 3, 5, you will get less values. Sorry, I think like the value is 5, right? So okay, so n neighbors value is 5. So instead of using a n value of 5, if you use 3 and 10, you will get less values. Similarly, if you use poly, RBF, or sigmoid, and if you use like 5, 10, and 20, you will get lesser accuracy score. So that is what we are understanding from here. And for random forest classifier, 83.8 is the highest accuracy that we are getting, and we are getting that when we are using the n estimator is equal to 100. So if you use like 50, 40, or 30, we are not getting highest accuracy. So this is how you can compare different, not only like models with default hyperparameters, but with different set of hyperparameter values. So these are all the different hyperparameters that we have considered. And once we have come to this conclusion, so now we will split our data into our training data and test data. And instead of training it with logistic regression or SPC or k nearest neighbor, we will train our random forest classifier model. And the important thing is we will choose this n estimator is equal to 100. So this is how you can kind of do model selection as well as hyperparameter tuning for multiple models. So in this case, I have just considered like few hyperparameters so that this code kind of looks simple. So apart from the C, we also have different hyperparameters for logistic regression and for k nearest neighbors, as well as for random forest like random forest also. So if you see this, k nearest neighbor, we also have this different set of values that we can consider. So along with this n neighbors, so you can just put a comma here and you can just create a list with all these values as well. So this is just similar to this kernel and c. So here we have considered two hyperparameters. In other cases, we have just considered only one hyperparameter. So you can also use these hyperparameters as well, and you can train that for that combination as well. So this is how you kind of you can do this model selection and hyperparameter tuning. So once you've done that, once you have find which is the best model and best hyperparameter, do a train test bed and train with that particular hyperparameter. So what will be the next step here is, I will split my x and y. So I have this x and y, right? So I have this x and y, so I will split this x and y to training data and test data. So once I split this, I will train my training data with my random forest classifier, and I will pass my n estimated value as 100. So this is the best result I get. So this is how we can do this model selection in Python. So let me just put text here as my inference. Random forest classifier seem to have the highest accuracy. Or let me put this as random forest classifier with n estimators is equal to 100 as the highest accuracy. Okay. Okay, so highest accuracy, and it's not like this is the only result that you get. So if you consider different hyperparameters, there can be different result also. You may also get like k nearest neighbor can also be a good model, but it is like highly unlikely. But if you consider different hyperparameter, you may get a different result. In this case, I just considered only like one parameter in each case, except for SPC where we have considered two hyperparameters. So you can try that well, where you can consider different hyperparameters as well. And I hope that you have understood all the contents covered in this video module. We have discussed about the topics such as cross-validation, hyperparameter tuning, model selection, etc. And the next topic that we are going to move on is model evaluation. Model evaluation is one of the most important and basic tasks that we have to do in any machine learning use case. And the significance of this model evaluation is that it helps us to understand how accurate our model is and how is the performance of our model. So we try to quantify the performance of this model, and this is what we call as model evaluation. And the first topic in this model evaluation is accuracy score and confusion matrix. So in this video, let's try to understand what is meant by this accuracy score and what is meant by this confusion matrix and how we can implement this in Python. So this will be the agenda for today's video, and let's get started. So the first thing that we have to discuss here is the types of supervised learning. So we have discussed this like several times before in our machine learning course. So we know that we divide supervised learning into two kind of tasks. One is classification and regression. So a classification is a problem when we have to predict a particular class or a discrete value, whereas regression is about predicting a quantity or continuous value. Let's say that we are predicting whether a person is going to get a job or not. So this is like an yes or no question where yes is one class and no is another class. Whereas if you try to predict what is the salary that the person is going to get from that job, then it is called as a regression problem because we are predicting some numerical value, some quantifiable value. Whereas in the classification, we just try to classify the data points. So this is the difference between these two. The example of this classification is like predicting whether an object is red in color or green in color, or true or false, whether a person is having diabetes or not. So this is like example of classification problem. Whereas predicting the salary of a person or age or predicting the price of a house or a car, so these comes under regression. Okay. And the model evaluation technique for classification problem, so one such example is accuracy score. Okay. And in the case of regression, we cannot use this accuracy score, so I'll explain you why we can't use that. And whereas in the case of regression, we use this error values like mean absolute error, mean squared error, etc. So we will discuss about this regression evaluation matrix later, but let's try to understand about this accuracy score. So how we are calculating this, and what is the limitation of this accuracy score and why we need this confusion matrix. So these are the things that we will be discussing in this particular video. So I'll just start with the definition of this accuracy score. In classification problems, accuracy score is the ratio of number of correct predictions to the total number of input data points. Okay. So what we take here is like we need two values. One is the number of correct predictions made by the model. Okay. Divided by how many total data points are there for predictions. So let's say that we can consider the accuracy score formula something like this. So accuracy score is equal to we have to take this number of correct predictions. So we have to divide it by total number of data points, and so this value will be between 0 to 1. So like it will be 0.80 or 0.90. So if the accuracy score value is 0.95, that means the model is 95% accurate. In order to convert it to percentage, we can multiply it with 100. So the value will be in percentage. Okay. So let's try to understand this with an example. Let's say that the number of correct predictions made by the model in a case is 128. Okay. Let's say that we are building a machine learning model that can predict whether a person has diabetes or not. And so out of the test data that we are going to predict, the model is making correct predictions for 128, and the total number of data points that we have is 150. Okay. So we are checking 150 people. So based on like some factors like what is their age, what is their gender, and so on. So that let's say that there are like these factors, and based on these factors we have to determine whether that person is diabetic or not. So we are checking this for 150 data points, or you can consider this as 150 different people. Out of this 150 different people, let's say that the model has predicted correctly for 128 people or 128 data points. So you just have to plug in these values. So number of correct predictions is 128, and the total number of data points for which we are predicting is 150. So we just have to divide it, and when you divide 128 by 150, this is the value that you get. So 128 by 150 is equal to 0.853, and when you multiply it with 100, you will get 85.3 percentage. So the accuracy score of your model is 85 percentage. What does this 85 percentage means is, if you using this model, if you try to predict for 100 data points, you will get correct predictions for 85 data points. So this is what accuracy score means, generally speaking. So there is not a thumb rule, but we can say that if the accuracy score of the model is like greater than 80%, then it is like a decent performing model. If the accuracy score is like greater than 90 or 95, then it is like a very good model that can make like accurate predictions. So we can import this accuracy score from this sklearn module called as sklearn.metrics. So I'll show you in code as well how we can do this, but you can remember that we can import this from sklearn.metrics import accuracy score, and I'm sure that most of you might already know this. So like there is one limitation of this accuracy score. So we have discussed all these things, and we have not like we have seen that this is how we can quantify the performance of the model, but there is like one significant limitation to this accuracy score. So accuracy score is not reliable when the data set has an uneven distribution of classes. So this is very very important. Let's say that we are training our model to predict whether a person has heart disease or not. So this is again two classes: person with heart disease, person without heart disease. Let's say that the total size of the data set is like 1,000. If there is like uneven distribution, in that case accuracy score can be misleading. Okay, so we cannot rely on accuracy score. Let's try to understand this with an example. So let's say that we are building some deep neural network in order to predict whether an image represents either a dog or a cat. Okay, and the total number of images we have in the original data set are 800 dog images and 200 cat images. Okay, as we can see here, there are two classes. First class is dog and the second class is cat. Here, as I've told you, there is a very high uneven distribution of classes. So it is like 4:1 ratio of dog images to cat images, and like the dog images is the number of dog images is very high compared to the cat images. When we have a data set like this, if we train our neural network or any machine learning model with this kind of data, the machine learning model cannot understand the difference between a dog image and a cat image, just because the number of images for one class is very high. So what happens is it will predict all the images as dog. It won't predict any cat images as cat. So this is the problem with uneven distribution of data. So let's say that the number of images predicted as dog is 1,000. So we have, let's say that we have trained our neural network with this 1,000 images, and we are like again predicting using this neural network, we are predicting with the training data. Let's say this is our training data, which is 800 dog images and 200 cat images. As I've told you, as there are there is like insufficient amount of cat images, all the images will be predicted as a dog. So there is a possibility for this. So let's say that out of 1,000, all the images has been predicted as dog. If you calculate the accuracy score in this case, let's see what is the value that we are getting. So the number of images predicted as cat is 0, obviously, because all the images are predicted as dog. So the number of correct predictions in this case is 800, right? Because obviously, so out of these 1,000 images, 800 are dog images. So we will consider these as correct predictions. Whereas the total number of data points in this case is 1,000. So if you want to find the accuracy score, we will divide it by 800 divided by 1,000 into 100%. So this is what we have seen before. Number of correct predictions divided by total number of data points, and this is what we get. 800 divided by 1,000 into 100. So the final accuracy score that you get is 80%. Okay, right? So we can say that 80% is a good accuracy score, right? But this is not a good performing model. So this is actually an underperforming model. Let's try to understand why. So we are going to use this trained model that has been trained on uneven distribution of dog images and cat images. And now let's say that we have a different test data. And in this test data, there are 200 dog images and 200 cat images, right? And the model hasn't seen these images before. So when you use that model, which is trained on an uneven distributed data set, if you use that particular model, again, all the images will be classified as dog because the model doesn't understand how a cat image looks like. So out of these like 400 images, so there are like 200 dog images and 200 cat images. all the images will be predicted as dog by our machine learning model, and no images will be predicted as cat. So in this case, the total number of correct predictions is 200, and the total number of data points is 400, right? Because out of these 400, 200 are dog. So 200 are obviously correct, and the remaining 200 are wrong, right? So the total number of correct predictions is 200, and total number of data points is 400. In this case, if we try to find the accuracy score, it is correct predictions by total number of data points, which is 200 by 400. In this case, the accuracy score is 50 percentage. So there is like a huge difference between this accuracy score, which is 80 percentage, and this accuracy score. So this is why accuracy score is not reliable when there is an uneven distribution of data. Okay, so if there is like let's say that in the training data there are like an uneven distribution, in that case we may get an high accuracy score, but it is actually a wrong score because all the images are predicted as scared. So we can say that the model is not performing well, and we can capture this incorrect performance of the model when only like when we have a data set like this where the distribution is kind of even. So this is where the metrics like confusion matrix or precision and recall comes into play. So in this video, let's try to understand how confusion matrix kind of helps us in order to understand this this limitation of this accuracy score and how we can use that efficiently. In the next video, I'll explain you about this precision and recall and all those things. So let's discuss about this confusion matrix now. So confusion matrix is a matrix used for evaluating the performance of a classification model. So again, we can use this only for classification model, and it gives more information than the accuracy score. So like let's say what is that particular information that is helpful for us. Let's say that this is the true class of the data points, so positive and negative, and this is the predicted class. So in this case, the previous case, the two classes are dog and cat. So in this case, we are considering as positive and negative as the two classes that we have. So this is the true class, so true labels, and this is the value predicted by our model. Let's say that we are doing this for COVID-19 test cases. So let's say that there is some test like RT-PCR or this rapid antigen test. So we have these two tests for COVID-19. Let's say that uh, we have this true class and predicted class. So true class is whether a person is really having this COVID-19 infection, and predicted class is, let's say, the values predicted by our model. So let's say that we are building a ML model that can predict whether a person has COVID-19 infection or not based on certain symptoms. So let's consider this. So the first quadrant of this confusion matrix represents my true positive. So what does this true positive means is, so the true class of the person is positive. That means a person actually has a COVID-19 infection, and the model also predicted correctly. So you have to see this label and this label. So this is my true class and this is my predicted class. So both these things matches, right? So we can say that this is my correct prediction. So what this basically means is a person really has COVID-19 infection, and the model has also predicted correctly. And what does the second box represent is, true class is negative. That means a person doesn't have any COVID-19 infection, but the model has predicted that that person has COVID-19 infection. So this is what we call as false positive, because this positive is not correct one. So this is an incorrect one. Whereas we call this as true positive, which is represented as TP because the person is actually positive. And the third quadrant in this case is false negative. So in this case, the true class is positive, which means a person has COVID-19 infection, but they have been predicted as negative. So this is what we call as false negative, and the final quadrant is true negative. So the person doesn't have COVID-19 infection, so they are like really negative, but the model has also, so the model also predicted as negative. So this is what we call as true negative. So these two green color boxes represent my correct predictions, and these two red color boxes represent my wrong predictions. So true prediction is nothing but, so TP means when a person is tested positive for COVID-19 and the model also predicted correctly that they have infection, so it is called as true positive. And what is meant by this true negative is that a person doesn't have COVID-19 infection and the model has also predicted correctly that they are negative for COVID-19 infection. So these two are my correct predictions. And false positive is something when a person doesn't have any infection. So we have this true class is negative, but the model has predicted it as positive. So we have this as false positive. And finally, we have this false negative, which means like a person actually has the infection, but the model has predicted that the person doesn't have any infection. So TP plus TN count represents my correct predictions. Okay, true positive and true negative represent my correct prediction, and false positive and false negative represent my wrong predictions. And you can use this sklearn.metrics.confusion matrix in order to use this confusion matrix. We will also discuss how we can implement this in Python. And again, so this is a very important concept that you have to understand. So there will definitely be questions on this particular topic in most of the machine learning and data science interview that you attend. Okay, so the easiest way to understand is by through this COVID-19 infections or any other this medical condition, because like there is like a true positive and false positive, false negative and true negative cases. Like these terms are used in the clinical field as well. So this is how like they kind of represent people who have been tested positive if they are if they don't have any infection and things like that. So this is an actual term that is used in the clinical field, and this is what we use in confusion matrix as well. So the advantage of this confusion matrix is, even like when there is this uneven distribution of classes, even though there is like this high accuracy score. So in this case, we know that the accuracy score is high. But when you implement a confusion matrix in such cases, we can clearly see whether the model is making good predictions, or whether all the models has been predicted as one class. So this is how confusion matrix will be helpful for us. And now let's try to understand how we can kind of implement this in Python. Okay, so I'll open my Google Colab. So I have this code ready already. So the data set in this case that I've used is this art disease prediction that we have used before. I'll also give the link for this video where I have completely explained you how you can use this data set in order to predict whether a person has this art disease or not. So I'm not going to go into all these details. Let's directly come to this model evaluation part. So we have processed this data set, splitted it into training data and test data, and we have trained our logistic regression model with this X train and Y train. Okay, so this is my model evaluation part, and I'm going to calculate my accuracy score. So I'm importing my accuracy score function from sklearn.metrics. Okay, and I'm creating a variable called as extreme prediction, and I'm going to predict the values. So model is my logistic regression model, which is trained on the training data, and I'm predicting the labels for my training data. Okay, so extreme prediction is equal to model.predict. So I'm storing all the predicted labels in this extreme prediction. Okay, and I'm going to calculate the accuracy score. So that accuracy score is stored in the variable called as training data accuracy. So I'm using this accuracy score function, and within this I have to mention the true label and the predicted label. In this case, the true label is Y train, which we have obtained from this train test split. So here your Y train, okay, which is my training data prediction, and the prediction made by the model, which is X train prediction. So accuracy score will compare these two set of arrays, and it will give us the accuracy score. So in this, if I print this accuracy score, the value is 0.8553, which is equal to 85.53 percentage. And if you want to round this to percentage, you can use this round. So round will kind of it is used to remove some decimal places, or it can also convert like floating point value into integers. So it will basically round the values. So what I'm doing here is I wanted to round this training data accuracy, which is in this range of like 0.85 or something. So I'm going to multiply it with 100 in order to convert it to percentage. What does this 2 represent is, I want two decimal places. I want two decimal values. So if you want like three decimal values, in this case we have to mention 3. So this has been rounded, so it is like 85537. So this 3 has been rounded to 4, as we have the value as 7 in this case, and we are adding a percentage symbol to it. So as you can see, in this case the accuracy score value is 85.54 percentage, which means if you predict for using this model, if you predict whether a person is having heart disease or not for 100 people, 100 data points, the model can make correct prediction for 85 people. So this is what we call as an accuracy score. So this is the accuracy score on the training data, and this I'm just doing the same thing. The only difference is that I'm calculating the accuracy score for test data, and this accuracy score is like very important. The training data accuracy is not that important, but test data accuracy is very important. So I'm calling my X-test prediction, where I'm storing all the predictions made by the model, and I'm storing this to X-test prediction, and I'm using this accuracy score function. So Y-test comma X-test prediction. So I'm comparing the true test labels and the labels predicted by my model using this accuracy score function, and the accuracy score is 80.32 percentage. So when I round this to two decimal places, I'm getting the percentage value as 80.33 percentage. So I'm sure that most of you would know this already, calculating this accuracy score. Now let's move on to confusion matrix in order to understand that how we can represent that matrix using this confusion matrix. So from sklearn.matrix, I'm importing confusion matrix. So this is the function in order to calculate this, and I'm creating a variable called as CF matrix. So CF matrix, confusion matrix of y test and x test prediction. So it is just similar to this step. So instead of using accuracy score, we are using this confusion matrix function, and we are storing this matrix to CF matrix. So as you can see, the result is stored in a matrix. That's why we are naming this as confusion matrix. I'm creating a variable as a short form of CF matrix, and I'm printing it. So this is the value that I'm getting, 22, 6, 6, 27. But we are not sure what does these values means, right? Like in this case, we have two labels. So the first label is 1. 1 means a person is having R disease. 0 means a person doesn't have R disease. Okay. But in this case, we are not sure. Like what does this 22 mean, 6 or 27 mean? So we are not sure which is true positive or which is false negative and so on. You can go to this sklearn.matrix.confusion matrix documentation in sklearn. You can see the order here. So in the case of binary cases is when you have like two classes. In this case, we have two classes as person with R disease and person without R disease, right? So this is the order. First is true negative, and then we have false positive, false negative, and true positive. So these are like the order that we have, and you can kind of get this values using this dot travel function. So I'm going to like extract these values using the CF matrix dot travel. CF matrix is where I have stored my confusion matrix, and we will get all this true negative value, false positive value, false negative value, and true positive value. So this is how you can extract all these values. And also the other important thing is you can also build this confusion matrix for multi-class classification problem. If you see in this one, they have like multiple classes, ant, bird, and cat, whereas in this case we have only two classes. So you can also use this confusion matrix for multi-class classification problems as well. And if you are not sure on what does this number represents, and if you want to represent this in an heat map, that is also possible. And it is like a more efficient way in order to understand this confusion matrix. So it is like similar to how we have built this confusion matrix here. So you can import this cborn library, as we know that this is a data visualization library, and we are going to load this confusion matrix in the form of a heat map. Okay, so I'm calling this sns.heatmap function, and the parameter I'm passing is my confusion matrix, and annotation is equal to true. So like I want these values, so label values. So that's what this annotation means. Now let's see what does this confusion matrix, this particular heat map represents. So we have the value 0. Here also we have the value 0. So this means my true prediction. So you can just see this label in the y-axis and the label in the x-axis. If both the things match, that is my correct predictions. So in this case 0, let's say that this is my true class, okay, true label, and this is my predicted label. So in this case, what does this 22 means is like 22 data points as the label 0, and all those 22 data points has been classified as 0. And this 27 means is like those 27 data points as the label 1, and they have been predicted as the label 1. So these are my correct predictions. So these are the green colored boxes represented here. So you just have to see the label in both the sides. Here it is positive, where it is also positive. So we have like green color here, which is the correct prediction. So in this case, we have positive and negative. So there is like a mismatch in the classes that we have in this case. So this is a wrong prediction. In this case, if you see in this third quadrant, we have negative and positive. So it is a wrong prediction. So here, if you see, this is negative and this is also negative. So this is a true prediction. So that is the idea here. So here we have the value as 0 in the x-axis for this quadrant. The here also the value is 0. So this represents, this 22 represents my correct prediction. And in this case, 1 represents like here we have 1, here also we have 1. So 27 is my correct prediction. And the 6 and 6 are my wrong prediction. So what this means is like 6 people who so let me go to the 0. Let's try to understand what this 0 means. So 0 is LTR means a person doesn't have R disease, right? So this 6 means 6 people doesn't have R disease, but they have been predicted as 1. So if you see this quadrant, you have to just see the horizontal label and the vertical label. So if you go here, this is my 0 and this is my 1. So there is a mismatch. So people doesn't have R disease has been predicted as people with R disease. So there are like 6 wrong predictions in this case. And in this case, like people do have R disease, so we have the label 1, and they have been predicted that they don't have R disease. So these two represent my wrong prediction. So you just have to see the labels in the y-axis as well as the x-axis, and you will know which are the correct predictions. So when there is like a problem like this, so we have seen, right? So when we have a problem like this, when there is a chance that the data is undistributed, even though the accuracy score is kind of high, you can try to build this confusion matrix and heat map to understand whether the model is making good prediction, or all the values has been predicted into only one labels. Okay, so that is the importance of this confusion matrix. So in that case, the model will be predicting like only zero will be predicted in both the cases. No prediction will be made for the class one. So that is what happens for this uneven distributed data, and that is where we use this confusion matrix. And again, we have also metrics like precisions and recall, which we will discuss in the upcoming video. So this is for only binary classification problem, right? You can also again use this for multi-class classification also, when we have like more than two labels. And I have another example for you, and I'll share this Google Colab file link in the description of this video. You can check that out. I have given a link of a Colab file, which is again an example for multi-class classification problem. So we have already worked on this in our channel. So this is the MNIST and written digit classification using neural network. I'll also give the link for this video in the description as well. So we have worked on this. So here we are predicting whether an image, like what is the digit represented in the image. So the images that we are considering, ranges from 0 to 9, whether it is 0 or 1 or 2, all the way up to 9. So this is what we are predicting. And here also we can build this confusion matrix. So here, so this is the accuracy on the training data, which is 90, like 0.989, which means like 98.9 percentage. So this is my training data accuracy, and you can get this test data accuracy using this evaluate function when it is deep learning problem. Okay, so this is when we use sklearn models. This is when we use like neural network from keras and tensorflow. So here we are building this neural network using this, sequential from keras. So let me just open this. So yeah, so we are building a neural network here using keras, and when you do that, there is a function called as evaluate, and this will calculate my test data accuracy. And in this case, the test data accuracy is 97.1 percentage. So this doesn't give any more information. So we can know that out of 100 values, the model can predict correct values for 97 data points, right? So now let's try to understand how can we build this confusion matrix. So yeah, so this is my confusion matrix, function that we are importing. So let me just go to this one. So yeah, so from TensorFlow.math. So we don't have to import this from sklearn.metrics. So this is we are importing the confusion matrix from sklearn.metrics. We also have this function in TensorFlow as well. So TensorFlow.math has this function called as confusion matrix, but the function is the same. So in both the cases, the function is same. In this case, as we are working with keras and TensorFlow, we are importing the confusion matrix from TensorFlow. So I'm creating a variable called as confusion. So CONF mat, which is my confusion matrix, and I'm passing my y test and y pred labels. So y test is my true test data labels, and y pred labels is the label predicted by my model. If I print my confusion matrix, this is the value that I'm getting. So in this case, this won't make any sense. And now we can pass this confusion matrix to an heat map in order to understand this better. So here I'm building a heat map. So plt.figure, where I'm setting the size of this plot, and I'm saying sns.heatmap. So I'm constructing an heat map with this confusion matrix. So I'm just mentioning that annotation is equal to true. So fmt is equal to d means I want all the values in the form of integers. So I don't want any values in floating point values. cmap blues. So I'm just setting the color of this heat map. So PLT y label and x label. So I'm going to set the true labels as my y axis and predicted labels as my x axis. Now let's try to understand how we can infer this. So this is actually the same data that we have here. So instead of having this in numerical values, we are constructing a heat map. Now let's try to understand what does this signifies. I told you, right, when the two classes match. So in this case, so we have positive and positive. That means the predictions are correct predictions. So in this case, we have negative here and negative here. So this is my true predictions. So in this case, positive and negative. So there is a mismatch in the class, in this red color quadrant, in this red color quadrant. So you have to check whether the classes are matching. So this diagonal thing, so all the values in the diagonal represent my correct prediction, because if you see the corresponding labels here for this first quadrant, the y-axis value is 0. If you just come to this x-axis label, it is 0. So this is my true label, this is my predicted label. So what does this 969 represent is, if you go to this y-test prediction, so let me go here. So x test dot shape. So this is the pixel size of the image. So it is like a 28 into 28 image, and the total number of test data points that we have is 10,000. Okay. So in this case, the training data, let's see, uh, the number of training data that we have here, I think is 10,000. Yeah. Yeah, as you can see, so this is the white range shape, white test strip. So totally we have 60,000 training data images, which are like 60,000 images of numbers, and 10,000 test images. So the totally there are like 10,000 test images, and out of those 10,000 images, 969 images have the label 0. That means that image represents 0, and this 969 images has been correctly predicted as 0. So that is what we have here. So you have to see the y-axis label and the x-axis label. Consider this as x-axis and consider this as y-axis. So 969 images represent 0, and those has been predicted correctly as 0. So that is a match of class. If you see the next quadrant value, it is 1. That means one image and the true label of this image is 0 has been predicted as 1. So what does this signifies is an image that has the image of 0 has been predicted as 1, and in this case 1 again. So in this case only one image which is actually 0 has been predicted as 2. So that is what these values represent. If you see this 3, so 3 images which actually represent 0 has been predicted as 8. So this is how you can infer this confusion matrix. So if you see this 1122, so 1122 values represent the image 1, and they have been correctly predicted as 1. So if you see this 4 images of 1 has been predicted as 8, and so on. So if you see which has the highest value, 24. So what does this 24 means is the true label for these 24 images are 9, but they have been predicted as 4. So you can just understand like 9 and 4 may kind of look similar to the model, as you know these are like handwritten images. So these 24 images has been wrongly predicted as 4. So 9 like 24 images of 9 has been predicted as 4. So whereas if you consider this one, so there is 9 here and there is 9 here. So there is match of class. So this is how you can infer a confusion matrix in the case of a multi-class classification problem, and it is always better to load this confusion matrix into an heat map to understand it better. So if there is a match of class, then in that case it represent correct prediction. If there is like mismatch, that it represents wrong prediction. Or the other thing that you can understand is this diagonal represents my correct prediction, all the other values represent my wrong prediction. So here also this diagonal represent my correct prediction because we have match of class 0 and 0, 1 and 1. So for this, so similarly we have the 0 and 0 here, 1 and 1 here. So this diagonal represent my correct prediction. So this is how we kind of use this confusion matrix in order to understand like we kind of like understand the performance of the model better. Whereas in the case of accuracy score, it will just tell you that 97 percentage. So out of 100 images, 97 images will be predicted correctly, and for 1000 images, 970 images will be predicted correctly. So this is what this accuracy score means. Whereas if you build this confusion matrix, it will tell you what images are being predicted as what. So if you see this one, 23 images of 3 has been wrongly predicted as 5. So this is some information which accuracy score won't tell you. So this is why confusion matrix is very important for us, and like we can infer a lot from it. So that's it from my side, and I hope that you understand all the things that we have covered in this video about accuracy score and confusion matrix. In this eighth module, we are discussing about the topics such as cross-validation, hyperparameter tuning, model selection, and model evaluation. The previous video was on accuracy score and confusion matrix. So I explained you in detail about what is the concept behind this accuracy score and how we can find this accuracy score and confusion matrix in Python. So in this video, we are going to discuss about some more important evaluation metrics that we have, that includes precision, recall, and F1 score. As I have told you, these are some of the important model evaluation techniques that we have, which is used to tell us whether a model is good or bad, whether the performance is well or it is not that good. So this is what the importance of precision, recall, and F1 score is. So before diving into these topics, I'll just give you a quick recap of what we have seen in this accuracy score and confusion matrix. So if you wanted to get a clear understanding on this topic, please watch the previous video. I'll also give the link of that video in this video description. So we know that accuracy score is a very important evaluation metric that we have in machine learning, especially in classification machine learning problem, where we will try to classify the data points into different types or classes or categories. So you can say any of them. So it is basically the ratio of number of correct predictions made by our classification model divided by the total number of input data points that we have. So this is the ratio. So number of correct predictions divided by total number of input data points that we have. So this is the formula for it. and the value that you get when you divide this number of correct predictions by the total number of data points will range between 0 and 1. And if you want this in percentage value, you can simply multiply it with 100, so you will get the value in percentage. Okay, so 90 percentage basically tells you that if you use your model to predict for 100 data points, your model will give you correct predictions for 90 data points. So this is what accuracy score means. Let's try to understand this with the simple example that we have discussed before as well. So let's say that the number of correct predictions that is made by your model is 128 and the total number of data points is 150. So you simply like divide 128 divided by 150. So you will get the accuracy score as 0.853, and when you multiply it with 100, you will get the accuracy score as 85.3 percentage. So 85.3 percentage basically means out of 100 data points, your model can give correct predictions for 85 data points. Okay, so that is what this accuracy score means. And you can import this accuracy score from sklearn.metrics. So we have seen this before. So the main limitation when it comes to accuracy score is that it is not at all reliable when you have uneven distribution of classes. So what is meant by this uneven distribution of classes is, let's say that you are building a model that can predict whether a person has diabetes or not. So in that case, the two classes are person with diabetes and a person without diabetes. Let's say that there are like 500 patients in that particular data set, and let's say that out of the 500, 400 people doesn't have diabetes and 100 people have diabetes. So this is what we call an uneven distribution because there is almost a 4 is to 1 ratio. So when you have two classes or even when you have multiple classes, when the distribution is even, then only your accuracy score can give you like reliable values. So if there is like uneven distribution, in that case your accuracy score value will be high but it is not reliable. So if you want to understand this much better, please watch the previous video. I have explained that in detail with an example, so you will understand that better. So when we have this kind of confusion, when there is like where is this uneven distribution, so that is where we will move on to the metrics like confusion matrix. So as we have seen in the previous video, confusion matrix is simply a matrix, and again it is used for evaluating the performance of a classification model, and it gives the information that the accuracy score cannot give. So accuracy score will just give you the percentage, but this percentage can be deceiving, so we cannot rely on this completely. So we have this confusion matrix where we have four terms. So TP basically means true positive, FP means false positive, FN represents false negative, and a TN represents true negative. I hope that most of you would probably know this. So if you don't know what these things means, I'll explain you about this. So we can consider these two things. So this true class is basically my actual label values or actual class. Okay, it's positive and negative. You can think about this positive as person with diabetes and negative as person without diabetes, and you can also think about this positive as covid positive and negative means covid negative. So you can also consider that example, and this is the predicted value. Again we have this positive and negative, so this thing in this horizontal axis represent my true class or actual labels that is present in my data set, and predicted class represents the labels, the two labels negative and positive predicted by my model. Now let's try to understand what these four terms means. First, we have true positive. So what does this true positive means is, so let's say that 50 people in the data set, let's say that data set contains like 150 data points, and out of these 150 data points, 50 people have a covid infection positive. Okay, so they have like covid positive, and out of those 50 people, let's say that our model is predicting correctly that 40 people have covid. Okay, so this is what we call as true positive. So in this case, the true positive count is 40. Okay, so the total number of the total number of people with positive covid infection is 50, but our model is predicting correctly only for 40, so your true positive count will be 40. So it is basically, so the actual value and your predicted value are matching, so this is what we call as true positive. And tn means true negative. Okay, so let's say that out of we know that 150 people, 50 people have covid infection, so remaining 100 people doesn't have covid infection. Let's say that in this case, you can say that your model is predicting that let's say 80 people doesn't have covid infection. Okay, so that is what we call as true negative. So in this case, the actual value is negative and the model is also predicting the label as negative. So this is what we call as true negative. So true positive and true negative basically are your correct predictions, and false negative and false positive are your wrong predictions. So we cannot get this information when we use this accuracy score, because we will get only the percentage value. So false positive means the person doesn't have COVID, so they have like negative COVID infection. So this is my true class. So actually they don't have COVID, but the model has predicted that they are COVID infection positive. So this is what we call as false positive. And what this false negative means, so a person actually has COVID infection, as you can see this positive here, but they are predicted as negative. So this is what we call as false negative. So if you take this quadrant, you just have to compare these two things. So this class and this class. So if these two things match, it is correct prediction. Okay, so in this case, if you see this T in fourth quadrant, so the horizontal class that we have is negative, and the this vertical class we have is also negative. So these two things are matching. So we can say that these are correct predictions. So if you see the second quadrant, which is false positive, so here we have negative, here we have positive. So we know that there is mismatch of true class and predicted class. So our model is predicting these things wrongly. And in this case, if you see this F and false negative, we have positive in the true class and negative in the predicted class. So this is what these four things mean. Okay, so true positive and true negative contributes to your correct predictions made by your model, and false positive and false negative contributes to the wrong predictions made by your model. So this is like very important for us in order to understand whether a model is performing well or not. So basically, in ideal situation, you must have high number of true positive and true negative, and low number of false positive and false negative. Okay, so this is same as saying your model should have several or high number of correct prediction and minimum number of wrong prediction, which is false positive and false negative. Now we know that accuracy score is kind of a percentage value. It is like a single value, but when you build a confusion matrix, we have four terms, so four numbers are there. So our idea here is to build something, to build an evaluation metric that will give you a single score, so that we can understand the performance of our model better. So if you see this true positive, false negative, and true negative are basically the number of data points that is being predicted. So this is where precision recall and F1 score comes into play, where it will take into account these four terms. Okay, so these correct predictions and wrong predictions, so it will take all these things into consideration, and it will give us a better score. Okay, so let's try to understand how we can understand this precision recall and F1 score. So I'll start with the formula for precision, and after that I'll explain you what is the significance of this. Precision is equal to true positive divided by true positive plus false positive. So this is the formula. So we know that true positive, which is my TP, FP, and so on. So you can understand that. So precision is equal to TP or true positive divided by true positive plus false positive. And this value also range between 0 and 1. And if you want, you can also multiply with 100 in order to get it as percentage value. Now, if you just memorize this formula, it is not a good way, but you this actually seem confusing. So you may like confuse this with false positive, with false negative, and so on. But there is a better way to understand this. Let's try to understand what does this mean. So I'll give this confusion matrix that we have seen before. Now look at this denominator. So in the denominator we have true positive plus false positive. Let's try to locate this in this confusion matrix. So this is nothing but my true positive and false positive TP and FP. If you look at this, these two things actually mean the data points that are predicted positive by my model. Okay, so this is my predicted class, and in this case the predicted class is positive, as you can see, and this is like the positive values that are correct. So here the actual value, actual label, which is positive, matches with the predicted value positive. So this is again the labels that are being predicted as positive, but they are actually negative. So what is meant by this precision is, we take this true positive divided by the total number of predicted positive. Okay, so total number of predicted positive is nothing but true positive plus false positive. So you just have to look at this confusion matrix. So like precision is nothing but true positive divided by total predicted positive, because we know that if you just put a square here, so true positive plus false positive, so these are nothing but all the data points that are being predicted as positive. Now let's try to understand what does this signifies. So precision is the ratio of number of true positive to the total number of predicted positive. It measures out of the total predicted positive, how many are actually positive. So this is what precision means. So we know that it is a ratio, and we know that the value ranges between 0 and 1. Now look at the second statement. It measures out of the total predicted positive, how many are actually positive. So let's say that there are 500 people, and out of these 500 people, let's say that our model is predicting, let's say that 200 people have COVID infection. So it is like a positive predicted class. But in the actual reality, let's say that all 200 people doesn't have COVID infection. Only like 150 people have COVID infection. So in this case, the number of true positive value is 150, and the total predicted positive is 200, right? So I'll just repeat this again so that you can understand this better. So there are 500 patient, and out of this 500 patient, 150 people actually have COVID infection. Okay, but your model is predicting that 200 people is having COVID infection. So in this case, if you try to build this precision, the total number of predicted positive is 200. Okay, so it should go to this denominator, and the true positive is 150. So you will try to find this value, and this is my precision. So it will tell you what percentage of value is true positive out of this total predicted positive. Okay, so this is how you can understand this precision. And the importance of precision is that this false positive, so precision measures the error caused by false positive, as we have discussed in this COVID-19 infection. So it takes into account mainly the false positive errors. So it is measures the error caused by false positive, and means it is a good evaluation metric when false positive predictions are critical. So this part is very very important. So we know that we have this accuracy score, and we have this confusion matrix, precision, recall, and F1 score. And the interesting thing here is you don't have to take into consideration all these evaluation metrics. You just need like few metrics, but there is an interesting key that is hidden here. So, whenever your false positive predictions are critical, whenever you don't want to make false positive predictions, in that case, you try to have a model that has a minimum precision. Okay. So, one such example is face authentication. So, let's try to understand this sentences better. So, it measures the errors caused by false positive. If the number of false positive is very high in your model, in that case precision value will be low. If you have like less false positive values, in that case your precision value will be high, because we know that false positive is in the denominator and it is like inversely proportional. Now let's try to understand what we mean by saying that false positive predictions are critical. So let's consider this example of face authentication. Let's say that I have installed a face recognition system in my door. So there is a camera that will detect my face whenever I come in front of the door, and only when my face is detected, the door will unlock. Okay, so it will happen automatically. So in this case, true positive is when I stand in front of the door, and it will scan my face and it will tell that this person is Siddharthan, and the door will open. So this is what we call as true positive, because in this case the actual class is my name, and the predicted class is also my name. So in this case the two things are matching, and then we have this true positive. Now let's try to understand what is meant by this false positive. Let's say that someone else is coming and they are standing in front of the camera, and this face recognition system mistakenly tells that that person is Siddharthan. So this is what we call as false positive. So in actual reality, it is not positive. It is actually negative, which means it is, so that person is a different person, but the model or the face recognition system is telling me that it is me. So this is what we call as false positive. So in this case, false positive rate is very critical, right? So in the case of face authentication, we have to minimize the number of false positive that we have. So it shouldn't like recognize different person as me. So this is very very important. Whereas if you consider the rate of false negative, so what does this false negative means? I stand in front of the camera and it tells me that you are not Siddharthan. So this is what we call as false negative, which means as a true class, in reality it is me. So consider that positive is my name, negative is some other people. So it should open the door only when it is me. The person standing in front of the camera should be me. Okay. So false negative means I'm standing in front of the camera, and it is, instead of predicting my name, it is predicting that this person is someone else. So this is what we call as false negative. And in this face authentication, in most cases false negative is not a big issue, because I can like redo this. I can like reset this camera, and I can stand in front of the camera again so that I can be detected correctly. Whereas false positive is very critical, because there can be someone who doesn't belong in the home, and in that case, if the face recognition system unlocks the door, that becomes a problem. So in this case, false positive value is critical, so we will try to minimize this. So whenever you wanted to build a system, or whenever you have a problem statement in which you cannot have several false positive, in that case we will try to build a model which has like good precision score. Okay, so precision score of 0.95, which is like 95 percentage, will tell you that like if I scan in front of like the camera like 100 times, it will correctly predict me for 95 times, and five times different people will be predicted as me. Okay, so that is what we mean by this precision of 95. Okay, so if we consider this COVID-19 example, so precision of 95 means, 95 percentage of the people are predicted correctly as COVID infection positive people, and false positive. It means like 5 percentage, like out of 100 people, 5 people will be wrongly considered as COVID infection positive. So this is what we mean by this precision, and this is where like precision comes into play. So whenever you have a business problem statement or any problem statement where false positive value is critical, in that case we should build a model that has a good precision score. That means like high precision score. Now, let's understand about this recall. So again, let's try to understand the formula. Recall is equal to true positive divided by true positive plus false negative. So you don't need to memorize these formulas. So you don't need to memorize this. You just need to understand this one. So second formula is easy to understand, and it is like easy to interpret what this means. So precision means true positive divided by total predicted positive, and recall is true positive divided by true positive plus false negative. Now let's try to understand why we are choosing these two terms alone. Again, we are going to the confusion matrix image that we have, and we know that this represents my true class or the actual values, and this y-axis represents my predicted class, positive and negative. Now let's try to group this true positive and false negative. So this means true positive and false negative. If we draw a line here, what this basically means is total number of data points that is positive as true class. Okay, so we can write this as recall is equal to true positive divided by total actual positive. Okay, so what this total actual positive means, again, let's say that there are 500 people and we are building a model that can predict COVID-19 infection. And out of this 200 people, let's say that let us say that 250 people have COVID-19 infection positive. So all these people have COVID-19 infection. How many people? 250 people. But our model is saying that out of 500, 200 people is COVID-19 positive, and let's say that remaining are false negative. So remaining doesn't have COVID-19 infection. So in this case, the true positive value will probably be, so if we consider like the true positive, so I'll just repeat this once again. So out of 500 people, actually speaking in the real life, 250 people have COVID-19 infection positive. Okay, but our model is saying that only 200 people have COVID-19 infection positive, and remaining 300 people doesn't have COVID infection. So here the true positive count is 200. Okay, and the false negative count is 50, because the total number of people with COVID-19 infection positive is 250. Okay, so true positive count is 200 and false negative count is 50. So these two things contribute to your total actual positive. So you can think about this total actual positive as total number of people in real life that has COVID-19 infection, but in this case the model is predicting wrongly. So you can understand this recall as the ratio of number of true positive to the total number of actual positive. So it measures out of the total actual positives, how many are predicted as true positive. So this will, again, it is the ratio and the value will range between 0 and 1. So 95 means like it's similar to 95 percentage, but this is not, this 95 percentage is not similar to 95 percentage of accuracy score. So this is different. So this percentage is different. So it measures out of the total actual positive. So in this case, if you think about it, so 250 people are actually they are like positive for COVID-19, right? So out of 250, we have the true positive rate as 200. So here the recall will be 200, which is my true positive, divided by total actual positive is 250. So the answer that you are getting is your recall. Okay. So as we have discussed before, precision is useful when the false positive predictions are critical, as we have seen in this face authentication example. Whereas recall is critical when the false negative predictions are very, very critical. Let's try to understand this. So recall measures the error caused by false negative. So if there are like several false negative, predictions in your model, in that case, a recall value will be less. So if your false negative value is count, your recall value will be high. So our main goal is to have, maximum value of this precision and recall. Okay, so it measures the error caused by false negative, and hence it is a good evaluation metric when false negative predictions are critical. So there can be like business problems and problem statements where you should not have several false negative values. So your model should not like predict this false negative value. So in that case, we try to focus mainly on recall instead of like precision. So we need precision as well, but this recall, we will be giving high importance. Let's try to understand why this is. And I'll also give you an example of when this false negative predictions are critical. So one such example is diagnosis. So let's say that, let's say like we are, let's consider a serious, this is like cancer. So let's say that we are building a machine learning or deep learning model that can predict whether a person has cancer or not. So in this case, true positive means a person has cancer and the machine learning model is predicting that this person has cancer. So false positive means actually that person doesn't have cancer, but the model is predicting wrongly that that person has cancer. So this is what we call as false positive. So in this case, false positive is not that much important for us, because if the model is predicting wrongly that this person is having cancer or something, in that case they may check one more time to to get assured that whether there is actually this particular disease or not. So in this case, false positive is critical, but it is not that critical compared to false negative. Now we have to think about this false negative, which is like very, very critical in this case. So what this false negative means is, actually these people have cancer positive. So these people are affected by cancer, but the model is telling that these people doesn't have cancer. So this is very, very important, because diseases like cancer requires like immediate treatment, right? And if the model is predicting wrongly that this person doesn't have cancer, this is like a huge problem, because they need to get the treatment quickly. So in this case, false negative rate become very critical. So our model shouldn't make high number of false negative. So this is where the metric like recall comes into play. So if you have high number of false negative, your recall value will be low. So if you're building a system like cancer diagnosis or something, you must have high value of this recall. Okay, so it shouldn't make several false negative predictions. Whereas we know that previously we have discussed about this precision, where our focus was mainly on false positive, because in that case it cannot make like wrong predictions, which is my false positive. So in this case, false negative becomes critical. Okay, so this is where precision and recall comes into play. It's not like you build a classification model and you calculate this accuracy score, confusion matrix, and you just calculate this precision, recall, and f1 score. So it shouldn't be like this. So the focus or the importance for this precision and recall depends mainly on the problem statement that we are working and the nature of the prediction. So if the false negative predictions are very critical, in that case we should have high recall value. If false positive value are critical, as in this case, the precision value should be kind of we should have like high precision values. So that is what the difference between this recall and precision is. And now let's move on to the next metric that we have, which is f1 score. So the F1 score is more of a combination of this precision and recall. Okay, so it is an again important evaluation metrics when it comes to binary classification problems. So all this precision and recall also we use in binary classification, where we are predicting between two classes. So in the previous example, whether a person is having a cancer or not, and in the precision example, whether the person in front of the camera is Siddharthan or it is someone else. Okay, so this is what we call as binary classification problem, and F1 score is again an evaluation metric for binary classification problem. And what it does is it combines the values of this precision and recall, and it is basically an harmonic mean of precision and recall. Okay, and as I've told you, these things, precision, recall, and especially F1 score, is very much useful when the data set has imbalanced classes. As I've told you, imbalanced classes means if you have two classes, one classes will have several data points and one classes have very low data points. Say for example, let's say that we are building a system that can look at an image and say whether this image represents a dog or cat. If you have like 800 dog images and 200 cat images, so this is like a very imbalanced classes. So in that case, accuracy score is not at all reliable. As I've told you, if you wanted to understand about this imbalanced class and why this affects accuracy score, please watch the previous video. Okay, so whenever you have this imbalanced classes, comparing to accuracy score, F1 score is a better alternative. And also we have seen that precision we use when the false positive predictions are critical, and we use this recall, like we focus mainly on recall when the false negative predictions are critical. And the thing about this F1 score is, let's say that in some cases both false positive as well as false negative value can be critical, right? So they are like equally critical. So in that case, we cannot choose between precision and recall, so we will go with F1 score so that we have a more reliable kind of metric. And the formula for this F1 score is, F1 score is equal to 2 into precision into recall divided by precision plus recall. So this is what we call as the format of harmonic mean. So this F1 score is a harmonic mean of precision and recall, and this is the formula. So it's 2 into precision into recall divided by precision plus recall. So it kind of combines both this precision and recall, so that we have a better model that has good precision as well as like good recall as well. So I'll just, this is the last part of this video where we just take a simple example and try to calculate this precision, recall, and F1 score. So this is the confusion matrix that we have. So you can just think about anything like this positive means like COVID-19 positive and COVID-19 negative, or you can also think about positive means like people with diabetes and negative means people without diabetes. True positive means like people who actually have diabetes and they are predicted as they have diabetes. So false negative means, um, false negative basically means, so they they have diabetes but they are predicted as they don't have their diabetes. So this is what we call as false negative, and so on. I hope that you understand this at this point. Okay, so in the previous case, we add this true class or the actual label or actual class in the x-axis. In this particular image we have this in the so the actual value, actual label or true class is present in the y-axis. So this is not like that important, so you just need to understand this better. So in this case we have just flipped this one. So it's not that predicted class should be in y-axis and true class should be in the x-axis. It's not this one. So in this case it is kind of flipped in this particular image. And now let's try to calculate this precision recall and F1 score. So we know that the precision, the formula is true positive divided by true positive plus false positive. The other way of remembering this precision is true positive divided by total predicted positive. So you just need to plug in these values. So true positive, which is my TP, is 50, right? So it will be 50 divided by 50 plus 5. So true positive, we know this, it is 50, and false positive. So false positive is my FP, which is equal to 5. So false positive means that person doesn't have any infection or doesn't have diabetes, but they are predicted as they have positive infection or positive diabetes. So that's what we call as false positive. So it's basically 50 divided by 55, and the value that we get for precision is 0.91. Okay, so it is basically the percentage of true positive in your total predicted values. And for recall, so true positive divided by true positive plus false negative, and the other way to remember is, as we have seen, it is true positive divided by total actual positive. Okay, so it is my recall and we just need to plug in the value. So true positive, we know that it's 50. So 50 divided by 50 plus false negative value is 10. So in this case, false negative is the count of false negative is I than false positive, right? So here it will be 50 divided by 50 plus 10 because of this 10. And in this case the recall value will be 0.83. As you can see, in this case false negative, number of false negative count is 10, which is like I. So we have this recall value which is low. So if you compare this false positive value and false negative, false positive value is low, right? So it is 5 and false negative is 10. So this is why we have this precision value as I precision value. So this is why I told you, like, precision will try to calculate the error caused by false positive. So if we go to the previous slides, so here I mentioned that precision measures the error caused by false positive, and recall measures the error caused by false negative, right? So in this case the number of false negative is high, so hence we have a lower recall value, and the false positive error is low, so we have high precision value. And now we have this precision and recall, and now we can plug in these values to this F1 score formula, which is 2 into precision into recall and divided by precision plus recall. So when you do this, the final answer you get is F1 score is 0.87, which is more of a combination of this precision and recall. So we get a overall picture of what this model performance is. So how the model is, whether it is like working well, it is making good predictions or not. So this is like much reliable compared to an accuracy score, especially when there is an imbalanced class of data. Okay, so I hope that you have understood all these things clearly, and this is like a very important concept. And this particular thing about precision recall and F1 score, so this question will be asked in several interviews, so you have to be clear conceptually about this precision recall and F1 score. And in the next video, let's try to understand how we can calculate this values in machine learning in Python. So it will be an hands-on value where we will try to have a trained machine learning model, and we will try to calculate these values of precision recall and F1 score. In this eighth module, we are discussing about the topics such as cross validation, model selection, hyperparameter tuning, and model evaluation. In the last video, I explained you what is meant by precision, recall, and F1 score, and we have also seen what are all the formulas involved in this and how we can calculate this precision, recall, and F1 score. And in this video, we are going to get an hands-on experience of these three concepts. Okay, so I'll show you how you can calculate this metrics in Python for a machine learning use case. So that will be the agenda for today's video, and let's get started. So for this, we will be working on the art disease prediction dataset. So in my YouTube channel, I have already posted video on predicting whether a person has art disease or not based on this dataset that we have worked on. You can see here. So 1 year represents so people with art disease, and 0 represents people who doesn't have any art disease. So this is what we have worked on. So if you want a detailed explanation on all the data processing parts and how we are training the model and all those things, so I'll give the link of that particular video in this video description. You can check that out. Okay, so here I have uploaded this art.csv, which is my dataset file. I'll also give the link for this dataset file. So in the last video, so like before this precision recall and F1 score video, I have explained you in detail about this accuracy score, and how we can find this accuracy score for training data and test data and so on. So this is the accuracy score we have, which is 0.85, which basically means 85 percentage. So 85 percentage means, so out of 100 predictions, your model can predict 85 correct data points. So that's what accuracy means. And we have also discussed that there are some limitations to this accuracy score, because it doesn't tell us the rate of true positive, true negative, false positive, and false negative, and so on. So that is why we are focusing on the metrics such as precision, recall, and F1 score. So where we have understood the other advantages that we can get from using these metrics. So if you haven't watched the previous video, I suggest please watch those things. So in that case only you can understand this clearly. So this is the definition for this precision. So it is basically the ratio of true positive to the total number of predicted positive. Okay, so true positive means, so in our data set there are people with art disease and without art disease, right? So true positive basically tells you how many people are predicted as people with art disease, and they actually have art disease. Okay, so here the predictions made by the model matches with the actual positive. Okay, so false positive is just opposite to it. So in that case, a person doesn't have art disease, but our model is telling that that person may have art disease. So that is what we call as false positive. So this is how it corresponds to the true negatives and false negative and so on. So you would get a clear understanding of these terms if you watch the previous videos. Okay, so now we have this accuracy score details and so on, and now let's try to understand how we can calculate these three metrics: precision, recall, and F1 score. And other important thing is, this is used only in the case of binary classification problem. So binary classifications means we are classifying the data points into two classes. So in this case it is person with art disease and person without art disease. The other example is you can try to predict image represents a dog or a cat. So there are only two classes, and we are trying to predict among these two classes to which a particular data point belongs to. So that is one thing. And so yeah, let's get started with the coding aspects. So first I'll import this precision score from sklearn. So from sklearn dot metrics, So this is where we have this accuracy score, mean absolute error, and so on. So all the evaluation metrics will be in this metrics module of sklearn. Okay, so from sklearn.metrics, let's import precision score. So precision score. So I'll run this one, and now we have to pass the true value and the values predicted by our model. So we have already did those things in this step. So if you don't understand this, as I've told you, please watch that accuracy score video and the art disease prediction video. You can get a clear understanding of it. So you can find the link in this video description. So here you can see. So we are training our model here. So we are taking a logistic regression model, and we are specifying the iterations, and we are training it with the training data X train and Y train, and we have split our data into training data and test data. So X train and Y train are my training data, X test and Y test are my test data. Okay, so you can see, so it is 80 is to 20 ratio. So test size is equal to 0.2, which means test size is 20%. So we have split the data and we have trained our model using this training data. So this is the accuracy on the training data, and this is accuracy on test data. So here X-train prediction is the values predicted by your model for the training data, and X-test prediction is the values predicted by your model for the test data. Okay, and the true values are your Y-train and Y-test. Okay, so this is the true values for training data. This is the true labels for your test data. So we have to pass these four things individually in order to calculate this precision score, recall, or reference score. So whatever we need. Okay, so here I'll make a comment as precision for training data. Okay, precision for training data predictions. So we will be finding this accuracy score as well as precision, recall, and difference score for both training data and test data, because then only we know whether our model is overfitted. Overfitting means in that case your model would have overlearned, and when that happens you will get a good accuracy score, good precision value only on the training data, but your model performs really bad in your test data. So that is what we call as overfitting. So the main idea is to make sure that the training data accuracy and test data accuracy are close to each other. In this case, the training data accuracy is 85.54% and the test data is 80.33%. So we know that it is almost close. So there is no overfitting is happening and the model is working well. In fitting aspects, overfitting and underfitting aspects, we don't have any issues. So now we have this precision for training data prediction. And here I'll create a variable as precision train. So this is the precision value for the training data. And here we have to use this function precision score. So precision score, and here we have to pass the no, we have to pass two parameters. One is the true labels and the other one is the values predicted by your model, which is your extreme prediction. So this is just so it's extreme prediction. Okay, so here this is just similar to the accuracy score that we are calculating. So it is like very similar to it. So this is the values predicted by your model. As you can see, model.predict x test. So we are passing the test data points, features, and we are predicting the labels, and we are storing this in x test prediction. So this is where we are predicting it. So this is for test data, and the same thing we have done for training data as well. So we just have to follow these steps. So I'm just giving this here as precision underscore train, precision score. So Y train and X train. So this is my true labels for my training data, and these are the labels predicted by my model. Okay, and here let's print training data precision. Okay, so training data precision is equal to precision train. Great. So here we are creating a variable, and here we are using this precision score, which will calculate this score using the true labels and the labels predicted by our model. Okay. So this will give us a value, and this value will range between 0 and 1. 1 being your all the values are actually correct. So that's what it means. So it ranges from 0 and 1. So if you want, you can convert this into percentage as we have done here. So you can round this to two decimal points, and you can include a percentage symbol and multiply with 100. So it basically converts this value, which ranges between 0 to 1, to a percentage value. Okay, so in this case the percentage is 82.9. Okay, so almost 83 percentage. So what this 83 percentage means is, you can refer to this definition. So it is the ratio of true positive to the total number of predicted positive. Okay, so I have explained this in my previous presentation. As you can see, precision is the ratio of the same definition. So it's basically true positive divided by total predicted positive. So out of all the predicted positive, how many are actually truly positive? So in our use case, it's out of all the people who are predicted as those having our disease. Let's say that 100 people are predicted as with our disease. Out of those people, how many are actually having heart disease? So that is my true positive. So total predicted positive means all those people who are predicted to be having some heart disease. So that is what precision tells us. So the disadvantage with accuracy is it cannot tell us these details, and these details are very important for us. And I have also explained this in the previous video itself, that it measures the error caused by false positive. Okay, so total predicted positive is nothing but true positive plus false positive. So it will kind of help us to know the error caused by this false positive. So it will tell us this particular thing. So 82.9 percentage are true positive out of the total predicted positive. Now we can find the same for the test data as well. Okay, so I'll just copy this one. So this is for training data precision, and I'll just paste this code and I'll just change this training to test. Okay, so let's name this as precision test. And so here the white range should be replaced as y test, and x train prediction should be replaced as x test prediction. So this is my test data precision, the precision test. Okay, so I'll just check everything is correct. The precision for test data prediction, precision test, precision score, y test, x test prediction. Okay, so if you see here, x test prediction is nothing but the labels predicted by my model for my test data, and here y test is my true labels for test data which we have splitted using this train test split. So this y test, and the values predicted by my model is stored in x test prediction. So similarly in this case, so we have used y train and x train prediction. Now we have to use y test and x test prediction. So I'll run this one. So this is my test data prediction, which is like 0.818. So almost it's 82 percentage, right? So this is the precision. So recall is, so the implementation is almost the same. So we just have to replace this precision with recall, and everything else kind of remains the same. And this is the definition for this recall. I hope you have watched the previous video. So it basically tells you the ratio of number of true positives to the total number of actual positive. Okay, so I'll just open this PPT quickly. So this is what it means. So true positive divided by total actual positive. Whereas in the case of precision, we have worked on total predicted positive. So if you don't understand what this total predicted positive means, or true positive, false positive, please refer the previous video. Okay. So let's go to this recall. So here we have to change this precision. So in sklearn.metrics itself, we have another score called as recall. So from sklearn.metrics, I'm importing this recall score, and I'll just copy all these things. I just have to change this precision score to recall score. Okay, so I copy this one as well and paste it here. Now let's copy this recall score, put it here. Okay, yeah, and yeah, so here as well. And I'll just change these things. So this should be my recall for training data prediction, and let's name this as a recall train. Recall score. So all these parameters kind of remains the same. So this will be my training data recall. Okay, so here we have to replace this. I'll just copy this recall and replace this precision. Okay, so this is the recall for test data prediction, and this is my test data recall. So precision test. So let's run this one. So this is from sklearn.metrics. We are importing recall score. So recall train. So recall of the training data is recall score of y train, which is my true labels, and x train predictions. Training data recall. Okay, so here we have to change this. Precision train should be replaced with recall train. So this will give you the recall value, which is 92.4 percentage, and for the test data we get the recall as 81.81 percentage. So for this particular data set, I think the for the test data recall precision and recall kind of remains the same. So whereas you can see the change in this precision and recall for training data values. Okay, again, so this is the same for the F1 score as well. So you just have to rename this. So I'll copy these three cells if possible. So I'll copy these cells and I'll paste it here. Okay, so now we can replace this recall score to F1 score. Okay, yeah, so this will be my F1 score. So again, F1 score is, it's kind of a wrapper of these two values. So it will try to find a mean of precision and recall, but it is not a normal mean, but a harmonic mean, and this is the formula for it. So 2 into precision into recall divided by precision plus recall. So this is the harmonic mean. If the precision and recall value is the same, in that case, you will get the same value as your F1 score. So just like mean. So this is what we call as an harmonic mean. So here we have this F1 score. So let's replace this. F1 score. So let me put this recall train as F1 score of train and F1 score. Okay. So let's rename this recall test to F1 score test, and this should also be renamed to F1 score. So as we know that Y test X test prediction and Y train X train prediction kind of remains the same, as they are the parameters on which we are working on. So here let me put this as F1 score for test data prediction. So let's run this one. So here it is recall train. So it should be replaced with F1 score train. This should be replaced with, okay, so here it is correct. So here we are calculating the F1 score using this F1 score function, and we are storing it in this F1 score train. So white and index train prediction printing training data F1 score. So this is the same. So this should be training data F1 score, and in the next step we have test data F1 score. Let's run these two things. So here the training data F1 score is 87.4 percentage, and the test data F1 score is 81.8. It's almost 82 percentage. So as you can see, the precision for training data is 82.9 percentage, and the recall for training data is 92.4 percentage. So you will get this harmonic mean value to be 87.45 percentage, which we will get using this particular formula. Okay, as I've told you, in this case precision and recall kind of remains the same for test data, so the F1 score will also be the same, as it is just another form of a mean. Okay, so there is just one more thing that we can do here. So instead of calculating this precision recall and F1 score separately, we can also kind of build a function through which we can print all these values. So the reason we are calculating this different separately is we don't need all these three metrics all the time. So they are like there are like specific advantage to it. So say for example, in the case of precision, it is very helpful for us in order to in the cases where false positive rate is critical, or where we wanted to measure the error caused by false positive. Whereas in the case of recall, it measures the error caused by false negative. So whenever false negative predictions are critical, in that case we will look into recall more specifically. So that's why I just wanted to show you how you can calculate these values separately. So you will understand this with this particular example. If you have seen the previous video where I've explained you why is that critical, why false negative is critical sometimes, and why why false positive is critical sometimes. So you can understand from that video. Now let's just create a small function incorporating all these things: precision score, recall score, and F1 score, which will help us to give all these values when we run the cell for one single time. So I'll name this, I'll just put some text here as precision, recall, and F1 score. Okay, so just a second. So F1 score, and here we are going to create a function. Okay, so DEF, which stands for define, and let's name this as precision, recall, and F1 score. Okay, so this is the function that we are creating, and here we need two parameters. So the first parameter is true labels, and the next parameter is our prediction labels. So let's put this as spread labels. So true labels is the Y train or Y test. Okay, so what we have here, so while splitting it, yeah, so Y train and Y test. Okay, so in this case, the prediction will be your extend prediction or your X test prediction. So that will be the two parameters that we have to give here. So here let's create three things. So one is precision value is equal to, and next let's create okay, so let me just complete this. So this will be precision score. So first you have to import this. Okay, so I have already imported this precision, recall, and F1 score separately. So if you are not doing this individually, you need to import these three functions. So precision score, so I have to say true labels comma red labels. Okay, and I'll just copy this, and we just have to replace this precision with a recall. So I'll replace this precision with a recall. Okay, so this should be my F1 score value. So here also we have to replace those functions. Recall score, and this would be my F1 score. Okay, so if you are wondering where this precision score, recall score, and F1 score comes from, as I've told you, we have imported. So we have imported F1 score here and imported recall score here and precision score here. So we are using those functions. So we know that for all these scores, true labels is the first parameter and prediction label is my second parameter. Okay, so which is similar to how we calculate this accuracy score. So here I'm going to print three statements. Okay, so if you want, you can return this precision value, recall value, and F1 score value. So for this function, so the purpose of this function is to print precision value, recall value, and F1 score value. So that is what we are interested in. So I'll put this text here as precision is equal to precision value. Let me just copy this and paste it quickly. Now we can replace this precision with recall, and here we can replace this with F1 score. Okay, so this recall value we have to paste here. So it is just the same thing that we have done before. So I'll show you in a moment. So we are just doing the same thing, finding the precision, recall, and F1 scores. So instead of doing this in three different steps, we are putting those together in a function, which will be helpful for you in several cases. So instead of doing that separately, you can set up this function and you can use that multiple times in multiple use cases that you are working on. So that's the idea of this, and nothing kind of new to it. So we are creating a function called as precision, recall, and F1 score, and these are the names of the parameters that we have to pass. So while calling this function, so instead of true label, we say y test prediction and prediction label x test prediction. For training data, we will say this true labels to be y train and prediction label to be x train prediction. So I'll run this function. And now, so we know that these are classification metrics, right? So I'll just put a text here as classification metrics for training data. So in the end of this video, I'll tell you where these scores are, very important. So classification metrics for training data. So let's name this as, you know, let us call this function, which is my precision, recall, and F1 score. So once you execute this, so these values will be printed. So these precision value, recall value, and F1 score value will be calculated, and we will print it. Okay. So let's pass the parameters, which are my, yeah, so this is my training data predictions, right? So I'll just copy these two things and paste it here. So the reason we are putting these two things is because we have true labels and prediction label as a parameters, as we have mentioned here. So I'll run this one. So this will give me my precision value, recall value, and F1 score value, as you can see here. So which we have got previously. So this is the precision for training data 82.9, which we have got here. So similarly, we have got recall value and F1 score value for training data. Now we can just copy this. So instead of doing all those things, we just have to call this function. So this is for test data. So we are not doing all the things that we have done here. So we have calculated this recall and calculated this precision and so on, right? So you just have to call this function, replace this y train with y test, and replace this x test with X test prediction, and these three values will be printed. Yeah. So as I've told you, in this case we are getting the precision recall value to be the same for the test data. As these two values are same, we get the FN score value as also the same as it is an harmonic mean. Okay. So this is how you can create a simple function that will give you this precision recall and F1 score. So you can also like kind of find these values individually if you want. So let's say that you are more focused on precision. In that case, you can just import this precision score alone. You don't have to go to recall and F1 score and so on. So this is how you can create a function. Okay. So the main aspect in which we use this precision recall and F1 score is when your data set is imbalanced. So that is where these are like very helpful, because accuracy score will be misleading when your data set is imbalanced. Let's say that we are building a machine learning system or deep learning system that can look at an image and say whether it is a dog or cat. So let's say that we have 1,000 dog images and 100 cat images. So this is what we call as imbalanced data set, because the classes are imbalanced. So in that case, you will get a higher accuracy value, but it is not reliable. So I have explained about these things in the previous accuracy score value. So this is where precision recall and F1 score will be helpful for us. So in those cases, these values will be very less. So that is an indication for us to know that even the accuracy score is high, that the model is not performing well. Okay. So that is one main aspect. So you can just remember this or make a note of it. So precision, recall, and F1 score are very important in the case of imbalanced data set. And we also have a function in sklearn.metrics, which is precision underscore recall underscore F score underscore support. So this will give you four values: precision, recall, F1 score, and support. The support is another interesting aspect, which basically gives you the number of true classes, or the number of true prediction in each class. Okay. So so we are just in this case we have this art disease, people with art disease and people without art disease, and we are making predictions, right? So in each of these two classes, how many correct predictions are made? So that is the support metric that we have. But in the case of ML, we mainly focus on precision, recall, and F1 score. And it is always a good practice to calculate these three metrics along with the accuracy score as well. So people may work on some machine learning model trained with the data and calculate this accuracy score, but it is always a good practice in order to focus on this precision, recall, and F1 score as well. And this is a very important concept that you have to know, and this will be asked in several machine learning and data science interviews as well, as this is one of a key evaluation metrics that we have for binary classification problem. So that's it from my side. I hope you have understood all the things that is covered in this video. So please practice all these codes and see for yourself how these things works and how we can build this machine learning system that can predict big mart sales. Okay. So first of all, let's try to understand this problem statement better. Let's say that there is a grocery store company or a supermarket company that has several outlets or several stores around the world, and they want us to predict the sales which they can expect. Okay, so you may ask, what is the application of predicting this sales? What can happen by predicting the sales? So there are actually a lot of things that are helpful which we can derive from this predictions. So if we can predict the sales revenue, we can tell the company that what are the challenges they may face, and what are the brands and what are the products that sells the most and other such kind of things. Okay, so this helps the sales team to understand which product to sell and which product to promote and such kind of thing, and they can also make several marketing plans. Let's say that a particular product in particular store is selling the most, and we may find some insights from it as of why this product is selling the most, and this helps the company to make better marketing decisions. So these are some advantages of this particular project. So as we have understood about the problem statement, I would like to explain you one more thing. So this particular project is a regression based machine learning project. So machine learning is generally classified into supervised learning and unsupervised learning. So in supervised learning, we train our machine learning model with labeled dataset. Whereas in unsupervised learning, we train the model with unlabeled dataset. So you may ask, what is meant by these labels and what is meant by unlabeled dataset? So in this particular project, the labels are the target. So to be more precise, I should say that these are targets. So in this case, the targets are the sales amount. Okay, so sales cost or price they are getting. Okay, so that is the target. If we train our machine learning model with those targets as well, we call it a supervised learning. In case we don't use those labels or targets, we call it as unsupervised learning. And this supervised learning can be classified into two types: classification and regression. Okay, and classification, so you can see the definition of both classification and regression. So classification is about predicting a class or discrete values. So we are just predicting some categories, so these categories can be male or female, true or false, and such kind of things. Whereas regression is about predicting a particular value, a continuous value. So this can be, predicting the salary of a person given their experience, and predicting a person's age and such kind of things, where this is not category but some numerical value. So this is called as regression, and this particular project is called as regression because we are predicting the sales. Okay, so with that being said, let's try to understand what is the workflow which we are going to follow. Okay, so the first thing is to get the data for this particular project. So for this project, we are going to use Big Mart sales data. So if you are, working or learning about machine learning for a while, so you would have come across this Big Mart sales prediction. So this is a very interesting and important project when it comes to machine learning and data science. So we will be discussing what are the different features and variables this dataset contains later. So just understand that we are going to use this Big Mart dataset. Okay, so once we have this data set, there are a lot of processing to do. So this is like, in the previous projects, we also had this processing, but the processing work is more in the case of this particular data set. Okay, so there are a lot of processing like encoding the categorical features and other things. So there are some, processing things which we need to do in this particular project. And after that, we need to analyze the data. So it's called as exploratory data analysis, where we put the data in some suitable plots and graphs and see what are the distribution of various data points and what is the count of various features and such kind of things. So this data analysis helps us to find the meaning the data has to tell. Okay, so this is very important to understand about the data. So once we complete these tasks, we will split our data set into training data and testing data. So what happens is, in machine learning, we train our machine learning model with training data and we test or evaluate it with the test data. Okay, so once we split our original data set into training data and testing data, we will feed this to our machine learning model. In this machine learning project, we are going to use a regression model called as XGBoost regressor. Okay, so once we train this regressor with training data, we will evaluate it based on the test data. Okay, so this step is called as evaluation. So these are the things which we will be doing in this particular video. Okay, so now let's get into the coding part. So we will be doing our programming in Python. So it will be in Google Collaboratory. So if you are new to Google Collaboratory, or if you are not aware about this Google Collaboratory, just go to my channel, and in the playlist you can find this module called as Python for Machine Learning. In that, the first video will be on how to access this Google Collaboratory and what are the various features in it. Okay, so now let's get started with our programming. So I have uploaded this data set file. So this is the BigMart sales data, and you can get this data set from Kaggle as well. Just search as BigMart sales dataset in Kaggle. Okay, so if you search that in Google, so you can find this dataset, this train.csv. So once you download this data, so here there will be a connect option to connect your Google Collaboratory environment. So you can see this files options here. So you need to go here and you can use this upload to session storage option, or just right click here. So you will find this upload option. So from there you can upload your dataset file. So as you can see here, this is a CSV file, which means comma separated value. Okay, so now let's get started with this. The first step is to import the dependencies. So let me make a text here, importing the dependencies. Okay, so let's run this. So for running a particular cell and go to the next one, you can press shift plus enter. Okay, so first let me import some basic libraries. First, let's import NumPy. So let's import NumPy as NP. So NumPy library is very useful for making NumPy arrays. Okay, and let's import Pandas as PD. So Pandas is useful for creating Pandas data frame. So as you know, we have the data set in a CSV file, right? So it is not easy to analyze the data from a CSV file. So we use Pandas library to get Pandas data frame. So we feed this data set to this data frame, and from there we can do some analysis and processing. Then we need some data visualization libraries. So import matplotlib.pyplot as plt. So this matplotlib.pyplot is useful for making some plots and graphs. So we need one more plotting library. So it is nothing but cbon. So import cbon as SNS. So as you can see, I'm importing the libraries in the short form. So this numpy snp, so pandas spd. So this is just to abbreviate the libraries. So every time I don't want to use this matplotlib.pyplot, so I just want to use it simply as plt. Okay, so this is the general convention, everyone uses when it comes to these libraries. So that's why we are importing in this small abbreviated forms. Okay, so we have imported numpy, pandas, matplotlib, and seaborn. And now let's import some functions from sklearn dot preprocessing import label encoder. Okay, so this sklearn library is one of the very important machine learning libraries. We get several models and pre-processing functions from it. So from there we are importing this label encoder. So I'll be explaining you what is the use of this functions like label encoder and other things. So we need one more function. So from sklearn dot model selection import train test split. So if you remember, I told you that we will split our data into training data and testing data, and this splitting will be made using this train test split function. Okay, so now we need to import our model. So in this we are going to use the machine learning model called as XG boost regressor, right? So from XG boost import XGB regressor. Okay, so this model can also be used for classification. So I have explained you what is meant by this classification, where we will predict the categories, whether it's yes or no, male or female, such kind of things. Okay, so and then we need to input from sklearn import metrics. So this metrics is used to give us some metrics functions that will be used to find the performance of our model. So these are the dependencies which we need. So in this video I will not be explaining how this XGBoost regression model works and such kind of things. So we have a separate module on explaining this how this model works, what is the math behind this model and such things. So I will be uploading those videos in the future, but in this video it's all about implementing this. Okay, so if you want to know more about this, please wait. So I will definitely be making videos on several models, several important models on machine learning. Okay, so you can also see my machine learning course curriculum file. I'll give the link for it in the description of this video. Okay, so the next step is data collection and processing. So I just make a text here, data collection. Okay, so let's put data collection and analysis. So first let's analyze our data before processing it. Data collection and analysis. Okay, so you can see that I have already uploaded this data set here. So I'll give the link for this data set in the description of this video. You can download it from here. So here, just go to this options menu. There you can find this copy path option. So just copy the path. So now we are going to load the data from CSV file to a pandas data frame. Okay, so let me make a text here as loading the data set from CSV file to a pandas data frame. Okay, so now let me create a name for this particular data. So let me name this as Big Mart data. So Big Mart is very famous supermarket networks. So they provided this data, and it is a very famous data set in machine learning. Okay, so Big Mart data, which is equal to pd dot read csv, and inside the quotes let's paste the path of this data set file. So we have copied the path earlier from here, so I have pasted the path here. So this pd dot, so pd represents pandas, as you can see here. So this read csv function will load the csv file in a pandas data frame. Okay, so pandas data frame is nothing but a more structured table. Okay, so let's print the first 5 rows of this data frame. So first 5 rows of the data frame. Okay, so mention the data frame name, which is bigmart data. Okay, dot yet. So this yet function will print the first 5 rows of the data frame. Okay, 1 second. Okay, so as you can see here, these are the rows. So let's understand what are these rows. So first we have this serial number. So And then the second column, so this actually is the first column, so let's not include the serial number. So the first column is on item identifier. So these are identification number for a product. Okay, so there are several products and each product has an identification number. Okay, so there will be three codes here. So here is this FD, right? So FDA, this FD represents food, so something, eatable. So this DR represents some drinks. So and it's the same here, FD and FD. And NC means non-consumable. So you can just come to this item type. So we have this item identifier, item number for each of the products, and we have this item type. So you can see here, as I told you, FD means food item. So it is some dairy products, and the DR represents drinks. So we have this soft drinks type here, and this is also again food type, which is meat, and we have again some foods, and NC means non-consumable. So non-consumables we have household. Like this, we have several types of products and several, item identifiers, specific identification for each of the product. Okay, so this is the first column. The next column is item weight. What is the weight of that particular project in kilograms? Okay, so that is given in this item weight column. And then we have the item fat content. So what is the fat content of this particular product? Okay, so we have this low fat level, regular fat level, and such kind of things is present in this item fat content. And this is item visibility. So what is the visibility of that project in a particular supermarket? Okay, in a particular store. So how much it is visible and how much people are buying this particular project. So each of this row represents one product. So this FTA represents some kind of dairy product, and this DR represents some kind of soft drinks, and this represents another food material, which is kind of a meat. Okay, so this is given in the item type. And we have the MRP price here. Okay, so it is, these are in US dollars. Okay, so these are given in item MRP, which is the maximum retail price. Then we have the outlet identifier. So similar to this product ID, we have this outlet identifier. So outlet represents different stores. Okay, so this Big Mart has several stores, and we got a set of stores here. Okay, so these are identification number for such stores or such outlets. Okay, so these are that identification numbers. And we have the year on which it is established. Okay, so these are the years. So 1999, this particular outlet 049 is established, and such kind of things. So we have various establishment years. And we have the outlet size. Okay, so we have a medium outlet size and a high outlet size, and we have this NAN value. So NAN means this particular value is missing. So in this video, we'll also be explaining you how we can handle this missing values. Okay, so it comes under data pre-processing. And then we have this outlet location type. So tier 1, tier 2, tier 3, whether it is present in a very populated region, or it is present in a less famous region, such kind of things. So tier 1, tier 2, and tier 3, such kind of outlet location type. And then we have this outlet type, whether it is a supermarket or otherwise it is a small grocery store. Okay, so such kind of outlet types, what is the type of that particular store. And finally we have this item outlet sales. So what is the particular sales value of that particular product. So if this is the FDA 15, so this product, and this is the sales of that particular product in that particular outlet. Okay, so similarly we have the outlet sales value. So what it represents is, in this particular outlet, what is the sales of this particular product. So that is given in this item outlet sales. So this is what we are going to predict here. So this is our target variable, and all these other things are called as feature variables. Okay, so as I have told you earlier, in this we are using the target variable also for our machine learning model. So hence it is a supervised machine learning project. Okay, so this is our target variable which we are going to predict. So I hope you have understand what are the different features that are present in this data set. So now we need to understand more about this data set and do some processing on the data set before feeding to our machine learning model. So what are these processing? You can see here, these are in the form of text and numerical values, right? So and then we have this as numerical values, low fat, regular, and such kind of things. So we cannot feed this string data. So string means text or some words. Okay, so we cannot feed this text data to our machine learning model. So we need to do some processing on this data. So these are categorical data. So I'll also explain you what is meant by categorical data later in this video. So we need to convert this text to suitable numbers. So I will be explaining you how we can encode these text data into numerical data as well. Okay, so now what we will do is, let's try to understand more about this data set. So now I'm going to see the number of data points and number of features. Okay, so here the data points represents the number of different products we have, so or the number of rows we have in this data set, and feature represents all these columns are features. Okay, so basically we are going to find the number of rows and columns in this data set, and data points represent rows and number of feature represents column. Okay, so mention the data frame name big mart data dot shape, so this will give us the number of rows and columns. Okay, so totally we have about 8523 values, so 523 rows or 8523 different products, and we have 12 features. So these columns are the features. So the first column is item identifier, item weight, and all the way through item outlet sale. So totally we have 12 features, okay, or 12 columns. So this is a pretty good size of data set, but this is not very large. In machine learning we also deal with data set which is several thousand data points large, or even lakhs or hundreds of thousand. Okay, so this is a pretty good size of a data set, so it is almost near to 10,000, so it is a good size. Okay, so now let's get some information about this data set. Getting some information about the data set, so we are going to see what are the data types in all these different columns about the data set. So again mention the data frame name big mart data dot info. Okay, so this info function will give us some important informations. So totally we have 8523 values and 12 columns. So here you can see non-null count. So null values means missing values. So you can see here in this outlet says in the first 5 rows we have one missing values, this NaN. Okay, so NaN means not a number, or it basically means it is a missing value. So non-null values means those values are not missing, or the values that are present in the data set. So out of 8523, all the values are present here, whereas in the item weight column some values are missing. Okay, and you can also see in this outlet size column we also miss about 2000 data points. Okay, so this gives us the number of values present in the data set. And what is the data type here? So you can see the data type as object, float, again object, and we have this int. Okay, so int and float represents numerical values, right? So here the item weight is float, it is a numerical value, and if you come to this establishment here, it is an integer value. Okay, so 64 represents 64-bit integer and float. And object, so we have this object, so you can see which columns are objects. So item identifier is object, so item identifier is, as you can see, so is an object. And then we have this item fat content, so it is also an object. Okay, so the values which are not numerical, so these are textual values. And to be more precise, we call these as categorical values, because so this item fat content contains two categories, low fat and regular. So these are two categories, right? So these are two classes. And if you come to item type, this is also categories, whether it is a dairy or soft drinks or meat, such kind of categories. And it is similar to this outlet identifier and outlet size, whether it is medium, high or small. So we don't have any numerical and discrete values. So we have some classes, right? And the same with tier 1, tier 2 and outlet type. So these are categorical values. So other than these numerical values, the others are categorical values. So I'll just make a text here and represent what are the categorical values we have, categorical features. So I'll make a text here, categorical features. Okay, so let me make a list of things. So item identifier, so it is an object type. So as we know, it is a categories of different products, right? So I just put it here. And the second one is, so the item weight is an integer, so it is not categories. And the item fat content is, of course, it is category. It tells whether it has high fat content, low fat content, or regular fat content. So it is a categorical value. The third categorical value is visibility. So visibility is also given in some metric, in some numerical value. So the next is item type. Okay, so let's just mention this also. So item type, so whether it is a meat or soft drink or something. Okay, so it is also a categorical value. And the next categorical value is outlet identifier, so it is also a categorical value because it is some identification value. So let's copy this outlet identifier. Okay, so we don't need to put this establishment here in the category, so let it be the numerical values. And the outlet size, so outlet size is also categories because it tells whether it is medium, high or small. Okay, so outlet size, so let's copy this. Okay, so the next one, so outlet location type, whether it is a tier 2 or tier 1, such kind of thing. So it is also category. So okay, so let us put it here. And the next one is outlet type. Okay, so this is also categories because it tells whether it is a supermarket or it is a grocery store, such kind of things. Okay, so let us put this here. Okay, so these are the different categorical features we have. So totally we have about 7 categorical features. So out of 12, 7 are categorical features and the remaining 5 are numerical features. Okay, so now we can do some more analysis and processing on these categorical features before we can feed this to our machine learning model. So now what I'm going to do is check for any missing values. Okay, so checking for missing values. So you cannot feed a data set which has a missing value to machine learning model. So we also have a separate video on this handling missing values. So it will be given in the fourth module of our course called as data collection and pre-processing. Okay, so everything is given in the playlist. So it will be in, so if you cannot find that video, just comment in the video. I just give you the link for that particular video. Okay, so now we are checking for missing values. So mention the data frame big Mart data dot is null. Okay, dot is null dot sum. So this will tell us the number of missing values we have in each column. So as you can see, we have totally 1463 missing values in the item weight column, and we have about 2410 missing values in the outlet size column. Okay, so the amount of data that is missing is pretty large in this particular data frame, so we need to do some processing with it. Okay, so now let's see how we can handle this, missing values. Okay, so here we can also note that this item weight is a numerical column, whereas this outlet size, it tells whether it is medium, small or large. So this is a categorical column. Okay, so let's see how we can handle this missing values. Handling missing values. Okay, so here we are going to be needing two metric. So one is mean. So we all know that mean represents the average value, right? So mean represents average value, and we need another parameter called as mode. So mode means most repeated value. So let's say that there are a set of numbers, and mean is what is the average of those set of numbers. So this is called as mean, and we will find the mean of this item weight column, and we will convert all these missing values to that particular mean. So it will be a good method to replace this missing value. So this method is called as imputation. So we are going to impute the missing values in this item weight column using the mean value of this column. Okay, and the second one is mode. As you can see here, outlet size. So this outlet size will be in either it is medium, small or large. So we cannot find the mean value of text data for a categorical data. So in this case we are going to use mode. So what is meant by mode? So mode is, let's say that list contains this small, large and high. So these three values in a repeated fashion. Okay, mode is nothing but which particular class or which particular text is repeated the most. So this is called as mode. So mean is the average value and mode is the most repeated value, and we will convert the missing values in this item weight with the mean of this particular column, and in this outlet size we will find the mode of this outlet size, and we will convert all the missing values to its mode. Okay, so the important thing to note here is we will be converting the missing values in the numerical column using the mean, and converting the missing values in the categorical feature using the mode of that particular column. Okay, so we cannot find we cannot replace this missing value with mean of other columns. So we just need to find the mean of this particular column and replace it. So that is one important thing to note. Okay, so now let's see what is the mean value of this item weight column. So mean value of item weight column. Item weight column. Okay, so big Mart data, let's mention the column name. So here you can see the column names if you put this quotes inside this square bracket. So you can also go to your data frame and see the column name. So okay, so here we are going to change the item weight, right? So you can give this item weight here. Now just put a dot and mean. So this will give us the mean of this particular column. So press shift plus enter to run this cell and go to the next one. So the mean value is 12.857. So this is the average or mean value of the product weight. Okay. So now let's see how we can fill the missing values in this particular column with mean. So filling the missing values in item weight column with mean value. Okay. So Big Mart data, again mention the column name, item weight dot fill NA. Okay, so fill NA means so it will fill all the missing values. So NA represents not available. So not available means missing values. Again mention the column name. So how we are going to fill this by taking the mean, right? So Big Mart data, item weight and dot mean in place is equal to true. Okay, so let's see what we are doing in this particular line of code. So we are taking this item weight column. In this item weight column, I am going to fill all the missing values by the mean of this item weight column present in this Big Mart data. Okay, so basically we are just taking this item weight column, replacing all the missing values with the mean. Okay, so in place is equal to true means I want to replace all the missing values. So in the place of these missing values, I want to replace it with mean. So that is why we are giving this in place. So if you don't mention this in place, uh, if you run this code without this in place, so it will give you the replaced values only in this particular set. It won't be stored in your original data set. So if you give this in place is equal to true, it will be, this missing values will be replaced in your original data set. Okay, so now let's run this. Okay, so now you can just copy this and paste it here and see whether the missing values is still there for item weight column. Okay, so now you can see here we have the missing values only for this outlet size column. That means we have replaced successfully all the missing values in this item weight column. So now we are going to see how we can replace the missing values in outlet size with mode. Okay, so I'll make a text here as um, replacing the missing values in outlet size column. So this is, kind of different from what we have did in this, in item weight column. So there are some different procedures which we need to follow. So replacing the missing values in outlet size with mode. Okay, so we need to do some processing here. So I'll create a variable as mode of outlet size. Okay, so mode of outlet size is equal to mention the data frame Big Mart data dot pivot table. Okay, so I'll explain you in a minute what is meant by this function. So you can also see this description of this particular function. So this pivot table, so it creates a spreadsheet style pivot table as a data frame. The levels in the pivot table will be stored in multi-index object. So if I run this, you can understand. So we are just getting some kind of a table where we want particular columns. Okay, so inside this we need to give some parameters. So you can see the parameters here. So first one is values, right? So values is equal to outlet size. So I want to take all the values from this outlet size column and mention this column. So we need another parameter. So this column. So you can see what is meant by this. If an array is passed, it must be the same length as the data. Okay. So key to group and pivot table. So if array is passed being used as the same manner. Okay. So let's use this. Here the column is okay. So columns is equal to outlet type. So I'll explain you why we are using this outlet type column along with this outlet size. So if you remember, there are no missing values in this outlet type. We have missing values only in this outlet size, right? So let's understand why we are using this. and we need another function, this agg function. Okay, so in this we are going to use a function in this particular parameter, so agg func. Okay, and here we are going to use a lambda function, lambda, and x is to x dot mode 0. Okay, so let's run this. Now I'll explain you why what we are doing in particular case. Okay, so outlet size, so it should be in caps. This, yes, because it's given in caps in our data frame. Okay, so now I'm going to print this mode of outlet size. I'll just copy this, print. Okay, so this is the pivot table. So what we are doing is we are taking two columns, outlet size and outlet type, because these two columns are correlated. Okay, so if you take this, we have this outlet type column here. So there are one, two, three, and four different outlet types. So the first type of outlet is grocery store. The second one is supermarket one. Which is supermarket type one is the second one, supermarket type one, supermarket type three. So these are the four different outlet types, and you can see the outlet size. So this is the mode value of grocery store. So mode means, as I have told you, it is the more number of repeated values. So if the outlet type is grocery, in most of the cases the outlet size is small. As we know, the grocery store is almost small when compared to a supermarket, right? So most of the grocery store are small, and most of the supermarket type 1 are small, and for supermarket type 2 the outlet size is medium, and for type 3 it is also medium. Okay, so this is the mode for each of these different outlet type. Okay, so we cannot take the mode of this entire column, so it won't be a correct method. So what we are doing is we are comparing this with outlet type. So if it is a grocery store, then the mode's repeated value is small, so this becomes its mode. And for type 1 it is small, and type 2 medium. So what we are going to do is take these 240 missing values. Okay, and in that missing values we will be taking the the outlet type. So let's say that this particular this is missing, right? So in this fourth row, so this ftx07, we have a missing values in outlet size. So what happens is, so it will see what is the outlet type. So it is a grocery store, so it will change it to the mode which is small. Okay, so likewise it takes all the missing values, and it will compare it with the outlet type, and it will replace the outlet size depending on this outlet type. So that is what we are doing. Okay, so now I'll create another variable as missing values. So missing values, because we need to take that value separately and replace them. So missing values is equal to big Mart data, mention outlet size, and is null. So I'm taking all the null values or missing values. So what happens is this will give us a list or array of true or false values. So you can just print this and see. So print missing values. Okay, so you can see it gives a list of true or false. So it is checking whether it is null. So false means it is not null. That means the value is present. So what happens is true represents a particular value is missing. So you can just see this. I'm checking whether a value is missing, whether it is null, false. That means the value is present. So whether the value is null, true. That means the value is missing. So we get an array of true or false, where false represent the value is present and true represents the value is absent. So now we are going to take all these true and convert them to the mode of the respective outlet type. So that is what we are going to do. And for this, let's do some work. So now we need to understand what we are doing in this particular function, right? Okay, so we take this pivot table. So we are just creating this spreadsheet like table. So in order to compare what is the mode of their respective outlet type based on this size. Okay, so the values we are taking is outlet size, column which we are comparing is outlet type, and argument, so this arg function. So we are using this lambda function. So what is meant by this lambda? So we all are familiar with functions, right? So we use this def. So if we want to create a function in Python, we use this def. So this is a keyword, right? So if you mention this def and let's mention some, let's say that label. So this will create a function called as label, right? So in this particular function, we can write some few lines of code, and we can use that particular function again and again in our code. What if in case we need just use that function in only one situation? So we don't want to use a particular function in several cases. So in that case, we use lambda over define. So define means you will just mention that function in one place, and you can use that function multiple times. So here don't want to use this function multiple times. I just want to use this function only one time. So in this case, we can use this lambda. So the functioning of this lambda is very similar to define function in Python. So they both are function, but it can do only one function. So what we are doing is we are taking this x. So x represents this particular outlet size column, and it is taking the mode of that particular column. Okay, so we are just taking the mode for this outlet size and outlet type. So that's why we have mentioned the 0 to represent the index. So we are taking this x and finding the mode of this column. Okay, and we are just using it to print it here. Now let's see how we can use this lambda function again to convert this missing values to a mode value. So we need to again create a separate lambda function. So this lambda function is just to give this mode. Now we will create another line of code to replace the missing value with the mode. Okay, so bigmart data dot loc. So loc means locate. So it's going to locate some values. What values we are going to locate is this missing values. Okay, so I just copy this and put it here. Okay, so I'm going to locate this missing values. So you check for which values are true and false, and where I'm going to find the missing values is in the outlet size column, right? The outlet size, and this is equal to bigmart data dot locate again the missing values, comma outlet type dot apply lambda. So again we are creating a lambda function, and this time to replace the values. X is to mode of outlet size. Okay, so what we are doing is, so I'm taking this bigmart data, so I'm locating particular values. So which values I'm locating is this missing values. So all these true and false will be taken. So this missing values will be taken for this particular column. So I won't disturb any other columns. So we have totally 12 columns. I just want this outlet size column, and in that size column I'm going to convert some things. So what I'm doing is again I'm taking this locate. So I'm just locating some values in this missing value. So what I'm locating is outlet type, and I'm applying a function. So what I'm doing is this x represents this outlet size and outlet type. So I'm taking the mode of outlet. So this is very similar to this particular case. So we are taking these four outlet type: grocery store, type 1, type 2, type 3. So and we are converting all the outlet size to whether if it is a grocery store, it will be converted to small. For this type 1 it is small, type 2 it is medium, and such kind of things. Okay, so this is what we are doing this in this lambda function. So we will take this outlet size and outlet type, and for missing values we will convert the missing values based on this outlet type. Okay, so let's run this. So this will replace all the missing values with mode of the corresponding outlet type. So again you can check the number of missing values. So I just copy this. Let's see whether the missing values is filled or not. Okay, now you can see here we don't have any missing values in any column. So this is how you can handle missing values in a numerical column and in a categorical column. Okay, so the next step is to do some analysis on the data. Okay, so let's make a text as data analysis. So now we are going to put this data in some graph and see what is the distribution of the data and other some insights that we can get from this data. So this part is about data analysis. So bigmart data, so dot describe. Let me explain you what is the use of this particular describe function. So this describe function will give us some statistical measures about the data. Okay, so let's run this. Okay, so it gives some statistical measure only for those numerical values. So first is the count. Count means the number of values we have for all the numerical columns. So these are the numerical columns, right? So what is the count? So 8523. So totally we have 8523 data points, and we have these many item weight values. And what is the mean of these item weights? Okay, so the mean is 12.85. So most of so okay, so this is the average of all the item weight column, and we have the standard deviation. So what is the standard deviation for each of this column? So each have their own mean and their standard deviation. So second is the item visibility, item MRP, etc. And then we have the minimum value. So what is the minimum item weight value, what is the minimum visibility value, and such kind of things. And then we have the 25th percentile, 50th percentile, and 75th percentile maximum value. So what is the maximum value in this item weight? And percentile, so these are not percentage. So percentile means, so if it is 25 percentile, that means 25 percentage of values are less than 9.31. 50th percentile is 12.85. So that means 50 percentage of the values are less than 12.85. So that is meant by this percentile. Okay, so now let's take this numerical features and do some plots. Numerical features. So I'm using this SNS.set. So if you remember, we have imported this Cbond library as SNS. So this SNS dot set function will give us some theme for our plots. So it will give some grids and other things. So that is the use of this SNS dot set. So if you run this one time, it will be followed in all the plots you make. So first I'm going to create a plot for item weight column. So item weight is the first numerical column we have. So item weight distribution. So what is the how the value is distributed in this particular column? So that's what we are going to understand. So for that I'm going to use this plt dot figure. So plt dot figure. So plt means matplotlib.pyplot. So we have imported it in the short form as plt. So we are using that particular library. So plt dot figure. So in this mention the figure size. The figure size is equal to 6,6. So you can change. This is just to the size of the plot we want. So this is the x-axis size and this is the y-axis size. Okay, so figure size, and then I'm going to use a distribution plot. So this distribution plot function is present in Cbond. So sns dot dist plot. Okay, so dist plot means distribution. So mention big Mart data. So I'm going to make a distribution plot in this particular data set for item weight column, right? So item weight. Okay. Now let's also give a title for our plot. Okay, so the title is not necessary. Let's just show the plot. So plt.show. So this plt.show will print our graph, print our plot. Okay, let's run this. There is some error. Okay, so we need another parenthesis here. The figure size is equal to, this should be enclosed in another parenthesis. Okay, so one closing parenthesis. Okay, so got fig size. So got an unexpected argument called as fig size. Okay, so we need to remove this underscore. So this is how our item weight column is distributed. So we have the item weight from 5 kilogram to 20 kilogram, and we have maximum values in this 12. Okay, so there are a lot of values in this 12, and this is the reason we get the mean values 12.85 something. Okay, so a lot of values are distributed in this particular weight. Okay, so these are the insights which are very important for us. Okay, so this tells us what is the average weight when compared to the other products we have. So in this total products, so this total 8,523 products, the average weight is about 12.8. Okay, so now let's also find the distribution of other columns as well. The second numerical column is item visibility, right? So item visibility, I'll just copy everything here and let's just change the names. So this is for item, we can copy it from here. Item visibility, just put it here and also here. So it will give us the distribution for this item visibility column. Okay, now as you can see here, there is a skewness. Skewness means there is value distributed more in one side of the graph. So these are the distribution. So the item visibility values and more as a value around 0.05, and less values have values more than 0.15. Okay, so this is about item visibility column. And next let's find the distribution of the third one, which is item MRP. Okay, again I'll copy this So it is already, yeah, okay. So let's put it here, and now we need to change this item by to item MRP. Item MRP. Okay, so let's run this. Okay, so as you can see here, a few values are, so it is not a normal distribution. So there is peaks in some kind of, in some products. So there are a good amount of products around this 50 rupees or $50 price, and also in this $100 and $200. After this, the products is kind of less. So we have more products in this range of 100 and 200. So 100 and this 170 mark. Okay, so this is how the price value is distributed in our data set. Okay, so you may ask why we are doing this. So this tells us important insight. So if you are working on some data science projects, these insights are very important because they tell us what how our data is distributed and how the values are in a range. Okay, so next we have this item establishment here and outlet establishment, a particular outlet establishment here, and item outlet sales. So I just copy this outlet sales, item outlet sales. So first let's just put this here. So, and I'll copy this. So we are going to see the distribution of sales. Okay, so this is also a kind of skewed, or it is also more in but one side of the curve, and it is not a normal distribution. So more sales are in the range of about 2000, so 10,000 to 2000. Okay, so this is how you can understand the distribution of numerical values. And finally we have this outlet establishment here, right? So here we are going to use a count plot instead of a distribution plot, because count plot gives us a better meaning for this particular feature. So outlet establishment here, let's copy that. Outlet establishment here column. Okay, so plt dot figure, and figure size. So let's put the figure size as again 6,6. Okay, so now we don't want a distribution plot, we want a count plot. So SNS dot count plot, and in that mention x. So here the x is nothing but the column name. So mention the column name, which is establishment here, and we also need to mention the data. And here the data is nothing but Big Mart data. Okay, so Big Mart data plt dot show. Okay, so we have the outlet establishment here. So we have the year 1985, 1987, 97, all the way to 2009. So these are the years on which different outlets or different stores are established, and we have a lot of values, a lot of stores are established in the year 1400. Okay, so a lot of products are basically created in this particular year, and the distribution is kind of similar for all the years, but it is kind of less only in this 1998. So this tells us how many products are sold in what years. Okay, so that is what we are getting it here. So that means more number of outlets or more number of products are sold and created in this particular 1985, and it is very less in 1998, and all the other years are almost same. Okay, so this is what we are getting in this. So these are distribution, but these represents the actual numbers. So in this 8,000 data sets. So we have this 8,000 data sets, right? So in this, the most of the data points, about more than 1,000, are in created in this year 1980. What is the year? It's 1985. So others are almost similar, the density of these particular values. Okay, so these are the numerical values, and next we need to check the similar things for categorical features. Okay. So in this categorical features, we know that totally we have seven categorical features, right? In this, we are going to exclude this item identifier and so we'll be excluding this item identifier and outlet identifier because they are just identification numbers, so we don't want to put that in some plots, but we will find the plot for the remaining columns. Okay, so we are just going to use the same count plot as we have used for this establishment here. Okay, so I'll just copy everything here. Let it let us put this here, and just we need to change the column name. So the first categorical column we have this item item, so we are not going to include this. So it's item fat content. Okay, let's see what are the different features this item fat content has. Let's run this. So we have columns as low fat, regular fat content, again low fat content, LF and regular. So the important thing to note here is we need to clean this particular column because this low fat and this LF all represent the similar thing, right? So we need to put this low fat data and this LF data to this particular low fat data, and regular also represents regular. So we need to put this data in this. So this means this data is not clean and we need to process this data. So we will be dealing with this in a later point of time after we analyze this data. Okay, so this is one thing that we have we got interested in while we found the analysis. Okay, so we are going to put both of these columns in this particular label, and the regular to regular. Okay, so the second categorical column, so again I'll just copy this, and the second categorical column is item visibility is a numerical column, item type. Okay, so let's put it here. Okay, so it is very congested, so we need to increase the size of this x-axis. So this is the x-axis size. The first number is the x-axis size and the second number is the y-axis size. So 30 will be a good number for this particular plot. So now that it is in a spacious manner. So these are the different uh, items or food types we have. Okay, so the item type, so it is dairy, soft drinks, meat, fruits and vegetables, household, baking goods, snack foods, frozen foods, breakfast, etc. Totally we have about in this case it's around 16 values. Okay, so 16 item type values are here, and we have more values in this fruits and vegetable columns and snack foods column. Okay, so this is the distribution of this item type. Okay, so the next column which we need to plot is the outlet size column, right? So I'll just copy this. So we just need to change this item type to outlet size. Okay, so I'll just copy this again and put it in the 6. Okay, so we don't want this title, or let this title be. Okay, so let's run this. Okay, so I'll just change this size to 6,6. Okay, so we have three outlet size here. So one is medium, small, and high. Okay, so these are the outlet size. So similarly, you can find the plots for the other categorical columns. So the other categorical columns are outlet location type and outlet type. Okay, so it is the similar procedures. You just need to change the column name. Okay, so okay, 1 second. Okay, so the next thing which we need to do is data pre-processing. Okay, so we are done with the data analysis part where we have plotted this numerical values and categorical values. So the next step is data pre-processing. So I'll just make a text here as data pre-processing. So let's again print the first 5 rows of the data frame. So big Mart data dot 8. Okay, so in this case what we are going to do is convert all these categorical columns or categorical columns into numerical values. So as I've already told you, we cannot feed this text data or string data directly to our machine learning model. So we need to encode all this data to suitable numerical values. And for this, we are going to use a method called as label encoding. Okay. So now what I'll do is, so there is another thing which we need to discuss here. So I have told you previously that we need to change this low fat and LF to this low fat, right, and the regular to this particular regular. So let's do that thing before encoding it. So big mart data and item fat content. item fat content. So in this we need to see what are the different values we have. So value counts, this will tell us all the unique values. So we have low fat, regular, LF, reg, and low fat. So we need to change these three, right? So let's do that now. So big mart data dot replace, and we need to mention this curly brackets here. So I'm taking item fat content column. So item, let's copy this, item fat content, and in this I want to replace few things. They are, if the value is low fat, I want to encode it to low fat like this, okay? And if it is LF, I want to change this to again low fat, okay? And the final thing is to change this reg. So it should be in quotes. So reg to regular, okay? So it should be changed to this regular, okay? Okay, so these three things we want, and finally we need to mention this in place. So this will change, this will replace all those values, and it will edit it in the original data frame. So we need to mention this in place. So in place is equal to true. So we are just taking this big mart data, and in the item fat content we are changing low fat into this kind of low fat. So both are in caps. So this LF also to low fat and reg to regular. So let's run this. Okay, so invalid syntax. So okay, so I think I have missed some codes here. Mm, regular. Okay, so it shouldn't be equal to sign. So that's the error here. So let's run this. Okay, so we can again check this value counts whether it, so to see whether it has worked well. Let's run this. Okay, so now you can see here we have only two categories here. One is low fat and the other one is regular. So we don't have these three other columns. Okay, so now let's do this label encoding. Okay, so I'll just make a text here, label encoding. So in this what we are going to do is take all the string values. So we are going to take all the categorical values. So the here we have this categorical values as, yeah, so these are the 7 categorical values, and we are going to take all these categorical value and transform them to some numerical values. Okay, so just come here and let's do the label encoding part. So encoder, so we have imported this label encoder function from sklearn.preprocessing, right? So let's put that here, label encoder. Okay, so let's run this. And now we have the Figmart data. Mention the column name. So the first column is this item identifier, right? So item identifier, Figmart data, item identifier. So this is the first categorical column, which is equal to. So we need to mention this encoder. So this encoder is nothing but label encoder function. So encoder dot fit transform. So this will transform all the numerical values into corresponding labels. So fit transform Figmart data and item identifier. So again we need this item identifier here. Okay, so when you run this, what happens is it will take all the values in this identifier and it will give one label to each of the unique values. Let's say if we have this low fat and regular, right? So this low fat will be changed to 0 and this regular will be transformed to 1. So these are called as labels. So this is how you can convert categories into numerical values. Okay, so it's I'll check whether this is correct. So bigma data item identifier, which is equal to encoder dot fit transform. Okay, so now what we are going to do is do the same for all the other categorical columns, so all the other 7 categorical columns. Okay, so I'll just copy this. So this is for the second column, this is for third, fourth, fifth, sixth, and finally 7. So totally we have 7 columns, right? So the second one is for this item fat content, so which has low fat and regular. So you need to change it here and here. Okay, and the third column is item type. So I'll copy this. So it's the third column, so item type, and the fourth one is outlet identifier. So let's copy this, and next one is outlet size, and outlet location type. Okay, sorry, I again copied it. Outlet location type, and finally it's outlet type. Okay, so this will encode all the categorical columns into corresponding numerical values. Okay, so let's run this. Okay, so now you can again print the first 5 rows of the data frame. Now let's see whether these categorical columns are there or not. Okay, so now you can see here we only have numerical values here. So these categories are given some specific numerical values if it is unique. So this is how you can encode all the categorical columns into numerical values, and this is the important data pre-processing step. So the remaining steps are very simple. So now what we are going to do is we are going to split our data and features. So I'll just make text here. So splitting, sorry, not data and features, it's splitting features and targets. Features and target. So as you know, here the target is outlet cell, right? So this last column, item outlet cell. So that is the target. The remaining columns are features. So let's take two variables, x and y, and let's store all the features in x and all the target in y. Okay, so big Mart data. So now what I'm going to do is drop the target column. Okay, so dot drop columns is equal to item outlet sales. So this is the column I want to drop, and let's put axis is equal to 1. So if you are removing a column, you need to mention axis is equal to 1, and if you are removing a row, we need to mention the axis is equal to 0. Okay, so what I'm doing is I'm removing this outlet item outlet cell, the target, from this data frame and storing it in x, and this particular item outlet will be stored in this y. Okay, so big Mart data item outlet set. So this will give us x and y, where x is the feature and y is the target. So we can print x and y separately. Now you can see it doesn't have this item outlet cell, whereas if you print y, it contains this entire last column. Okay, so this column will be stored in y. Okay, so this is how you can split your features and target. So the next step is to split our data into training data and testing data. Okay, so splitting the data into training data and testing data. Okay, so we need to create 4 arrays: x train, x test, y train, and y test. Okay, so we need to use the train test split function. So if you remember, we have imported this train test split function from sklearn.model selection. So x and y test size is equal to 0.2. So 0.2 means I'm taking 20% of the data tested. So I'll explain you in a minute what we are doing in this line of code. And I'm taking this random state. Random state is equal to 2. Okay, so let's run this. So what we are doing is we are splitting the data into training data and testing data. So we are just taking this x and y. So this x will be splitted into training data and testing data, and the corresponding y for the training data will be stored in y train. Okay, so you can see this x train, right? So X train is the training data. So this X is splitted, and the corresponding Y value, this corresponding outlet sales value will be stored in Y train. And we have this testing data here, and the corresponding this Y value will be stored in Y test. So basically, we are splitting this X and Y into these two kinds of data, and that's why we are mentioning this X and Y here. Test size means the size of our testing data. Generally, we take 10 to 20% of the data as testing data, and random state is equal to 2. So random state means if you mention random state is equal to 3, your data will be split in a different manner. If I use 2, it will be in a different manner. If you want to split your data in the same manner that I am splitting, you need to mention this 2. Okay, so this is like an identification number for similar splitting. Okay, so now we can just run this. So we have already run this, right? Okay, so now let's print the original data set shape, x dot shape comma x train dot shape and x test dot shape. Okay, so let's run this. It will give us the number of data points we have for training data. So this is the original data set, which is X. It is 8523, and for training data we have 6818 data points, and for testing data this is 20% of this data, which is 1705. Okay, so the next step is training our machine learning model. So we have successfully splitted our data set. Then we just have two more steps to do. One is training our machine learning model and evaluating it. So machine learning model training. Okay, so the next, let me name the model. So we are just using a XGBoost regressor, right? So XGBoost regressor. So if you remember, we have imported the XGBoost regressor function from this. So go to this importing dependency. So you can see this XGBoost, right? So from there we have imported this XGB regressor. So I'll just copy this and let me create a variable as regressor is equal to XGB regressor. Let's put a parenthesis. So let's run this. So this will load this regressor model to this regressor variable. Okay, so XGB regressor to this regressor variable, and now we are going to fit this data. The regressor dot fit. So this is what is called as training our machine learning model. So in the fit, we need to mention the training data. So as I've told you, we will be training our machine learning model with this training data, and we will be testing it with testing data, right? Evaluating with the testing data. So here the training data are X train, and the corresponding price value is in Y train. So we need to mention it here. Okay, so this is just like plotting. So X train and Y train. Okay, so what happens is now the model tries to find the pattern between X and Y. So here X is the feature, Y is the target. So it will find the pattern between them. So what is the relationship between them? So if it is a particular item, and if it is a particular weight, and it is in a particular store, the value can be, the price value can be, in this range. And similarly, it will find this for all the data, and that is what is happening in this regressor dot fit function. Okay, so when we run this, our model get trained. Okay, so now this regression model is trained, and we can use this model to make our prediction. Okay, so the next step is evaluating it. So this is the last step, which is evaluation. So first I'm going to predict this on training data as well. So okay, so prediction on training data. So training data prediction is equal to regressor. So as we know that we have trained our regressor model, so mention this regressor dot predict. So this will predict the y value if you give the x value. Now I'm going to give this x train. So what I'm doing is, if you see here, we have trained our model with x train and y train, right? So now what I'm going to do is, I'm going to use this trained model to predict some values. So I'm giving this y train alone, so it will try to predict the y values, and I'm storing this predicted value in this variable called as training data prediction. So this y train is the original y value, and training data prediction is the values predicted by our model. Okay, so let's run this, and now let's find the r squared value. So r squared value. So r squared value is very useful for checking the performance of our model. So this r squared value lies in the range of 0 to 1. Okay, so that is the range of this particular value. Let's put this as r2 train. So if you remember, we have imported sklearn. From sklearn we have imported this metrics library, right? So this metrics library has this R2 score function. So R2 train is equal to metrics dot R2 score, and we need to mention the original values. So the original values are y train, and the values predicted by our model is training data prediction, right? So it will try to find the distance between them. So what it basically is, so it sees whether, how close the value is predicted by the model and how close is the original value. So y10 is the original value and this is the one predicted by our model. So it tries to find the distance between them. Okay, so let's try to print it. So generally we say that if the R2 score value is R squared value is, if it is close to 1, then it is a good model, maybe more than 7.75 or something, but it is not always the case. So this r goodness of this r square value varies, depending on the data set. So it is relative to the data we are using. Okay, so print r squared value. So you can generally say that, if it is greater than 0.75, if it is 0.85 or 0.90, then the model is performing well. But it is not always the case. In some cases, IR value can also mean that the model is overperforming. So we don't want that kind of thing. So I will be explaining you in detail about how this R squared function works and how we, evaluate our model, other kind of things in model training module. Okay, so I'll be making a separate module on those topics. But in this, just try to understand that this r squared value, goodness of this value can change depending on the data set. So it is relative to the data set, and we cannot give a general, generalization that if it is more, if the r squared value is more, then the regressor is performing well, or if the r squared value is less, it is not performing. So we cannot generalize it. So it varies relative to the data set. So that is one main thing. Okay, so now let's try to print this r2 train. Okay, so we get a r squared value of 0.63, which is actually kind of good. Okay, so in this particular case, and now we need to do the same thing, but in this case, we need to predict for testing data. Okay, so we have already predicted for training data. Now let's predict for test data. So we just need to change few things. So this is for testing data, test data prediction. So the importance of test data is our model already, seen this training data. So it is trained on this training data. So evaluating on training data alone is not, necessary. So we need to evaluate it on based on the testing data as well, because our model didn't see the testing data. Okay. So now I'm going to predict the y value for this test data. And again, I'll find the r squared value. So the r squared value should be almost close to each other for R2 train and R2 test. So if that value is very different, then that means our model is overtrained. Okay. So R2 test, here we need to change this to Y test. So if you can see here, Y test is the corresponding Y value for this X test. So this is the original values, and this test data prediction is the one predicted by our model. Okay. Now let's again print this. So R2 test. Okay. So let's run this. So we get a value of about 0.58. So this is how you can evaluate our model. Okay, so these two are close to each other. So this is about Big Mart sales prediction. So I'll just give you a quick recap of what we have done. So the first step is to import all the dependencies. Then we have loaded a CSV file to a pandas data frame using this read CSV function, and then we have just printed the first 5 rows to see what are the different features. So I have explained you what is meant by all these columns, and then we have seen what are the missing values and what are the categorical features, and I've explained you how we can handle this missing values, and we have replaced this, numerical missing values by means of average, and with this mode by more repeated values. Okay, so and then we have we did some data analysis, we got some statistical measures, we found the distribution plot of some numerical values, and then we use the count plot to find the distribution of the categorical columns, right? So after the data analysis, we did some label encoding where we have transformed all the all the string data or text data into numerical values, and then we have splitted our data into features and target. Later we have splitted our data into training data and testing data, and we have trained our machine learning model, which is a XGBoost regressor model, using this training data, and we have tested it based on this R squared value. Okay, so you can use some other regression models as well instead of XGBoost regressor, and you can think of how you can increase the performance of this model. Okay, so I cannot explain all those things in this video, so in some other modules I will be making videos on how to increase the performance or efficiency of the model and how to make better predictions. Okay, so but that is a topic for a different day. So I hope you have understood all the things we have covered in this video. In today's video we are going to discuss how we can build a breast cancer classification system using machine learning in Python. This is one of the standard use cases that we have in machine learning that is related to healthcare field. So first of all, let's try to understand more about this problem statement. Then we can discuss what is the workflow which we are going to follow for this particular use case. And then we can move on to the hands-on part where we will try to build this classification system in Python. Okay, so let's get started. So first of all, we need to understand the different types of tumor before going into this. So basically there are two types of tumors. One is benign tumors and the another one is malignant tumors. So tumor is nothing but we know that a human body is made of cells and tissues and organs and all those kind of things, and all the cells in our body divides and grows, right? And sometimes what happens is some of the cells in our body may divides repeatedly, without some control. So in that case it forms an abnormal mass, an abnormal tissue, and those abnormal mass is called as a tumor. So these tumors can be called as benign if those tumors doesn't move to the other parts of the body, whereas malignant tumors are those which have the capability to move to the other parts of the body. So all those malignant tumors are called as cancerous tumors, whereas the benign tumors are not that much harmful. So they are called as non-cancerous tumors. So the important feature of these malignant tumors is that they have the property of metastasis. So you can see this particular word here. So metastasis basically means when a tumor can travel from one part of the body and then it can move on to the other part. So say in this case we are discussing about a breast cancer, right? So what happens if malignant tumors is not treated is that, so we call those as cancerous tumors, and it has the capability to move on to the other parts like bones, brains, kidneys, and other kind of organs. So we need to determine whether that particular tumor is benign or malignant. So if it is a benign tumors, there is nothing to worry about, but if it is a malignant case, then the patient should be given immediate treatment. So that particular tumor has to be removed and they will be subjected to treatments like chemotherapy and radiation and so on. So in this use case, we are going to work on a data set which contains the details about this benign tumors and malignant tumors, and we are going to classify these tumors are benign or malignant. Okay, so this is the problem statement that we have, and let's discuss about the data set that we have now. So this particular data is derived from a test called as fine needle aspiration. So this is an example of a biopsy test where if a person is suspected to have some tumor, they will try to get some mass from that particular tumor and they will try to do some test on that particular tumor. So this is called as fine needle aspiration, and I have mentioned this particular procedure in this statement. So you can pause the video and go through this particular statement. You can also do some research on this. Okay, so this is one of the conclusive evidence that a pathologist takes. So a pathologist is a person who will basically conduct some test, blood reports, and all this kind of things, and they will try to find the diagnosis for a particular patient. Okay, so the data that we have is derived from this particular test called as fine needle aspiration, and this is the standard procedure in order to find whether a particular tumor is benign or malignant. Okay, and the data set that we have looks something like this. So we have the diagnosis here. 0 represents a person with a malignant tumor and 1 represents that particular tumor is benign, so there is nothing to worry about. So these are the two kinds of things that we have, and we are basically going to classify these tumors as benign or malignant, and we have measurements like radius, texture, perimeter, area, smoothness, etc. So these are nothing but the properties of the cells. So as we have told, you can just read this particular definition. So fine needle aspiration is a type of biopsy procedure. So biopsy procedure means they use a needle to get some particular mass. So we call this as an invasive procedure, whereas there are procedures like ultrasound and other kinds of scans. So a patient is not given any invasive treatment, whereas this is an invasive procedure which is called as a biopsy, where a needle is used in order to get that particular mass for testing. Okay, so a thin needle is inserted into an area of abnormally appearing tissue or body fluid. As with other types of biopsies, the sample collected during fine needle aspiration can help make a diagnosis or rule out conditions such as cancer. So this is all about a fine needle aspiration, and all these are the properties of the cells that are being tested. Okay, so once they have all this data, they will try to figure out whether that particular tumor can be benign or malignant. So this is the data set that we have, and we can use our machine learning models in order to find some relationship between the data so that we can classify these tumors. So this is all about the data set that we have, and now let's try to discuss about the workflow which we are going to follow. So the first step is data collection. So we will try to figure out the data which we are going to work on, and once we have this data set, once the data collection process is completed, we will process this data. So we cannot feed this raw data to our machine learning model. So there are some data pre-processing steps which we will cover here, and once you process the data, and then we need to split our data into training data and testing data. So the purpose of this is we will train our machine learning model using the training data, and then we will evaluate our model using the test data. So this is the purpose of splitting the data into training data and test data. And once we do that, we will train our machine learning model. So in this case, we are going to use a logistic regression model, because logistic regression is one of the best model when it comes to binary classification. So in this also we have a binary classification, right? Binary classification in the sense we are going to classify the data points into two types. Here the two types of are benign and malignant, or in other words it is nothing but 0 or 1, right? So here we are going to use a logistic regression model. So once you train your logistic regression model with this particular training data set, you will have trained logistic regression model, and we will also do some evaluation on this model using the test data. So once all these things are completed, we can have a new data, and once you give this new data, the model can tell you whether that particular tumor is benign or malignant. So this is what we are going to do in this particular use case. So I hope everyone is clear up to this point, and now we can move on to the hands-on part where we will try to build this system in Python. Okay, so let's get started. So I'll go to my Google Collaboratory. So here I'll just connect my Google Collaboratory system, and the first step is in order to import the dependencies. So first let's try to import the libraries and the functions that we need. So I'll just make a text here as importing the dependencies. So first of all, I'll import the basic libraries like NumPy. So I'll import NumPy as NP, and pandas as PD, and we are going to get this particular data set from sklearn. So sklearn actually has this data. So as I've told you, this is one of the standard use cases that a person learns while he or she is trying to learn machine learning. So we can get this data set basically from sklearn. So I'll import sklearn dot datasets. Okay, so you can also get this dataset from Kaggle. So if you import the dataset from sklearn, it will be in the form of NumPy arrays. Whereas if you want a CSV file, you can just go to Google and search as breast cancer dataset Kaggle. So you can see this particular Kaggle site here. So breast cancer Wisconsin diagnostic dataset. So this is the same datasets that we have in sklearn. So you can open this particular site. So there you can see here. So this is also available in UZI machine learning repository as well. So here you can see about the details about this particular data set, so when it was derived and other kind of things, and you can see all those information here. So all the input features that we have, so totally we have 31 columns here. So you can see here, so 10 of 32 columns. So if you want to download the CSV file, so go to the site and you can see this download option here, so data.csv. so this is the CSV file. You can download this CSV file from here, or you can use the data set that we have in this sklearn. Okay, so as you can see here, we have two labels as B and M. So this is our labels, where B represents benign and M represents malignant. Okay, and we have about 32 columns. So you can just go to this option and mention all. So if you do that, you can see all the columns that are present in this particular data set. Okay, so you can just slide this and see all the data sets that all the columns that you have. So these are the main columns. So the radius, texture, perimeter area, and all that. So basically, first of all, there will be a mean value, and then there will be standard error value and worst value for all these features. So first of all, like say for example, we have the radius, texture, perimeter, like all those columns, and then we have the standard error of radius, standard error of textures, and all those things. So again, you will have 10 different columns, and then you have this worst or largest value of all these values. So those are the 30 columns. So it's basically this 10 columns and then the standard error and the worst value of again these 10 columns. So that constitutes about the 30 columns that we have in this particular data set. Okay, so let's discuss more about this, but first of all let's try to import this dependencies. So we will use the data set from sklearn, as I've told you, and again you can use the data set from here as also you can download it from this particular option. So and now I'm going to import my train test split function from sklearn dot model selection import train test split. Okay, so this particular train test split function is used in order to split your data set into training data and testing data. And then we are going to import our logistic regression model. So from sklearn dot linear model import logistic regression. Okay, so we have also discussed how we can build this logistic regression from scratch in Python. So you can also refer to that particular video. So in this, we are going to use the logistic regression model that is available in sklearn. Okay, so now the last thing that we are going to need is the evaluation metric. So from sklearn dot metrics, I'm going to import my accuracy score. Okay, so this accuracy score is used to evaluate our model. In other words, it is used to determine how many correct predictions our model is making. Okay, so first of all, we will try to train this model using the data set that we have. So once we train that, we can give new values in order to so that the model can predict whether that particular tumor is benign or malignant. So we will also be making a predictive system for this particular use case. So this is the first step, which is importing the dependencies. So I hope everyone knows about this libraries. In case you are not sure about this, NumPy library is one of the important libraries that we have in Python, and it is used to make NumPy arrays. Okay, so we generally import this in the short form as NP. Okay, and pandas is the library which is very helpful in order to create pandas data frame. So generally the data sets that you have will be in the form of a CSV file or NumPy arrays. So we will load this data into a data frame which are more of structured tables. So that is the importance of pandas, which is used to create data frames, which helps us to analyze the data, process the data in a more structured way, and we import the pandas library in the short form as PD, and then we have the sklearn.datasets from where we are going to import this breast cancer data, and then we have this train test split function which we are importing from sklearn.model selection, and we are importing this logistic regression from sklearn.linear model, and finally we have also this accuracy score which is used to determine how many correct predictions our model is making and all that. So the next step is data collection and processing. So this is our next step. So I have to make a text. Just a second. Okay, so this is our next step. As I've told you, you can use this data.csv file as well. So basically they are the same data, only the format is different. So in case you are using this data.csv file, you will be using the function pandas.readcsv. So that particular function in pandas, so pd.readcsv will read the data from the csv file and it loaded to a data frame. So in this case, we don't have a csv file, so we are going to use the dataset from sklearn. So I'm going to load the dataset from this particular library. So I'll just make a comment here as loading the data from sklearn. So I'll name this as breast cancer data. Okay, so breast cancer dataset. So I'm going to import this from sklearn.dataset, so which we have imported here. So sklearn.datasets, and in this we need to use this load breast cancer. So these are the simple data sets that we have in this sklearn.dataset. So in this we are going to use this load underscore breast underscore cancer. So this is the name of the data set that we have, and you need to mention this parenthesis. Okay, so I'll run this. So this will load the data from this sklearn library to my variable called as breast cancer dataset. So you can also try to print this breast cancer data. So this will be in the form of a numpy array, so numpy n dimensional array. So we have the data, right? So this values represents all these column values. So we have this radius and textures, perimeter, and all that, right? So these are all those values, and then we have 0 and 1. So this basically represents the labels. So labels where 0 represents malignant case and 1 represents benign case, and then we have the names of the columns. So you can see here, so we have the radius, so mean smoothness, mean compactness, and just a second, you can see this target names here. Yeah, so feature names, so feature names are nothing but the column names that we have here. So these are the column names, so smoothness, mean, compactness, etc. So you have all those things in this array called as feature names, so mean, radius, mean, textures, and all that. So the first array is the data array, which contain all the values, and then we have the target array, which contains all the labels, and then feature names, which contains the name of the features. So we need to load all these things to a pandas data frame. So that is our next step. So I'm going to load this data. So I'll just make a comment here as loading the data to a pandas data frame. So it will be more convenient for us to analyze the data and process the data once we load it to a data frame. So I'll name this as data underscore frame. Okay, so let's call this data frame. So you can give any name. So you can give the name as df and anything like that. So I'll name this as data frame, and we are going to use the pandas library. So if you remember, we have imported the pandas in the short form as pd, right? So pd dot, so pandas has a function called as data frame. So note that the D and F should be in caps, and in that we need to mention some parameters. First is the data that we have, breast cancer dataset. So the name of the dataset that we have loaded. So we have loaded this data in this name, right? So breast cancer dataset. So we need to mention this. So breast cancer dataset dot data and columns. So columns is equal to, again you need to mention the name of the dataset dot feature names. So what I'm basically doing here is I'm going to load all this data. So you can see here the name of the data is a breast cancer data set, and we have we have this in the form of a dictionary. So you can consider this data as your key, and so you can consider this data as key and all the values as the values that are associated to it. So we know that in a dictionary there are key value pairs, right? So you can think about this like that. So we have the key value as data, and all the values are stored here. So if you want to access all those values, you need to mention the key, which is nothing but the data, and all the target values are present in the key called as target. And if you come here, all the column names or all the feature names are mentioned in the key called as feature names. So we need to mention all this. So when I'm mentioning breast cancer dataset dot data, I'm basically representing this particular aspect, because this array, so this array is called as data, right? So you can see the word here, data. So that's why I mentioned breast cancer dot data, and columns is equal to, so in this columns parameter we need to mention the names of the features that we have. So the names of the features are nothing but, so all these things, so they are represented using this array called as feature name. So you can see here, so if you drag this here, you can see this feature names here. It contains all the names of the features or all the names of the columns. And if you want to access the target or the labels, you have to use the word called as target. So you will basically represent this as breast cancer dataset dot target. So this is how you can load the dataset from this particular sklearn arrays, sklearn numpy arrays to a pandas data frame. Okay, so I mentioned the data, and in this columns parameter I'm mentioning the feature names. So I'll run this, and now let's see how this particular data frame looks like. So I'm going to print the first 5 rows of this data frame. So print the first 5 rows of the data frame, and for that you need to mention the data frame name. So we know that we have named this as the data underscore frame, right? So we need to mention that here. So data frame dot id, and we need to mention the parenthesis here. So if you run this, it will print the first 5 rows in this particular. So you can see here this particular data is not very structured, so hence we are loading it to a pandas data frame, which is more of a tabular view. Okay, so we have the mean, radius, mean, texture, and all that. So first 10 values contains the mean of all these values, radius, texture, perimeter, etc. And then we have the next 10 values are again the same, radius, texture, perimeter, etc., but they are for the standard error for all those 10. And then we have the worst values. So these are the features ranges that we have. So totally we have about 30 columns here. And now what we are going to do is, this doesn't contain the label column. Okay, so this contains only this particular data, so we need to include this target column as well. Okay, so that's what we are going to do here. So for that, what I'm going to do is, so this step is adding the target column. So adding target column to the data frame that we have. Okay, so we can let's name this column as label. So we need to mention the data frame, which is data underscore frame, so the name of the data frame that we have created. And we have to use the square brackets here, and within this you need to name your column. So I'll name this particular column as label. So you can give any labels, like you can also name this as diagnosis and anything like that. So I'll name this as label. So in this particular label column, we are going to add all these values, zeros and ones. So we are basically adding one more column to this particular data frame. So this doesn't contain the target column, so we are going to add that. For that, we need to mention the data set, which is breast cancer dataset dot target, because this target is the array which contain all these values, so 0 and 1. So target. So you can run this, and now again you can try to print the first 5 rows of the data frame, or you can also try to print the last 5 rows of the data frame. So printing, so I'm going to print the last 5 rows of the data frame here. So for that, again you need to mention the data frame name dot tail. So if you use this yet function, you will print the first 5 rows of the data frame, and if you use the tail function, it will print the last 5 rows of the data frame. Okay, so you can see the last 5 rows of the data frame. So the only difference between this particular data frame and this is that now we have added our label column. So this is the label column which we took from this particular data set, which contains either 0 or 1, where 0 being malignant and 1 being benign. Okay, so this is the data set that we have. And now we can just analyze this data. So let's discuss how many data points are there, what is some statistical measures about the data, and all those things. So the next step will be the basic analysis and processing. So I'm going to print the number of rows and columns in the data set. Okay, so that is our next step. For that, you need to mention the data frame name dot shape. So here you shouldn't mention the parenthesis, because what you will get will be a tuple. So this is basically a tuple object. So in case of tuple object, you shouldn't mention the parenthesis here. So if you mention those parentheses, you will get some error. Okay, so tuple object is not callable, so you need to remove this parenthesis. Whereas in the previous case, while we are using the set function and tail function, we use this parenthesis. Okay, so when you run this data frame dot shape, it will give the shape of your data frame. So 569 31. So what this basically means is there are totally 569 different rows and 31 different columns. Okay, so 30 columns are for the input feature, and the last column is for our label. Okay, so 569 means we have the data for 569 different people. Okay, and this is what is this is how you can find the shape of the data frame that you have, and you can also get some information about the data. So getting some information about the data. So for that, you can use the function called as data.info. So dataframe.info. So it will give us some basic information about the data set. So it tells us what are all the different columns that we have, and whether it contains null values or not. So null values are nothing but missing values. So often in real world data set, what happens is a lot of the values will be missing. So in case the values are missing, what we will do is we will work on some techniques like imputation, where we will try to replace all those missing values with some mean values and median values and other kind of things. So we have already discussed about this imputation in our video in the 4th module, so you can also refer that. So the 4th module is called as data collection and processing in our machine learning course. In that, I have explained you how you can handle the missing values. So in this case, we don't have any missing values. So totally we have about 569 rows, right? So in each column we have 569 non-null values. Non-null values means these values are not missing. Okay, so null values means missing values, and non-null means those values that are present. So we don't have any missing values, and the data type for all those values is float. Okay, so it is a floating point. Floating point is nothing but a decimal value, and the last column is an integer value. It's only 0 or 1, so it will basically be an integer value. So this is how you can get the information about the data set, size of the data set, and so on. And there is also a specific way for us to find whether there are any missing values or not in our data set. We know that there are no missing values, but I'll show you a method which you can use in order to find whether there are any missing values. So this is checking for missing values. So these are all the standard things that we do in every machine learning use cases. So you can just take note of this. So I'm mentioning my data frame name dot is null dot sum. Okay. So this will tell you whether there are any missing values in each of the columns. So all the column names will be mentioned, and it will tell you how many missing values are there in each column. So 0 basically means there are no missing values in any column. So that's why we have here. And in most of the cases, we will basically have some missing values and we need to deal with it. So in this case, we don't have that. So we can move on to the other aspects. So now we are going to, find some statistical measures about the data. So this step is statistical measures about the data set. So often if you're working mainly on data analysis aspects, all these things are needed, but we don't need all those things. So we just need some basic information about this data, and this is how you can get it. So you can find the values such as what is the mean value, standard deviation, and all those things. So mention data frame dot describe. So describe parenthesis. So this describe function is used in order to give us some important statistical measures about the data. So we have all the columns here, right? So all the columns are here, and we have the count. So count basically tells you how many values are there in each column, and then we have the mean value. So this particular thing gives the mean value for all the values in this mean radius, and we also have the standard deviation value, and what is the minimum value in this column, and what is the 25th percentile. So these are not percentage values, these are percentage. So there is a difference between them. So 25 percentile means 25 percentage of the values are less than 11.7. 50th percentile means 50 percentage of the data are less than 13.37, and so on. And then we have what is the maximum value here, and so on. So we have all these statistical measures for all the columns in our data set. So now we can move on to the other aspect. So now we are going to see how many benign cases and malignant cases are there. So we are going to basically count how many 0 values and 1 values are there in our data frame. Okay. So this is checking the distribution of target variable. So target variable is nothing but our labels. So yeah. So mention the data frame label. So we have named this as label, right? So we have created a column called as label. Yeah, so this is the column that we have created here, and we have used all these target values, right? So we are going to call this particular column called as label. So you need to mention the name of this label. So data frame within this square brackets mention label dot value counts. So let's run this. So here, as you can see here, so totally we have 357 values as 1 and 212 values as 0. So we know that 1 represents malignant and 0 represents, 0 represents malignant and 1 represents benign. So you can also see here. So I'll come to this Kaggle data set. So just a second. You can see here. So totally we have about actually I think it's mentioned here. Yeah. So totally we have 357 benign cases, right? So and 212 malignant cases. So you can just compare this with 1 and 0. So 1 represents 357, which is basically the benign cases, and 212 is malignant cases, which is represented as 0. Okay, so we have just basically labeled all the malignant cases as 0 and benign cases as 1, whereas in this particular CSV file it will be in the form of B and M. So if you use the dataset from this sklearn, it is actually labeled as 0 and 1. Okay, so it is better to have the label as this integer values rather than having character values as B and M. So that's why we are using this particular data set, and you can also get more information about this if you search for UCI machine learning repository. So that particular repository contains the original data set for this particular data set. So the one main thing that you need to understand here is 1 represents for benign data points and 0 represents data for the malignant data points. So I'll just make a text here as 1 represents benign, and let's say that this 0 represents malignant. So malignant tumors are those which can spread to other parts of the body, which is more riskier than the benign, which is not that much riskier when compared to malignant cases. So now we are going to group this data set based on the label that we have. Okay, so I'll mention data frame dot group by and mention label here, label dot mean. So what I'm going to do here is, so we are going to take all these values for 0 and 1. So like what happens basically here is all the values for the zeros will be taken. So all the malignant cases will be taken and the mean value will be determined for all the columns, and then the same will be done for the benign case as well. So I'll run this, you will understand. So we have two labels here, right? So 0 and 1. So all the values, in each column will be taken for malignant cases, which is represented by 0, and the mean value will be found for all the columns, and then the same is done for the benign column. So the important reason that we are doing here is, you can just look at the data that is present here, the value of the data present here. So we know that 0 is malignant, which is a more riskier state, and 1 is benign, right, which is nothing to fear in that particular case. So in the case of malignant, all the values are slightly larger than the values of the benign cases. So you can see the mean radius. So these are all, we know that values of the nucleus of the cells that are being studied. So we have the mean radius value, the mean of this entire value is around 17 for all the malignant cases, where it is slightly lesser for benign cases. Again, the texture value is high, whereas in this case it is low, and so on. So we can see a clear distinction between the malignant case and the benign case, and in the malignant case all the values are almost greater when compared to this benign case. So this is one of the important difference that we can see in this data set, and this is going to be very helpful for our model in order to differentiate the data, in order to differentiate and see whether a person is having benign tumor or a malignant tumor. So this is very, very important. Okay, so this is how we can manually look at the difference between the two classes of the data that we have. So the next step will be splitting that input features and the target. So all these are called as the input features. So all the 30 columns from this mean radius all the way to this worst fractal dimension. So all these are called as the input feature, and the last column label. So this is called as the target column. So we are going to separate this data. Okay, so the reason is that we will try to feed this data. So all these data, all these input features are called as X, and all the label values are called as Y. So this is basically like fitting a curve to x-axis and y-axis. So we will take all the input features as Rx, and the label value as y. So we need to separate this x and y. So all the 30 columns will be considered as x, and this label column will be considered as y. So this is one of the important things that we need to do, because while fitting the data to our machine learning model, we will fit it with this x and y. So this part will be separating the features and target. Features are nothing but all the columns except the target column. Features and target. So once we train the model, so once you give the feature values, it can predict the target value, whether it is either 0 or 1. Okay, so I'll name two variables here, x and y. So x will be my input feature. So what I'm going to do is, I'm going to take my data frame and I'm going to drop only one column. So I'm going to drop my label column. So column is equal to label, and axis is equal to 1. Okay, so what we are basically doing here is, we are taking our data frame and we are dropping the label column alone, because we need all the features separately, right? So we will be dropping this label column alone, and we will be storing this label column in y. So it is a very simple procedure. So I'm dropping the column and I'm mentioning this axis as 1. So whenever you are dropping a column, you need to mention the axis value as 1, and whenever you are dropping a row from a data frame, you will mention the axis value as 0. So here we know that label is a column, right? So we are mentioning the axis value as 1, and this y will be the label column. So data frame, and in the square brackets mention label. So we are storing all the values except for label in this x, and all the labels values are stored in this y. So you can try to print this x and y. So this contain all the input features. So we totally have 569 rows and 30 columns, and as you can see here, there is no label column here anymore. So X doesn't contain the label column, and you can try to print this Y. So Y contain all the labels, either 0 or 1. So again, it contains 569 values, the corresponding labels for each column. So you can see the first row. So the first row is numbered as 0. So the label for this first row is 0, the corresponding label here. And for the label for this second row, which is represented by this numbering 1, so the label for this particular column is this 0, again 0. So we have the labels in this particular Y variable. And now what we are going to do is we are going to split our data into training data and testing data. As I've told you, we use the training data in order to train our machine learning model, and we will use the test data to evaluate our model. So we need to separate this data set as training data and testing data. So splitting the data into training data and testing data. So this is the next step. So this is also one of the important steps that you need to remember. So I'm going to create 4 arrays here. So they are xtrain, xtest, and ytrain, and ytest. So these are the 4 arrays that we have, numpy arrays. And I'm going to use the train test split function. Okay, so train test split. So I'll just complete this line of code, and I'll explain you what I'm doing here. So test size, we can give the test size as 0.2, and you can give some random state. Random state is equal to 2. Okay, so here first we are creating 4 arrays: xtrain, xtest, ytrain, and ytest. So what we are doing here is, so this x value, this x array will be split into 2 parts. One is training data and the testing data. The training data is called as xtrain, and the testing data is called as xtest. And the corresponding labels for all the values in this xtrain is stored in this ytrain, and all the corresponding labels for this xtest is stored in this ytest. So you can just consider these two things, xtrain and ytrain. Okay, so the labels for this xtrain is present in this ytrain, and the xtest labels is present in this ytest. So we are basically splitting this x and y into 2 groups of data. One is training and the other one is testing data. Okay, so these are the 4 arrays that we are creating, and for this we are using the train test split function. So where does this train test split function comes from? So we have imported it. So in the first cell, we have imported a train test split function from sklearn.model selection. Okay, so this function will help us in order to split our data into training and testing data. And we have some parameters here. So just a second. Yeah, so we need to split this x and y. So we need to mention them in this particular parenthesis. So x and y, because I'm going to split this x and y alone. And we have this test size as 0.2. So 0.2 basically means like out of this entire data set, out of this 569 rows, I want 80% of my data to be training data and 20% of the data to be test data. So that's why we have mentioned 0.2. So 0.2 is nothing but 20%. So 20% of data will be your test data, and the remaining data, which is 80%, will be your training data. And then finally we have a random state. So this is not actually very important. So the what this random state do is, so each time you run this train test split function, your data will be splitted in a different way. Okay, so it won't be splitted in the same way. But if you use this random state value as some number, it will be splitted in the same way. Let's say that you are practicing this code, and you are splitting this data set again, and if you mention this random state is equal to 3, your data split will be splitted in a different way. But if you mention the same number that I'm using now, your data and my data will be splitted in the same way. Okay, so this is just for a way of splitting the data. So this is just basically to reproduce the code, reproduce how it has splitted the data before, and so on. So that is the importance of random state. So you can run this, and now you can try to print the shape of x dot shape. Again, you shouldn't mention parenthesis for this shape, as it is a tuple data type. So it should be just x dot shape. So you shouldn't mention the parenthesis like this. So x dot shape, and then we have to mention x train dot shape. So now we are just checking how many data points are there in our training data and test data. Shape and x test dot shape. So x is my original data set, right? So x is the original data set that we have without the label column, and x train is my training data, X test is my testing data. So I'll run this. So as you can see here, so the original data set contains about 569 data points, and out of those 80% of the data, which is 455, comes into this X train, and 20% of the data, which is 114 values, comes to this X test. Okay, so this is how we can split our data into training data and testing data, and we are almost in the last part of this particular use case, which is to train our logistic regression model. So this step is called as model training. And here we are going to use a logistic regression. As I've told you earlier, logistic regression is very useful for binary classification problem where you just have two classes. In this, the two classes that we have are benign and malignant. So logistic regression, and we have already imported this logistic regression from sklearn.linear model. Okay, so from sklearn.linear model we have imported this logistic regression model. So we are going to use this. As I've told you, we have already tried to build this logistic regression model from scratch in Python in our channel, so you can also refer that video as well if you want a detailed explanation on what is meant by this logistic regression or when to use that and all those kind of details. So this particular video, we are just going to see the implementation of it. So I'm creating a variable called as model, and within this I'm going to load an instance of this logistic regression model. So mention logistic regression and parenthesis. So I'm loading an instance of this logistic regression to this variable called as model. So run this, and now we are going to fit our data set, fit this X train and Y train to our logistic regression model. So this will be training the logistic regression model using training data. So training data are nothing but X train and Y train. So I'm going to use this model. So this model is now is nothing but this logistic regression that we have loaded. So model dot fit. Okay, so model dot fit X train and Y train. So this is just like X coordinate and Y coordinate data. So we are going to fit these two data to our logistic regression model, and it will, what happens here is it will try to figure out the relationship between this X train and Y train. So how this all the values, all the input feature values are related. So you can see all the input feature values, right? So you can see the 30 columns here. So from mean radius all the way up to worst fractional diameter, which is our X, and this label is our Y, right? So it will basically try to find the relationship between all those X values and the Y value. So now it knows, like, how the data looks like if the label is 0, and it also knows how the data looks like if the label is 1. So that's what basically happens when you try to fit a logistic regression model with some data set. So it tries to learn it repeatedly. It will try to go through the data repeatedly, and it will try to find a best fit for this particular data set. So let's run this, and this will train our logistic regression model, and now we can evaluate our model. We can see how well our model is performing and all that. So this part is about model evaluation. Okay, so model evaluation, and for classification problem we basically use a metric called as accuracy score. Okay, and let's see how we can use this. And we have already imported this accuracy score function from sklearn.metrics. So accuracy score, and this will be, first let's try to find accuracy on training data. So we have trained our model with this X train and Y train, right? So we will try to give this X train alone now, and we will ask our model to predict the label values, and then we will compare the predicted values with this true value, which is Y train. So first we will train evaluate our model with the training data, and then we will evaluate it with the test data that we have, which is X test. Okay, so this is accuracy on training data. So this is the first step, and I'm going to create an array called as X train prediction. So I'm going to predict all the values, and I'm going to store all the label values in this X train predictions. So I'm going to use this model.predict. So again, model.predict is a function which is used to predict the label value. So the two functions that we are using here is fit and predict. Okay, so the fit function is used to fit the data set to our model, and once your model is trained, so when you run this fit function, your logistic regression model will be trained with the data set, and after that you can use this predict function in order to predict the label given the X values. Okay, so that is what this particular thing is all about. And I'm going to use my extrain value. So what happens basically here is, so I'm going to give my extrain values and I'm going to predict whether the label is going to be 0 or 1 using my model. Okay, so all those values predicted by my model will be stored in this extrain prediction. So this is the predicted values. So this predicted values will be compared with the true values. So the true label values is nothing but y train. Okay, so the true values that are present in our data set is called as y train, and I'm going to compare this y train and the extrain predictions. Okay, so it's let's see how we can do that. So if you use this accuracy score, you can get that particular value. Let's name this as training data accuracy, and here we can use the accuracy score function, and within this we need to mention the true value, which is y train, and this extrain prediction. Okay, so here your y train is the true value and the extrain prediction is your predicted value. So the value which is predicted by your model. So we are comparing these two values using the accuracy score function, and that particular value will be stored in this training data accuracy variable. So let's run this. So it will give this value to this training data accuracy now, and we can now try to print this accuracy value. So use a print function, print, and I'll just mention some text here as accuracy on training data is equal to, so you can just copy and paste this particular value here, training data accuracy. So it will try to give you the what is the accuracy. So the accuracy is about 0.949, so it is around 0.95, right? So 0.95 means 95 percentage. So in other words, out of 100 data points or out of 100 cases, your model can predict correctly for 95 cases, and this particular accuracy is actually very high, right? So like out of 100 times you can get correct prediction for 95 values, which is actually high. So this is the accuracy value on our training data, but as I mentioned earlier, the accuracy value on test data is very important, because test data is mainly used for evaluating the model. So that is the reason why we try to find the accuracy score for this training data. I'll tell you that in the next step, but now let's try to do the same thing. So let's try to find the accuracy score, but in terms of this the test data, which is X test and Y test. So I'll just copy these cells. So I'll just copy this. We just need to do some small changes. So I'm going to change this to accuracy on test data, and instead of X train we should use X test. Okay, so X test is nothing but as you can remember, we have splitted the data into training and test data, and the test data is called as X test. So we will be giving only this X test value, and we will be predicting the X test labels. Okay, and again this should be Y test, and this should be X test prediction. Okay, so and this is test data prediction. So we are just basically doing the same thing, but we are changing the data set that we have. So we are evaluating our model for test data. So I run this, and again we can print this accuracy score, accuracy on test data. So test data accuracy. Okay, so now we can print this and we can check the accuracy score now. So in this case, the accuracy score is about 93%. So for the accuracy score on training data is around 95, and in the case of test data, it is 93%, which is also very high. So the reason we are trying to find the accuracy score for both training data and testing data is that sometimes our model tends to overfit in the sense it will try to learn more from the training data. So in that case, what happens here is, so your accuracy on training data will be it will be like very high, whereas the accuracy on your test data will be very low. So if you have an accuracy score of about 95% on a training data, the test data accuracy can be 50% or 60%. So that means your model has overfitted. So what overfitted models will do is, it can only make correct predictions for the training data alone, but it cannot make correct predictions for the test data. So that is the reason we will always try to check the accuracy on both training data and the test data as well. But the accuracy on test data is what is actually very important for us. So this is how we evaluate our model, and we are in the last step of this particular use case, which is to build a predictive system. So now we know that our model is trained, right? So if you give a X value, it should predict whether the label is either 0 or 1. In other words, whether the tumor is benign or malignant. So that's what we are going to do now. So we have already seen this in multiple projects. So it is actually the same thing. So building a predictive system. So I'm going to create a list here as input data. List or tuple, you can just create anything. So input data. Okay. So in this, I'll copy and paste some values. So you can see this CSV file, right? I have downloaded this particular file. So you can see that particular file here. So, and I'm going to open this with my notepad. So this contains the ID number. So we don't need this ID. Okay. So this is the data set that I downloaded from Kaggle. So we have the ID and the diagnosis. So diagnosis tells you whether, it's benign or malignant, and M represents malignant, and B represents benign. Okay. So and then we have all the other values. So I'm going to copy some random values here. So I'll just copy this particular value. So remember what is the label in this value. Okay. So in this case the label is M. Okay. So M basically means malignant, and the label for M is 0, right? So once we feed this data to our model, it should tell that the label is 0. So let's see how it is predicting. So that is what we are going to do here. So I'll paste that particular value in this input data. Okay. So now I'm going to convert this tuple. So this is basically a tuple. So when we put the values in this parenthesis, it's called as a tuple. So it is a different data type, and I'm going to convert this to a NumPy array because we need to do some processing before we can feed it to our logistic regression model. So this step is to change the input data to a NumPy array. Okay. So we know that we have imported the NumPy as NP, right? So this will be to convert it to a NumPy array. So I'll name this as input data as NumPy array. So you can just give short names. So I don't want to give short names because it will be a bit confusing when you just look at the code. So I'm just putting it in a longer format, but you can just name this in a short form as well. So input data as NumPy array, and for this we are going to use the function from NumPy as np.asArray. Okay. It's np.asArray, and within this you need to mention this input data. So what happens here is this tuple will be converted to a NumPy array now. So this is the second step, and then we need to reshape this array. So this reshape the NumPy array as we are predicting for one data point. Okay. So the reason we are doing here is, so in previous cases we have trained our model with about 455 data points and so on, right? And then we tested with a lot of data, but the model doesn't know how many values we are predicting. So we need to reshape this array so that the model knows that we want to predict the label for only one value. So that's why we will reshape this array, and let's name this as input data reshaped. So we cannot do this in the case of tuple and list. So that's why we are using a NumPy array. Okay, so that's the reason we have converted it. So input data reshape is equal to, so mention the name of the array, and we have the function called as reshape 1 comma -1. So this will reshape this array in this particular shape, and then now the model knows that we want to predict the label for only one value. And then now we are going to make the prediction. So prediction is equal to model.predict. So as I have told you earlier, this predict function is we have this predict function in this logistic regression, so which we have already used in order to predict the labels for xtrain and xtest. So we are going to use the same function. So when you give some value for this particular predict function, it will give you the label value. So we are going to predict the label for this particular input data reshape, right? So I'm just going to paste this, and you can try to print this prediction. So print prediction. Okay, so I'm predicting the value, and I'm storing that particular prediction value in this variable called as prediction, and you can try to print this. So you can run this. So now the model should give the label value as 0. So we know that malignant are represented by the label as 0, right? So I'll go to this particular, yeah, so we have represented here. So 0 is represented as malignant. So we know that this particular data point that we copied is for the malignant case. So, so it is M. So it should give the label value as 0 because 0 represents malignant. So let's run this and see whether the model is predicting the values correctly. Yeah, so you can see here, so we have the value as 0. So we know that 0 means malignant, right? So you can also try the same for benign cases as well. So let's just add one more thing. So I'm going to add if condition here. If my prediction value is 0, okay, so if my prediction value is equal to 0, in that case I want to print that the breast cancer is malignant, and else. So if else basically means if the value is you know 1, then we can print that it is benign. So this is what we are going to do. So if the label value is 0, it will tell it is malignant. If the label value is 1, it will tell it is benign. Okay, so we can run this. So the prediction will be basically in the form of a list. So we know that the values enclosed in square brackets is in the form of a list. So all the values you get will be in the form of a list, and I am accessing the first value. So when so this particular list is nothing but your prediction variable. So this is the list that we are getting, and prediction square bracket 0. So what this means is the first value in this prediction list. So if that particular first value, so we know that there is only one value, so that's why we are mentioning this. So if that value is 0, then we can call this as malignant. If it's not the case, in the sense if the value is 1, I want this to be printed as benign. Okay, so you can also copy the data for some benign case. So I'll copy this. So here you can see the label as B, and you can copy this value, and I'll paste it here. So in this input data, so you can change the value here, and once you paste this particular data here, now it should tell us that it is a benign case. Okay, so let's see whether it is predicting correctly or not. So now we can see here, so the label value is 1 and the breast cancer is benign. So this is how you can build a predictive system where if you give all those X values, all the features, it will try to print the label value. So this error is not actually important. So what it tells is X does not have valid feature names. So the reason is that, so if you see here, so in this X we have this mean radius, mean texture, and all that. So we have this feature names here, right? So we trained our model along with the feature names, but when we are giving the input data, we are not mentioning that particular feature name. So that's what it is mentioning here, but it is not a problem. So we are just getting the predictions correctly. So that's what is important, and this is how you can build a predictive system. Okay, so I hope everyone is clear up to this point. I'll just give you a quick recap of what we have done all along, so that you can just understand all the things clearly. So the first important step is importing the dependencies, and this is what we do in any Python programming. So we have imported all the libraries that we need. So the important libraries are NumPy, Pandas, and sklearn, and we have imported this train test split function for splitting our data into training data and testing data, and then we are using this logistic regression model, and accuracy score is used to evaluate our model to find what is the correct predictions percentage, and we need this NumPy for creating NumPy arrays and Pandas for creating data frames. And here we have loaded the data set from the sklearn library, and once we do that, we are loading that particular data to a Pandas data frame, and we are naming this as data underscore frame. Okay, and for this we are using the function from Pandas which is called as data frame, and in that we are calling the data from this particular sklearn data set and the feature names, which is for our column names. So you can print the first 5 rows of the data frame using the set function, and after that we are adding the label column. So label is nothing but the target, whether it is either 0 or 1, where 0 being malignant and 1 being benign, and we are adding that particular column, and we are trying to print the last 5 columns in our data frame. Now you can see that there is a label column added here, and after that we are trying to see how many rows and columns are there using the shape function, and then you can get the information about the data set using this info function, and then we are trying to see whether there are any missing values in the data frame. And the next step is to get some statistical measures about the data, which we can do by using the describe function. And the next step is some basic data analysis parts. So how many 1 values are there and how many 0 values are there. So we found that about 357 values are benign cases, which is represented by 1, and 212 malignant cases represented by 0, and we can group this data based on the labels. And we have seen that so this is one of the most important insight that we get. So all the values are slightly higher for malignant cases compared to the benign cases. So you can see the clear difference between these two values in the 2 rows. Okay, and then we have splitted all the X value and Y values, X being all the features and Y being our target. And after that, we have splitted this x and y into our training data and test data. And then finally we have trained a logistic regression model from sklearn. So we have fitted the x train and y train. So once the model training is done, we are trying to find the accuracy value for training data as well as the test data. And the final step is about building a predictive system which tells us whether the cancer is benign or malignant. Okay, so I hope everyone is clear up to this point. Machine learning project series, and in this video we are going to discuss how we can build a machine learning system that can predict the amount of calories burnt during exercise. So this is a very interesting machine learning use case, because like we face this in our day-to-day life regularly. A lot of people are very interested in the exercise that they do and the diet that they take, and what is the amount of calories associated with them. Say for example, how much calories they intake when they eat, and how much calories do they burn when they do exercises, and things like that, right? And in this video we will be discussing the same, where we will be using machine learning to solve this problem. Okay, so first of all, let's try to understand more about this problem statement. So I'll be explaining you what happens inside our body when we do exercise. So what are the metabolic activities that are taking place when we do exercise. So it helps us to understand this problem statement better. And then I'll explain you the workflow which we will be following for this particular project. And then we can go to the coding part. Okay. So it will be the steps in this video. So first now, let's understand what happens when we exercise. Okay. So let's consider that a person is exercising. So he can be doing a heavy lifting like bench press, or he can be just running in a treadmill. And let's say that before 4 or 5 hours of his workout, he has taken some good meal. Okay, and the energy in this food will be used by that person, so the body of that person, to do that exercise, right? So what happens is, so let's say that the person ate something that is more of carbohydrates. So this carbohydrates will be broken into more simpler forms like glucose, and when the person do some exercises, this glucose will be broke down and it will be converted into energy using oxygen. So the muscles that are doing exercise need more oxygen, and this oxygen is supplied by blood, right? And what happens is, as the body requires more oxygen now, the heart rate, the heartbeat will increase a lot. Okay, so increased heartbeat means increased blood flow. So this increased blood flow will give more oxygen to the muscle, which oxygen, this oxygen is used to break those glucose molecules. Okay, so this is what happens. So the main thing that we can infer from here is, when we do exercise, the normal heartbeat will be more. So normally in normal conditions, the average heartbeat will be around 75 beats per minute, but when we are doing exercise, the heartbeat can be more than 100 beats per minute. So this is one of the important inference. And when this energy is used to do exercise, only a part of this energy is used, the remaining part is converted into heat. Okay, so the body temperature will increase when we do exercise, and as a result of which, in order to reduce this temperature, our body will release sweat. So this is the reason that we get sweat when we do exercise. Okay, so to cool down this body temperature. So these are some important parameters which we need. So what we will be doing is, we will be taking the parameters such as the duration for which the person is doing exercise, and what is his average beats per minute. So heartbeat, what is the average heartbeat of that person during the exercise, and what is his body temperature. So these parameters will be used, and also the height and weight of the person will be used to predict how much calories the person will be burning. So this is our problem statement. So this is what we are going to do in this particular project. Okay, so I hope you have understood what we are going to cover in this video. Now let's understand what is the workflow we will do for this project. Okay, the first step will be to collect the data. So this is the main thing about machine learning is, it learns from the data, right? So we need appropriate data to train our machine learning model, so that it can find what is the amount of calories that the person is going to burn. Okay, so the first step is getting the data. So once we have the data, we cannot feed it directly to our machine learning algorithm. So before feeding, we need to process the data. So this step is called as data pre-processing, where we clean the data and do some processing on it. So this step is called as data pre-processing. And after pre-processing, we need to do some data analysis. So this data analysis helps us to understand our data set better. So understanding our data set better, helps us to make better inference and better predictions. So the third step will be data analysis, where we will use some visualization techniques, where we try to plot the data in some plots and graphs. So once we analyze the data, the next step is to split the data set into training data and test data. So the reason for this is, so we will train our machine learning model with the training data, and we will evaluate our model. So we will test our model with this test data. Okay, so After we split the data, we need to train our machine learning algorithm. So in this case, we are going to use a XGBoost regressor. So this is the machine learning model which we will be using in this particular case. So we will be training our XGBoost regressor with the training data. So once we train this XGBoost regressor, we will evaluate this model with the help of test data. So this is the workflow which we are going to follow. Here you can see here that we are using a regressor model, right? So because this is an example of a regression problem. So there are two types of problems in supervised learning. So one is classification and the another one is regression. Classification is all about classifying. Let's say that we can take a project like diabetes prediction, where we will try to predict whether a person has diabetes or not. So it is just an yes or no question, right? So those kind of problems are called as classification problem. And regressional problem is something in which we try to find some particular value, particular number. So in this case we are trying to find the calories burned, right? So the amount of calories is nothing but a particular value or particular number. So this is an example of a regression problem. So in case of diabetes, we are just predicting yes or no. So those kinds of problems are called as classification problem. So as this is a regression problem, we are going to use XGBoost regressor. Okay, so there are also other regression algorithms and the regression models. So in this case, let's use XGBoost regressor. So with that being said, let's get started with the coding part. So before starting with the video, I'll just give you a quick introduction to my YouTube channel. So in case you are new, just watch this, and if you already know about my channel, you can skip this part and go to the video. So this is my YouTube channel, and in my channel I'm making a project based, and once you go to this channel, you can see this machine learning course curriculum. So in this video, I have explained all the modules and the videos that I will be covering in this channel. Okay, so you can download the course curriculum file from here. So in that I have mentioned all those videos, topics which I'll be covering. So you can go to the playlist section. There, if you scroll down, you will see this hands-on machine learning course with Python. So here the videos will be module wise. So the first module will be on machine learning basics, the second module will be on Python basics for machine learning, and so on. So currently we are in the fifth module, which is on the mathematics for machine learning. Okay, so every Monday evening and Wednesday evening, I will be posting videos on this machine learning course order, and every Friday I will be posting one machine learning project video. Okay, so totally I will be posting three videos in a week, and two videos will be on the order of the machine learning course, and one video will be on this machine learning projects. Okay, so that is about my channel. So I'll give the link for the playlist, the machine learning project playlist and the machine learning course playlist in the description of this video. You can also check it out from there, and you can join my Telegram group and my LinkedIn. You can connect with me in LinkedIn or my Facebook group. So I'll give all those links in the description of this video. So now we will be doing our Python programs in Google Collaboratory. So Google Collaboratory is a cloud-based environment where we can run Python programs. So Google Collaboratory is very helpful for machine learning and data science projects. Okay, so if you are new to this Google Collaboratory and if you are not aware of how to use this, you can go to the second module, which is Python basics for machine learning. And if you go to this playlist, you will see this 2.1. So video index is 2.1, and it is on Google Collaboratory for Python. And in this video, I have explained detailedly about Google Collaboratory, on how to use Google Collaboratory and how to use the various features of Google Collaboratory. Okay, so you can watch that video. So now let's get started with the coding part. So here there will be a connect option. So before running any codes, you need to connect your system here. Okay, so once you connect your system, you will see this green tick mark. So now let's start the programming part. So the first step in any Python program is to import the dependencies. So you can make text here in Google Collaboratory. So you can just do some description, make some description about what you're doing in that particular code. So in this, I'll just make a text as importing the dependencies. Okay, so dependencies are nothing but the libraries and the function which we need for this particular project. So let's import some basic libraries such as NumPy and Pandas. So I'll import NumPy as NP and Pandas as PD. So I'll explain you what is the use of these libraries once I complete this particular cell. So let's import Pandas as PD, and let's import Matplotlib. So import matplotlib.pyplot as PLT, and import cborn as SNS. Okay, and then I need to import from sklearn dot model selection, import train test split. Okay, then From XGBoost, import XGB regressor, and from sklearn, import metrics. So these are the dependencies that we need. Okay, so we have created the cell. Now in order to run this cell, to execute this cell, you can press shift plus enter. So when you press shift plus enter, it will run this cell and automatically go to the next one. So you can press that. Okay, so first of all, let's try to understand these libraries. So numpy is the library which is used to make arrays. So arrays are nothing but list of numbers or list of values, and it is very useful for our processing. So I'm importing numpy library, and I have imported numpy as np. So it is just a short form for numpy. So when you mention this as, so instead of using this numpy, we can just use this np. Okay, so it is just an abbreviation. So every time I don't need to mention numpy, I can just mention np. So this is the general convention that everyone uses in machine learning, where we import numpy as np. And so as I told you earlier, it is used to make numpy arrays. And then we have this pandas library. Pandas library is used to make data frames. So data frames are structured tables. So if we load the data set we have into the data frames, it will be easier for us to analyze the data and to process the data. So that is the role of this pandas library, so which is to create data frames. So I have imported pandas in the short form as pd, and then we have this matplotlib.pyplot. So this matplotlib library is used for creating plots. So we have seen that we need to do some data analysis, right? So in data analysis, so we use some visualization libraries. So visualization libraries are like those which are helpful to make plots and graphs. So matplotlib library and seaborn, you can see the seaborn library here. So both these libraries are data visualization libraries which are used to make plots and graphs. And then we have this train test split function. So I've already mentioned in the workflow that we need to split our data into training data and test data, right? And we will split the data using this train test split function, and we are importing this train test to split function from sklearn.model selection. So sklearn is one of the very important machine learning libraries, so that we will use. And after that, we are importing this xgb regressor. So we have seen that we will be using a xgboost regressor. So I'm importing this from the library xgboost. And finally, we are importing this metrics from sklearn. So this metrics is used to evaluate our model. So we measure some error values to check how well our model is performing. So for this, we need this sklearn.metrics. So these are the dependencies that we need. So as we have imported all the dependencies, now we can go to the next step. So the next step will be to data collection and processing. Okay, so I'll just make a text here as data collection and processing. So you can go to Google and search as calories burnt prediction Kaggle. So Kaggle is those sites which host machine learning and data science competition, and it also has a lot of data sets. So this is the data set which we are going to use. I'll give the link for this particular data set in the description of this video. So it will take you to this link from where you can download the data set. Okay, so this is the data set that we are interested in. So you can see here we have two CSV files. Okay, so one is calories and the second one is CSV. Sorry, the second one is exercise.csv. So you can just see this preview of this data set. So we have the columns, we have our user id. So we have some identification number for each value. So each row represents values of a person. So like first value represents the data for one person, second value represents the data for another person, and so on. So we have the user id, the identification number for each person, and we have gender, whether the person is male or female, and we have the age of that person, and we have height and weight of the person, and duration, so duration of the exercise they are doing. So this value is in minutes. Okay, so the duration on which they are doing the exercise, and we have the average heart rate. So I have already told you that the normal heart rate is about 75 beats per minute, and when we are doing it reaches 100, and it also will be greater than 100 at times, so per minute. So it is the average heartbeat during that duration. So here you can see the values are in the range of hundreds, right? So this is the heart rate, and then we have this body temperature values in Celsius. So the normal body temperature is around 36 and 37 degrees Celsius, and we know that the temperature will increase when we do exercise. I have already explained you. So we can see here the values are around 40 and 41, right? So this is the data set we have. So using this particular data set, we need to find the calories burned. So you can go to this calories.csv. So it contains the same user id. Okay, so you can just check this user id. It contains the same user id as those are present in this exercise.csv, but it just contains the calories burnt value. Okay, so you can see here, so this is the user id and this is the calories burnt value. So we need these two data sets and we need to combine these two data sets. Okay, so what you can do is go to this calories.csv. Now you can download this calories.csv file and then go to this exercise.csv, and from this download option you can download this file. Okay, so we will be using these two files, and once you download these two files, go to your Google Colab and you can find this files option here. So you can click here, and there will be an option called as upload to session storage. Okay, so if you click this, you can upload your files from your computer to this Google environment. Okay, or you can just press right click here, so there will be this upload option where you can upload the two CSV files. So you can see here I have already uploaded my calories.csv file and exercise.csv file, and we will be using this for our processing. Okay, so just a second. Okay, so now let's see what we can do with this data set. As I've told you, we need to use data frames for analysis and processing. So that's because you can see here the values are in the form of a CSV file. So CSV is nothing but comma separated values. So comma separated values means all the values are separated by commas in this particular file. So you can just open this CSV in a notepad and you can just see the data, and all the values will be separated by comma, and we cannot analyze the data when it is in the CSV file. So we need to load this data from the CSV file to a pandas data frame. Okay, so that's why we have imported this pandas library. So I'll just make a comment here as loading the data from CSV file to a pandas data frame. Okay, so let's name the data frame as calories. So calories is equal to pd. So pd means pandas library, which we have imported in an abbreviated form, pd dot read csv. Okay, so you can see here this read CSV function will help us to load the data from CSV file to a pandas data frame. So inside this parenthesis mention quotes, and inside this quotes we need to paste the path of the file. So first let's take this calories.csv file. So you can find this options menu here. So there you can copy the path of the file and just put it in these quotes. Okay, so now you can press shift plus enter to run this cell and go to the next one. So this will execute the cell and this data will be stored in the pandas data frame. Now we can check the preview of the data frame. So what we will do is print the first 5 rows of the data frame. So let's get the sample of our data frame to see what are the features we have. For that you need to mention the data frame name dot yet. Okay, so this yet function will print the first 5 rows in our data set. So we know that this calories.csv file has user id and calories column, right? So these are the first 5 rows we have, and you can check the values in this calories column. Now we need to do the same for this exercise.csv. So we need to load this exercise.csv to another data frame. After that we can combine both of them. Okay, so here I'll copy the path of this exercise.csv, and let's create another data frame as exercise data, which is equal to pd.readcsv. So we know that this read csv function will load the data frame from csv file to a data frame, right? So I'll just paste the path here. Now let's try to print the first 5 rows of this exercise data. So mention the data frame, which is exercise data dot yet. Let's see. Okay, so now we can see the first 5 rows of this exercise data, and it contains all the values here. So it contains this user ID, gender of the person, age, height, weight, duration, heart rate, and body temperature. So these are the parameters which we will use to find the calories burnt. Now you can get a doubt like we are just predicting the calories burned based on the duration on which they are doing exercises, right? And we can say that a person is going for a walk for 30 minutes. Okay, and we are calculating the number of calories burnt, and there is another person who is going a jog for 30 minutes. So we definitely know that the amount of calories burned by the person who is jogging will be more than the person who is just walking, right? Because like more energy is needed when you are going for a jog or when you are running, and when you are doing some heavy lifting, the amount of calories will be far more larger than that, right? So now you may get a doubt that what if that varies with the the exercise that we are doing. So let's think like this. So we need to distinguish between the calories burnt in different exercises. Say for example, when the person is going for a walk, the calories burnt will be less. When a person is running, the calories burnt will be more. And when a person is doing some heavy lifting, the calories burnt will be more even than the jogging, right? So now you may get a doubt that how we can do a prediction without that exercise, right? So you may get the doubt. Now let's try to understand this data set better. You can see the heart rate here. So when a person is going for a walk, the heart rate won't be that much high, and the body temperature won't be that much high. And when a person is going for a jogging, of course the heart rate will be more, and when he is doing heavy lifting, the heart rate will be even more, right? So we can distinguish the exercise based on these values. So what I'm trying to tell you is there is an indirect relationship between the heart rate and body temperature with the exercise that they do. So let's consider two cases. So you can see here, so there is like two durations here. So one is 10 minutes and the another one is 13 minutes, where the heart rate is around 100, and here the heart rate is 81. So it can tell us that this person, the data point 4, in this case the person is doing some light exercises. So we can say that that person is just going for a walk, and that person's heart rate is around 81 beats per minute. Whereas in this case we can say that that person is doing more intense exercise, that's why their heart rate is more. So this is an indirect measurement or indirect inference that we get based on the exercises. So what I want you to understand here is, so this heart rate is an indirect measurement of the intensity of the exercise that they are doing, and based on this we can find the calories burned. So this is the idea behind it. Okay, so the next thing which we need to do is combine this calories value with this exercise data. Okay, so it's not of useful when we have this data separately. So what I'll try to do is I'll just take this calories data frame, and I don't want to combine this user ID, because like you can see here, both of these user IDs are same because they are data of the same person. So I want this calories column alone. I want to put this calories column beside this body temperature column. So now we can see how we can do that. So I'll just make a text here as combining the two data frames. Combining the two data frames. Okay, so let's create a new data frame as calories data. Okay, so this is the data frame that has both this exercise values and the calories burnt values. So calories data is equal to pd, which is pandas dot concat. So concat refers concatenation, which means to join something. So we need to concat two data frames. So the first data frame is exercise, right? So exercise data, and the second data frame which we need to join is this calories data, right? So mention, so the name of this particular data set is calories. So the c should be in small letter, so it shouldn't be in caps. So calories, and in this calories I don't want this user ID, I just want this calories column. Okay, so now you can just mention a square bracket here. Okay, so inside this square bracket mention the column name, which is calories. So here C is in caps, right? So you need to put the column name here, but we need to enclose it in quotes. So what I'm doing is I'm taking this exercise data, and with that exercise data, and I'm combining this calories column of this particular data frame. So that's what I'm doing here. And we need to mention another parameter here, which is okay. So we need to enclose this in a square bracket as well. So in this square bracket, we need to mention the two data frames, and after that, we need to mention the parameter axis is equal to 1. So axis is equal to 1 means in pandas, 1 refers to column and 0 represents rows. Here we need to join the data frames column wise, right? So I want to put this column beside this column. So we are using this axis is equal to 1. Let's say that we have two data frames and we want to add those data frames row after row. So in that case, we will mention axis is equal to 0. In that case, let's say that we have 5 values here, so 5 rows here, right? And we have 5 rows here also. And if we mention axis is equal to 0, all those rows from the second data set will be added after this row. Okay, whereas if you mention axis is equal to 1, data will be added after the last column. Okay, so that is the difference between axis is equal to 1 and 0. So 1 represents adding data column wise, and axis is equal to 0 represents adding data row wise. So let's run this, and now you can print the first 5 rows of this data frame. So this data frame is nothing but calories data. So this is the new data frame we have, which is calories data dot yet. So we can print this, and now you can see here the exercise data and the calories data. So both of these data frames are joined. So this is how you can combine these two data frames. Okay, so now let's try to understand more about this data. So let's check how many data points does this data frame has. So I'll just make a text here as checking the number of rows and columns. Okay, so for this, mention the data frame name calories data dot shape. So this shape function will give us the number of rows and columns we have. Here we can see that we have about 15,000 data points. So it is a good data set size. So like for example, like in machine learning, we deal with data set around this magnitude, and when it comes to deep learning, we can train our neural networks with data set that are that contains rows of like 1 lakh or even more than those data points. Here we have about 15,000 data points, and it is a very good size. Okay, so in some cases the data points will be very less, like we will be having only 500 rows or 600 rows, whereas here we have 15,000 data points, which is a good number of size. So we have 15,000 rows, that means data points for 15,000 different people. So each row represents different people, and we have totally for 15,000 people, and we have 9 features or 9 columns. So the second number represents column and the first number represents rows. So the 9 columns are user ID, gender, age, height, and all these columns. So totally we have 9 columns. So this is the shape of our data frame. And now let's try to get more information about our data set. So this step will be to getting some informations about the data. So mention the data frame calories dataset dot info. So let's run this. So this will give some important information about the data frame. So it can tell us the number of entries. So the number of data points we have, which is 15,000, and the number of columns, which is 9 columns, and you can see the number of non-null values. So null values means missing values, and non-values means the values that are present in the data set. So out of 15,000 data points, we have all the data points is filled, and we don't have any missing values. So that means this non-null count. And we also have the data type of each column. So you can see this integer, 64-bit integer. So this is user ID is in the form of integer, right? That's why. So object, so you can see that the gender column is object because it is in the form of text, whereas the other values are in the float 64. So floating points is nothing but, so these are 64-bit floating points. So floating points are nothing but decimal. So we can see that these values are in decimals, right? So this is what you can get when you use this dot info function. So this is very helpful to check for missing values. So there is also another method through which you can check the number of missing values. So I'll just show you, because like this particular line is very important. So checking for missing values. So calories data dot is null dot sum. So I have told you null values means missing values, right? So calories data dot is null dot sum. So this will give us the number of missing values we have in each column. So here we can see that we don't have any missing values though. So the missing values in each column is 0. That means we don't have any missing values, which is a very good thing. If we have missing values, we need to process those missing values before giving it to our machine learning model. So for that, we use methods like imputation, where we will replace the missing values with values such as mean, mode, median, etc. So we have already made a video on handling missing values in my channel. So to see that video, you can go to the fourth module, which is on data pre-processing and collection. So in that, I have explained you detailedly about how you can handle missing values in a data set. So here we don't have any missing values, which is a good thing. So we can continue our process. So the next thing which we will do is, let's get some statistical measures about our data set. Okay, so this particular step in our project will be on data analysis. So we have already discussed that we need to analyze our data to get more understanding, right? So this part will be data analysis. So Okay. Now what we can do is, so I'll just make a comment here. So I want to get some statistical measures about the data. Statistical measures about the data. So it tells us to tell what is the range, the values are present in each column. So what is the mean value of each column? Say for example, what is the mean age of the people in this data set, and what is the minimum value, and some percentage values. So those values will be, we can get from this particular cell. So calories data. So this is our data frame, and we need to use the function describe. So this particular describe will give us some statistical measures about the data. And you can see here, so we have this user ID column, so we don't need this user ID column. So we don't need the mean of user ID, and also it is just an identification number. So you can just skip this column, and you can see this age column. So we have the count. Count means the number of values we have. So we know that there are totally 15,000 different people, right? So there are totally about 15,000 values of age, and the mean value of age is about 42.7 is the mean value. So the mean age of that entire data set. And we have the standard deviation value, and we have what is the minimum age, and what is the percentile values. So percentile means like 25 percentile represents 25 percentage of the values are less than 28 age. Okay, so that means like in 15,000 you can count, or you can calculate the number of values for 25 percentage, and those many values are less than the age 28, and 50 percentage of people in this data set are less than the age of 39. So that is the meaning of this percentiles, and they are not percentage. So there is a difference between them. So similarly we have the maximum values. So we have these values for each column. So we have the height, so it's mean height of the people in the data set, and what is the minimum height, and this height value is in centimeters. So you can say it from the magnitude here. So 174 means centimeters. So you can see the height here, and we also have the mean weight, and minimum and maximum weight, and we also have the duration for which they have did the exercise, and we also have the heart rate. So here you can see the mean heart rate as 95. So I have told you already that the normal heartbeat will be, from 70 to 80 in normal conditions, in rest condition, and when we do exercise it will be kind of more. And we can see here the heart rate is kind of high, like, it is about 95 beats per minute. So we can also see the body temperature here, and the normal body temperature is about 37 degrees Celsius, and here the body temperature is around 40, the mean temperature. That means the temperature is high in those people who are doing exercise, right? So in that time period in which they are doing exercise, the body temperature will be more. So this is the important inference we are getting, and we have this mean value of calories burnt and minimum and maximum values. So the important insights which we need to gain here is, the heart rate and the body temperature will be more when the person is doing exercise. So this distinction is very important for us. So this is helpful for us to calculate exactly how much calories will be burnt during that exercise. Okay, so this is why this finding the statistical measures is very helpful. And now the next part will be to visualize the data. So I'll just make a text here as data visualization. So here we will try to put the data in some plots and graphs, and try to understand it better. So first what I'll do is, so I'll just run this sns.set. So this sns.set will give us some theme for our plot. So if you remember, we have imported the seaborn library as sns, right? So this sns.set will give some basic theme for our plots. Say for example, it will give some grid lines in our plots and the background theme in our plot. So that is the reason for this. So you just need to run this once. So now what I'll do is, so let's try to plot the different columns in our data frame. So first we have this gender column, right? So ignore this user ID column. So we don't need that. So we have this gender column, and let's try to find the distribution of this gender column. Like how many males are there in this data point, and how many females are there in this data point. So in this step, let's see. I'm going to plot. So plotting the gender column in count plot. So it helps us to find the distribution of males and females in this data set. So mention SNS, which is the seaborn library, dot count plot. So this is a categorical column. So it contains values such as two categories, which are male and female, right? So this is an example of categorical column, and we can plot the categorical columns in count plot. So mention the data frame, which is calories data. and inside the square bracket mention the column name. Here the column name is gender, right? So now you can run this to find the distribution. So here you can see here the blue the data marked in blue color is represents male data points, and orange color represents female data points. And the important thing which we are getting here is the data point is almost similar, right? So you can see the size here, and we have equal distribution of male data points and female data points. So if we have just if one value is more, let's say that out of this 15,000, if we have only 5,000 values for female data points and 10,000 values for male data points, then that data set is not distributed in a good way, right? So now we have these two classifications or these two distribution where the value is almost similar. So it is around 7,000 for each data points or each types. So it is a very good distributed data set. So now let's try to understand or try to analyze the other values. So next we have this age column, height column, and weight column, right? So we cannot put this columns in count plot, because like count plots are very useful for categorical columns, and age is a categorical columns because it has only two values, either male or female. But we cannot do that in this case because age varies a lot. So we can have values all the way from 20 to 70, right? So we cannot put these values in count plot. So instead, we use a distribution plot to find which range of age as I distribution. So like what this means is, say in this example or in this data set, people at the age from 30 to 35, maybe more, and this can be found by using a distribution plot. So I'll just make this plot. You can get a better understanding of that. So I'll just make a comment here as finding the distribution of age column. Okay, so here we will be using sns.distplot. So dist plot means distribution plot, and inside this parenthesis mention the column name, calories data, and the column name is ch, right? Okay, so let's run this. Now you can see the distribution here. So the x-axis represents the age of the person in the data set, and density means like how much data is present for that particular age. So you can see here we have more values in the range of 20 and 30, right? So you can see a peak in this curve. That means more values are present in the value of 20 and 30. That means in this 15,000 data points, more values are present in this range of 20 and 30, and the value is kind of decreasing. That means like people less people tend to come to gym at a older age, right? So that's the inference that we are getting, and we don't have much values less than 20. So this is how distribution, finding the distribution of the data is very helpful. So it tells us which range of values is more in this particular data set. Now let's try to find the distribution of other columns as well. So we have this height column, weight column, and duration, heartbeat, etc., right? So let's try to find all those values. So you just need to copy this particular line and just change the column name. So let's now check it for height. Okay, and I'll just replace this with height. Okay, so you can just check the column name here. So this column name should be exact. If the value is in caps, you need to put caps, or if the letter is in small letter, you need to put in small letter. Okay, so now let's check the height distribution values. Okay, so now you can see a normal distribution. So more people are present in the height of 160 and 8, and people who have a very less height are very less, and more height is kind of also less. So we have a normal distribution. So like there is the age or height value is not that much one-sided. Okay, so we have a normal distribution. And now let's check this for weight column. So I'll copy this, and you can copy this weight column here and replace the value here. Okay, so when you see it, we can find similarly the distribution of weight, and we have more people in the weight of around 60, and we also have some increased value in this between this 80 to 100. So this is how you can find the distribution of various features in a data set. So similarly, just try to find the distribution of other columns such as duration. So what is the duration they are doing, and what is the distribution of this heart rate data and other columns. Okay, so it will be of very interesting to see you the distribution of the data. So you just need to copy this line of code and change this weight to duration or art rate, etc. So it will be a similar step. So after that, now what we will do is we will try to find the correlation between the data. So I'll explain you in a minute what is meant by this. Finding the correlation in the data set. So I'll just create a variable as correlation, which is equal to mention the data frame, which is calories data dot corr. So corr means this is the function that helps us to find the correlation value. So let's run this. So there are two types of correlation. So the first type of correlation is nothing but positive correlation. So I'll just put it here, positive correlation. And the second type of correlation is negative correlation. So what is meant by this positive correlation and negative correlation? Let us come to this data. So here we can see here, we can tell that if the duration for which a person is doing the exercise is more, then the number of calories they burnt will be more, right? So these two values are directly proportional, duration and calories. If the duration increases, the calories burnt also increases. If the duration decreases, calories burnt also decreases. So both of them are in the same direction. So that means these two features, these two columns are positively correlated. And if there are columns where if one column increases, the other column decreases, that means the two values are negatively correlated. So that is meant by this correlation. It is nothing but the relationship between the two features. Okay, so this is why finding the correlation is very important, because it tells us which columns are positively correlated and which columns are negatively correlated. Where positive correlation is something where two features will increase. If one feature increases, the other feature also increases. In that case, it is positively correlated, and it will be calculated by this .corr function. Just a second, I'll just check whether it's recording. Okay, so correlation is equal to calories data dot core. And now let's try to construct a heat map to visualize this correlation value. So constructing a heat map to understand the correlation. Okay, so plt dot figure. So if you remember, we have imported this matplotlib library, right? So I have imported this matplotlib library as plt. So we are going to use this library, and inside this we need to mention the figure size. So fig size, which represents the size of the plot, and let's put 10 comma 10. So it is just the size of the figure. You can just put any values you want. So less values means the plot will be smaller, and if the value is high, the graph will be larger. Okay, so plt dot figure and sns dot heat map. So we need to construct a heat map, and inside this we need to mention some parameters. So let me complete this first and explain you what is meant by these values. So first is correlation c bar, which is the color bar, true, and square is equal to true. And next we need to include fmt is equal to dot 1f 1f. So just give me a minute, I'll just complete this. Annotations is equal to true, and kws is equal to size. So size should be enclosed in quotes. Let's make the size as 8. And c map, so color of the map, let's take blue color. Okay, so blues. And finally we can run this. I'll explain you what is meant by this heat map. So we can see a color map here. So heat map gives values based on, gives colors based on the values. So we have the values from 0 or 2 1. Okay, so 0 means the lowest value and 1 means the highest value, and this value is calculated based on the relationship between the data. So the relationship between this various features. So you can see the column names here. So user id, age, height, weight, etc., and you have the same columns here. So now each column will be compared to the other columns, and if the value is larger, if the value is 1, then that means the two columns are positively correlated. If the value is very less, that means the values are negatively correlated. And if the value is zero, that means there is no correlation at all. Let's now try to understand this. So you can just skip this diagonal. So we don't need to see this diagonal, because like both of these columns represent the same values. Here you can see here, this is user ID, and here it is this, in this x-axis it is the user ID, right? So that's why it has this value 1. And then you can see here the second column is age, and it is also age. That's why this particular diagonal is of the value 1. So you can just ignore this. Now you can see the other positively correlated column. So you can see here height and weight have a correlation of about 1.0. So it is a, if you think logically, we can tell that if a person is very taller, then that person's weight will also be kind of more, right? So that's the inference from this height and weight correlation. The important correlation that we are interested in is how much this duration and calories burnt are correlated, how much the heart rate and the calories are correlated. So we know that if a person do exercise for a long time, then is more probably going to burn more calories, right? So that's why this duration, and you can see in this axis like calories, so the calories value is highly positively correlated. So if duration increases, the calories burned will also increase. And these values are also correlated because like when a person do exercise for a more time, then they are going to have a increased heart rate, right? So that's why this heart rate is correlated with the duration, and it also similar in the case of body temperature also. So that's why these three columns, which are duration, heart rate, and body temperature, are positively correlated with this calories value. And this is how we are going to find the calories burned. So this is just to understand what is the relationship between the various columns in our dataset, where we have found that the height and weight are positively correlated, and we can say that the duration, heart rate, and body temperature are highly positively correlated with calories. So that means higher duration of exercise will ensure that more calories will be burned, and it also ensures that the heart rate will be more, and if the heart rate is more, then more calories will be burned, because that person is more likely to do more exercise. Okay, so this is the correlation that we are getting. So now what we will do is, so next we can split our data set into training data and test data. After that we can feed it to our machine learning model. Just there is one more step which we need to do in our data set. So I'll just come to this data frame here. You can see this gender column. So all the values in our data frame are in the form of numerical values, right? So age is in the form of numerical value, height, weight, duration, everything is in the form of numerical values. But this gender column is in the form of text. So it is, the value is either male or female. So we cannot feed this text data to our machine learning model. So computers don't understand text better. So we need to replace these values with appropriate numerical values so that the machine can understand. So what I'm going to do here is convert. So wherever there is this value as male, I'm going to replace male with 0, and I'm going to replace female with 1. So this becomes categories, right? So this column will then contain values as either 0 or 1. So it will ensure that this column also contain values in the form of numerical values and not in the form of text. So this step will be to convert. So I'll just make a text here as converting the text data to numerical values. Okay. So this is called as categorical data encoding. So mention the data frame name, which is calories data, and we need to use the function called as replace. So this replace function will replace the values of male and female. So we need to mention it here. So calories data dot replace, and inside this just open a curly bracket, and we need to mention the column name, and the column name which we are interested in is gender, right? So the gender column. And another thing, so this is in the form of categorical column, and those categorical columns won't be included in this correlation map. So that is one thing which I failed to explain you. So that is gender column. Okay, so I forgot to tell you that here. So when you find the describe also, so here we have found this describe, right? So we found some statistical measures, and we don't have this gender column here because we cannot find a mean value for a text value. We can find the mean and standard deviation only for numerical values. That's why we don't have the text data here. So this gender column is ignored here, and similarly the gender data is ignored in this case because we cannot find correlation between a categorical column and the target variable. Okay, so calories data dot replace, and inside this mention the column name, which is gender, and we need to replace the values, where we will replace all the values of male as 0 and female as 1. Okay. Now let's mention in place is equal to true. So let's run this. So what happens here is I'm just taking this calories data and I'm replacing the values. So I'm using this replace function, right? So I'm replacing all the values in this gender column. And how I'm replacing is I'm taking the male values and I'm replacing all the male values with 0 and I'm replacing all the female values with 1. So this is what we are doing here. And we have this another parameter called as in place is equal to true. So in place means like I want to change this as a permanent change. So if you don't mention in place is equal to true, so the values will be changed only for this particular output of this cell. So if we mention this in place is equal to true, this change will be carried out throughout. Okay, so this is just to retain that particular replacement. Let's run this. Okay, so we have some error here. Okay, so calories data, so I'll just see what has happened here. Male female is equal to 1, calories data dot replace gender male. mm, okay, it's nothing if you just print this line again. Calories data dot date. You can see here the value has been replaced. I don't know why, but we are getting this error even though it has converted the values. It is just giving this error, so it is not of that that of an issue. So I'll just go to this runtime and restart and run all the codes. So I think we won't get that error now. So this error is not that significant because like I think this time it will be corrected. So let's see. Yeah, okay, so I haven't changed anything here, so it is everything is saying. So everything is same. So I'm just running this again. So now you can see here now the male value is replaced by 0. So you can go to this particular gender column. So this male value will be replaced by 0 and female value will be replaced by 1. And here you can see here how the replacement is happened. So if I think you will also probably find this error if you run the code. So what you do is just after you have replaced this, just try to print the first 5 rows of the data frame, and that error won't be there. So the value will be replaced. Just go to this runtime and give restart and run also. Your session will be replaced and all the cells will be all the cells will be executed again. So it is not a big of an issue here. So now what we will do is let's separate the features and the target. Here the target column, the target which we are interested in is calories, right? So let's separate this calories column and other columns. So other columns are called as features and this calories column is called as target. So I'll just make a text here as separating features and target. Okay, so let's take two variables. One is x and the another one is y, and mention the data frame calories data. And here we are going to drop some values. So I just want all those features and not these calories, right? So I'm going to drop this calories column, and also I'm going to drop this user ID column because we don't need this identification number. So it is of no use for our particular training. So training the machine learning model. So let's drop this user ID column and calories column. So this calories data dot drop. So this drop function in pandas is used to drop some columns in our data frame. So drop, mention the column names which you want to drop. So columns is equal to, so I'll just create a square bracket and mention the columns which are user ID because I don't want the user ID column as well. And the second column which I want to remove is calories. Okay, so now I'll mention axis is equal to 1. So I have already explained you that axis is equal to 1 represents column in pandas and axis is equal to 1 represents rows. In case if you want to remove a column, we will mention axis is equal to 1. And let's say that we want to remove this fifth row. So in that case, we will mention axis is equal to 0. So 0 means row and 1 represents column. Now what happens is X will contain all the columns except this user ID and calories. Okay. Now what I'm going to do is store this calories column in this y variable. So mention calories data. So calories data, and inside the square bracket mention calories. Okay, so what we are doing is taking this gender, age, height, weight, duration, heart rate, and body temperature in X, and this calories column alone in Y. Okay, so let's run this. Now you can print this X and Y. So this X won't contain user ID and calories column. So you can see here it only contain these from gender column to body temperature column. So this user ID and calories will be removed. When you print Y, it will contain only the values of calories burned. So this is how you can split your features and target, because like we need to split this data before splitting our data into training and test data. So it is one of the important steps that we do. So we need to separate features and target. So as we have successfully splitted it, now we can split our data into training data and test data. So splitting the data into training data and test data. Okay. So for this, we need to create four arrays. So they are xtrain, xtest, ytrain, and ytest. Okay, so what are these four arrays? So let's say that we have this x and y, right? So I'm going to separate this x as two arrays. One is xtrain and xtest. So xtrain represents all the training data and xtest represents all the test data. So we know that we will be using the training data for training our machine learning model, and test data will be used to evaluate our model. So this x will be split into two. One goes into the training data and the other set goes to the test data. Now the corresponding calorie values, the corresponding y values will go to y train, and the corresponding calories value for test data go to y test. So it is very simple to understand. So we have four values. So x train contains all the training data for x, and xtest contain all this data for test data, and the corresponding calories value for xtrain will be stored in ytrain, and the corresponding calories values for xtest will be stored in ytest. So that's what we are doing. Okay, so we are just splitting these two x and y into training data and test data, and for this we are going to use the function train test split, which we have imported from sklearn.model selection. So you can see here, right? So train test split, and inside this we need to mention some parameters. So the parameters are x and y, because we are going to split this x and y, right? So we have already splitted it into features and target, where x represents the features and y represents the target, and we are splitting it based on x and y. And just there is another two parameters, so just mention this test size is equal to, let's put 0.2. So test size is equal to 0.2. So 0.2 means 20 percentage. That means I want 20 percentage of the data as test data and 80 percentage of the data as training data. So generally we take 10 percentage or 20 percentage of the data as test data. So it is the general convention, and 80 percentage or 90 percentage of the data goes into the training data. Here I'm just taking 20 percentage. Okay. So there is another parameter which we can mention, which is random state is equal to 2. So random state is just to reproduce the code. So when you use this train test split function, your data will be splitted in an automatic manner. So there is not any general manner in which your data will be splitted. But when you mention this random state, so random state, I'm mentioning this random state is equal to 2. That means my data will be splitted in a specific manner. And let's say that you are practicing this code and you also want to split the data in the same manner that I did. In that case, we both need to mention the random state is equal to same number. If you mention random state is equal to 3, then your data will be split in a different way. If you mention the random state is equal to 2, then your data will be split in the same way that my data is getting splitted. So this is just to have the similar splitting of data. So let's run this. Okay, so now let's try to print the shape of all this data: x dot shape, x train dot shape, and x test dot shape. So here you can note that for every function we will use parentheses after. Like for example, for yet function, so you can go to this yet function, we have used parentheses. But in the case of shape, we won't use it because it is kind of a tuple, and we don't use parentheses after this shape function alone. Let's run this. Here x represents the original data, and x train represents the training data, and x test represents the test data. So the original data set, we have about 15,000 data points, right? So that is the shape of x, and x train contains 80 percentage of original data, and 80 percentage of data is 12,000, and x test contains 20 percentage of data, which is 3,000. So this is how you can split your data into training data and test data. So now the next part will be on model training. Okay, So as I've told you earlier, we are going to train a XGBoost regressor model, right? So I'll just make a text here as XGBoost regressor, XGBoost regressor. So I won't be going in detail about what is the math behind this model and how this model works. So I'll be explaining you this in a different video. So it is out of scope of this particular video. So the idea of this video is just to show you the implementation of this particular project. So I'll be making videos in the future modules on what is meant by these models and what is the math behind this model and how we can build these models from scratch. So that will be covered in a different module. For now, let's see how we can implement this. So if you remember, we have imported the XGBoost regressor. So you can see here XGB regressor from XGBoost. Now I'm going to use this XGB regressor. So I'll just copy this, and now we need to load the model. So loading the model, let's create a variable as model, and inside this model let's load our XGB regressor and mention a parenthesis here. So this means we are loading one instance of XGB regressor to the variable called as model. So just press shift plus enter. So this cell will be executed. Now this model will contain this XGB regressor. Now we can train this particular model. So training, we know that we need to train our data with the training data, right? So training the model with xtrain. Okay. So I'm using this model, which is model. For training, we need to use the function model.fit. So when you use this model.fit, we need to mention the training data, which are xtrain and ytrain. So we know that we have splitted the data into xtrain and xtest, where x represents the features, right? So xtrain is the training data features and ytrain is the calories for that data. So it is just giving an x-axis and y-axis, where x-axis is the features and y-axis is the ytrain. So when we run this model.fit function, it helps our model to train. So this part is called as model training. So when you give this data to our XGB regression model, it finds the pattern between the data. Say for example, it can understand like if the duration is more, then the number of calories burnt will be more, and if the heart rate is more, also the number of calories will be more, and those things will be learned by our model automatically. And that's what we are doing in this model.fit, where we give this x train and y train. So you can just run this model, and these are the parameters which we have for our model. So now our model has learned from the data. Okay, so now we can evaluate our model. So this doesn't take much time. But when you are working on deep learning and when you are working with a very large data set, so we can also work with data set that contains a lakhs of data points. So in that case, the training will take a long time. So this is just a numerical data set, right? If we work in image data set and audio data sets in case of deep learning, the training time will be very large. So it can also take days and weeks for training a model. So this is a very simple data set. So it doesn't take much time. So as we have trained our model, now we can evaluate our model. Okay, evaluation. So I have already explained you that we will train our machine learning model based on the x-train, that is the training data, and we will test our data or evaluate our data based on our test data, right? So now let's just evaluate our model based on the test data. So I'll just make a text here as prediction on test data. Okay, so you can also find the prediction on training data as well. So there is nothing wrong in that, but I'll just find the prediction on training on the test data alone. So training data prediction, sorry, test data prediction. Now what I'm going to do is, so we know that we have trained our model with x train and y train. So y train is nothing but the calories value. And now I will just give this y train alone, and our model will find the number of calories burnt. Okay, and that will be compared with the original values. So sorry, I will give this x test. Okay, so I won't give this y test, which is the calories burnt. So with this data, with this test data, our model can find what is the calories burnt, and we are going to compare that value with the original values, which is y test. Okay, so I'll just do this, you can understand it better. So test data prediction is equal to model dot predict. So this model is now a trained model. So you can see here model dot fit. So when you run this, your model will be trained, and I'm using the trained model here. So model dot predict x test. So I'm not giving the y test, which is the calories value. I'm just giving the features, the duration, age, gender, etc. So that values alone. So let's run this. So what happens is now our model goes through this X test and find the calories burnt values for this X test, and all those values will be stored in this test data predictions. You can also print this and see print test data prediction. So this will give us the value. So these are the values of the calories burned. So like there is three dots that represents a lot of values are there in between. So this is the values of calories burnt, and this is how you can predict the calories burnt by giving those features. So these features are nothing but the age, gender, duration, heartbeat, and body temperature. So this is the values predicted by our model. Okay, so we have trained our model with X train and Y train, and we have found the values of X test based on our model. Now what we need to do is compare the values predicted by our model with the original values. The original values are nothing but Y test, right? Now we need to compare this Y test and this test data prediction. Okay, so for this we will be using a metric called as mean absolute error. Mean absolute error. So it will tell us what is the magnitude of error that our model is making. Let's take this 129. Let's say that the actual value for this 129 calories is like 135 calories. Okay, but our model is as predicted as 129, right? So this value will be separated or will be subtracted to be more precise. So 135 will be subtracted in this 129. The value we get is 6, right? So 6 is the mean absolute error our model is making. So you can consider this 39, and let's say that the model has predicted as 39 and the real value is 36. In that case the difference is 3. So there is not positive or negative sign here, you just need to find the difference. So that is why it's called as mean absolute error. So in this case the mean absolute error for this data point is 3, right? So similarly we will find the the absolute error for all the values, and the error we will take a mean for all the values and find what is the mean absolute error, the overall error that the model is making. Okay, so for this we'll be using this sklearn.metrics. You can see here we have imported this metrics from sklearn library. So let's use this particular library. Now I'll create a variable as mae, where mae represents mean absolute error, and call this metrics module. So metrics dot mean absolute error. Okay, so mean absolute error, inside the parenthesis mention the original value which is y test, and the value is predicted by our model is test data prediction. I'll just copy this. Okay, so these are the two values where y test is the values, original values, and test data prediction is the values made by our model. Okay, so now let's run this to find the mean absolute error. Let's print it as mean absolute error. So this mean absolute error should be as low as possible, right? So it's nothing but the difference between the actual values and the values predicted by our model. Let's see what is the values we are getting. So I'll just put this MAE. So this will print our mean absolute error value here. So the mean absolute error value which I are getting is 2.71, which is a very good score. So the error value is very less, because like it means like if the original value is 131, let's say that the original calories burned value is 131, then the model is predicting 129, and this is very close, right? Like the magnitude of 2 is very close, and there is not any general value of mean absolute error here. That it depends on the magnitude of each value. Let's say that we are predicting the car prices. Okay, so let's say that car price is around 10 lakhs and our model is predicting, and our model is making a mean absolute error of 1000. Okay, so 1000 or 2000 rupees. Out of those 10 lakhs, the mean absolute error of 1000 or 2000 is not very much. So in that case the mean absolute error is actually good. But when you are considering price of a mobile phones, let's say that we are predicting the price of mobile phones and the price of the mobile phone is around 12,000 or 13,000. In that case, if our model makes an mean absolute error of about 1000 or 2000, in that case the value is very large, right? So the error is very large, so we cannot accept that kind of error. So it all depends on the magnitude of the values, and the magnitude of values we have here is around hundreds, 50s, right? So we have the values in hundreds, 200s, and in 40s, right? So in this magnitude, mean absolute error of 2 is very good actually, because like for 131 calories our model can predict the value of 129. For 225 our model can predict a value of 223, which is very close. So in this case, a mean absolute error of 2.7 is 1 is very close. And what I want you to understand here is there is not a general thumb rule of what is the best mean absolute error. So it varies depending on the problem statement. It varies depending on the data which we are working. In our case, we have the values in the range of hundreds, and in the value of 100, mean absolute error of 2 or 3 is really good. So this is how you can evaluate our model. And you can also make a predictive system. You can build a predictive system. In my previous videos, I have explained you how you can build a system when you can, like, in let's consider this case. When you give some input data, when you give the gender of the person, age, duration, and heartbeat, it can find what is the calories burnt. So we can also build some predictive system like that. So I'm not going to do that in this video. So I have already made several videos on how to build that predictive system. So if you want a reference, just go to the medical insurance cost prediction video. So in that I have explained you in the final step on how to build a predictive system where you can just give the input data and find the value. So you can use the same method in this case, where you will be giving the input data such as gender, age, etc., and your model can predict what is the calories burnt calories burnt value. So that will be a very good exercise for you. So I hope you have understood all the things that we have covered in this video. So I'll just give you a quick recap of what we have done in this project so far. Okay, so the first step is about importing the dependencies. So we have imported some basic libraries such as NumPy, Pandas, and data visualization libraries like Matplotlib, Seaborn, etc. And we have imported this train test split function to split our data into training data and test data. And then we have imported our XGB regressor from XGBoost, and finally metrics for evaluating our model. So we got two data sets from our data, which is, so one dataset file is on calories and the other dataset file is on exercise. And we have seen how we can combine these two datasets using this pd.concat. And after that, we have checked the number of data points we have, the number of rows and columns we add, and what is the general information of the data. And we have checked whether we have any missing values, and unfortunately we didn't have any missing values in our data. And we did some data analysis where we got some statistical measures of the data, and we have visualized some features in our dataset and found some distribution of our dataset. After that, we have find the correlation, so some positive correlation between the features and the negative correlation between the features. And then we have converted this male and female to 0 and 1. So we have converted this text value to numerical values. And then we have separated this data into features and target. So calories becomes our target, and the other columns are nothing but the features. And we have put it in X and Y respectively. And we have split our data into training data and test data. And once we have split our data, we have trained our XGB regressor using the training data. And we have split, and after that we have evaluate our data based on the test data. So I hope you have understood all the things that we have did in this project. So if you have any doubt, please mention in the comments video in our machine learning project series. And in this video, we are going to discuss how we can build a movie recommendation system in Python. This is one of my personal favorite applications of machine learning, and I hope that you are interested as well to learn about this. Here, we will create a system in Python where a user can give the name of his favorite movie, and based on this input, we are going to recommend certain movies to him. And this is what we are trying to accomplish in this particular project. Okay, so first of all, in this video, I'll explain you what are the different types of recommendation systems that we have, and after that let's discuss about the workflow that we are going to follow for this project. And then we can move on to the hands-on part where we will try to build this movie recommendation system in Python. Okay, so let's get started. So most of us are familiar with the OTT platforms like Netflix, Prime Video, Hotstar, etc. And in the recent years, these OTT platforms have been used extensively by a lot of different people, right? And the main reason for this is these platforms and apps knows what kind of movies and series each user likes. So it tries to analyze the user's watching pattern, and it tries to recommend movies to them. And this is one of the main reasons why these OTT platforms have been used a lot. And we need to understand how these apps can do this. And the main reason behind this is they have their own recommendation systems. Okay, so when we talk about recommendation systems, there are three main types. First is content based recommendation system, second one is popularity based, and the third one is collaborative type recommendation system. Okay, so let's try to understand about all these three recommendation systems. And these recommendation systems are made using several machine learning concepts and techniques. Okay, so this is one of the main applications of machine learning which we need to be aware of. So let's try to understand each of this each different types of this recommendation system. So first is the content based. So the content based system promotes movies or recommends movies to a user based on the content of the film that they have watched before. Say for example, a person is watching multiple superhero movies. Now this kind of content based recommendation system will recommend more of superhero based movies to him. And let's say that if some other person is watching some movies which is related to space and other things, then this content based recommendation system will mainly recommend them space related movies and so on. So this system is completely based on the content of the movie and its story and so on. And the second type is popularity based recommendation system. So this kind of system recommends which movie or series has been very popular. So in Netflix there is an column called as top 10 movies in India and top 10 movies of all time and such kind of things. So it is completely based on popularity, and popularity basically increases if more number of people watches those kind of films. Okay, so that is the popularity based recommendation system, which mainly relies on what is the popularity of films and what is the popularity of the actors acted in the movie, directors and so on. Okay, and the third one is collaborative recommendation system, and this type of recommendation system groups people based on their watching pattern. Let's say that there is a group of people, and this certain group of people are watching similar kind of movie, but these people doesn't know each other. This is the data collected by these kind of apps. So let's say that, okay, so these group of people watch some kind of movies, and now let's say this there is a new user and he watches one or two movies which are watched by those group of people. Now the system knows that this group of people and this new user has a similar taste, so this new user will be recommended movies which were watched by those people. Okay, so this is how collaborative recommendation system works, where the system will try to recommend movies based on the watching pattern of an individual based on some previous data it has collected from the other individuals. Okay, so these are the three main types of recommendation system, where content based mainly uses the content and the story and other things which are similar to the movies a user has seen, and the popularity based system is mainly based on what is the popularity and how much popular a movie is and so on. And the third one is collaborative, where the system mainly focuses on the user's behavior and the user's watching pattern and so on. Okay, so in this we will try to incorporate content based and a certain amount of popularity based recommendation system. Okay, so while building the system we will try to incorporate the things such as the title of the movie, the cast, director, and what is the theme of the movie and so on. So that's what we are going to do in this particular video. Now let's try to understand what is the workflow which we are going to follow for this project. So first is data collection. So we need to have the data of these movies and several details about them. Okay, so we need to have the details such as who is the director, what is the genre of the movie, and what is the description of the movie and so on. Okay, so that will be our data. So once we collect this data, we need to process this data. So we have to clean this data if there are any missing values and so on. So that part will be our data pre-processing step, and this is our second step. Okay, and the next step will be feature extraction. So the main thing about this movies dataset is that all the data will be in the form of text, right? So this is an example of a textual data, because this data contains the name of the movies, name of the people acted in it, etc. And we cannot use this data directly, so we need to convert these textual data into numerical values. To be precise, we will convert them into feature vectors, and this is the process for it. So we will do feature extraction on this movies dataset in order to convert them into numerical values. So after that, we will try to find the similarity score between the movies. Okay, so let's say that we have about 5,000 movies in our dataset, and we will try to find which movies are similar to each other by giving them a similarity score, or we can call this as a similarity confidence score. So once we do that, we will ask the user to give an input. So now the user will give the name of their favorite movie, and based on this data and based on this input, we are going to suggest them which movies they can watch. And for this we are going to use something called as cosine similarity, and this cosine similarity algorithm is used in order to find the similarity between the vectors. So here we are just converting each movies into a kind of a vector, and we will try to find the similarity between them using this cosine similarity. Okay, so when a user gives a movie name, we will try to compare that movie, and we will just try to find which movies are similar to the one given by the user. Now we will get a list of movies, and we can now suggest this list of movies to our user. Okay, so this is what we are going to do. So first we will collect our data, and then we have to process the data, and after that we need to convert them into meaningful numerical values called as feature vectors, and then we will try to find the similarity between them using the cosine similarity algorithm. And once we have done that, we are going to get input from the user, and based on this input we will try to find which movies are similar to the one given by the user, because we already have the data from this particular data data set, right? So we will look in this data set, and then we will suggest the list of movies a user may like. Okay, so this is what we are going to do. And one thing that you need to understand here is we don't use any machine learning models here. I mean, we can use a machine learning model with this cosine similarity, but in this case we are just going to use this cosine similarity alone, because it yields a better result in this case. So this is cosine similarity is also one of the main things you need to understand, because this is very much helpful in order to find the relationship between different data points. Okay, so you may also use this in other applications as well. So let's try to understand how we can apply this. So let's get started with the hands-on part now. I just go to my Google Collaboratory. So I hope everyone is aware about this Google Collaboratory. If you are not sure about how to use Google Collaboratory, I have already made a video explaining how you can access this and what are the different features of it. I'll give the link of that video in the iCards. You can check that out. Okay, so you can see the files option here. So here I have already uploaded my dataset file, which is movies.csv. So you can find this upload option here, or you can just right click here and you will find this upload option. From this you can upload the dataset file. I'll give the link of this particular dataset file in the description of this video. You can download it from here. So the first thing that we are going to do is import the dependencies. So the dependencies are nothing but the libraries and the functions that we need. So I'll just make a text here as importing the dependencies. So first of all, I'll import NumPy library. So import NumPy as NP and import pandas as PD. So we know that NumPy library is used in order to create NumPy arrays, and we are importing NumPy in the short form as NP, and we are importing pandas in the short form as PD. So pandas is used to create pandas data frame. The data frames are nothing but structured tables. So the data that we have is in the form of a comma separated value, and it's not easy to analyze and process the data from a CSV file. So we load this data from the CSV file to a pandas data frame, which is a more structured form of a table where we can do some analysis and processing on it. Okay, so these are the first two libraries that we need. And next we are going to import difflib library. So the purpose of this is, as I've told you before, once we complete the code, we need to get the name of the name of a movie from a user. So the user has to give the name of their favorite movie, and we need to recommend movies based on those movies. So here there is a possibility that the user can make some mistakes on the movie name, right? So there can be some spelling mistakes or other things. So we need to find what is the close match of the movie name given by the user. So we need to take the value given by the user, which is nothing but the movie name, and we need to compare it with the data set that we have. So this data set contains a list of movies. Okay, so there will be around 5,000 different movies. So we need to compare with all those movie names and find which movie is the closest to the one which is given by the user. And for that purpose we need this difflib library. So you will understand while we are implementing this. For now, just understand that it is used to create, get the closest match of the some value. And now I'm going to import the vectorizer function from sklearn dot feature extraction dot text import TF-IDF vectorizer. So in our previous video where we have tried to build a spam mail prediction system, in that we have used this TF-IDF vectorizer, which is used to convert the textual data into numerical values. Numerical values in the sense feature vectors. Okay, and we are going to do the same in this case also, as we have a lot of textual data such as the title of the movie, director name, cast name, etc. Right? So it is in the form of text. So this data will be in the form of text, and we need to convert it to meaningful numbers, which are our feature vectors. And for that we need to use this TF-IDF vectorizer. And the last thing that we need is from sklearn dot metrics dot pairwise. Let's import cosine similarity. So as I have explained you before, we need to find the similarity confidence score of all the movies, and we will do that by using this cosine similarity. If you use this cosine similarity, it will give some similarity score for all the different movies compared to the other movies, and we are going to use this similarity score in order to recommend it. So let's say that the user is giving some movie name, and we need to find the similarity score of that particular movie with all the other movies, and we have to find which movies has the highest similarity score. So highest similarity score means those movies are similar, and we are going to recommend those movies, and that is the purpose we need this cosine similarity function. So first we are importing NumPy and pandas library, and then the difflib library in order to get the most closest match to the name of the movie given by the user from our dataset, and then we are using this TF-IDF vectorizer in order to convert the textual data into numerical values, and finally we have this cosine similarity, which is the most important part in this code. Okay, so the next thing which we are going to do is data collection and processing. So I'll just put a text here as data collection and pre-processing. So you can download the dataset from this video description. I'll give the link for it. So you can also search Google for this particular dataset. So you can go to Google dataset search, and you can find this dataset there. Or I think it is also available in Kaggle. I'm not sure about this, but I'll give the link for this particular dataset. So now what we are going to do is we are going to load the data from the CSV file to a pandas data frame. So that is our next step. So I'll just make a text here as loading the data from the CSV file to a pandas data frame. So I'll name this data frame as movies data. So movies data is equal to pd dot read CSV. So this read CSV function will load the data from the CSV file. So the CSV file is nothing but this movies.csv to this data frame called as movies data, and we need to put the opening and closing quotes here, and within this we need to paste the path of this particular file. So if you go to this files option, so you will find this options menu here. So from this you can copy the path of this particular file and paste that in within this quotes. So this will load the data from the CSV file to the data frame, and this data frame is nothing but movies data. Now what we are going to do is look at the sample of this data set. Sample is nothing but we are going to look at the first 5 rows of the data frame in order to understand what is the different columns that we have in our data set. So this will be about printing the first 5 rows of the data frame. Okay, so mention the data frame name, which is movies data dot yed. So this yed function will print the first 5 rows of the data frame. So this is what we have. So each line or each row represents one movie, and we have different columns here. So first is the index column. So index is nothing but the serial number for all this movie, and next we have a budget. So what is the budget of the movie, and the next one is genre. So some people call this as genre, some people call this as genre. So that's not our concern for now. So I'll just call this as genre. Okay. So genre is nothing but what is the theme of the movie. So you can see the text like action, adventure, fantasy, science fiction, etc. So the first movie that we have is Avatar. So you can see the title here. So most of us would have seen the Avatar movie, right? So it is nothing but some alien war kind of a thing. So they go to a planet called as Pandora, where they try to fight with the avatars there, and you can see the genres here. So it is an action movie, and it is an adventure kind of movie, science fiction, and so on. So this contains this third column. So first is the index column, second is budget. So this third column contains what is the theme of the movie, which is nothing but its genre. And then we have the home page. Home page is nothing but the official site where you can watch the movie and so on. And then we have some ID for the movie. Okay, so the other columns that we have are, so let's try to look at all the columns and try to understand what they are. And then we have the keywords. Keywords is nothing but these words tell you it kind of tell you the idea of about what the movie is like. So for Avatar movie we have the keywords such as culture, clash, future, space, war, etc. And this movie is based on these factors, right? So this keywords contains some words which kind of represents that movie. And then we have the original language. So what is the language that the movie has been made? And then we have the original title. So the first movie that we have is Avatar, and the second movie is Pirates of the Caribbean, and so on. So we have different movies. Okay, so fourth is nothing but the Dark Knight Rises, John Carter, etc. So next is the overview. Overview is nothing but some general description of the movie. It is like the plot of the movie. Okay, and then we have the popularity score. So popularity score tells you how much popular a movie is. If the popularity score is high, then it means that the movie is very popular. Okay, so we have the popularity score for all the individual movies, and then we have production companies. So all the columns are self-explanatory. You can just read this column name and you can understand what it basically means. So what is the company that has produced that particular film, and what is the country of that particular production house, and then we have the release date here, and then we have the revenue. So this column represents what is the revenue that the movie has generated, and then we have the runtime, the duration of the movie, and then we have the spoken languages. So what is the languages that has been spoken in the movie, and the status is nothing but whether the movie is released or not. So the other columns that we have are tagline. Okay, so tagline is also similar to each movie has a tagline. So if you look at this Avatar, it's enter the world of Pandora. So Pandora is nothing but the planet where everything happens in that Avatar movie. Okay, and the tagline for the second movie. So the second movie is Pirates of the Caribbean. So at the end of the world, the adventure begins. Okay, so it is like a tagline for each movie. So each movie has its own tagline, and then we have the title of the movie. Okay, so the first is Avatar, Pirates of the Caribbean, so and so on, and then we have vote average. Vote is nothing but the movie's rating. Okay, so movies rating out of 10, and then we have the vote count. So how many votes are there for all this votes? So and then we have the cast. So cast is nothing but the actors who have acted in that particular movie, and then we have the crew. So crew is nothing but what is the team that has acted here. So who is the cameraman, editor, and so on. And finally we have the director names. So now out of these columns we won't be using all the columns, but we will be using some most relevant data that we need for our recommendation. Okay, so we need to choose the features or the columns specific for our problem. So that will be our next step. But before going to that, I just wanted to look at how many rows and columns that are there in my data set. Okay, so now I just wanted to find the number of rows and columns in my data set. So number of rows and columns in the data frame. So mention the data frame name, which is movies data dot shape. So this will tell you the total number of rows and columns here. So the first value tells the total number of rows, and the second value tells the total number of columns. So 4803 represents, we have totally 4803 rows, and each row represents each movie. Okay, so totally we have 4800 different movies, and 24 represents different columns. So totally we had about 24 columns, and not we are not going to use all the columns here. So that is not necessary, but we are going to use some most relevant columns. So that will be our next step. So this is selecting the relevant features for recommendation. Okay, so this step can also be called as feature selection. So I'll create a list here called as selected features, and in the selected features I'm going to mention certain columns that I'm going to need. Okay, so I'm going to choose a particular set of columns. So I'm not going to take all the columns, but certain columns that we need. So as I've told you before, this recommendation system will be slightly a content based and popularity based recommendation system. So I'll be using the columns such as the genre of the movie. So if you want to build a content base, you need this genre, right? So genre of the movie, and then we will be taking the keywords of the movie and what is its title and so on. So I'm going to take the genre, keywords, title, and we can also take the tagline. Okay, so what is the tagline of the movie, and finally we can take the cast and director of the movie. So these are the things that I'm going to need. So I'm going to choose 5 columns. One is the movie's genre, the keywords of the movie, tagline, cast, and directors. Okay, so it's not that you have to choose these features alone, these columns alone. So that is not the case. You can choose any columns you want, but it should be relevant to your recommendation system. I'm just choosing these 5 columns. So one main thing is you need to mention the column names within this list. So you need to just copy the words from here and paste it. So these words should be accurate. Okay, so there shouldn't be any spelling mistakes in these words. So mention all the columns that you need. So first I'll include my genre, and then I'm going to include keywords and tagline, cast, and finally I'm going to take director. So the reason I'm taking cast and director is that, let's say that a person is a fan of Robert Downey Jr., and there is more likely that that person is going to watch a movie which is acted by Robert Downey Jr., right? So cast and director is one main thing that we can use for a recommendation. Say for example, some people can be the fan of the director Christopher Nolan, and if you suggest the movie is directed by Christopher Nolan, they're most probably going to see that movie. So that is the reason I'm taking cast and director. And then we have the contents such as the genre of the movie, keywords, taglines, and etc. So you can also take the overview of the movie. So overview is nothing but the movie's plot, right? So you can also take that, but now I'm not going to take this. I'm just going to take these 5 features alone. So if you want, you can also take more features which are relevant to build your recommendation system. So this is the list, and I'll just print this list for some reference. Okay, selected features. So I have named this list as selected features as I'm selecting all these features. So totally I have 5 features. Okay, so there is some mistake here. Yeah, FE. So these are the 5 features that we have. Okay, genre, keyword, tagline, cast, and director. Now what we are going to do is, in my previous video also I have explained you that textual data contains a lot of missing values called as null values, and we need to replace this with null string. Okay, and now we are going to do that, but we don't need to do that for all the columns because we don't need all the columns, right? We just need these 5 columns alone. So I'm going to show you how you can replace the null values with null string in this 4 columns alone. So I'm going to use a for loop for this. So this step is replacing the missing values or the null values with null string. Okay, so let's create a for loop here in order to go through each column individually. So I'll name this as for feature in selected feature movies dataset. So I'll just complete this for loop and explain you what I'm doing. Feature is equal to movies data and feature dot fill in. So what we are basically doing is we are creating a for loop, and in this for loop what we are doing is we are replacing the null values with this null string. So null string is nothing but an empty string, so that's why I haven't mentioned anything within this codes. Okay, so for feature in selected features, so I'm going to run a for loop within the selected features list. So we know that the selected features list contains the values such as genre, keyword, tagline, cast, director, etc, right? So each time the for loop will take one values. So the first time the for loop runs, it will take this genre value, and after the for loop is completed once, the second time it will take the value keywords. Okay, and after that tagline and so on. So let's say that while the for loop is running for the first time, this feature will take the value genre. Okay, so this is nothing but for genre in selected features. So now is like just think about replacing this feature with this genre. Okay, so it will be like movies data genre. So in that particular column, so movies data genre is nothing but this column. Okay, the third column, and in that column we are going to replace all the missing values with null string. Okay, so fill na, so na means not available or missing values, so we are going to fill those values with null string. So that's what we are doing. So once the for loop is completed for once, and now this word feature will take the value keyword because that is the second value in the selected features list. Okay, so this is a simple for loop. I hope you are understanding this particular thing. So each time this feature will take each value, and each time it will replace all the missing values with null string in each of these columns in the movies dataset. So we have mentioned the data frame name, so we know that we have named the data frame as movies data, right? So we are taking the movies data, we are representing features. So feature is nothing but all the name of these columns individually, and we are replacing this with null string. So I'll run this. So this will replace all the missing values. Now what we are going to do is we are going to combine all these columns. So if you take this first movie avatar, so the genre, keywords, movie's title, cast, and director, so all the data will be combined together. So similarly all the rows will be combined together in their respective columns. If you think about Pirates of the Caribbean, so we will put together this genre column, it is adventure, fantasy, action, and then this keyword, so this keyword, genre, and the title of the movie, cast, and director, so all this will be combined together. So that's what we are going to do now. So this is combining all the 5 selected features. Okay, so let's create a variable as combined features, and within this we are going to combine all the relevant features, the 5 features that we have chosen. Okay, so here we need to mention the data frame name. So because we are going to take the data from the data frame, right? So mention the data frame name, and within the square brackets you need to mention the column name. So the first column name is nothing but the genre, so genre of the movie, and the second one is, so just a second, so we need to combine all those. So you can just add this addition symbol, so you just add this plus mark and you can just add a space here, and then again add the next column. So the next column is nothing but genre keywords, so I'll mention this keywords. So we just need to add 3 more columns, right? So plus movies data, It's the same thing again and again. You just need to mention the column names separately. So movies data, the third column is my tagline. Yeah, tagline. And then I'm going to include my movies data cast. And finally, we have the last column, which is director. Movies data, director. Okay, so 1 second. So what we are doing is we are just combining all the data here. So this is just like concatenating two strings. Concatenating is nothing but joining different strings, right? So all these are strings because these are text. So I'm creating a variable called as combine feature, and in this variable I'm storing all the combined features. So I'm taking this genre column and I'm concatenating it with the keyword, tagline, cast, and director column. So we are just combining all the features together. Okay. So I'll run this. So there are no errors. Now you can try and print your combined features column. Okay. So I'll just run this. So now it will contain the number of rows will be the same, right? Because we are just combining all the columns. So this first row will contain the genre of the avatar movie, keywords of the avatar movie, tagline, cast, and director, all the things of avatar movie. Similarly, the second line will contain the genre, keyword, tagline, cast, and director of the Pirates of the Caribbean movie. So we are just combining all the text and data together, respective of each film. Okay, so this is our next step. Now what we are going to do is we are going to convert this textual data to feature vectors. Okay, or in other words, we are going to convert them into numerical values. So this step will be converting the text data to feature vectors. So the reason we are doing here is doing this particular task is we cannot find the cosine value. This is cosine similarity value easily with the text data, but if you have a numerical data, you can easily find the cosine similarity value, and that is the reason we are converting it using this vectorizer function. So we are going to use this tf-idf vectorizer in order to convert the text to numerical values. So let's do it now. So if you want to know more about this text to numerical data conversion and about this TF-ID vectorizer, I'll give the link for that video as well. I have already made the video on that topic. You can refer that one. So vectorizer. So I'm just creating an instance of this TF-ID vectorizer. And yeah, so you need to mention this parenthesis here. Now we need to fit and transform the data. So I'll run this and I'll create a variable as feature vector. Feature vectors. And feature vectors is equal to vectorizer dot fit transform, and within the bracket you need to mention combine features. So what we are basically trying to do is, so we know that we have imported the tf-idf vectorizer, right? So we have imported it from sklearn.featureextraction.text. So I'm loading this tf-idf vectorizer to an instance called as vectorizer. Okay, so I'm just using this vectorizer instead of using this tf. It's basically the same. I am loading this tf-idf vectorizer into this vectorizer variable, and I'm going to use this vectorizer in order to fit and transform the data. Now what happens is, so I am mentioning feature vector. So I'm creating another variable called as feature vectors, and this is where I'm going to store all the numerical values now. So I'm calling this vectorizer, which is nothing but my tf-idf, and I'm fitting and transforming all the data. So which data I'm transforming here is the combined features, right? So the combined feature is nothing but the combination of all the columns that we have in our data set. So this will transform the data to numerical values, which are nothing but a feature vector. So it will be stored in this variable, and now let's try to print this. So print feature vectors. Okay, so this is how your data would look like. So the data which looked previously like this is converted to this. Okay, so this data is nothing but your combined features, and we are fitting and transforming this combined feature to this feature vector. So that's what we are doing, and this is how you can convert the textual data in order to numerical data. So whenever you are using some machine learning models also, we don't feed the textual data directly. So we will convert them to feature vectors, and then we will feed the data to our machine learning model. Okay, so this is one of the common steps that we do with the textual data. And the next step is the most important one, which is to find the similarity score. So for this, we are going to use the cosine similarity, which we have discussed before. So cosine similarity, I'll make a text here and also make a comment here as getting the similarity score. You can also call this a similarity confidence value. Okay, so I'll just call this as similarity score, getting the similarity scores using cosine similarity. So we have imported this cosine similarity function, right, previously from sklearn.metrics.parallel. So we have imported this cosine similarity and I'm going to use this function now. So let's store all the similarity score. Similarity score is nothing but you will get some score value, some numerical score value for all the different movies. So I'll store all the values in a list. Okay, so similarity is equal to cosine similarity, the function which we have imported, and here you need to mention for which you need to find this cosine similarity. So it is nothing but your feature vectors. Feature vector is nothing but we have converted the textual data into numerical values, right? So I have stored all the values in my feature vectors, and now I'm going to feed this to my cosine similarity. Now this cosine similarity function will go through all these values and it will try to find which values are similar to each other, and the end result is that it can find which movies are related to each other. So that's the idea. So you are going to convert the textual data into numerical values, which are your feature vectors, and then you are going to find the similarity score value using the cosine similarity. Okay, so let's run this, and now you can print and see your similarity value. Okay, so this is the similarity value of all your movies. So you can also print the shape, similarity dot shape. Okay, so 4803. So this is nothing but first is the index, the movie's index, and second value represents its similarity score. So totally we have 4803. So what it basically means is like for each movie, we will compare it with all the other movies. Say for example, let's take this Avatar movie. So how this cosine similarity works is it will take this Avatar movie and it will try to compare it with all the other movies that are there in this data set, and it will try to give a similarity score value, and then this will be carried out for all the other movies as well. So first, once the Avatar is over, then it will try to find the same for the Pirates of the Caribbean movie. It will try to take this movie and try to find the similarity score by comparing it with all the other movies. So this will be done for all the movies, and you will get an array like this, which is 4803. So you will get some value, and this value represents what is how much similar a movie is to other movie. Okay, so that's what is represented by this. Now what we can do is, so as we have the similarity score, now we can ask the user to give an input. Now the user has to give the name of his favorite movie. So once he has given it, what we will do is we will try to find whether that movie is present in this particular data set. So if it is present in that particular data set, we will try to find which movies are similar to it using the similarity score which we have found. Okay, so you will understand once I am implementing this. So this part will be getting the movie name, from the user. Okay, so I'll name this as movie name. So this value has to be given by the user is equal to, so in order to get some value from the user, you can use this input function, right, in Python. So this is just like a scanf function in C programming. Okay, so enter your favorite movie name. And this was favorite movie name. Okay, so I'll run this. Now we need to give the name of our favorite movie in this particular bar. Okay, so I'll name this as Iron Man. So I'll say that Iron Man is my favorite movie. Now we need to write the code which can get the similarity score of Iron Man with all the other movies, and it has to give me a list of movies. So that will be our next part. So now I just need to create a list which contains all the names of the movies. So this part is creating a list with all the movies, the movie names, given in the data set. So if you don't follow or if you don't understand what we are doing here, it's completely fine, because it's hard to understand the order we are doing it. So once I complete the code, I'll explain you clearly what are the steps that we are doing here. Just hang in there, okay? So creating a list with all the movies given in the data set. So here what I want to do is I'm going to create a list, and this list will contain all the name of the movies that is present in this data set. So I just want this movie name alone. So you can see this title here. So we have this title, right? So title of the movie, and I'm going to take this column alone. So the reason I'm taking the name of the movies is I want to compare it with the value given by the user. Okay, so that's the reason I'm creating this list. So list of all titles. So list of all titles is equal to mention the data frame movies data, and we want to take the title column alone. So dot to list. So this will take all the values and it will create a list. So that's the reason for using this to list function. Okay, so let's also print this, print list of all titles. Okay, so now this list will contain the names of all the movies that is present in our dataset. Okay, so all the 4,803 movie names. So the reason we are doing the particular reason is we need to find the best match for the value given by the user. So we need to check whether this value is present in this particular dataset. Okay, so this part will be finding the close match for the movie name given by the user. So as I've told you, in order to get this best match, we need to use this difflib, right? So what we will basically do is take this Ironman value, the value which is given by the user, and we will compare it individually with all the values in this particular list. So we know that this list contains the name of the movies, right? So we need to do that now. So find a close match. So I'll name this as find close match is equal to difflib, which we have imported before, and this library contains the function called as get close match, and movie name list of all titles. Okay, so as I've told you, so once we get the name of the movie from the user, we need to compare it with the list of all the other movies present in our data set. So we are just comparing those values. So we need to find whether that particular movie is present in the list. This list is nothing but all the movies that are present in our data set. Okay, and I'll also print this close match. Okay, so let's print this, print find close match. Okay. Okay, so these are the close match. So totally you get three values or three film names. So basically what we are doing is we are getting the name of the movie from the user, and then we are comparing it with the movies present in our data set. So we find out that there are totally three movies which are very close to the name of the movie given by the user. So Iron Man, Iron Man 3 and Iron Man 2. Okay, so the three parts of the Iron Man movie basically. Now what we are going to do is take the first value alone, because we just want one movie now, and after that we will try to compare which movies are similar to this Iron Man movie. So as you can see here, this find close match turns out to be a list, right? And we are going to take the first column of this list alone. So we let's mention close match. I just want only one value. I don't want these three values. I just want only one match. Okay, so close match is equal to the first value in this list. So the list name is find close match and mention 0. So find close match 0 is nothing but the first value in this list. So you can now print this close match. So print close match. Okay, so this will print this Iron Man alone. Okay, so what we are doing is we are comparing the value given by the user with all the movie names, and we are getting some close matches, and it turns out that there are totally three movies which is similar to the one given by the user, and we are taking the first value alone. First value is nothing but the most relevant or most similar movie name, which is Iron Man, and I'm taking that value alum. So I'm printing the first value in that list, and it turns out that it is Iron Man. Now what we need to do is find the index of the movie. So you will understand why we are doing it. Just wait for some time. So this part is finding the index of the movie with title. So using this title, I'm going to look for its index. So I will locate this title in this column, and I'm going to find the index of the movie. Okay. So yeah, you can see the index here. So I'm going to find the index of the movie based on the title. So that will be the next step in our code. So I'll name this as index of the movie is equal to movies data dot title is equal to close match. So close match is nothing but Iron Man in this case. So close match index dot value 0. Okay, now we can print this index. Print index of the movie. So what I'm going to do is, so I got the close match as Iron Man. Now I'm going to take this Iron Man and I'm going to check which particular row as this Iron Man. So I will compare it with this title column. Okay, so I will go through this title column and I will see what is the index of the movie. Let's say that the Iron Man is in the fourth column, so there will be Iron Man here, and I will find the corresponding index value. So I want this index value so that I can find the similarity score later. So that's the reason for finding this index value. So basically what we are doing is we are taking this close match value and I'm going to find the index. I'm going to store it in this particular variable called as index of the movie. So I'm taking this data frame, which is movies data dot title. So in this title I am checking for close match. So close match is, in this case, it is Iron Man, right? And for that I'm going to take the index value. So this is basically like what I've explained before. So you have to locate the name of the movie here. So once you locate it, you will find the corresponding index value from here. So that's what we are doing here in this particular step. So again, it will be in the form of a list. That's why we are mentioning 0. So 0 will give you the actual index of the value. So there is some error here. Close match. 1 second. Movies data dot title. Okay. So you should mention again movies data. Yeah, I think it will work fine now. Let's see. Yeah, so we got the index value as 68. So this is how you can find the index of the particular movie using its title. Okay. So now I'm going to take this index value and find the similar movies. So we can do that because we have this similarity score. So this similarity score will contain the index and its similarity score value, and I'm going to take it from here. So this will be getting a list of similar movies. Getting a list of similar movies, and we are going to find it based on the index value. Similar movies. So similarity score is equal to list enumerate. I'll explain you what this means just a second. Enumerate similarity index of the movie. Okay, so similarity. Yeah, so similarity is nothing but your similarity score value, right? So I'm taking this as similarity score. List enumerate similarity score of index of the movie. So index of the movie is 68. So what we are doing here is I'm taking this movie, this Iron Man movie, and I'm going to find the similarity score of all the movies in my data set. I'm going to find that value. So the movies which are similar to this Iron Man value will have higher similarity score value. So the movies which are not relevant to the Iron Man movie won't have any similarity, have a very small similarity score value. So that's the idea in this. And enumerate is nothing but this enumerate is just used to run a loop in a particular list. So the loop or the iteration that we are doing here is we want to find the similarity score for all the movies, right? So we don't want to do that individually. So we are creating a loop, and for that we can use this enumerate. So enumerate is basically used to carry out a loop in a list, and also we want to get the index of index, not the index, the counting of that particular loop. I'll just run this and explain you. So now you can print this similarity score. Okay. So what this basically outputs is, yeah, you can see here 0, 0.033, 1, 0.054, and so on. So here what we have is the first value represents the index of the movie, and 1 represents, yeah, I mean the first value represents the index of the movie. This 0, this 1, 2, 3, etc. So these values represents the movie's index, and this value represents the similarity score of the movie compared to the Iron Man movie. Okay, so if you just come here, yeah, so the first movie is Avatar. So the similarity score of Iron Man and Avatar is 0.0335. So on the second movie has a similarity index of 0.54. So if you come here, the second movie is Pirates of the Caribbean. So the similarity score, that is the similarity between the Pirates of the Caribbean movie and the Iron Man movie, is 0. Um, 0546, etc. Like if there is movies like Iron Man 2 and Iron Man 3, Captain America, these kind of superhero movies, the index value will be very high. Okay, so this is how we can get the similarity score of movies of a specific movie. So we are taking this movies alone. So if you give Avatar, then this particular similarity score will change. So we are taking only one movie, and we are getting the similarity score of all the movies present there. Okay, so this will totally contain 4,803 values. So length similarity. So this will contain 4,803 values. So what this means is we are finding the similarity score of all the movies that are present in the data set. So that's why this contains this many movies. But we don't want all this, right? So we want only the movies which has higher similarity score values. So that will be our next step. So once we find those values which have higher similarity scores, we can recommend those movies to the user. So that will be the last step of our code. Now we need to sort this. So this is in the order of the data set, right? So this particular similarity score is in the order of this data set. So Avatar, Pirates of the Caribbean, etc. Now we need to sort this based on the higher similarity score value to the lower similarity score value, so that we can recommend the movies with higher similarity score values to the user. So that is the next step. So this is sorting the movies based on their similarity score. So I'll create a list as sorted similar movies. So sorted is a function that you have in Python in order to sort or arrange the elements of a list and so on. So I'm going to sort this similarity score list. So this is nothing but a list value. Okay, so this list contains multiple values, and this represents one element of the similarity score list. Similarity score, and I'm going to use a lambda function here. I'll explain you what this means. Lambda x is to x of 1, and reverse is equal to true. Okay, and now we can print sorted similar movies. Okay, so what we are doing is we are going to sort. Sort is nothing but we are going to arrange the movies from higher similarity score value to the lower similarity score value. It's nothing but the descending order, and that's why we have used this reverse parameter. Okay, so reverse is equal to true will tell you that I want to arrange the values from the descending order, simply descending order, higher value to lower value. And now you can find this key lambda x is to 1. So we are taking this particular list, which is similarity score list, and I am taking a key here. The key is nothing but x is to x of 1. Basically means x is nothing but your this particular list. The similarity score is represented as x, and x of 1 is this value. Okay, so if you mention x is equal to 0, so let's say that I'll mention x of 0. So x of 0 basically means the first element. The first element is nothing but your index. whereas the second element is your similarity score value, and that is represented by this x square bracket of 1. Okay, so I am taking that value and I'm arranging all the values in the reverse order, that is in the descending order. So that's the meaning of this particular line. I'm creating a list called a sorted similar movies. In that I'm sorting all the values and I'm sorting based on the descending order based on this x of 1 value. X of 1 is nothing but this second value. Okay, so this is the zeroth value, which is the first value. This is the second value. So this will be done for all the movies, and if you run this, you will get a list of movies again. So 68 is nothing but the Iron Man movie. 79, so 79 will be other movie which is very similar to the Iron Man movie. So as you can see here, now the similarity score value is very high, so it is 1, and here it is 0.40, so 0.31, so on. So these have a higher similarity score, whereas these are lower similarity score. So now we are arranging the movies based on the, so we can say that the top movies in this list are similar to the one given by the user. The movie given by the user is Iron Man, right? So these are the similar movies. So now we need to take maybe 10 or 20 movies from this list and we can suggest that to our user. So that will be our next step. So this is the last part of this particular code. Okay, so print. So don't worry if you don't understand few things. So once I'll complete this, I'll explain all the things in order, and at that time it will make clear sense to you. Okay, so just hang in there. So print the name of similar movies based on the index. So now I have the index of the movie. Okay, so I'm using this index of the movie. I'm going to find the title. So it is very simple. It is just like the one we have did before. So previously we have used the title of the movie in order to find the index, and now we are going to use the index of the movie, and using this index we will just find the movie name. Okay, say for example, if the index is 31, we just go to the data set and we will look at the 31st index, and we will see what is the corresponding title name. So that will be the similar movie to the one given by the user. So this will be the next step. So I'll just put a text here as print movies. Okay, so movies suggested for you. So these are the movies that we are suggesting for our user who want to get some recommendations for the movie. So movies suggested for you. So let's go to the next line in order to print the movies. So I'll create I is equal to 1. So I'm going to create a for loop for movie in sorted similar movies. So I'll just complete this code and explain you what we are doing here. Just give me some time. Index is equal to movie 0 and title from index. Title from index is equal to movies data. Again mention. So it's the same thing that we have did before. So previously we found the index of the movie using title. Now we are using the title. So I mean we are using the index. So we have the index value, right? 79, 31, 7, 16. Using these values, I'm going to find the title of the movie. So that's what I am doing here. So movies data dot index is equal to index title dot values is equal to 0. So this is actually similar to the one which we have did before. Okay, yeah, this part is getting the index of the movie using the movie name, right? So this is the same thing here. The only difference is that we have interchanged the index column and the title column, because in this case we are finding the name of the movie using the index. So there should be L. Okay, so if I is less than 0, so I'm going to suggest 30 movies for the user, okay, based on his favorite movie. So if is print I, comma dot. So I'm going to print the movies with the serial number, title from index. So you will understand once I run the code. Index I is equal to plus is equal to 1. So this is our for loop. So basically what we are doing here is, so now we got the list of movies in the descending order. Descending order means this first value has a higher similarity score, second is also having higher similarity score, but it is less than 1. So the first 20 movies or 30 movies can be considered as the movies which are similar to the Iron Man movies, and it's not like it is similar to it. It is like we can say that the user is going to enjoy the movie because it is similar to the one which is his favorite movie. Okay, so I'm going to take the first 30 movies from this list and I'm going to print the name. So I'm taking the values individually. So I will take this first element and I will take this index value alone. So using this index value, I will find the name of the movie from my data set. So so this will be the first step of the for loop. So the second time the for loop is running, so it will go to this second element and it will take this 79, and then again it will try to look at the data set and find the title of the 79th movie. So similarly, the third step will be finding the name of this movie. So that's what I'm doing in my for loop. So I'm creating I is equal to 1. So initially I'm giving I is equal to 1. So, and for movie in sorted similar movies, so when we run the for loop for first time, this movie will take this particular value. Okay, 69 1.0002, because this is the first element in the sorted similar movies list. Okay, so this is the list we are printing, and in this list I want to run the for loop, and this movie will take this first element. Okay, so in this first element I don't want these two values, I just want this index value alone. So with this index value I can find the title, right? And hence I am mentioning movie of 0. Okay, so movie of 0 is nothing but this value, and this is nothing but my index. So that's what I am mentioning here. So for movie in sorted similar movies, that is for 68 comma 1.002 in sorted similar movies, index is equal to movie of 0. Movie of 0 is this value 68. Okay, if you mention movie of 1, then this will be this value. Okay, so if you mention with 1 represents second value, 0 represents first value, right? So if you mention movie is 0, this is this value. Now substitute the 68 for this index. So title from index, so you can just substitute this value as 68, so it is similar to it. Okay, so now using this index value, I'm going to find the title from this movies data set. So that's what I am doing here, and after I find this, this has to be run for 30 times, because I want to give 30 different movies for my user. So that's why I'm creating this. So this if condition will go as long as the I is less than 30. So each time the for loop runs, I have given a increment for I. So for the first time the for loop runs, this I value will be changed to 2. So the next time the I will have the value of 2. So similarly it will go again and again this till the I value reaches 30. So this is just to give the number of movies. So let's say that you want to give only 20 movies to your user. In that case you will mention 20 here. So if you want to mention just 10 movies, you can just mention 10 here. So this if condition is just to uh, determine the number of movies you want to recommend for your user. So that's it. Okay, so I'll just say that I want to recommend 30 movies for my user based on the favorite movie given by him. So that's what I'm doing here, and let's run this. So this will give all the movies we can suggest for him. So title from index is not given. So title from index, yeah, I made a spelling mistake here. Okay, so title from index. So let's run this. So these are the movies I am suggesting for my user. So these movies are nothing but Iron Man, Iron Man 2, Iron Man 3, Avengers Age of Ultron, Captain America, X-Men, Apocalypse, and these all of these things are superhero movies, right? So that's what I have been telling you all about. So if you give a movie, this system will give you all the other similar movies. So if you mention this I is less than 20, you will get 20 movies, as you can see here. Okay, 20. So like it's 19 because in Python indexing starts from 0, right? So that's the reason. So you can just mention 21 if you want 20 movies. So that's very simple. So I'll just put this as 30. Okay, so let's run this. So I'll get 30 movies, 30 or 29 movies, which is similar to the one given by our user. So this is how our movie recommendation system works. I'll just do one more thing, a last thing. So I just want to incorporate all the codes in a single cell. So I'll just go to this, just make a text here. So make a text here as movie recommendation system. So this is like the predictive system that we have been building in our project videos. Okay, so that is this is similar to it. Recommendation system. So in this part of the code, so I'm not going to do anything different. I'm just going to copy the last part of the code and put it together, so that when we run the cell, it will ask the user to give some movie name. So once the user gives the movie name, it will tell us 30 different movies which we can watch. Okay, so we need to copy this movie name. Yeah, from this. So we want to get the movie name from the user, and where is this? Where is this? I'll just copy and paste this movie name. Yeah, and then list of all the movies, all the titles. Don't want to print. Just want this first thing alone. So we don't want to print this. So list of all the titles. So I'll explain you what I'm doing. Just wait for a second. So list of all the movies, and now we need to find the close match. Hmm, yeah, this one. Find close match. So I'm just incorporating all the codes together. That's it, nothing else. So index of the movie close match is equal to find close match 0, and then index of the movie is equal to this. And the next part is similarity score. Similarity score. Sorting. Oh, sorted similar movies, and then yeah, the last step. Okay, so when you run this code, now this will ask you to enter the name of some movie. So once you run this, it will give you the recommendations for you. So that's what we are doing. We are just incorporating all the codes together. So I'll run this. So I need to give the name of my favorite movie. So I'll just say that my favorite movie is Batman. Okay, so we know that Batman is also a Superman movie. I mean superhero movie, right? So we get the movies such as Iron Man and okay, just a second. I think it is printing the same thing. Yeah, one second. Title from index. Should I change something? Just a second. I'll just try to give some other movie name. Avatar. Yeah, so I just need to change few things. I'll just pause the video and I'll just look for the error here. So actually the problem is I just missed a particular line. So I didn't include this similarity score line. So that's the problem. I just need to include this line as well. Okay. So I'll just paste this now. So this should come here. Yeah. So now let's run this. So first I'll say that my favorite movie is Iron Man. Okay, so let's see. So these are the suggestions I'm getting, and I know that all these are superhero movies, and they're like similar to the movie. So we can say that the user is going to like the movie. And now I'll just run this cell again, and now I'm going to give a different movie name. So here I'll give Batman now. Now, as you can see here, the suggestions have changed. So first is Batman, Batman Returns, Batman and Robin, The Dark Knight Rises, etc. So most of these are DC movies. So these are not Marvel movies. Like these are more related to Batman, right? So Superman movies and etc. So again, all of these are superhero movies, but they are more related to Batman. Now I'll just give Avatar movie. So we know that Avatar is a space and fantasy related movie, right? So I'll just give Avatar. Now I'm getting movies like Avatar, Aliens, Guardians of Galaxy, and all these movies are based on space and space sciences, etc. Right? So this is how you can create your movie recommendation system. So once you give the favorite movie of the person, so it will give you suggestions that you want. Okay. So now I'll just explain you clearly all the things. So I'll just give explain you in order what we have done from the starting. So it's just like a recap. So please watch this. Then only you can understand the code completely. Okay. So first, basically what we are doing is we are importing some libraries. So I think we haven't used NumPy library. So if you want, you can just remove this. But yeah. So we have imported NumPy libraries, pandas, difflib. So this difflib is used in order to get the close match. So we know where we are getting the close match, right? So in a particular part of the code, we will try to ask the user to enter his favorite movie, and we will try to see whether this particular movie is present in our data set. So we try to find the close match, and for this we need this difflib. So difflib, we are using this get close matches, and this is the reason we are importing this difflib library. Okay, and we need this tf idea vectorizer in order to transform the textual data to numerical feature vectors. So once you have this numerical features vector, it will be easier for us to find the cosine similarity values. So that is the reason for this. And then we have this cosine similarity. We know that it is used to find the similarity score value. If the similarity score value is I for two movies, then these two movies are similar to each other, then there is a high probability that the user is going to like that movie. So that's the idea. And then we have the next step is data collection and processing. So we have the data in a csv file called as movies.csv, and we are loading the data from the csv file to a data frame called as movies data, and then we are printing the first 5 rows of the column. So sorry, the first 5 rows of the data frame. And we have discussed what are the different columns that we have in a data set. So we have various columns such as the genre, the keywords, taglines, etc. Right, after that we try to check how many rows and columns that we have, and we found out that totally there are 4803 rows and 24 columns. So these are the basic things that we do with all the data sets. So this is completely fine. I think everyone understands up to this part. So this is how things will get a bit tricky. Okay, so the next thing is selecting the important features. So as I've told you, you don't need all the columns. So certain columns such as the id of the movie, and certain index is not that much relevant if you want to recommend the movie. So I'm just choosing the relevant features alone. So I'm choosing the features such as genres, keywords, tagline, cast, and director. So you can also try the same code, you can just include some other columns as well. Okay, so you can try that. So you will get some more recommendations, and maybe your recommendations may be better than what I have did, because I've just considered these 5 columns alone. So you can also include the description as well, this overview as well, so you may get a better result. Okay, and then what I'm doing is for all these 5 columns, I'm replacing the missing values with null string. So that is the this part. I'm, instead of doing it separately, I'm just putting all those together in a for loop. So that is this step, and then I'm combining all the selected features. So I'm just putting together or concatenating all the 5 columns together for each row. So now all the columns will be combined for each rows, and then I am converting this textual data to numerical values called as features vector using this tf idea vectorizer, and I'm transforming, fitting and transforming the data. So this is how we will use this vectorizer function. So we will fit and transform this combined features value, and this will give you the feature vector. So it will be in the form of numerical values, and we are finding the cosine similarity from this values, and this is the similarity score. Okay, and the next part is getting the name, getting the name of the favorite movie of a particular user, and here the user can give the name of which the movie they like. And now we are creating a list. So this list is created with name of the all the movies that is present in our data set. So we know that our data set contains about 5000 movies, right? I just wanted to get this title alone, so you can see the title. So we have this, we have 2 columns, one is original title and the another one is the title. So original title can be the title which was named before the movie has been released. This title is the one which has been given to the movie when it has been released. So in some cases people may change the title, right? So at the last minute, so we want this title column. So I'm taking a list, I'm creating a list which contains all the title names. And the reason I'm doing this is I want to find the close match of the movie name given by the user. So I know that my user has given the name Iron Man. I want to compare it with all the movie names, and I find that there are 3 movies which are similar to the one given by the user, and I'm just taking the first value alone. So in order to find this close match, I'm using this difflib.get close matches movie name. So this is nothing but the one given by your user, and the list of all title is all the movie names present in your data set. So you get all these 3 values, and I'm just choosing the first value, which is Iron Man. And now I'm trying to find the index of the Iron Man movie. Okay, so because only if I find the index, I can compare it with all the other movies and can find the similarity score. Okay, so I'm trying this 2 lines is used in order to find the index of the movie using the title. Okay, so I found the index of the Iron Man movie is 68. So if you use Batman or Avatar movie, you will get different indexes. Okay, so you can also, instead of Iron Man, try Avatar or Batman or any other movies, Pirates of the Caribbean, etc. Try other movies, okay? And once I get the index, I want to get the similarity score of Iron Man. So basically, what I'm going to do is I'm going to compare this Iron Man movies with all the other 4,800 movies, and for each movies, I'm going to get the similarity score. If the similarity score is very less, that means that particular movie is not similar to Iron Man. And if I suggest that, the user may not like it. If the similarity score is high, then that movie is similar to this Iron Man movie, and there is a more chance that that person is going to like that movie. So that's the reason I'm creating this enumerate list. So I'm looping over the list, and this enumerate will give you the index, or it will give you the count, how many times the list is running, and again it will give the value. So we need two values, right? One is the index, and the other one is the value, the similarity score, and you can get this using this enumerate function alone. So that is the reason we are doing this. And then we are sorting the values based on the descending order of the similarity score. So this order is based on the order that is present in your data set. So Avatar, Pirates of the Caribbean, etc. Okay, but this order I want to make this in a descending order. Okay, yeah, this one. So for this I'm using this lambda. Here x is to x of 1 is nothing but the second value. So I want to sort it based on this particular value in the reverse order. Reverse order is nothing but the descending order, and you will your movies get arranged in the descending order of your comparisons or the similarity score. After that, I'm creating a for loop where I'm just getting this index value, and using this index value I'm finding the title of the movie from my movies data frame. Okay, so that's what we are doing here, and we are doing this 30 different times because I wanted to give 30 suggestions for my user. If I want to give 20 suggestions, I will change this to 20 and so on. Now our code will output this, and now I am putting all those codes together from this yeah, movie name. So the part where we are getting the movie name from the user, I'll just make a text here as getting the user value, or getting, I'll just put the same thing, getting the movie name from the user. Okay, so we need to copy all the codes from this part. You can just you don't need to include this print options. So I've incorporated this print to show what this list contains. Okay, so you can just ignore this print lines, and you can copy and paste the other lines. So all the other lines are important for us, and when you put all these things together, you can run this, and it will ask you to enter a movie name. So if I enter it as Avatar, I will get suggestions of the movie which are similar to Avatar, which are related to space and so on. Okay, and I can just run this again, and I can include movies like Batman, and it will give me some other suggestions which are related to Batman. Okay, so this is how you can create a movie recommendation system, and I hope everyone is clear up to this part. So this is not the end of this project. So as you can see here, this data set contains only 4,803 movies, right? But we know that there are more than that. So you can also try to increase the data set. You can try to increase the data points that you have. You can create some other data set with more films, and you can just combine it with this particular data set. And if you do that, you will have more movies in your data frame. Or one thing that you can do is, if you are someone who watches Bollywood movie, you can curate a data set like this for Bollywood movies, and you can do the same for Bollywood movies, or you can do this for Tamil films, or etc. Okay, so this is what you can do from your side. Okay, so this will be a very good interesting task for you, where you can create a system that can give the suggestions of Hindi movies if a user give the name of a Hindi movie that he or she likes. Okay, so this is how you can build your recommendation system. How we can use K means clustering algorithm to do customer segmentation. In customer segmentation, we will try to group customers based on their spending patterns and purchase behavior and such kind of things. Okay, so this is what we are going to achieve in today's video. So in case you are watching my videos for the first time, hi. In this channel, I'm making a project-based machine learning course, and you can go to the playlist section to learn about my other machine learning project videos and also about my machine learning course. Okay, so with that being said, let's first try to understand today's problem statement. After that, I'll explain you the workflow which we are going to follow, and after that, we can get started with coding part. Okay, so this is the problem statement. Consider that there is a very famous mall, and you are a very experienced data scientist, and this mall wants to get insights about their customers, and they have their customer data regarding their purchase behaviors and other aspects to it. Okay, so as a data scientist, you can build a system that can cluster customers into different groups. So one group of customer may represent those that tend to purchase more in that mall, and some other group may represent a group of customers that don't purchase that much in a mall. So having these groups of customers will give us better insights, and it helps that mall to make better business decisions, to make better marketing strategies and such kind of things. So this is the problem statement which we have today. So this is an example for clustering machine learning projects or clustering machine learning problems. So far we have discussed about only the classification and regression problem. So classification and regression comes under supervised learning, whereas this clustering comes under unsupervised learning. So we have already made videos regarding these topics. So if you are not clear about those classification, regression or clustering, just let me know in the comments. I'll give the link for those videos. Okay. So now let's try to understand the workflow which we are going to follow. First, we need the small's customer data, because we need data to train our machine learning models, right? So first is getting this customer data, and once we have this data, we need to process this data. So we cannot feed this data directly to our machine learning model. So we need to select few features which we need. So those things will be covered in data pre-processing. Then we need to also analyze the data, so to see which features are important for us and what are the various features that particular data set contains and such kind of things. So that will be covered in data analysis. And after that, we need to choose the correct number of clusters. So we need to tell the machine learning model that I want 3 clusters or 5 clusters, or this many group of customers. So I want to split my data into these many groups. So we find that number by using a method called as within cluster sum of squares. So we will try to find this WCSS value, and we it tells us the correct number of clusters that is suitable for this particular data set. So I'll explain you more about this when we implement this method. And once we have the number of clusters we need, we can feed this data to a k-means clustering algorithm. So once you feed this algorithm to this model, it can group the data depending on the similarities, depending on the similar spending pattern, etc. Okay. So after that, we can visualize these clusters by putting these data, the predictions made by this particular k-means clustering model, into plots to get better insights about this data. So this is the workflow which we are going to follow. Okay. So now let's get started with coding part. So I'll be doing this programming in Python, and for Python programming, I'm going to use Google Collaboratory. I'll link the video for this Google Collaboratory. I've already made a video explaining all the features of Google Collaboratory and how you can access Google Collaboratory. I'll given the cards for the link of that video. So if you are not aware about this Google Collaboratory, you can watch that video. Okay. So with that being said, now the first step which we need to do is import the dependencies. So I'll make a text here as importing the dependencies. Okay, so dependencies are nothing but the libraries and the functions which we will use for this particular project. Okay, so I'll import some basic Python libraries, NumPy and pandas. So import NumPy as NP, and let's also import pandas as PD, and import matplotlib.pyplot as PLT, and import cborn as SNS, and finally I'll import sklearn.cluster. Okay, so it should be from sklearn.cluster. Okay, so from sklearn.cluster, import k-means. Okay, so these are the dependencies which we need. So NumPy is all about NumPy arrays. So this NumPy library is useful for making NumPy arrays, and pandas is all about making data frames. So data frames are nothing but structured tables. So the data set which we have is in the form of a CSV file. CSV represents comma separated values. So it is better to load the data into pandas data frame, as they are structured tables, and we can do better processing and analysis. And then we have this matplotlib library and a cborn library, and these libraries are useful for making plots. So these are data visualization libraries. And finally, from sklearn, from this sklearn library, in this cluster module, we are importing k-means. So this is the k-means clustering algorithm. Okay, so these are the dependencies which we need. So let's run this cell. To run this cell and go to the next one, you can press shift plus enter. Okay, so the next step is about data collection and analysis. Okay, so you can see this files option here, right? So go to this files. So as you can see here, I have already uploaded my dataset file. So I'll give the link for this dataset file in the description of this video, so you can download it from here. You can also find this dataset in Kaggle. Just search as mall customers dataset Kaggle, so you can find this dataset. So after that, so once you open this files, you can go to this upload to session storage option. From there you can upload your dataset file. Now I'll copy this path of this particular file. So once you give this options, you will find this copy path. So I'll copy the path of this file. Now we need to load the data from a CSV file. So you can see that it is in a CSV file, right? Now let's load it to a pandas data frame. So I'll make a text here as loading the data from CSV file to a pandas data frame. Okay, so let's name this data frame as customer data. So customer data is equal to, so we have imported pandas in the short form, in the updated form as PD, right? So we need to mention PD. So PD dot read CSV. So this read CSV function will read the CSV file and load all the contents of the CSV file to a pandas data frame. So inside this, we need to mention the path of the file. So we have already copied the path of the file, right? So now let's run this. So this will load this to the data frame named as customer data. Now let's try to print the first 5 rows of this data frame and see what are the columns or what are the features we have in this data set. So first 5 rows in the data frame. Okay. So let's mention the data frame, which is customer data dot yet. So this yet function will print the first 5 rows of the data frame. Okay, so as you can see here, we have first 5 rows, and totally we have about 5 columns. The first column is customer ID, so each customer has a unique ID, and we have the gender of each customers, and we also have their age and their annual income in $1,000. So 15 represents $15,000, 17 represents $17,000 annual income. Okay, and finally we have spending score, and the value of spending scores range from 1 to 100. If the value is greater than 70, and if it is close to 100, that means that person is buying so much in that particular mall. They are spending more. And if the value is kind of less, that means that person is not spending that much in that particular mall. Okay, so this is all about this spending score. Now let's try to find how many rows and columns we have in this particular data frame. Okay, so we already see that we totally have 6 columns, right? So finding the number of rows and columns. Okay, so I'll mention the data frame name, customer data dot shape. Let's run this. So the first value represents the number of rows and the second value represents the number of columns. So 200 means, so totally we have 200 rows or 200 data points. That means we have the data for 200 different customers. So this is a good sample size, and totally for features or for columns, so we have totally 5 columns, right? So this is the shape of this data set. Now you can get some more information about this data set using dot info function. So these are the some basic things that we used to do in all the projects we do. So it is better to understand our data before. So these are such kind of drill which we used to do in a regular basis. So getting some information about the data set. Okay, so I'll mention the data frame name, customer data dot info. So totally we have 200 entries. That means the 200 rows from 0 to 199, and totally 5 columns. So null value means missing values, and 200 non-null values means no values are missing. So that's what we are getting from this non-null value count. How many non-missing values we have? So that's given in this non-null count, and we also have the data type of each of the column, right? So int 64 represents a 64-bit integer value. So except this gender column, which have this string value, so this string value is taken as object. So other than that, everything is an integer data type, right? So this is how you can get the information about this data. So you can also get more information about the missing values in a data set. So I'll mention a text here as checking for missing values. Okay, So customer data dot is null dot sum. So this particular line of code will give the number of missing value in each column. So as you can see here, we don't have any missing values in this case, which is a good thing. If we have any missing values, then we follow methods like imputation to replace those missing values with suitable values. Okay, so as we don't have any missing values, we can proceed to the next step, right? So now we are going to choose which columns we are going to need for our clustering. So as you can see here, totally we have 5 columns. The first column is customer ID. So we don't want this customer ID, it's not required, because we are going to group the customers based on their spending behavior, and for that customer ID is not required, and also gender and age is also not that much required for this case. So you can also use, but in this case I'm just going to use the two features, annual income and spending score. So what we will get is group of customers, and these groups of customers will be classified based on their annual income and spending score. So I'm going to choose these two columns alone. Okay, so now let's extract these two columns alone from this customer data. So I'll put a text here, choosing the annual income column and spending score column. Okay, so I'll put a variable, give a variable as x. So I'm going to take these two columns and store it in the variable x. Okay, so customer data, and we need the last two columns, right? So for this I'm going to use the function iLoc. So we are going to locate specific columns, and for mentioning the columns we need to slice this data frame. So it's 3 comma 4 dot values. So I'll explain you what we are doing in this particular line of code. Okay, so what we are doing is we are taking this customer data. So this is the data frame we have, right? So customer data, and in this we are locating particular columns. The columns are nothing but 3 and 4. Here indexing in Python starts from 0. So it, number count doesn't start from 1, but it starts from 0 in Python. So the index of this first column, this customer ID column, is 0, and the index of gender column is 1, and for age is 2, for annual income 3 and 4. So totally we have 5 columns, and this is 0, 1, 2, 3, and 4. So we are going to take these two columns, right? So the index of this annual income column is 3, and the index of spending score column is 4. So I have mentioned this 3 comma 4. So you can see here I have mentioned a colon here and a comma here. That means I am taking uh, third and fourth column. That means the index third and fourth column. If I don't mention this column, it means that we are taking third and fourth row. So that is this particular slicing thing which we are doing here. So we are mentioning that I want this column with index 3 and 4, which are nothing but annual income and spending score. Okay, so dot value. So I'm just going to take all the values, nothing other than that. Okay, so let's run this. Now you can print your x and see what are the values you have. Okay, so totally we have a list of values, and each list contains two values. The first value represents the annual income. So you can see here the first value here is annual income 15, and spending score is 39. You can see here 15 and 39. So all the values in this first column represents the annual income of specific customers, and the second value in each list represents their spending score. So these two values are the ones which we need for our clustering. Okay, so in our x-axis we will take their annual income, and in y-axis we will take their spending score. So that's why we need these two values alone. So we won't be taking any other values like their age or gender. So we will just take these two values. Okay, so now what we need to do is, so as I have mentioned before, the next step is to choose the correct number of clusters. So choosing the number of clusters. So in this case, we don't know that whether we need to choose. So I'll just remove this for now. Okay, so we don't know for this particular data set. So totally we have 200 data points or 200 rows. We don't know that how many clusters we can make from this data, right? So we can make 3 clusters or 4 clusters or 5 clusters, any number of clusters, but we need to find what is the correct or what is the optimum number of clusters that is suitable for this data set. So this number of clusters varies depending on the data set. If you are dealing with a different data set, then you need to choose a different number of clusters. So we will choose the correct number of clusters by using a parameter, and this parameter is called as WCSS, and WCSS represents within clusters sum of squares. Okay. So you can search in Google if you want to get more information about this within cluster sum of squares. I'll just explain you what is meant by this. So you can see here, this is the formula for finding this within cluster sum of square value. So it tends to find the distance between each data point and their centroid. So you can see here, so the plus symbol represents each data point. So here we have x, right? Here the x represents, so I'll just run this. Here x represents, so the first value or the x-axis value represents the annual income, and the y-axis value represents their spending score. Similarly, if we take our annual income in x-axis and y-axis, we will plot all the data points in this graph, and plus represents all these data points, and this square represents the centroid. So each clusters have as their own centroid. So in this case, the number of clusters we have is 3, right? So when you try to find this WCSS value, it tries to find the distance between each data point and the centroid of those clusters. Okay, so for a good cluster, this data points should be very close to this particular centroid. So that means we get good partitioned clusters. Okay, so as you can see here, in this case these data points are close to this cluster, and it is the similar in this case as well. So when you have the correct number of clusters, the WCSS value should be very less. That means the distance between the data point and the centroid should be very less. For this, we will find this WCSS value and build plot like this. So you can see here, this plot or this graph is called as an elbow graph. So in this elbow graph, we will see which number of clusters has minimum WCSS value. I'll show you how we can find this. So this is called as elbow method. So I'll just make this as finding WCSS value for different number of clusters. So in this case, we are going to create a for loop, and in each cases, so in the first case, we will find the WCSS value when we consider for only one cluster. Then we do it for two clusters, then three clusters, all the way up to 10 clusters. And in this 10 clusters, we will try to find for which number of clusters there is minimum WCSS value. So this is the end result that we want for this particular step. Okay. So I'll create an empty list as WCSS. So I'll create this empty list. Now we can create a for loop for I in range 1 comma 11. Okay, so 1 comma 11 represents I will be taking values from 1 to 10. So when you mention two numbers inside this range keyword, it takes this first value. So here the first value is 1, and the second value is 11. So it is like n minus 1. So it will take all the values from 1, 2, 3, 4 and up to 10. So this second number won't be included. So if I mention 1 comma 20, then it takes the number of clusters from 1 to 19. So the second number will be excluded. So here I want the number of clusters to be 10. So it will be checked for 1 clusters, 2 clusters, all the way up to 10 clusters. So I need to mention 11 because this 11 will be excluded, right, for that purpose. So for I in range, let's create a variable as k-means, and this k, inside this k-means, we are going to load the k-means cluster function, which we have this is the k-means clustering model. So I'm going to use this k-means function, and I'm going to load it inside this k-means variable. So k-means is equal to, so k and m should be in caps, k means, and inside this we need to mention the number of clusters we want. So you can see all the parameters. Okay, so the first parameters is n clusters. So the number of clusters we want is I. So the first time this for loop runs, we will take the value 1. So in this case the value become 1, and once this for loop is completed, again this particular for loop will be carried out, and in that case the value will be 2, and in that case the n clusters will be 2, and similarly the process goes on. So it is a simple way of our for loop works. So n clusters is equal to I, and the initiation step which we are going to use is k-means. So k means plus plus. Okay, so there are other initiation steps like froggy initiation and random partition initiation, and the best initiation method is k means plus plus when it comes to k means clustering. So you don't need to worry about all these things in this video. So I'll, in future videos I'll be making videos on machine learning model where I will be explaining you how a machine learning model works, like a k-means clustering model. So I will be explaining you how this model works and what is the math behind this model and how we can build these models from scratch, those kind of things. So in that I'll explain you in detail about this model. The purpose of this video is to understand how we can implement this model in our projects. Okay, so you don't need to worry much about this. So you can understand that the good initiation method is k-means plus plus, and for finding the number of clusters we can use this within cluster sum of square value. Okay, so the next parameter we need is random state. So random state is equal to, you can give any number, so I'll just give a random number as 42. So like this data will be taken in a random fashion when you do this kind of processing. So here I have mentioned this random state 42, right? So if you mention some values like 1 or 2, then the way your data is arranged will be different. Okay, so if you mention the same number, as here I have mentioned 42, if you mention the same number 42, then your data will be splitted in the same way that my data is splitting. So this is just for the reproducibility of code, so this is not that significant in this case. Okay, so the significant things are this number of clusters and the initiation method which we are using, and then we need to fit this k-means to our data. Here our data is x, right? So here x represents the annual income and this pending score, right? So we have loaded that data in x, so we need to fit this data to this k-means. So k-means dot fit x, and now we need to find so this will give us the wcs value. So wcss dot append, I'll just make a space here. So wcs dot append k-means dot inertia, k-means dot inertia. Okay, so this k-means dot inertia will give us the WCSS value. So this particular inertia function lies in this k-means algorithm. So when you do this, it will give us the WCSS value for each clusters, and this value will be stored in this list. So in the first case, when this for loop is running, this I will take the first value, which is 1, and this I goes here. So I'm splitting the data as only one clusters, only one group, and it will fit this data and it will find the WCSS, the within cluster sum of square value, and it will put that value in this particular list. And once this for loop is completed, then it will again carry out this loop again. Now it will take the second value, which is 2. Now the n clusters value will be 2, and again this will be created, and it will run and it will give the WCSS value for 2 clusters, and this process will be carried out until we do the same up to 10 clusters. Okay, so I'll run this. Now, as I have told you before, that we will create a similar elbow graph to see for which number of clusters we get minimum sum of square values. Okay, so now I'm going to create a elbow graph. So plot an elbow graph to find which cluster has minimum value. So we have already imported the Seaborn library. So I am mentioning, so we have imported Seaborn in the short form as SNS.set. So this will give the basic themes and basic parameters required for the graph. And then I'll create the plot as plt.figure. Okay, so plt.figure, and okay, so we don't need to mention this. So plt.plot dot range. Range is the same, which is 1 comma 11. So this value will be taken as x-axis, so value from 1 to 10, and the y-axis value is the list which we have within cluster sum of squares. Now you can give a title to your plot, plt.title, and the title is nothing but the elbow point graph. Okay, and we can give the x label as plt.x label, number of clusters. Okay, so the y-axis label is plt.y label. 1 second, I'll just check this. Okay, So the y-axis label is WCSS, and finally we can show our .plt.show. Okay, so let's run this. This will give us an elbow graph. So this is the elbow point graph, or you can also call this cutoff point graph. So in the y-axis, we have this within cluster sum of square values, and I have told you that this value should be minimum for the optimum number of clusters. And in the x-axis, we have the number of clusters. So 1, 2, in the middle we have 3, 4, 5, 6, and all the way up to 10, right? So when you analyze this graph, so there is a cutoff point here. So there is a sudden drop in the value here for this number of clusters is 3, and there is also another drop in the value for the number of clusters 5. So now we have two elbow points. So these points are called as elbow points, and in these two elbow points we will take this particular value. So here the value is number of clusters is 5, because after this there is no significant drop, right? So there is no sharp significant drop. So the correct optimum number of clusters we can choose is 5. So this is how you can interpret an elbow point graph, where we will see the elbow point after which there is no significant drop in the value. Okay, so now I'm going to I'll just make a text here as the optimum number of clusters. Optimum number of clusters will be 5. So we have interpreted it from our elbow point graph. Now we just need to do the same thing. So we have already fitted this to the k-means clustering algorithm. So we will just do the same thing, but in this case we will give the clusters is equal to 5. Okay, so this part is about training the k-means clustering model. So this is an example of an unsupervised learning model. K means clustering model. Here K is nothing but the number of clusters we are taking. So K represents the number of clusters, and in this case K, the value of K is equal to 5. Okay, so I'll mention this K means the same variable which we took. So we have imported this K means from sklearn.clusters, and inside this we need to mention n clusters, which is equal to 5, because we know the optimum number of clusters for this particular data set is 5, and initiation is K means plus plus, and again the random state. So you can mention any number we want. I'll just mention it as 0. Okay, so here we are taking 5 clusters. So this number of clusters varies depending on the data set we have. For this particular data set, the number of clusters is 5. So this is found by fitting the this k-means value with x, right? So you can see here we have fitted it with x. So this particular graph depends on the values present in this particular x. So x is nothing but the annual income and spending score, right? If we have another data set, based on that data we may get the optimum number of clusters as either 3, or it can also be 4, 5, 6, or any number of clusters depending on the data set. So it is not the same. It is not that in each cases in every cases we will get the optimum number as 5. So it varies depending on the data set, and for this particular data set it is 5. Okay, so I mentioned here n clusters is equal to 5, and this will load our k-means model to this variable named as k-means. Okay, now we need to return a label for each clusters. So I'll just mention it here. Return a label for each data point. Each data point based on their cluster. Okay, so what we are going to do is we will take all the values in this particular x. So this x will contain 200 data points, because totally we have about 200 data points, right? So all these values will be split into 5 clusters based on their similarity values in annual income and spending scores. So each value will get a label. So we are taking 5 clusters, right? So each cluster will be given a label. So the first cluster will be given a label as 0. Second cluster will be given a label as 1. So similarly we have 0, 1, 2, 3, and 4. So 5 clusters, and each this data point, so this is one data point, and each data point contains 2 values, right? So they will get their own cluster number. So I'll just show you here how we can get it. So we are going to return a label for each of the clusters. So let's store this label in a variable called as y, and k means is equal to k-means dot fit predict. So this fit predict will return a cluster number for each of this data point. Okay, so fit predict x. So we are fitting all the values of x and finding which clusters they are belong to. Okay, so now let me print this y. Let's run this. So as you can see here, we have several values, and the values are nothing but 0, 1, 2, 3, and 4. So there will be only 5 values because we have mentioned that we need 5 clusters. So all the data points with the cluster 0 are one cluster, and all the data points with the value 1 represents one cluster, and similarly 2, 3, and 4. So they represents one cluster. Okay, so this is the cluster number. So the cluster in which they belong to for all the x values. Okay, so these are the clusters they belong to. Now what we can do is we can plot the data. So along with their cluster number and along with their annual income and their spending score to see how this data is looking. When we are just doing data visualization to get better understanding of this clustering project. Okay, so the next step is about visualizing all the clusters. So I'll just tell you briefly about how this k-means clustering works. We can understand more intuition. We can get more intuition about this when I make a separate video about k-means clustering. So you can see here, this is how k-means clustering clusters data. So these black dots are nothing but centroids. I have also mentioned you about centroids. So totally we have three clusters here, and each cluster has their own centroid. So these centroids are the representation point or the midpoint of each cluster. So the midpoint or the centroid of this particular blue color clusters is this point, and for this yellow color cluster is here it's given here the black one, and for it is also. So each cluster has their centroid. So what happens is the k-means algorithm will randomly plot clusters. So in this case, the x-axis will be taken as the annual income. So as I've already told you, so in our case the x-axis will be taken as annual income, and the y-axis will be taken as their spending score, and based on these values we will get different clusters. So in this case we have just only 3 clusters, but for this customer segmentation we got about 5 clusters, right? So we will have 5 centroids, and each data point will be plotted in this graph, and their distance from that particular data point and this centroids. So each of the 5 centroids will be calculated, and only one centroid will be closer to this value. Say for example, we are taking this first value. Okay, so the first value is nothing but 15 comma 39, right? Yeah, the annual income is 15,000 US dollars and the spending score is 39. So we have randomly plotted 5 centroid values, and it will be plotted in those centroid values will be plotted in the graph, and we will plot this 15 comma 39. So 15 is the x-axis value, 39 is the y-axis value, and it will be plotted, and the k-means clustering model will check which centroid is closer to this data point. So then the centroids will be moved accordingly after all the data points are plotted. So when this process is completed, you will get different clusters and also their centroids as well. So the centroids are the very important thing here. So you can understand how this particular clustering works in the future, but just let's see how we can visualize this data. So this is the basic working of our k-means clustering work. So you just need to know that the centroids will be plotted first, and then uh, the data point will be plotted, and it will be checked that which centroid is closer to that data point, and then it will be rearranged. So this k-means clustering model will reiterate. I mean, reiterate means it do this again and again to find the correct clusters that the data point belong to, and after that we can have clusters like this. So different clusters. So now let's try to visualize these clusters. So we just need to make some plots here. uh, Plotting all the clusters and their centroid. So centroid means the center point or the representation point of each cluster. So 5 clusters means we will have 5 centroids. So and their centroids. So I'll show you how we can plot this. Okay. So plt dot figure. So we are creating a matplotlib plot, and I'll just mention the figure size here. So what is the size of the plot you want? And let's mention that 8 comma 8. So this is the x-axis unit and y-axis unit. So this is just for the size of the plot. So if you want a bigger plot, you can increase these values. And plt dot scatter. So we are going to create scatter plot like this. So these are examples of scatter plot where we will mark different points. Okay, so this is an example of scatter plot. Plt dot scatter. And so I'll just complete this code and explain you what I am doing here. Okay, so it will make sense once I complete this. So y is equal to 0 comma 0, and x is nothing but y is equal to 0 comma 1. S is equal to 50. Don't worry, I'll just mention you about these parameters after I complete this line of code. S is equal to 50 and C is equal to green. Okay, C is equal to green. Label is equal to cluster 1. Okay, so we just need to copy this line and paste it again 5 times, and we just need to change few things. So first is the x coordinate, y coordinate, size of the point. Okay, so I'll just put it 5 times. Okay, so I'll just change this cluster to cluster 2, 3, 4 and 5. So totally we have 5 clusters, and we need to change these values as well. So first one is 0 comma 0, then we need to change this as 1 comma 0. I'll explain you what these numbers signifies in a minute. So 2, 3 and 4, and then here we have 0, 1, 2, 3 and finally we have 4. Okay, so 0 comma 0. Okay, so what we are doing is, so this all these y values, so y represents their cluster identity or cluster label corresponds to this x. Okay, so here we have this last data point as 137 comma 83, and the label for this last data point is this last value, which is 2. So that means this particular value belongs to second cluster, right? So this second cluster, so we need to plot this data along with their clusters. So here we have this 0 comma 0. So this particular point here, so from this, sorry, so from, so this is the x coordinate of this particular cluster 1, and this second, so for here we have x and y is equal to 0 comma 0. So this is the x coordinate and this is the y coordinate. Okay, so for all the clusters 1, and cluster 1 is nothing but the label is 0, right? So totally we have 5 clusters here. Here the 5 clusters are nothing but, I'll just put a text here so it's better for your understanding. 5 clusters, and each of the clusters as, so the 5 clusters are 0, 1, 2, 3 and 4, right? So here the second value here represents the first cluster. So I want to plot all the first cluster value. And sorry, okay, so this is the, so here I have mentioned 0 comma 0. Here the 0 represents the cluster number, so that means I am plotting the first cluster. So you can also see here that I have mentioned cluster 1, right? So when I mention 0 here, it will take all the values of cluster 0, or that means the first cluster. And here we have the second 0, right? Second 0 represents the first column of this x. So the first column is nothing but the annual income, and the second column is spending score. So the index of this first column is 0 and the index of the second column is 1. So that's what we have mentioned here. As so you can see here all the values are 0. So here the x coordinate is taken as annual income, because we know that the 0 represents the first column, which is annual income. So we have mentioned all of them as 0, and all of this first part represents x-axis, and the second part represents y-axis, and all the 1 represents the spending score, which is the second column value. So I am just giving x-axis and y-axis value, and the first line is for first cluster. So that's why I mentioned 0 in the first value. Here 0 here and 0 here represents the first cluster value. Now it will change. So 1 means the second cluster. Here we also have 1. again 2 3, so we have 5 clusters. So each of this represents data point of each 5 clusters, and here the 0 represents the x-axis value, which is annual income, and here the 1 represents spending score. So this will give us data visualization and plots of all the data points, uh, along with their annual income and spending scores, as well as their labels of clusters. Now we need to plot the centroids. As I mentioned you, we have this centroids, right? So this black dots, so those are almost the center point of each clusters. So now we are going to plot the centroids. Okay, so plt dot scatter k means, so k means is the function which we have loaded. K means dot cluster center. So this is the centroid values. So we need to mention colon comma 0, and k means dot cluster centers 1. Okay, so it is very similar to the one which we have did before. I'll explain you what we are doing here in a minute. S is equal to 100 and color is equal to, let's give cyan, so it looks different, and here the label is centroid. Okay, so here S represents the size of the dot. So I told you that we are going to make scatter plots, right? So scatter plots, we make these dots, and we need to mention the size of these dots. So if you increase this size, you will get bigger dots. And the C represents the color of the dots. So we can give different colors here. So I'll just change this color to red. So let's put each cluster in different colors. So green, red, and we can take yellow color in this. So just take 5 different colors. So C represents color, and we need to give those parameters, and blue. So each cluster will look in a different color. Okay, and finally we have this centroid values. Here 0 represents the centroid of those x-axis. So when you have a plot, so let's take this. When you choose a particular dot in a graph, we need x-axis as well as y-axis, right? So for this particular centroid, the x-axis value is 0 and y-axis value is also 0. So for this it can be around 5, and almost it's -1, right? So we need the x-axis value and y-axis value for any point to mention. Here this 0 represents the x-axis value of clusters, sorry, the x-axis value of the centroids, and 1 represents the y-axis value of centroid. So it is just plotting a point in the graph. So we are taking cyan color for all the centroids, and we are taking 5 different colors for all the centroids. Now we can just give the names for our plots and plot this graph. So I'll give the title as plt.title. Let's name this as customer groups. Okay, you can just mention it groups or clusters, anything you want. So I'll just mention this as customer groups, and plt dot xlabel annual income. So we are taking annual income as our x-axis, and y-axis will be spending score, right? plt dot y label, it will be spending score. So the spending score value ranges from 1 to 100. Spending score. We can finally use plt dot show to print our graph. Let's see whether we did all the things correctly. Okay, so this is our plot. So as you can see here, we have multiple clusters here. So this is one cluster, this red in color, and we have a violet color cluster, green color cluster, yellow and blue. So all these clusters are partitioned in a good way. There is not any mix. So here we have just close values between this data point and this one, and a few data points are closer to each other, and apart from that, all the clusters are partitioned in a different way. So this is the clusters group of customers which we are getting. So this is an amazing data visualization to see that our data points, sorry, our data set as, so we have, so this is the data set as 5 different groups of customers. So let's just get some insights from this particular visualization. So here red color is the second cluster, right? So just look at this graph. So in the x-axis we have annual income, and in the y-axis we have spending scores. So if you take this particular red color group of people, so this is one cluster, and this particular group of people don't have a very high annual income, but they have a very good spending scores. But here you can see here, these people, these group of customers has a very less annual income, and also they have a very less spending score, which is like understandable, because like people with less income tend to purchase less in supermarkets and malls. And you can see here this this particular set of people as, you know, kind of more annual income, but they don't spend much, so they are just cautious about what they are buying. So this group of people represents people with more annual income, and they are spending a lot, right? So these are the insights that we get. So what the small can do is they can give offers for those people who are just not buying too much. So here we can say that people who are not spending that much, so we know who these customers are, and we can give better discounts and offers for these people using some membership cards. And we also can give offers for these people who have high income value and also have very less spending in that particular mall. So when you give more offers and discounts, they can tend to, I mean, they tend to buy more, right? So this will increase the profit of that particular mall, and it will increase the customer satisfaction. So this is how the malls can improve their market value and then improve their profits. So this is the very important business insight that we get from this clustering. So this is how you can take a data set, and you can find some clusters or groups of people and can make better recommendations for them. So there are a lot of applications for this clustering. I would like to give you a few more examples. Let's say that there is a movie watching platform like Netflix or Amazon Prime. So one group of people tend to watch more superhero movies. There can be another group of people who tend to watch thriller movies or horror movies. When a new person watches a superhero movie, this Netflix system can suggest the movies based on the group of customers or big, group of people who are watching superhero movies. Like so, by this method, they can give better recommendations for people. So similarly, Google Ads and other things work where they group people in, based on their different interest, and using this data, they can make better recommendations for them. So there are a lot of applications that can be done using these clusters. So you can just search for them on what are the different aspects that we can do with clusters, and what are the things we can achieve regarding this. So I hope you have understood all the things we have covered here. I'll just give you a quick recap of what we have done here. So the first step, we have just imported the dependencies we want, the basic libraries we want, and then we have loaded our dataset to a dataset which is in a CSV file to a pandas data frame. After that, we just checked what are the different features we have, and checked the number of data points, number of rows and columns we have, and checked whether we have any missing values. After that, we choose the last two columns, which are annual income and spending scores, and stored them to the variable x, right? So after that, we checked the correct number of clusters we want using this within cluster sum of square value. After that, we plotted this elbow point graph and found the correct number of clusters is 5. And after that, we fitted this data to this k-means clustering model. Then we got this cluster, each cluster labels, right? And after that, we plotted these graphs, sorry, plotted these values in this scatter plots, and we have visualized the different groups of customers, right? So that is all about this clustering. I hope you have understood all this.